everyone, welcome to this DevOps Tools full course by Simplilearn. In this complete course, we'll learn everything that we need regarding several DevOps tools. We have Matthews and Chidanand to guide us through this journey. So let's look at what's in store for us. We shall begin with having a basic understanding of DevOps with a short animated video. After that, we'll dive deeper and understand the basics of DevOps, like its relevance in the current scenario and several DevOps phases. Once we know DevOps, we shall begin with learning different DevOps tools in detail. We shall learn about Git followed by GitHub, and in the process, we shall learn about various Git commands. Second, we shall see what Jenkins is, Jenkins Pipeline, and how we install Jenkins. After that, we'll move on to Docker and check out what Docker is and Docker container is all about. We'll also learn about the different processes and how to install Docker. Moving further, we'll understand the basics of Kubernetes, the difference between Kubernetes and Docker, and Kubernetes on AWS. The following tool in the list will be Puppet, where we shall know what Puppet is and why we use Puppet and the process to install it. Moving forward, we'll learn about Ansible and its installation process and what are the benefits of using Ansible. The last tool on our list is Selenium, where we shall learn about Selenium and all about its suite tools, followed by its installation processes. While we're learning all these tools, we shall understand them with a hands-on demo, making the understanding much more effective and more accessible. Finally, when we have a piece of deep knowledge regarding DevOps and several DevOps tools, we'll look at some of the most prominent DevOps interview questions that will help you excel in your forthcoming DevOps interviews. But before we begin, if you haven't subscribed to our channel already, make sure you hit the subscribe button and the bell icon to never miss an update. So without further ado, let's begin.
Right from the start, software development comprised two different departments. The development team that develops the plan, designs, and builds the system from scratch, and the operation team for testing and implementation of whatever is developed. The operations team gave the development team feedback on any bugs that needed fixing and any rework required. Invariably, the development team would be idle awaiting feedback from the operations team. This undoubtedly extended timelines and delayed the entire software development cycle. There would be instances where the development team moves on to the next project, while the operations team continues to provide feedback for the previous code. This meant weeks or even months for the project to be closed and final code to be developed. Now, what if the two departments came together and worked in collaboration with each other? What if the wall of confusion was broken? And this is called the DevOps approach. The DevOps symbol resembles an infinity sign, suggesting that it is a continuous process of improving efficiency and constant activity. The DevOps approach makes companies adapt faster to updates and development changes. The teams can now deliver quickly, and the deployments are more consistent and smooth. Though there may be communication challenges, DevOps manages a streamlined flow between the teams and makes the software development process successful. The DevOps culture is implemented in several phases with the help of several tools. Let's have a look at these phases. The first phase is the planning phase, where the development team puts down a plan, keeping in mind the application objectives that are to be delivered to the customer. Once the plan is made, the coding begins. The development team works on the same code, and different versions of the code are stored into a repository with the help of tools like Git and merged when required. This process is called version control. The code is then made executable with tools like Maven and Gradle in the build stage. After the code is successfully built, it is then tested for any bugs or errors. The most popular tool for automation testing is Selenium. Once the code has passed several manual and automated tests, we can say that it is ready for deployment and is sent to the operations team. The operations team now deploys the code to the working environment. The most prominent tools used to automate these phases are Ansible, Docker, and Kubernetes. After the deployment, the product is continuously monitored, and Nagios is one of the top tools used to automate this phase. The feedback received after this phase is sent back to the planning phase, And this is what forms the core of the DevOps lifecycle, that is, the integration phase. Jenkins is the tool that sends the code for building and testing. If the code passes the test, it is sent for deployment, and this is referred to as continuous integration. There are many tech giants and organizations that have opted for the DevOps approach. For example, Amazon, Netflix, Walmart, Facebook, and Adobe. Netflix introduced its online streaming service in 2007. In 2014, it was estimated that a downtime for about an hour would cost Netflix $200,000. However, now Netflix can cope with such issues. They opted for DevOps in the most fantastic way. Netflix developed a tool called the Simian Army that continuously created bugs in the environment without affecting the users. This chaos motivated the developers to build a system that does not fall apart when any such thing happens. So, on this note, here is a quiz for you. Match the DevOps tool with the phase it is used in. A. B. C. D. None of the above. Today, more and more companies lean towards automation, with the aim of reducing its delivery time and the gap between its development and operations teams. To attain all of these, there's just one gateway: DevOps.
Matthew with Simplilearn, and today we're going to go through and introduce you to DevOps. We're going to go through a number of key elements today. The first two will be reviewing models that you're already probably using for delivering solutions into your company. And the most popular one is Waterfall, followed by Agile. Then we'll look at DevOps and how DevOps differs from the two models and how it also borrows and leverages the best of those models. We'll go through each of the phases that are used in typical DevOps delivery, and then the tools used within those phases to really improve the efficiencies within DevOps. Finally, we'll summarize the advantages that DevOps brings to you and your teams. So let's go through Waterfall. So Waterfall is a traditional delivery model that's been used for many decades for delivering solutions, not just IT solutions and digital solutions, but even way before that. It has its history that goes back to World War II. So Waterfall is a model that is used to capture requirements and then cascade each key deliverable through a series of different stage gates that is used for building out the solution. So let's take you through each of those stage gates. The first that you may have done is requirements analysis. And this is where you sit down with the actual client and you understand specifically what they actually do and what they're looking for in the software that you're going to build. And then from that requirements analysis, you'll build out a project plan so you have an understanding of what the level of work is needed to be able to be successful in delivering the solution. After that, you've got your plan, then you start doing the development, and that means that the programmers start coding out their solution. They build out their applications, they build out the websites, and this can take weeks or even months to actually do all the work. When you've done your coding and development, then you send it to another group that does testing, and they'll do full regression testing of your application against the systems and databases that integrate with your application. You'll test it against the actual code, you'll do manual testing, you do UI testing. And then after you've delivered the solution, you go into maintenance mode, which is just kind of making sure that the application keeps working. If there's any security risks, that you address those security risks. The problem you have, though, is that there are some challenges, however, that you have with the waterfall model. The cascading deliveries and those complete and separated stage gates means that it's very difficult for any new requirements from the client to be integrated into the project. So if a client comes back and the project has been running for 6 months and they've gone, hey, we need to change something, that means that we have to almost restart the whole project. It's very expensive and it's very time consuming. Also, if you spend weeks and months away from your client and you deliver a solution that they are only just going to see after you spend a lot of time working on it, they could be pointing out things that are in the actual final application that they don't want or are not implemented correctly or lead to just general unhappiness. The challenge you then have is if you want to add back in the client's feedback to restart the whole waterfall cycle again. So the client will come back to you with a list of changes, and then you go back and you have to start your programming, and you have to then start your testing process again, and just you're really adding in lots of additional time into the project. So using the waterfall model, companies have soon come to realize that the clients just aren't able to get their feedback in quickly, effectively. It's very expensive to make changes once the teams have started working. And the requirement in today's digital world is that solutions simply must be delivered faster. And this has led for a specific change in agile. And we start implementing the agile model. So the agile model allows programmers to create prototypes and get those prototypes to the client with the requirements faster. And the client is able to then send the requirements back to the programmer with feedback. This allows us to create what we call a feedback loop, where we're able to get information to the client and the client can get back to the development team much faster. Typically, when we're actually going through this process, we're looking at the engagement cycle being about 2 weeks. And so it's much faster than the traditional waterfall approach. And so we can look at each feedback loop as comprising of 4 key elements. We have the planning, where we actually sit down with the client and understand what they're looking for. We then have coding and testing, that is building out the code and the solution that is needed for the client. And then we review with the client the changes that have happened. But we do all this in a much tighter cycle that we call a sprint. And that typically a sprint will last for about 2 weeks. Some companies run sprints every week, some run every 4 weeks. It's up to you as a team to decide how long you want to actually run a sprint. But typically it's 2 weeks. And so every 2 weeks, the client is able to provide feedback into that loop. And so you were able to move quickly through iterations. And so if we get to the end of sprint 2 and the client says, hey, you know what, we need to make a change, you can make those changes quickly and effectively for sprint 3. What we have here is a breakdown of the ceremonies and the approach that you bring to Agile. So typically what will happen is that a product leader will build out a backlog of products and what we call a product backlog. And this will be just a whole bunch of different features, and they may be small features or bug fixes, all the way up to large features that may actually span over multiple sprints. But when you go through the sprint planning, you want to actually break out the work that you're doing so the team has a mixture of small, medium, and large solutions that they can actually implement successfully into their sprint plan. And then once you actually start running your sprint, again, it's a 2-week activity. You meet every single day with the actual sprint team to ensure that everybody is staying on track, and if there's any blockers, that those blockers are being addressed effectively and immediately. The goal at the end of the 2 weeks is to have a deliverable product that you can put in front of the customer, and the customer can then do a review. The key advantages you have of running a sprint with Agile is that the client requirements are better understood because the client is really integrated into the Scrum team. They're there all the time. And the product is delivered much faster than with a traditional waterfall model. You're delivering features at the end of each sprint versus waiting weeks, months, or in some cases years for a waterfall project to be completed. However, there are also some distinct disadvantages. The product itself really doesn't get tested in a production environment. It's only being tested on the developer computers. And it's really hard when you're actually running Agile for the sprint team to actually build out a solution easily and effectively on their computers to mimic the production environment. And the developers and the operations team are running in separate silos. So you have your development team running their sprint and actually working to build out the features. But then when they're done at the end of their sprint and they want to do a release, they kind of fling it over the wall at the operations team. And then it's the operations team job to actually install the software and make sure that the environment is running in a stable fashion. That is really difficult to do when you have the two teams really not working together. So here we have is a breakdown of that process with the developers submitting their work to the operations team for deployment. And then the operations team may submit their work to the production servers, but what if there is an error? What if there was a setup configuration error with the developer's test environment that doesn't match the production environment? There may be a dependency that isn't there. There may be a link to an API that doesn't exist in production. And so you have these challenges that the operations team are constantly faced with. And their challenge is that they don't know how the code works. So this is where DevOps really comes in. And let's dig into how DevOps, which is developers and operators working together, is the key for successful continuous delivery. So DevOps is an evolution of the agile model. The agile model really is great for gathering requirements and for developing and testing out your solutions. And what we want to be able to do is kind of address that challenge and that gap between the ops team and the dev team. And so with DevOps, what we're doing is bringing together the operations team and the development team into a single team. And they are able to then work more seamlessly together because they are integrated to be able to build out solutions that are being tested in a production-like environment so that when we actually deploy, we know that the code itself will work. The operations team is then able to focus on what they're really good at, which is analyzing the production environment and being able to provide feedback to the developers on what is being successful. So we're able to make adjustments in our code that is based on data. So let's step through the different phases of a DevOps team. So typically you'll see that the DevOps team will actually have 8 phases. Now this is somewhat similar to Agile, and what I'd like to point out at the time is that again, Agile and DevOps are very closely related, that Agile and DevOps are closely related delivery models that you can use. With DevOps, it's really just extending that model with the key phases that we have here. So let's step through each of these key phases. So the first phase is planning, and this is where we actually sit down with a business team and we go through and understand what their goals are. The second stage is, as you can imagine, and this is where it's all very similar to Agile, is that the coders actually start coding. But they'll start using tools such as Git, which is a distributed version control software. It makes it easier for developers to all be working on the same code base rather than bits of the code rather than them working on bits of the code that they are responsible for. So the goal with using tools such as Git is that each developer always has the current and latest version of the code. You then use tools such as Maven and Gradle as a way to consistently build out your environment. And then we also use tools to actually automate our testing. Now, what's interesting is when we use tools like Selenium and JUnit is that we're moving into a world where our testing is scripted, the same as our build environment and the same as using our Git environment. We can start scripting out these environments. And so we actually have scripted production environments that we're moving towards. Jenkins is the integration phase that we use for our tools. And another pointer here is that the tools that we're listing here, these are all open source tools. These are tools that any team can start using. We want to have tools that control and manage the deployment of code into the production environments. And then finally, tools such as Ansible and Chef will actually operate and manage those production environments so that when code comes to them, that code is compliant with the production environment, so that when the code is then deployed to the many different production servers, that the expected results of those servers, which is you want them to continue running, is received. And then finally, you monitor the entire environment so you can actually zero in on spikes and issues that are relevant to either the code or changing consumer habits on the site. So let's step through some of those tools that we have in the DevOps environment. So here we have is a breakdown of the DevOps tools that we have. And again, one of the things I want to point out is that these tools are open source tools. There are also many other tools. This is just really a selection of some of the more popular tools that are being used. But it's quite likely that you're already using some of these tools today. You may already be using Jenkins. You may already be using Git. But some of the other tools really help you create a fully scriptable environment so that you can actually start scripting out your entire DevOps tool set. This really helps when it comes to speeding up your delivery, because the more you can actually script out the work that you're doing, the more effective you can be at running automation against those scripts, and the more effective you can be at having a consistent experience. So let's step through this DevOps process. So we go through and we have our continuous delivery, which is our plan, code, build, and test environment. So what happens if you want to make a release? Well, the first thing you want to do is send out your files to the build environment, and you want to be able to test the code that you've been created. Because we're scripting everything in our code, from the actual unit testing being done to the all the way through to the production environment, because we're testing all of that, we can very quickly identify whether or not there are any defects within the code. If there are defects, we can send that code right back to the developer with a message saying what the defect is, and the developer can then fix that with information that is real on either the code or the production environment. If, however, your code passes the scripting tests, it can then be deployed. And once it's out to deployment, you can then start monitoring that environment. What this provides you is the opportunity to speed up your delivery. So you go from the waterfall model, which is weeks, months, or even years between releases, to agile, which is 2 weeks or 4 weeks, depending on your sprint cadence, to where you are today with DevOps, where you can actually be doing multiple releases every single day. So there are some significant advantages. And there are companies out there that are really zeroing in on those advantages. If we take any one of these companies, such as Google, any given day will actually process 50 to 100 new releases on their website through their DevOps teams. In fact, they have some great videos on YouTube that you can find out on how their DevOps teams work. Netflix is also a similar environment. Now, what's interesting with Netflix is that Netflix have really fully embraced DevOps within their development team. And so they have a DevOps team, and Netflix is a completely digital company. So they have software on phones, on smart TVs, on computers, and on websites. Interestingly, though, the DevOps team for Netflix is only 70 people. And when you consider that a third of all internet traffic on any given day is from Netflix, it's really a reflection on how effective DevOps can be when you can actually manage that entire business with just 70 people. So there are some key advantages that DevOps has. It's the actual time to create and deliver software is dramatically reduced, particularly compared to Waterfall. Complexity of maintenance is also reduced because you're automating and scripting out your entire environment. You're improving the communication between all your teams, so teams don't feel like they're in separate silos, but that are actually working cohesively together. And that there is continuous integration and continuous delivery so that your consumer, your customer, is constantly being delighted.
A very warm welcome to all our viewers. I'm Anjali from Simplilearn, and today I'll be showing you the installation for Git on Windows. So we'll start by downloading and installing Git on our system. We'll then have a look at the Git Bash interface. We'll type in some basic Git commands. Next, we'll create a local repository. That is, we'll create a repository on our local machine. We'll then connect to a remote repository. And finally, we'll push the file onto GitHub. First things first, we need to download and install Git. So download Git for Windows. And I'll select the second link. So 2.19.1, which is the most latest version of Git, that's the one we want for Windows system. Choose your version. So mine is a 64-bit system and it's downloading. So this will take a while. So Git is now on our system. Click here, run. So go to next. We don't have to change this path. Just click on in quick launch and on desktop. Next. Next, again next, nothing to change here either. And install. So now Git is getting installed on our system. So we don't need to view the release notes, we just want to launch the Git Bash. So let's just tick that and then click on finish. And your Git Bash interface appears here. So we are on the master branch. The first thing we do is we'll check the version for our Git. So the command is git -- version. And as you can see, version 2.19.1 on our Windows system, which is exactly what we just downloaded. We'll now explore the help command. So let's just type git help config. So config is another command. And as I hit enter, the manual page for the second command opened up, which is config. So what help command does is that it provides the manual or the help page for the command just following it. So in case you have any doubts regarding how a command is used, what a command is used for, or the various syntax of the command, you can always use the help command. Now there's another syntax for using the help command itself, which is git config -- help. Enter. This does the exact same thing, as you can see. Now that we looked at the help command, let's begin by creating a local directory. So mkdir test. Now test is my new directory. I'll move into this directory. So cd test. Great. So now that we are inside our test directory, let's initialize this directory. So git init is the command for initializing the directory. And as you can see the path here, this is the local path where a directory is created. So I'll just show you the directory test, and it's completely empty. What we do now is we'll create a text file within this new directory that we created. So new text document, and I'll just name this demo. I'll open this and just put in some dummy content. So hello Simplilearn. Save this file and go back to your Bash interface. Let's just check the status now. So git status, and as you can see, our file has appeared, it's visible, but nothing is committed yet. So this means that we have not made any change to our file through the Git tool itself. So the next thing that we are going to do is we'll be adding demo to our current directory. The next command that we'll be applying is the commit command. And when you add certain files to the current directory, the commit command is applied on all the above directories. So git commit -m and a message that will appear once the file is committed. So as you can see, one file is changed and one insertion. I'll just clear the screen. Next thing we need to do is we need to link our Git to our GitHub account. So the command for doing that is git config global user.username. And this will be followed by our username. So let me just show you my GitHub account. So this is my GitHub profile and my username is Simplilearn-GitHub. So guys, before you begin this procedure, just make a GitHub account. Type in my username here, Simplilearn-GitHub, and enter. And there you go. Our Git is successfully linked with GitHub. Next thing we do is we'll just open our GitHub and we'll create a new repository. Give a repository name. So I'll name it test_demo and create repository. Great. So our repository is created. This is our remote repository. What we do next is just copy the link and then go back to your Bash interface. Now we need to link our remote and our local repository. So git remote origin and then paste the HTTP link. And now that our local repository and our remote repository are linked, we can push our local file onto our remote repository. So the command for doing that is git push origin master, as we are on the master branch. And that's done. So now let's move back to GitHub. I'll just click on test demo. And as you can see here, our local file has been pushed to our remote repository. With that, we have successfully completed our demo.
Thanks, Anjali. Now Matthew and Chidanand will take you through the remaining part of the course.
Hello, this is Matthew from Simplilearn, and today we're going to go through and explain how you can use Git for your software development. So what are we going to cover today? So we're going to introduce the concept of version control that you will use within your DevOps environment. Then we'll talk about the different tools that are available in a distributed version control system. We'll highlight a product called Git, which is typically used for version control today. And you'll also go through what are the differences between Git and GitHub. You may have used GitHub in the past or other products like GitLab, and we'll explain what are the differences between Git and services such as GitHub and GitLab. We'll break out the architecture of what a Git process looks like. How do you go through and create forks and clones? How do you have collaborators being added into your projects? How do you go through the process of branching, merging, and rebasing your project? And what are the list of commands that are available to you in Git? Finally, I'll take you through a demo on how you can actually run Git yourself. And in this instance, use the software of Git against a public service such as GitHub. All right, let's talk a little bit about version control systems. So you may have already been using a version control system within your environment today. You may have used tools such as Microsoft's Team Foundation services, but essentially the use of a version control system allows people to be able to have files that are all stored in a single repository. So if you're working on developing a new program, such as a website or an application, you would store all of your version control software in a single repository. Now, what happens is that if somebody wants to make changes to the code, they would check out all of the code in the repository to make the changes, and then there would be an addendum added to that. So there would be the version 1 changes that you had, then the person would then later on check out that code, and then be a version 2 added to that code. And so you keep adding on versions of that code. The bottom line is that eventually you'll have people being able to use your code, and that your code will be stored in a centralized location. However, the challenge you run in is that it's very difficult for large groups to work simultaneously within a project. The benefits of a VCS system, a version control system, demonstrates that you're able to store multiple versions of a solution in a single repository. Now let's take a step at some of the challenges that you have with traditional version control systems and see how they can be addressed with distributed version control. So in a distributed version control environment, what we're looking at is being able to have the code shared across a team of developers. So if there are 2 or more people working on a software package, they need to be able to effectively share that code amongst themselves, so that they constantly are working on the latest piece of code. So a key part of a distributed version control system that's different to just a traditional version control system is that all developers have the entire code on their local systems, and they try and keep it updated all the time. It is the role of the distributed VCS server to ensure that each client, and we have a developer here, and developer here, and developer here, and each of those are clients, have the latest version of the software, and then that each person can then share the software in a peer-to-peer like approach. So that as changes are being made into the server of changes to the code, then those changes are then being redistributed to all of the development team. The tool to be able to do an effective distributed VCS environment is Git. Now, you may remember that we actually covered Git in a previous video, and we'll reference that video for you. So we start off with our remote Git repository, and people are making updates to the copy of their code into a local environment. That local environment can be updated manually and then periodically pushed out to the Git repository. So you're always pushing out the latest code changes you've made into the repository. And then from the repository, you're able to pull back the latest updates. And so your Git repository becomes the kind of the center of the universe for you. And then updates are able to be pushed up and pulled back from there. What this allows you to be able to accomplish is that each person will always have the latest version of the code. So what is Git? Git is a distributed version control tool used for source code management. So GitHub is the remote server for that source code management, and your development team can connect their Git clients to that remote hub server. Git is used to track the changes of the source code and allows large teams to work simultaneously with each other. It supports a non-linear development because of thousands of parallel branches, and has the ability to handle large projects efficiently. So let's talk a little bit about Git versus GitHub. So Git is a software tool, whereas GitHub is a service, and I'll show you how those two look in a moment. You install the software tool for Git locally on your system, whereas GitHub, because it is a service, it's actually hosted on a website. Git is actually the software that's used to manage different versions of source code, whereas GitHub is used to have a copy of the local repository stored on the service, on the website itself. Git provides command line tools that allow you to interact with your files, whereas GitHub has a graphical interface that allows you to check in and check out files. So let me just show you the two tools here. So here I am at the Git website, and this is the website you would go to download the latest version of Git. And again, Git is a software package that you install on your computer that allows you to be able to do version control in a peer-to-peer environment. For that peer-to-peer environment to be successful, however, you need to be able to store your files in a server somewhere. And typically, a lot of companies will use a service such as GitHub as a way to be able to store your files. So Git can communicate effectively with GitHub. There are actually many different companies that provide similar service to GitHub. GitLab is another popular service, but you also find that development tools such as Microsoft's Visual Studio are also incorporating Git commands into their tools. So the latest version of Visual Studio Team Services also provides this same ability. But GitHub, it has to be remembered, is a place where we actually store our files and can very easily create public and shareable. It is a place where we can store our files and create public shareable projects. You can come to GitHub and you can do a search on projects. You can see at the moment I'm doing a lot of work on blockchain, but you can actually search on the many hundreds of projects here. In fact, I think there's something like over 100,000 projects being managed on GitHub at the moment. That number is probably actually much larger than that. And so if you are working on a project, I would certainly encourage you to start at GitHub to see if somebody's already maybe done a prototype that they're sharing, or they have an open source project that they want to share that's already available in GitHub. Certainly if you're doing anything with Azure, you'll find that there are thousands, 45,000 Azure projects currently being worked on. Interestingly enough, GitHub was recently acquired by Microsoft, and Microsoft is fully embracing open source technologies. So that's essentially the difference between Git and GitHub. One is a piece of software, and that's Git, and one is a service that supports the ability of using the software, and that's GitHub. So let's dig deeper into the actual Git architecture itself. So the working directory is the folder where you are currently working on your Git project. And we'll do a demo later on where you can actually see how we can actually simulate each of these steps. So you start off with your working directory where you store your files, and then you add your files to a staging area where you are getting ready to commit your files back to the main branch on your Git project. You will want to push out all of your changes to a local repository after you've made your changes, and these will commit those files and get them ready for synchronization with the service, and will then push your services out to the remote repository. An example of a remote repository would be GitHub. Later, when you want to update your code, before you write any more code, you would pull the latest changes from the remote repository so that your copy of your local software is always the latest version of the software that the rest of the team is working on. One of the things that you can do is, as you're working on new features within your project, you can create branches, you can merge your branches with the mainline code. You can do lots of really creative things that ensure that A, the code remains at very high quality, and B, that you're able to seamlessly add in new features without breaking the core code. So let's step through some of the concepts that we have available in Git. So let's talk about forking and cloning in Git. So both of these terms are quite old terms when it comes to development, but forking is certainly a term that goes way back, long before we had distributed CVS systems such as the ones that we're using with Git. To fork a piece of software is a particular open source project. You would take the project and create a copy of that project but then you would then associate a new team and new people around that project. So it becomes a separate project in entirety. A clone, and this is important when it comes to working with Git, a clone is identical with the same teams and same structuring as the main project itself. So when you download the code, you're downloading an exact copy of that code with all the same security and access rights as the main code. And then you can then check that code back in, and potentially your code, because it is identical, could potentially become the mainline code in the future. Now, that typically doesn't happen. Your changes are the ones that merged into the main branch, but you do have that potential where your code could become the main code. With Git, you can also add collaborators that can work on the project, which is essential for projects particularly where you have large teams. This works really well when you have product teams where the teams themselves are self-empowered. You can do a concept what's called branching in Git. And so say, for instance, you are working on a new feature. That new feature and the main version of the project have to still work simultaneously. So what you can do is you can create a branch of your code so you can actually work on the new feature, whereas the rest of the team continue to work on the main branch of the project itself. And then later you can merge the two together. Pull from remote is the concept of being able to pull in services, software the team is working on from a remote server. And Git rebase is the concept of being able to take a project and re-establish a new start from the project. So you may be working on a project where there have been many branches and the team has been working for quite some time on different areas, and maybe you kind of losing control of what the true main branch is. You may choose to rebase your project. And what that means though is that anybody that's working on a separate branch will not be able to branch their code back into the mainline branch. So going through the process of a Git rebase essentially allows you to create a new start for where you're working on your project. So let's go through forks and clones. So you want to go through the process. So you want to go ahead and fork the code that you're working on. So let's use this scenario that one of your team wants to go ahead and add a new change to the project. The team member may say, yeah, go ahead and create a separate fork of the actual project. So what does that look like? So when you actually go ahead and create a fork of the repository, you actually go and you can take the version of the mainline branch, but then you take it completely offline into a local repository for you to be able to work from. And you can take the mainline code and you can then work on a local version of the code separate from the mainline branch. It's now a separate fork. Collaborators is the ability to have team members working on a project together. So if someone is working on a piece of code and they see some errors in the code that you've created, none of us are perfect at writing code. I know I've certainly made errors in my code. It's great to have other team members that have your back and can come in and check and see what they can do to improve the code. So to do that, you have to then add them as a collaborator. Now you would do that in GitHub. You can give them permission within GitHub itself. It's really easy to do, super visual interface that allows you to do the work quickly and easily. And depending on the type of permissions you want to give them, sometimes it can be very limited permissions. It may be just to be able to read the files. Sometimes it's being able to go in and make all the changes. You can go through all the different permission settings on GitHub to actually see what you can do. But you'll be able to make changes so that people can actually have access to your repository, and then you as a team can then start working together on the same code. Let's step through branching in Git. So suppose you're working on an application, but you want to add in a new feature. And this is very typical within a DevOps environment. So to do that, you can create a new branch and build a new feature on that branch. So here you have your main application on what's known as the master branch. And then you can then create a sub branch that runs in parallel, which has your feature. You can then develop your feature and then merge it back into the master branch at a later point in time. Now, the benefit you have here is that by default, we're all working on the master branch. So we always have the latest code. The circles that we have here on the screen show various different commits that have been made so that we can keep track of the master branch and then the branches that have come off which have the new features. And there can be many branches in Git. So Git keeps the new features you're working on in separate branches until you're ready to merge them back in with the main branch. So let's talk a little bit about that merge process. So you're starting with the master branch, which is the blue line here, and then here we have a separate parallel branch which has the new features. So if we're to look at this process, the base commit of feature B is the branch. F is what's going to merge back into the master branch. And it has to be said there can be so many divergent branches, but eventually you want to have everything merge back into the master branch. Let's step through Git rebase. So again, we have a similar situation where we have a branch that's being worked in parallel to the master branch, and we want to do a Git rebase. So we're at stage C, and what we've decided is that we want to reset the project so that everything from here on out along the master branch is the standard product. However, this means that any work that's being done in parallel as a separate branch will be adding in new features along this new rebased environment. Now, the benefit you have by going through the rebase process is that you're reducing the amount of storage space that's required for when you have so many branches. It's a great way to just reduce your total footprint for your entire project. So Git rebase is the process of combining a sequence of commits to form a new base commit. And the primary reason for rebasing is to maintain a linear project history. When you rebase, you unplug a branch and replug it in on the tip of another branch. And usually you do that on the master branch, and that will then become the new master branch. The goal of rebasing is to take all the commits from a feature branch and put it together in a single master branch. It makes the project itself much easier to manage. Let's talk a little bit about pull from remote. Suppose there are two developers working together on an application. The concept of having a remote repository allows the two developers will be actually then checking in their code into a remote repository that becomes a centralized location for them to be able to store their code. It enables them to stay updated on the recent changes to the repository because they'll be able to pull the latest changes from that remote repository so that they are ensuring that as developers, they're always working on the latest code. So you can pull any changes that you have made to your forked remote repository to your local repository. The command to be able to do that is written here, and we'll go through a demo of how to actually do that command in a little bit. Good news is if there are no changes, you'll get a notification saying that you're already up to date. And if there is a change, it will merge those changes to your local repository and you get a list of the changes that have been made remotely. So let's step through some of the commands that we have in Git. So Git init initializes a local Git repository on your hard drive. Git add adds one or more files to your staging area. Git commit -m commit message is a commit changes the Git command, commits changes to head up. So the Git command commits changes to your local staging area. Git status checks the status of your current repository and lists the files you have changed. Git log provides a list of all the commits made on your current branch. Git diff views the changes that you've made to the file. So you can actually have files next to each other and you can actually see the differences between the two files. Git push origin branch name, so the name of your branch command, will push the branch to the remote repository so that others can use it. And this is what you would do at the end of your project. Git config -global username will tell Git who you are by configuring the author name, and we'll go through that in a moment. Git config global user email will tell Git the author by the email ID. Git clone creates a Git repository copy from a remote source. Git remote add origin server connects the local repository to the remote server and adds the server to be able to push to it. Git branch and then the branch name will create a new branch for you to create a new feature that you may be working on. Git checkout and then the branch name will allow you to switch from one branch to another branch. Git merge branch name will merge a branch into the active branch. So if you're working on a new feature, you can then merge that into the main branch. A Git rebase will reapply commits on top of another base tip. And git rebase will reapply commits on top of another base tip. And these are just some of the popular Git commands. There are some more, but you can certainly dig into those as you're working through using Git. So let's go ahead and run a demo using Git. So now we are going to do a demo using Git on our local machine and GitHub as the remote repository. For this to work, I'm going to be using a couple of tools. First, I'll have the deck open as we've been using up to this point. The second is I'm going to have my terminal window also available. And let me bring that over so you can actually see this. And the terminal window is actually running Git Bash as the software in the background, which you'll need to download and install. You can also run Git Bash locally on your Windows computer as well. And in addition, I'll also have the GitHub repository that we're using for Simplilearn already set up and ready to go. All right, so let's get started. So the first thing we want to do is create a local repository. So let's go ahead and do exactly that. So the local repository is going to reside in my development folder that I have on my local computer. And for me to be able to do that, I need to create a drive in that folder. So I'm going to go ahead and change the directory. So I'm actually going to be in that folder before I actually create and make the new folder. So I'm going to go ahead and change directory. And now I'm in the development directory. I'm going to go ahead and create a new folder. And that's gone ahead and created a new folder called Hello World. I'm going to move my cursor so that I'm actually in the Hello World folder. And now that I'm in the Hello World folder, I can now initialize this folder as a Git repository. So I'm going to use the Git command init to initialize, and that's going to ahead and initialize that folder. So let's see what's happened. So here I have my Hello World folder that I've created, and you'll now see that we have a hidden folder in there which is called .git. And if we expand that, we can actually see all of the different subfolders that Git repository will create. So let's just move that over a little bit so that we can see the rest of the work. And now if we check on our folder here, we'll actually see this is users Matthew development hello world.git, and that matches up with hidden folder here. So we're going to go ahead and create a file called readme.txt in our folder. So here is our hello world folder, and I'm going to go ahead and using my text editor, which happens to be Sublime, I'm going to create a file, and it's going to have in there the text hello world, and I'm going to call this one readme.txt. If I go to my hello world folder, you'll see that we have the readme.txt file actually in the folder. What's interesting is if I select the git status command, what it'll actually show me is that this file has not yet been added to the commits yet for this project. So even though the file is actually in the folder, it doesn't mean that it's actually part of the project. For us to do that, we actually have to go and select For us to actually commit the file, we have to go into our terminal window, and we can use the git status to actually read the files that we have there. So let's go ahead and use the git status command, and it's going to tell us that this file has not been committed. You can use this with any folder to see which files and subfolders haven't been committed. And what we can now do is we can go and actually add the readme file. So let's go ahead and we're just going to select git add. So the git command is add readme.txt. So that then adds that file into our main project, and we want to then commit those files into the main repository's history. And so to do that, we'll hit the git command commit, and we'll do a message in that commit, and this one will be first commit, and it has committed that project. What's interesting is we can now go back into readme file, and I can change this. So we can go hello Git. Git is a very popular version control solution, and we'll We'll save that. Now what we can do is we can actually go and see if we have made differences to the README text. So to do that, we'll use the diff command for Git. So we do git diff, and it gives us two releases. The first is what the original text was, which is hello world. And then what we have afterwards is what is now the new text in green, which has replaced the original text. So what we're going to do now is you want to go ahead and create an account on GitHub. We already have one. So what we're going to do is we're going to match the account from GitHub with our local account. So to do that, we're going to go ahead and say git config, and we're going to do dash, and it's going to be a global user dot name, and we're going to put in our username that we use for GitHub. In this instance, we're using the Simplilearn dash GitHub account name. And under the GitHub account, you can go ahead and create a new repository name. In this instance, we call the repository hello-world. And what we want to do is connect the local GitHub account with the remote hello-world.git account. And we do that by using this command from Git, which is our remote connection. And so let's go ahead and type that in. Open this up so we can see the whole thing. So we're going to type in git remote add origin https / github.com/Simplilearn -GitHub, and you have to get this typed in correctly when you're typing in the location hello-world.git. That creates the connection to your Hello World account. And now what we want to do is we want to push the files to the remote location using the git push command. Commit git push origin master. So we're going to go ahead and connect to our local remote GitHub. So I'm just going to bring up my terminal window again. And so let's select git remote add origin, and we'll connect to the remote location github.com/Simplilearn -GitHub /hello-world.git. Oh, we actually have already connected, so we're connected to that successfully. And now we're going to push the master, gish. So git push origin master, and everything is connected and successful. And if we go out to GitHub now, we can actually see that our file was updated just a few minutes ago. So what we can actually do now is we can go and fork a project from GitHub and clone it locally. So we're going to use the fork tool that's actually available on GitHub. Let me show you where that is located. And here is our branching tool. It's actually changed more recently with a new UI interface. And once complete, we'll be able to then pull a copy of that to our account using the fork's new HTTP URL address. So let's go ahead and do that. So we're going to go ahead and create a fork of our project. Now, to do that, you would normally go in, when you go into your project, you'll see that there are fork options in the top right-hand corner of the screen. Now, right now, I'm actually logged in with the default primary account for this project. So I can't actually fork the project as I'm working on the main branch. However, if I come in with a separate ID, and here I am, I have a different ID, and so I'm actually pretending I'm somebody else, I can actually come in and select the fork option and create a fork of this project. And this will take just a few seconds to actually create the fork. And there we are. We have gone ahead and created the fork. So you want to select clone or download with this, and so this is the, I select, that'll actually give me the web address. I can actually show you what that looks like. I'll open up my text editor. Oops, that's not correct. I guess that is correct. So I'm going to copy that, and I can fork the project locally and clone it locally. I can change the directory, so I can create a new directory that I'm going to put my files in, and then post in that content into that folder. So I can now actually have multiple versions of the same code running on my computer. I can then go into the forked content and use the patchwork command to actually, so I can create a copy of that code that we've just created, and we call it, that's a clone, and we can create a new folder that we're actually putting the work in, and we could, for whatever reason we wanted to, we could call this folder patchwork, and that would be maybe a new feature, and then we can then paste in the URL of the new directory that has the forked work in it. And now at this point, we've now pulled in and created a clone of the original content. And so this allows us to go ahead and fork out all of the work for our project onto our computer. So we can then develop our work separately. So now what we can actually do is we can actually create a branch of the fork that we've actually pulled in onto our computer. So we can actually then create our own code that runs in that separate branch. And so we want to check out the branch, and then push the origin branch down to our computer. This will give us the opportunity to then add our collaborators. So we can actually then go over to GitHub, and we can actually come in and add in our collaborators. And we will do that under settings and select collaborators. And here we can actually see we have different collaborators that have been added into the project, and you can actually then request people to be added via their GitHub name, or by email address, or by their full name. One of the things that you want to be able to do is ensure that you're always keeping the code that you're working on fully up to date by pulling in all the changes from your collaborators. You can create a new branch and then make changes and merge it into the master branch. To do that, you would create a folder, and then that folder in this instance would be called test. We would then move our cursor into the folder called test and then initialize that folder. So let's go ahead and do that. So let's create a new folder, and we're going to first of all change our root folder. We're going to go to development, and we're going to create a new folder. Call it test, and we're going to move into the test folder, and we will initialize that folder, and we're going to move some files into that test folder. Call this one test1, and then we're going to do file save as, and this one's going to be test2, and now we're going to commit those files. Git add, git add, and then we'll use the dot to pull in all files, and then git commit -m files committed, Make sure I'm in the right folder here. I don't think I was. And now that I'm in the correct folder, let's go ahead and git commit. And it's gone ahead and added those files. And so we can see the two files that were created have been added into the master. And we can now go ahead and create a new branch. You can call this one git branch test underscore branch. And let's go ahead and create a third file to go into that folder. This is file 3. We'll do file save as. We'll call this one test3.txt. And we'll go ahead and add that file. And do git add test3.txt. And we're going to move from the master branch to the test branch. Git check out test underscore branch. And it switched to the test branch. And we'll be able to list out all of the files that are in that branch now. And we want to go through and merge the files into one area. So let's go ahead and we'll do git merge test underscore branch. And it's, well, we've already updated everything, so that's good. So otherwise it would tell us what we would be merging. And now all the files are merged successfully into the master branch. There we go, all merged together. Fantastic. And so what we're going to do now is move from master branch to test branch. So git checkout test underscore branch. And we can modify the files, the test3 file that we took out, and pull that file up. And we can now modified. And we can then commit that file back in. And we've actually been able to then commit the file with one changes, and we see it's the text-free change that was made. And we can now go through a process of checking the file back in, switching back to the master branch, and ensuring that everything is in sync correctly. We may at one point want to rebase all of the work. It's kind of a hard thing you want to do, but it will allow you to allow for managing for changes in the future. So let's switch to it back to our test branch, which I think we're actually on. We're going to create 2 more files. Let's go to our folder here and let's go copy those. And that's created. We'll rename those tests 4 and 5. And so we now have additional files. And we're going to add those into our branch that we're working on. So we're going to go in and select git add -a. And we're going to commit those files. Git commit -a-m, adding 2 new files. And it's added in the 2 new files. So we have all of our files now. We can actually list them out, and we have all the files that are in the branch. And we'll switch then to our master branch. We want to rebase the master. So we do git rebase master, and that will then give us the command that everything is now completely up to date. We can go git checkout master to switch to the master account. This will allow us to then continue through and rebase the test branch and then list all the files so they're all in the same area. So let's go git rebase test underscore branch, and now we can list, and there we have all of our files listed in correctly.
Hello and welcome to Git Commands. My name is Chidanand and I am with the Simplilearn team. Today I'm going to cover a few essential Git commands and walk you through a demonstration for most of it. I begin by installing a Git bash or the Git client and configuring it for its first time usage. Once I'm done with configuring the Git client, I'm going to spin up few repositories locally and work on these repositories using Git commands. Once I'm happy with my local changes, I'm going to commit few of them and then push these changes to a Git server of my choice. For today's demonstration, I plan to use github.com, which is a cloud-hosted free service, and it provides free account registrations for anyone. Eventually, I will cover a few topics regarding Git branching and merging, because these two, in my opinion, are the killer features of the Git distributed version control tool. Git is one of the most popular distributed version control tools of recent times, and like any other distributed version control tool, it allows us to perform various version control tasks without really needing a network connection. Before I jump into my demonstration, let me spend some time explaining to you the Git client server working model. What does it take for a couple of users to collaborate and start working with Git? The bare minimal thing that any user would need in order to start working with Git is something called as Git bash or the Git client. This comes as an installer for all popular operating systems like Windows, all flavors of Windows, Linux, macOS, and other operating systems. So once you install Git bash, you get a command line utility using which you can fire up your Git commands and ensure that you can bring up repositories. You can work with these repositories by adding files to it, committing changes to it, and all those Git commands would work perfectly well. So you can bring up a small repository and you can work with your repository using this Git bash. But what does it take for you to share this repository with another user who has also got Git bash installed on his system? This is where you would need something called as a Git server. So for user one or one user to share his repository with another user, he would need to collaborate using something called as a Git server. So in the present market, there are a bunch of Git servers which are popularly available. Some of them are free. Some of them come with a cost because they are licensed. A bunch of these servers that I can think of are GitHub, which is one of the most popular Git servers that is around in the market for a long time now. It comes with two variants. One is the cloud hosted one, which is the github.com. And then the other one is an enterprise server, which comes as a black box that can be installed into your data centers. So typically organizations who don't want their source code to be put up on the cloud would go for this GitHub enterprise servers, wherein they buy these servers and these servers are hosted on their data centers. Other popular variant of the Git server is Bitbucket. This is from the famous Atlassian products and it integrates very well with all other Atlassian products like Jira. In recent times, there's one other variant of the Git server called GitLab, which is getting very, very popular these days because GitLab not just provides a Git server, it also provides something called as a runner. This is a part of the continuous integration strategy where as soon as you have a source code check-in that is going in, you have this runner that kicks up and builds your particular project. So all these are bundled together in a GitLab. And GitLab also provides you with a community edition, which is almost free of cost. Having said that, there are a bunch of these tools available. For my demonstration, what I'm going to do is I've already registered myself on the github.com by providing my username and my password. And I'm going to use a free account. So whatever repositories that I'm going to put up on this server is all public by default. So I've already registered myself by using my username or my email ID and my password. So this set of authentication is also referred to as HTTPS authentication. So in order for me to share my repository with say user2, the first thing that I got to do is have an access to a Git server where both user1 and user2 are set up. So once I have that, I can push my repository onto this server and provide right kind of access so that user2 or the other developer who wishes to collaborate with me on this repository can use his credentials. As long as he's registered properly on the Git server, he can use his credentials and pull down this repository and work with this repository. So this is the HTTPS way of authenticating and sharing repositories. Another popular way of sharing repositories or working with each other is called as SSH authentication. As many of you would know, SSH means nothing but creation of a private and a public key. A bunch of keys, public and private, are created on the client machine. While I create keys, I will be asked for a passphrase. I need to type in a passphrase and remember my passphrase. And then I take this public key and kind of post it onto my account within my Git server, so that whenever I'm going to connect next time using my command prompt or any of the tools, it's going to challenge me for my passphrase. As long as I remember my passphrase correctly, I can authenticate myself and get into the server. So both HTTPS and SSH are popular ways of communicating with the Git server. Having said this, let me just get started by installing the Git Bash on my local system and then fire up some of these Git commands and build up some repositories, make some changes in my repository, commit these changes, and later use my GitHub credential to connect to my GitHub server and push my repositories out there. Let me now go ahead and find my Git Bash for my Windows so that I can go ahead and install it. So I just type in Git client for Windows, open up a browser and type in for this. The first one that I find is a GUI tool. I don't need this GUI client, I need this one. So this is the Git client or the Git Bash that I was referring to. It's about 40 megs, and let me just download this. Pause this video for some time so that the download happens and come back to you once I have the download. The download seems to be complete. When I'm recording this video, the version that I have, the latest version that is there is 2.19.0, and this is a 64-bit version for Windows. So I've got that downloaded. Let me go ahead and find it and install this exe. Alright, I go ahead choosing all the default options. I want it to be installed in C: program files under the Git folder. Everything looks good for me. I'm not going to make any changes here. Git Bash from Windows. Yes, I may want to use Git from Windows command prompt. That sounds good for me. OpenSSH, that's fine. Looks good. Looks good. No, I don't want any of these new features. So what I'm doing is installing the Git Bash or the Git client so that I can start using my Git commands. And the version that I'm using is 2.19.0, which as I record this video, this happens to be the latest version. Alright, so looks good. I don't want to see the release notes. I'll say launch Git Bash. So what I get is this window. So this is the Git command prompt. So let me check if everything is looking good. Say Git version, it sounds good. Say Git help. Alright, a lot of Git help commands. Everything looks good. So I ended up installing the Git Bash. I can go ahead with all other commands. Now that I have Git Bash installed on my system, let me open up a Git Bash prompt and start using it. But before I do anything, I just need to configure it for the first time, stating what would be the username and the email ID with which I want the Git Bash to be configured with. The command to do that is git config --global, which means that this setting that I'm going to set would be a global setting. User.name, and this, the name of the user would need to be specified within a double quote. In my case, I am using a Simplilearn account, which is the official account, and this is the particular username of this account. The other setting is nothing but git config --global. This is also a global setting, and this would be the email ID. The email ID need not contain a double quote. So in my case, this is the email ID that I would be setting up Git to work with. Alright, let me check if the configurations were set correctly or not. Alright, if you see this, the username and the email ID has been picked up the way I wanted it to be picked up. Looks good so far. All right. So what do we do next? By default, whenever you open up the Git prompt, you're placed into your home directory. Let me create a folder here, which would be a repository folder from where I'm going to create all my multiple Git repositories. So I will create a folder called, let's say, git_demo. All right. There's already a folder called git demo. So let me just delete that in the first place. And let me create this git demo again. All right. Let me navigate to this particular folder. So this is the folder. Let me open up that folder using a command prompt. This is my git demo. So this would be a folder. So I would use this folder as a base folder for creating all other repositories as a part of this demo. So let me create my first repository. A repository is nothing but a folder. So let me create my first folder called first repo. And let me get into this repo. All right. As of now, this is just an empty folder. If at all I navigate to this, you would see that this folder is empty. There's nothing much in this folder at all at this moment. Okay. So let me create a repository out of this. How do I create a repository of this? It's pretty simple. I just run a git init command. When I say git init, it means it's going to initialize a repository. As of now, the folder contained nothing in it. It was an empty repository. So it initializes an empty repository in this particular folder. If at all I look at my content, you would see that there's a hidden folder. This would be a hidden folder since I've configured my Explorer to view all hidden folders. I see it, otherwise you wouldn't see it. So a folder by name .git is created within this first repo. And this was created because we ran the command git init. If I get into this folder, I see a bunch of directories and other configurations. If you see, there's something called as a hooks directory, a couple of configuration files that are here in this directory. All these relate to one or the other type of a client hook that can be enabled. And there's info, there's objects, there's references, a bunch of stuff that is there. So what is this folder? This is a magical Git folder. And this is created whenever a repository is initialized. So by default, if at all you get into any Git folder or any Git repository, you would see this .git folder. A word of caution, do not get into this folder and try to modify anything, because if you fiddle around with this and corrupt this particular folder, your whole repository will go for a toss. So let me come out of this and let me show you another thing. Now, if you notice here, when I was in the folder, the repository did not have anything after this. Now, when I say git init, there is something called as a master that shows up. So typically what happens is whenever a Git repository is created for the first time, it creates a default branch. The name of the branch is called master. And that is why you would see master within braces. This doesn't mean anything else other than we have a repository out in this particular folder. And by default, there is a branch called master and we are currently on that branch. If at all I create multiple branches in this folder, whenever I navigate to different branches, the branch name within these brackets would change. All right, so far so good. So we created a folder, we made it a Git repository by initializing that with a git init, and then I've not put anything yet in the repository. So let me try to do that. Let me create a few files within this particular repository. So I use a touch command. Touch is a Linux command. It kind of creates this particular folder. If at all you're not comfortable with the file creation by this way, you can always use a file explorer and create some files in this. So I create a file called touchmaster.txt. I'll open up in the notepad. Okay, so this is my first file. That's what I'm going to write inside this. I save this and I come out of this. All right, now let me do a git status command. So what does this tell you? There's no commit set. You're on the master branch. There is an untracked file and this shows up in red. It also gives you all the commands that is supposed to be run. So if at all you want to add this file, you would say git add and the name of the file, and then you're going to commit it. So what happened is that when the repository was initialized, it was an empty repository. Now that a git notices that there is a new file in this repository called master.txt. If at all you want us to let Git know that you want to track this file, we need to add this to the repository. So the command to add that is called git add, I can specify either the name of the file or I can give a wild character saying git add dot. Now, if I run the git status command again, it says there's no commits yet. Added a file, and the file which was earlier in red now shows up in green, and it says it's a new file, master.txt. Alright, it also gives you something called git remove command if at all you want to unstage or undo your changes. So what has happened is the file which was earlier untracked is been added into the git index, or it is ready for staging, or it's in a staged state. Now I can go ahead and commit this file if at all that's what I want to do. So let me do that. I'll do a git commit -m and I give a message that I want. I would say this is my first git commit. Alright, I run the git status command again and see it says on the branch master nothing to commit. It's all nice and clean. So typically what happened was I created an empty directory, made it into a git folder by doing a git init. I put a file into it. I made some changes to the file. I added that file into the repository and I committed to the repository. If at all I run the git log command, it says this was the commit ID or the commit number or the commit hashtag, and this is the author. If you notice, this is the email ID and the username that we set earlier. And this was done on this date, and this is the commit message that is there. All of it looks so good. Let me do one more commit into this repository. So I will touch master1.txt. I'll put in another file. I'll open up this particular file, write something into this. All right, I save this change. Let me also open up the older file, make some more change into this. All right, so what I did, I modified the older file that existed. I also added a new file to my repository. Now, if I run the git status command, it says modified this file, which is showing in red, and it says you have one more file, which was an untracked file. All right, now let me add both these files because these are the changes that I want to incorporate. I would say git add dot. I run the git status command again, and it says now this is a modified file, this is a new file. Looks good to me. Let me go ahead and commit this. So git commit with a message that says this is my second commit. All right, if I do a git log now, it shows both the commits. The first commit is the one that shows up at the bottom, and the topmost one is the latest commit that is there. So far, so good. If at all you notice, I'm doing all these git commands without really connecting it to any git server. I don't need any network connection for doing any of these things. I can keep on doing more and more git commands and run git commands the way I want to without really having any connections to the git server. Now that I have my changes the way I wanted, and I've checked in all the code changes into my local repository, I may want to share my repository with somebody else and work in a collaborative way. So the way to do that is, as I mentioned earlier, to host this repository or to push this repository onto a Git server. I already have a GitHub account wherein I've registered myself using my username and password. So I log into my GitHub account using my username and credentials, and let me go ahead and create a new repository. My repository is already there on the local system, so what I essentially need is just a placeholder for my repository so that I can link them together and push the content from my local repository to the server. If you notice, the name of my repository is this first repo. So let me copy this. I would create a folder structure or a repository structure on the server with the same name so that when I pushed my repository from my local box, it will go ahead and get created in the server. So the repository name should be the same as what I created on my local box. Description, I would say this is my first GitHub repository on the server. This is just an optional description that will show up. And if you notice, I can't have any private repositories. So whatever repositories that I'm going to create here would be a public repository. So I choose public, and I don't want to initialize this with a README file or anything of that because I already have a repository with some content with some code checked in. All that I need is a placeholder for my repository on the server. So with this option, with just the name and with an optional description and the repository being public, I go ahead and click on the Create Repository button. So if you notice, it gives me a bunch of commands that I would need to run in order to create a repository and push it onto the server. And also, important point, it shows me two URLs. One is the HTTPS URL and the other one is the SSH URL. As of now, we do not have any SSH keys that is set up. So let me use this HTTPS URL to connect my local repository with the repository on the server. So I've done all these things. I already have the repository set up. All that I need is a placeholder for me to connect my local repository with the server URL. So this would be the command that I need to copy, which essentially links or adds an origin with the URL of the Git server. I just copy this command and run it here. Git remote add. The name of the remote is called origin, and it points to an HTTPS URL, which is nothing but the placeholder that I've created on the server. All right, so let me check if it's added correctly. Okay, the URL looks good. I'm all set. I've got 2 commits in my repository. I'm done with all the changes. So let me try to push my repository onto the server. The command for doing it for the first time is git push -u. This is for linking the upstream origin master. So git push -u upstream linking origin master, link the master branch of my local repository with the master branch on the server repository. And where is it going to push? It is going to push by default to an origin, and the origin points to this URL. All right, let me try doing this. So it essentially opens up an URL asking me the credentials with which I need to log into my GitHub server. So let me just copy and paste the username and the password with which I've registered. I would say login. Okay, success. So I'm able to create a repository on the server, and the content seems to be pushed, and it created a new branch called master. It has linked the master branch from the local repository with the master branch on the server. So let me go back to my server and refresh this page and see if all my commits have come in. master1.txt. If at all I see the commits, there seem to be 2 commits. This is my first commit, this is my second commit. And if at all you notice, each of this commit comes with a hash key or a hash ID, which contains the details of my commits. In this commit, the files were added. This was the line that was added. If you look at the second commit, I added these lines. I made this, 1 line chain that was there. I also added this new file, which was not existing. These are the 2 commits that existed. And if you see the timestamp of the commit, this is the commit which was committed 15 minutes ago. So what does this mean is that the commit is the timestamp when we actually committed the code in the client. The pushing is just after we have committed the change, we have pushed it. So there's no timestamp of the push that happened. This completes the first part of the tutorial, wherein I created a repository on the client and then I pushed it to the server after creating a repository skeleton on the server. Now let me demonstrate to you the SSH configuration that is required for creating a pair of SSH keys and ensuring that I connect to the GitHub server using the SSH mechanism. So for doing that, I need to first create a pair of private and public key. The command to do that is ssh keygen -t. I will use the RSA mechanism for creating my keys, capital C, and I need to specify the email ID using which I'm going to connect to, or I need to create the keys for. All right, So generating a private and public key pair, it says, let me know what folder should I create the keys in. So by default, the keys are created in the user home directory under a .ssh folder. So this is pretty good for me. So let me go ahead and say that, that's fine. Enter a passphrase. So let me enter some passphrase. Keep in mind that I would need to remember my passphrase, because when I'm going to authenticate myself using SSH mechanism, it will challenge me for this particular passphrase. I need to enter the right passphrase so that I get authenticated. So the key is generated, and by default it is created in this particular folder. So let me go over to that particular folder. And this is the folder where the keys is generated. You would see a public key and a private key that is created. Let me open up the public key with a notepad and then copy the contents of the whole file. And now I would need to stick it in on the server so that I can get myself authenticated using SSH keys. So I've logged in to GitHub using my credentials and go to my settings. And you would see an SSH and GPG keys. Let me click on that. As of now, there are no SSH key or GPG keys. So I would click on new SSH key and let me paste my public key that I've copied, and I would say add SSH key. It prompts me for my password just to make sure that I've got the right kind of authentication to be adding a new key. So this one looks good. That means the keys were added successfully. Let me check if my SSH keys are working well. So I do SSH -T. I would say git at github.com. This is just to double check if my SSH keys are authenticated correctly. Are you sure you want a connection? Yes. You want to continue? Yes. All right. Now a check for my passphrase. Let me enter my passphrase. I hope I remember it correctly. All right. Pretty good. I've been successfully authenticated. So that means now my SSH keys are good, and just by using my passphrase, I can connect to my GitHub server using SSH. All right. So for the second use case, what I would do is create a repository on the server with some content in it and then clone that repository. Cloning is nothing but making a copy of that repository, linking the origin so that I create an exact replica of the repository which is there on the server on my local drive. So let me first create a repository on the server. I will create a new repository. Let me give a name for my repository and let me kind of initialize that with the README file. I would call this my second repo. Give some description. This is my second repo that is created straight on the Git server, on the GitHub server to be precise. It's a public repository. This time I'm going to choose this option. The reason being that I don't want to create just a skeleton as of now. I want to create a repository with some README file in it. A random README file with no content in it, but then I want a repository to be created on the server. All right, I say create a repository. So a random README file with some content in it gets created, and I can see there are two URLs to this repository, HTTPS and SSH. So this time, let me copy the SSH URL so that I will use this URL to clone this repository on the server, rather from the server to my local box. All right, so let me navigate to my root folder, the folder that I created for making all my repositories, Git repositories. If you see, my first repository is already here. So let me clone my repository, the second repo that I created on the server. The command to do that is git clone the URL of the repository that I want to clone. Oops, looks like I didn't copy the URL correctly. Let me copy that again. Copy this URL. All right. So if you notice, there is no HTTPS to it. I'm just cloning the URL, that is SSH URL of the repository. It asks for my passphrase again. Okay. So I just had first repository earlier. Now I have something called a second repo. This is an exact replica of whatever was the repository content that was created on the server. So if I get into the repository, there's just a simple readme file that is there. Let me try to add a new file out here. I would say notepad, second.txt, some text file I'm going to put in here. Yes, definitely you will not find that file there. This is my second file that I will push onto the server. I'm going to put in some content out there. I'm going to save this. And if I do git status, it says this is a new untracked file. Do you want to add this file onto the repository? Do you want to track this file? Yes, I definitely want to track this file. Let me also commit my change to the file with a message. This is my first commit for the second repo. I give in some particular message. And this time around, since I cloned my repository from a server, the origin is already set for me. I don't really need to add the origin and all that stuff, because what happened in the first case was that I was creating a repository from my local box and then pushing it on the server, which is why I had to set up the upstream branches and stuff like that. In this case, I have cloned an existing repository from the server. So when I clone, I get the replica along with all references to my repository. So I don't need to do anything more other than push the content. I would just say git push. To be on the safer side, I would say origin and master. Ask me for the passphrase. Okay, it pushed the content onto the server. Let me see if the contents have come in here. Okay, wonderful. I had only one commit. Now I see my second commit. So what was added as a part of the second commit? It says a new file was added. All this line that never existed got added. This is the second file, the content exactly what I pushed onto the server. Now this completes the tutorial when I created a repository on the server, cloned it, made some changes to the repository and pushed it to the server using SSH. A quick recap of all the Git commands that we ran till now. Git init is used to initialize a repository. So if at all you're creating a local repository, you can get into any of the folder which is not a Git repository and run this command. Whenever you run this command, a magical folder by name .git gets created in the folder, and from that time onwards, Git will start tracking any changes that happen to that particular folder. It also creates a new repository and a branch. By default, the branch that is created is called the master branch. Git add dot is a wildcard character for adding any number of new files into your Git repository. If you have a bunch of files, 1 file, 2 files, 10 files, a folder containing multiple files in it, all of them could be added into the repository using this command. So once you add any number of files into the repository, you can keep on adding more and more files into the repository. Once you're done with that, you want to commit the changes that has happened in the repository, you use the git commit command. Git commit -m with a meaningful message. This will commit all the work items that you have done in terms of the files that got changed, the files that got added, all this with one particular message. Git status will give you the status of all the files and folders, any file that got added, any file that got created, any file that was deleted, all the status of the files will be obtained using the git status command. Git log will show you all the commit history with the latest history or the latest commit showing up on top. Git add remote origin. This command is used whenever you want to link any local repository to a server. And this is when you want to really push a repository from the local to the server for the first time. Git push -u origin and master. This is the command that you would use whenever you want to push contents from the local repository to the server. Git clone and the URL of the server. This is the command that you would run whenever you have an existing repository on the server and you want to make a fresh clone or a fresh copy of that particular repository onto your local box. More than often, many developers or Git users find themselves in situations where they would want to go back in history and modify or change some of the files that they recently committed or checked into the repository. Now, from a perspective of Git, this is a very simple activity. However, from a perspective of version control tool, you will have to be really cautious about the change that you're going to do. In case the changes are pretty local. None of the developers or none of the other users who are collaborating with you would be affected by this change. You're good to go ahead and make this change. However, if your repository is being pushed to the server and you're trying to modify something from history, this would have a very bad or adverse effect on all the other users who will be using it. You need to be really cautious while running these commands. In case your repository contents are local, you've not pushed your changes to your repository, and if at all you made some changes to the repository, maybe to fix a defect or to include a new feature, and you missed few things, you can go ahead and modify this with some of these commands. Let's say I have this simple repository called undo repo, and if at all I look at the logs of these, I have the commit histories which are like this. I have about 5 commits that is there in my repository, and in C1 I've added a file, in C2 I've added another file, in C3 I've also added some file, in C4 I've made some changes to M1 and M3, and in C5 I've added another file called M4. Now this is my commit history. Now let's say I made these 2 commits, but possibly I want to club them together along with some other changes, because whatever changes I did not really fix things the way I expected it to fix. So there is a git command called git reset. This would allow me to go back in history, to go back to any of the snapshot, get rid of all this commit history or the commit messages, but retain the changes that were made as a part of these commits. So if at all I need to go back in history and go back to this particular commit, and however I just want to get rid of these commits that are there in terms of the commit messages, but I want the changes that were there as a part of these commits to still exist, I would do command called git reset -- soft. Now this would go back or unwind my changes back to this particular snapshot, getting rid of all the commit messages that were there as a part of these 2 commits, but a soft would ensure that the file changes that were done as a part of these 2 commits would still exist or full remain. So the command for that is git reset -- soft, which is the snapshot that I want to get back to. If this is the commit that I want to get back to, I just copy this and I paste this. Alright, it doesn't give me any message, but if at all I do a git log pretty one line, what it says is C1, C2, now the head, which is nothing but the current pointer, which was earlier pointing to C5, it's gone back to C3. Now what happened to the changes that were there as a part of C4 and C5? If at all you do a git status, if you see the changes that were a part of C4 was some changes to M1 and M2, and C5, a new file got M4 got added. If at all I do a git status, you would see those changes still exist. However, from the git history or the git commit history, C3 is the topmost commit that exists as of now. C4 and C5 have been gotten rid of, but the changes that were there still exist. Alright, now I can make some more changes that I want if as a part of my commit, and possibly go ahead and commit this whole thing as a new commit altogether. Maybe I'll open up a notepad and possibly create a new file called m6.txt and say one new file that was missed out. I make this change. I go to a git status. All these files are still there. I would say git add dot. I would say git commit -m C4 rewriting history, and I do a git log pretty. There you go. So C1, C2, C3 still existed, and whatever was a part of C4 and C5, the older ones, I've gotten rid of this. Along with those old changes, I also added a new file. I made some changes and I was able to commit it. Now if you look at my git history, it's all nice and clean. However, do this activity only when you don't push your git repository to the server. One other most powerful and useful command while undoing or resetting the history is something called as revert. This is a safe way of undoing some things. Remember what I talked about when exactly you can do a reset? It's only when your changes are local and is not being pushed to the repository. Take this scenario wherein, let's say I have a Git server and I have the changes which are C1, C2, C3 and possibly C4. Alright, so this is a bunch of commits that has happened. This was the oldest commit and this is the newest commit. And if at all developer 1 is the one who's responsible for pushing these contents in the first place. So he has got C1 to C4 on his history. I'm going to jump all these C2 and C3 and get into C4, and he's pushed all these contents out here. And there are a bunch of people from the server who has pulled this repository, and all of them are at the same level. Now imagine a use case where developer 1 then figures out that by mistake he put in the C3, which was the wrong thing to do, and possibly he could have done a better job of fixing this in a different way. So he wants to get rid of the C3 or C4 or any one of these commits. If he's going to do that and push it to the server, first of all, the Git server would not allow him to go back in history. But assuming that he forcibly pushed something, what would happen to all these people who are looking to work ahead from C4? All of them would be affected in an adverse way. So in short, never go back in history. If at all you need to undo something, go ahead and put in a new commit to undo something. Let's take this example. Maybe if at all a developer 1 wants to get rid of C3, better way to do that is by adding a new commit which is ahead, say let's say C5. And what does this commit do? This commit possibly gets rid of C3. Instead of going back in history, it actually is taking your Git history ahead. But as a part of this commit, you're undoing some part of the work that was done as a part of C3. In short, you're removing a commit, but to remove a commit, you're adding a new commit. And this is why you're doing it, because there are a bunch of other people who are using this repository collaboratively and who are planning to get ahead in terms of history. They cannot afford to go back in history and modify something in history. All right, the command to do this is called the git revert command. So let me take up this repository, which has got a bunch of commits in it. And if at all I do a git log, pretty one line, I have these bunch of commits. In C1, I've added a file. In C2, I've added another file. In C3, I've added one more file. And in C4, I made some changes. And this is the latest commit, and this is the oldest commit. So if at all I see the contents of the Git folder, it contains M1, M2, M3, and M4. And let's say, looking at the previous use case that I mentioned, I may want to get rid of this particular commit. I want to get rid of the C3, which is nothing but I've added a file called m3.txt, but I added it by mistake. I need a better way of fixing it. Possibly I'll look at it later on, but for now, I don't want this particular commit and the changes that were made as a part of that commit to exist. So the better way to do that is using the git revert command. So git revert and the commit ID, whatever I want to revert. So if I want to revert this, I copy this particular commit ID, and bear in mind that considering a reset, revert works on one commit at a time. So I can do one commit revert at a time. I can club a bunch of them together and do one commit, but otherwise the revert always works on one commit at a time. So git revert, paste this. Essentially what I'm trying to do, I'm trying to undo this particular commit. While I'm undoing this commit, what does Git do? It safely adds a new commit, and a part of this new commit, it undoes whatever changes that were done as a part of this commit. So if I say git revert this, all right, I forgot to mention a message, which is why this window is showing up, but that message is good for me. I say write and quit. All right, and if I do a git log, all right, if you see this, C1 still is there in history, and our history is going ahead from C5. I see another commit, but what was there as a part of this commit actually is getting rid of this commit C3. So if at all I see my files here, there's only M1, M2, and M4. M3 was added as a part of C3. Now I've gotten rid of M3 by getting rid of the revert command for C3. So this is a better way of undoing things. Now that we have acquainted ourselves with few of those basic Git commands, let me get into a very interesting topic regarding Git, which is about branching. The topic is interesting because Git deals with branches in a completely different way compared to any other version control tool. In most of the version control tools, whenever you create a new branch, a complete copy or a subset of the whole repository is created, which in my opinion is very cost inefficient because it is a very expensive operation both in terms of time and the disk space. However, in Git, you just create a very lightweight movable pointer whenever you create a branch. There is no folder or no copy of the repository that is created. In short, the branches are very inexpensive in Git. So go ahead and create any number of branches that you need. However, once you create your branches, do all the work relating to that branch in that specific branch. And once you've completed your task, go ahead and merge your branches back into your base branch and then delete the branch. Let me go ahead and create a repository with some branches in this and give you a demonstration of that. So let me go back to my base directory, which is git demo, and then I'm going to create a new folder here. I'll create a folder called org details. Alright, this is my folder here. Alright, I navigate into this folder and let me create a repository here. I initialize a repository and .git folder is created without any files in it. So let me create a few files in it. Say notepad name.txt. Organization name. I create a name.txt within this. Maybe I'll create one more file in this. Notepad employees.txt. Simplilearn has over 3K employees. I just put in some content in this. Save this content. Alright. So if at all I do a git status, I just see two files in it. So let me go ahead and add these two files and let me commit my changes. So git commit -am or -m. First commit. So if I do a git log, I see only one commit and there are two files, and you can see those two files that is here. Alright, so at this stage, let me go ahead and create a new branch. And the command for creating a new branch is git branch name of the branch. So let me name my branch as Bangalore branch, BLR branch. And this created a branch. But I don't see any changes in the folder structure or in the file that exists here. I've just created this branch. So if at all I do a git branch, I see these two branches. And whatever star means I'm currently in this master branch. So let me go ahead and get into the BLR branch. At this moment, the number of files that exist in this repository is same. There's absolutely no change in any of the branches. Both master and BLR branch point to the same snapshot. So let me get into the other branch, and the command to do that is git checkout BLR branch. Now I actually switched into Bangalore branch. If you see the content of the files, there's exactly two files the way it was earlier, because I've created a branch from my base branch, which is the master branch, and when I created a branch, there were two files existing here. If you see the content of these files, they would all be the same. Alright, so let me create a file that is specific to Bangalore branch. So I would just say notepad. Maybe I want to put down the address of this organization specific to Bangalore in this address.txt. So I say notepad address.txt. I'll say Simplilearn Bangalore office. Say located in some address. I would say Bangalore. That is the content of this file. and I'm creating all this new file in this BLR branch. So I would say git add dot, and I would say git commit -m Bangalore branch commit. Alright, if you see this, now I have an address.txt which is there only in the Bangalore branch that I'm presently on. Now let me switch back to my master branch. The command to do that is git checkout master branch. If you remember, when I forked out or when I created a new branch from the master branch, I didn't have this address.txt in it. So let me go back to git checkout master branch and keep noticing this particular. What happened to the address.txt? It kind of disappeared. Now, how did that happen? It's all because of this magical git folder. So what happened is, now git knows that when you are in the master branch, the file that was there in the Bangalore branch, which was called the address.txt, didn't exist. So git is playing around with the file system snapshot. So if I come back, let's say I come back to git checkout Bangalore branch. If you see this, the address.txt file appears. So this particular file is only present in the branch, and git is playing around with the file system snapshot by moving the pointers across and ensuring that whenever I'm switching to Bangalore branch, I see this address.txt. When I go back to my master branch, I don't see this Bangalore branch contents, which is the address.txt. Alright, now that I created this branch, maybe I may need to push this onto the server. So let me go ahead and create a particular repository structure on the server, similar to whatever we did in our previous exercise. So the name of the folder needs to be exactly this one. So let me copy this and let me create a repository very quickly. I'll go here and say new repository. Alright, this is the name of the repository, git branch demo. This is what I'm going to put in as a description. I would say public. I don't want any readme files in it because I already have a repository. I would just say create a repository. Alright, let me use the SSH URL. Yeah, this is the SSH URL. This is good for me. So let me copy this URL. Let me add it here. I'm linking my local repository with the server. And let me come back to my master branch. Let me first push my master branch. So I would say git push -u origin master. It asks for my passphrase. Alright, I pushed my master branch. It looks good. It says new branch master is created. So if I go back to my server and I do a refresh, if you see, it says only one branch, and it says what is the name of the branch, master. If you see the contents, there is employees.txt and name.txt. Now let's try to push the other branch that is there. The command to do that is a little different compared to the way we created it on the client, because on the client we created the branch with a git branch command. Now this branch doesn't exist on the server, and I need to push this new branch onto the server. So the command would be git push -u origin and the name of the branch that I want to specifically push. Alright, now it created a branch out here. Let me do a refresh of this. Alright, it says 2 branches. If I get into this Bangalore branch, I would see the address.txt. If at all I go back into master branch, I would not see this address.txt. Wonderful. Now let me do one thing. Let me try to get the changes from the branch that I created back into the master branch. That is what I would mean by merging. I would want the changes that is there as a part of the Bangalore branch to come back into my master branch. So if I go to git checkout Bangalore branch, I see this address.txt. This is there only as a part of Bangalore branch. Now, assuming that I'm done with the changes from the Bangalore branch, I want to get those changes back into my master. So let me come back to my master branch. And the way to merge in the changes is git merge. So what is it that you want to merge? I want to merge the Bangalore branch changes. And where will it merge? It will merge it into the current branch that I'm on. Presently, I'm in the master branch. So this command would merge the changes from the Bangalore branch into your master branch. So with this, if you'll keep looking here, the content that was there that was added as a part of Bangalore branch, which was nothing but the address.txt, this file should appear as soon as we do a merge. All right, so it happened quickly, and you would see this address.txt that is here. So if you see, let's check the contents in terms of the git log. All right, so there was only one branch that we had earlier, which had only one commit. Right now, we are at this Bangalore branch commit, which was there as a part of the Bangalore branch commit. So with this change, let me push this change onto the server as well. Git push origin master. Okay, those changes were pushed to the server, and now if at all I do a refresh out here, okay, I'm in two branches. The branches is master. Even if I'm in master branch, I should see this address.txt that is there. Even if I'm in the Bangalore branch, the content is all same because we have merged these two branches. Now that I've merged this branch, I don't need this branch anymore. So I would go ahead and delete this locally as well as push it onto the server so that it gets deleted from the server as well. So delete branch locally. The command is git branch -d and the name of the branch. Only thing you need to ensure is that you should not be currently on that branch which you're trying to delete. So I would say git branch, and I'm presently in the master branch, so I can go ahead and delete the other branch. So git branch -d Bangalore branch. All right, this got rid of our Bangalore branch locally. If at all I do a git branch -v, it shows there's only one branch as of now. However, this branch would still exist on the server because server doesn't know anything about the changes that we have done. We need to specifically push our changes onto the server. Okay, there are two branches still here. So let me go ahead and push these changes so that the branch gets deleted from the server as well. The command to do that is git push origin -delete and the name of the branch. All right, so this went ahead and deleted the branch from the server. Let's check that. Okay, if you see now, there's only one branch. These are the basic steps that you would need to know before you work with any of the branches within Git. And as I said before, the branches are very, very inexpensive in Git. Go ahead and create any number of branches that you want, but just ensure that once you create your branch, finish off your task, and once you finish off your task, go ahead and delete the branch. And before you delete the branch, please ensure that you merge in the branches so that you get in or take in the work that was done as a part of that particular branch. To summarize, the Git branching commands are as follows. To create a new branch, you issue a command git branch, the name of the branch, and this would automatically spin off or create a new branch from the existing branch from where you issue this command. If you are on the master branch and if you execute this command git branch new underscore branch, it creates a new underscore branch from the master branch. Once you create a new branch, in order to get into this branch, you would type in git check out the name of the branch. This would automatically switch the file system snapshot between different branches. Now the branches that are created are by default created on the local repository. In case you want to push any specific branch onto the server, you would have to issue a command git push -u origin and the name of the branch. So this will ensure that the contents of the new branch are pushed onto the server. At any time, if you want to list out all existing branches on your local repositories, the command would be git branch -av. Assuming that you did all your work in a new branch and you're happy with the changes, you would want to bring back those changes into the master branch. The command to merge the contents of any new branch into a master branch would be git merge and the name of the branch. And this would automatically merge the branch contents that you specified into the branch on which you currently reside. If at all you're on the master branch, and if you issue a command git merge new underscore branch, this would merge the contents of the new branch onto the master branch. So once you merge the contents of any branch, you would possibly want to go ahead and delete this branch. So the command to delete those branch locally is git branch -D and the name of the branch. This again would delete the branch locally. In order to make this change on the server, which is in order to remove this branch from the server, the command to do that is git push origin -delete and the name of the branch. This would also delete the branch that you created on the server.
Hello, this is Matthew from Simplilearn, and today we're going to deep dive into what Jenkins is and how it improves your DevOps continuous integration environments. So this is what we're going to be covering in this session. We're going to cover what life is like before using Jenkins and the issues that Jenkins specifically addresses. Then we'll get into what Jenkins is about and how it applies to continuous integration and the other continuous integration tools that you need in your DevOps team. Then specifically, we'll deep dive into features of Jenkins and the Jenkins architecture. And we'll give you a case study of a company that's using Jenkins today to actually transform how their IT organization is operating. So let's talk a little bit about life before Jenkins. Let's see this scenario. I think it's something that maybe all of you can relate to. As developers, we all write code and we all submit that code into a code repository, and we all keep working away, writing our unit tests, and hopefully we're running our unit tests. But the problem is that the actual commits that actually get sent to the code repository aren't consistent. You as a developer may be based in India, you may have another developer that's based in the Philippines, and you may have another team lead that's based in the UK, and another development team that's based in North America. So you're all working at different times, and you have different amounts of code going into the code repository. There's issues with the integration, and you're kind of running into a situation that we like to call development hell, where things just aren't working out and there's just lots of delays being added into the project, and the bugs just keep mounting up. The bottom line is the project is delayed. And in the past, what we would have to do is we'd have to wait until the entire software code was built and tested before we could even begin checking for errors. And this just really kind of increased the amount of problems that you'd have in your project. The actual process of delivering software was slow. There was no way that you could actually iterate on your software, and you just ended up with just a big headache with teams pointing fingers at each other and blaming each other. So let's jump into Jenkins and see what Jenkins is and how it can address these problems. So Jenkins is a product that comes out of the concept of continuous integration that you may have heard of as power developers, where you'd have two developers sitting next to each other coding against the same piece of information. What they were able to do is to continuously develop their code and test their code and move on to new sections of code. Jenkins is a product that allows you to expand on that capacity to your entire team. So you're able to submit your codes consistently into a source code environment. So there are two ways in which you can do continuous delivery. One is through nightly builds and one is through continuous. So the approach that you can look at continuous delivery is modifying the legacy approach to building out solutions. So what we used to do is we would wait for nightly builds, and the way that our nightly builds would work and operate is that as code developers, we would all run and have a cutoff time at the end of the day that was consistent around the world, that we would put our codes into a single repository. And at night, all of that code would be run and operated and tested to see if there were any changes, and a new build would be created. And that would be referred to as the nightly build. With continuous integration, we're able to go one step further. We're able to not only commit our changes into our source code, but we can actually do this continuously. There's no need to race and have a team get all of their code in at an arbitrary time. You can actually do a continuous release, because what you're doing is you're putting your tests and your verification services into the build environment. So you're always running cycles to test against your code. This is the power that Jenkins provides in continuous integration. So let's dig deeper into continuous integration. So the concept of continuous integration is that as a developer, you're able to pull from a repository the code that you're working on, and then you'll be able to then at any time submit the code that you're working on into a continuous integration server. And the goal of that continuous integration server is that it actually goes ahead and validates and passes any tests that a tester may have created. Now, if on the continuous integration server a test isn't passed, then that code gets sent back to the developer, and the developer can then make their changes. It allows the developer to actually do a couple of things. It allows the developer not to break the build, and we all don't want to break the builds that are being created, but it also allows the developer not to actually have to run all of the tests locally on their computer. Running tests, particularly if you have a large number of tests, can take up a lot of time. So if you can push that service off to another environment, like a continuous integration server, it really improves the productivity of your developer. What's also good is that if there are any code errors that have come up that may be beyond just the standard CI test, so maybe there's a code, the way that you write your code isn't consistent, those errors can then be passed on easily from the tester back to the developer too. The goal from doing all of this testing is that you're able to release and deploy, and your customer is able to get new code faster, and when they get that code, it simply just works. So let's talk a little bit about some of the tools that you may have in your continuous integration environment. So the cool thing with working with continuous integration tools is that they are all open source, or at least the ones that we have listed here are all open source. There are some that are private, but typically you'll get started with open source tools, and it gives you the opportunity to understand how you can accelerate your environment quickly. So Bamboo is a continuous integration tool that specifically runs multiple builds in parallel for faster compilation. So if you have multiple versions of your software that runs on multiple platforms, this is a tool that really allows you to get that up and running super fast so that your teams can actually test how those different builds would work for different environments. And this has integration with Ant and Maven and other similar tools. So one of the tools you're going to need is a tool that allows you to automate the software build, test, and release process. And BuildBot is that open source product for you. Again, it's an open source tool, so there's no license associated with this. So you can actually go in and you can actually get the environment up and running, and you can then test for and build your environment and create your releases very quickly. So BuildBot's also written in Python, and it does support parallel execution jobs across multiple platforms. If you're working specifically on Java projects that need to be built and tested, then Apache Gump is the tool for you. It makes all of those projects really easy. It makes all the Java projects easier for you to be able to test with API level and functionality level testing. So one of the popular places to actually store code and create a versioning of your code is GitHub, and it's a service that's available on the web, just recently acquired by Microsoft. If you are storing your projects in GitHub, then you'll be able to use Travis Continuous Integration, or Travis CI, and it's a tool designed specifically for hosted GitHub projects. And so finally, we're covering Jenkins, and Jenkins is a central tool for automation for all of your projects. Now, when you're working with Jenkins, sometimes you'll find that there's documentation that refers to a product called Hudson. Hudson is actually the original version of the product that finally became Jenkins, and it was acquired by Oracle. When that acquisition happened, the team behind Hudson was a little concerned about the direction that Oracle may potentially go with Hudson, and so they created a hard fork of Hudson that they renamed Jenkins, and Jenkins has now become that open source project. It is one of the most popular and continuously contributed projects that's available as open source, so you're always getting new features being added to it. It's a tool that really becomes the center for your CI environment. So let's jump into some of those really great features that are available in Jenkins. So Jenkins itself is really comprised of 5 key areas around easy installation, easy configuration, plugins, extensibility, and distribution. So as I mentioned, for the easy installation, Jenkins is a self-contained Java program, and that allows it to run on most popular operating systems, including Windows, Mac OS, and Unix. You can even run it on Linux. It really isn't too bad to set up. It used to be much harder than it is today. The setup process has really improved. The web interface makes it really easy for you to check for any errors. In addition, you have great built-in help. One of the things that makes tools like Jenkins really powerful for developers and continuous integration teams and your DevOps teams as a whole, when you have plugins that you can then add in to extend the base functionality of the product. Jenkins has hundreds of plugins, and you can go and visit the Update Center and see which other plugins that would be good for your DevOps environment. Certainly check it out. There's just lots of stuff out there. In addition to the plugin architecture, Jenkins is also extremely extensible. The opportunity for you to be able to configure Jenkins to fit in your environment is almost endless. Now, it's really important to remember that you are extending Jenkins, not creating a custom version of Jenkins. And that's a great differentiation because the core foundation remains as the core Jenkins product. The extensibility can then be continued with newer releases of Jenkins. So you're always having the latest version of Jenkins and your extensions mature with those core foundation. The distribution and the nature of Jenkins makes it really easy for you to be able to have it available across your entire network. It really will become the center of your CI environment, and it's certainly one of the easier tools and more effective tools for DevOps. So let's jump into the standard Jenkins pipeline. So when you're doing development, you start off and you're coding away on your computer. The first thing you have to do when you're working in the Jenkins pipeline is to actually commit your code. Now, as a developer, this is something that you're already doing, or at least you should be doing. You're committing your code to a Git server or to an SVN server or similar type of service. So in this instance, you'll be using Jenkins as the place for you to commit your code. Jenkins will then create a build of your code, and part of that build process is actually going through and running through tests. And again, as a developer, you're already comfortable with running unit tests and writing those tests to validate your code. But there may be additional tests that Jenkins is running. So for instance, as a team, you may have a standard set of tests for how you actually write out your code so that each team member can understand the code that's been written. And those tests can also be included in the testing process within the Jenkins environment. Assuming everything passes the tests, you can then get everything placed in a stage and release ready environment within Jenkins. And finally, you're getting ready to deploy or deliver your code to a production environment. Jenkins is going to be the tool that helps you with your server environment to be able to deploy your code to the production environment. And the result is that you're able to move from a developer to production code really quickly. This whole process can be automated. Rather than having to wait for people to actually test your codes or going through a nightly build, you're looking at being able to commit your code and go through this testing process and release process continuously. As an example, companies Etsy will release up to 50 different versions of their website every single day. So let's talk about the architecture within Jenkins that allows you to be so effective at applying a continuous delivery DevOps environment. So the server architecture really is broken up into two sections. So on the left-hand side of the section, you have the code the developers are doing and submitting that code to a source code repository. And then from then, Jenkins is your continuous integration server. And it will then pull any code that's been sent to the source code repository and will run tests against it. It will use a build service such as Maven to actually then build the code. And in every single stage that we have that Jenkins manages, there are constant tests. So for instance, if a build fails, that feedback is sent right back to the developers so that they can then change their code so that the build environment can run effectively. The final stage is to actually execute specific test scripts. And these test scripts can be written in Selenium. So it's probably good to mention here that both Maven and Selenium are plugins that run in the Jenkins environment. So before we were talking about how Jenkins can be extended with plugins, Maven and Selenium are just two very popular examples of how you can extend the Jenkins environment. The goal to go through this whole process, again, it's an automated process, is to get your code from the developer to the production server as quickly as possible, have it fully tested, and have no errors. So it's probably important at this point to mention one piece of information around the Jenkins environment, that if you have different code builds that need to be managed and distributed, this will require that you need to have multiple builds being managed. Jenkins itself doesn't allow for multiple files and builds to be executed on a single server. You need to have a multiple server environment with running different versions of Jenkins for that to be able to happen. So let's talk a little bit about the master-slave architecture within Jenkins. So what we have here is an overview of the master-slave architecture within Jenkins. On the left-hand side is the remote source code repository, and that remote source code repository could be GitHub, or it could be Team Foundation Services, or the new Azure DevOps code repository, or it could be your own Git repository. The Jenkins server acts as the master environment on the left-hand side, and that master environment can then push out to multiple other Jenkins slave environments to distribute the workload. So it allows you to run multiple builds and tests and production environments simultaneously across your entire architecture. So Jenkins slaves can be running the different build versions of the code for different operating systems, and the server master is controlling how each of those builds operate. So let's step into a quick story of a company that has used Jenkins very successfully. So here's a use case scenario. Over the last 10 or 15 years, there has been a significant shift within the automotive industry where manufacturers have shifted from creating complex hardware to actually creating software. We've seen that with companies such as Tesla, where they are creating software to manage their cars. We see the same thing with companies such as General Motors with their OnStar program. And Ford just recently have rebranded themselves as a technology company rather than just an automotive company. What this means, though, is that the software within these cars is becoming more complex and requires more testing to allow more capabilities and enhancements to be added to the core software. So Bosch is a company that specifically ran into this problem, and their challenge was that they wanted to be able to streamline the increasingly complex automotive software by adopting continuous integration and continuous delivery best practices, with the goal of being able to delight and exceed the customer expectations of the end user. So Bosch has actually used CloudBees, which is the enterprise Jenkins environment. So to be able to reduce the number of manual steps such as building, deploying, and testing, Bosch has introduced the use of CloudBees from Jenkins, and this is part of the enterprise Jenkins platform. It has significantly helped improve the efficiencies throughout the whole software development cycle, from automation, stability, and transparency, because Jenkins becomes a self-auditing environment. Now, the results have been tangible. Previously, it took 3 days before a build process could be done, and now it's taken that same 3-day process and reduced it to less than 3 hours. That is significant. Large-scale deployments are now kept on track and have expert support, and there is clear visibility and transparency across the whole operations through using the Jenkins tools.
Hello and welcome to Continuous Integration tutorial using Jenkins. My name is Chidanand and I am with the Simplilearn team. Today, let's get started with Jenkins. Jenkins, in my opinion, is one of the most popular continuous integration servers of recent times. What began as a hobby project by a developer working for Sun Microsystems way back in early or mid 2000s has gradually and eventually evolved into very powerful and robust automation servers. It has a wide adoption since it is released under MIT license and is almost free to use. Jenkins has a vast developer community that supports it by writing all kinds of plugins. Plugins is the heart and soul of Jenkins, because using plugins, one can connect Jenkins to anything and everything under the sun. With that introduction, let's get into what all will be covered as a part of this tutorial. I will get into some of the prerequisites required for installing Jenkins, post which I will go ahead and install Jenkins on a Windows box. There are a few first-time configurations that needs to be done, and I will be covering those as well. So once I have Jenkins installed and configured properly, I will get into the user administrative part. I'll create few users and I will use some plugins for setting up various kinds of access permissions for these users. I will also put in some freestyle jobs. Freestyle job is nothing but a very simple job, and I will also show you the powerfulness of Jenkins by scheduling this particular job to run based upon a time schedule. I will also connect Jenkins with GitHub. GitHub is our source code repository where I've got some repositories put up there. So using Jenkins, I will connect to GitHub, pull up a repository that is existing on GitHub onto the Jenkins box and run few commands to build this particular repository that is pulled from GitHub. Sending out emails is a very important configurations of Jenkins or any other continuous integration server for that matter. Whenever there is any notifications that has to be sent out as a part of either a build going bad or build being good or build being propagated to some environment, and all these scenarios, you would need the continuous integration servers to be sending out notifications. So I will get into a little bit details of how to configure Jenkins for sending out emails. I will also get into a scenario where I would have a web application, a Maven based Java web application, which will be pulled from a GitHub repository, and I will deploy it onto a Tomcat server. The Tomcat server will be locally running on my system. Eventually, I will get into one other very important topic, which is the master slave configuration. It's a very important and pretty interesting topic where distributed builds is achieved using a master slave configuration. So I will bring up a slave, I will connect the slave with the master, and I will also put in a job and kind of delegate that particular job to the slave configuration. Finally, I will let you know how to use some plugins to back up your Jenkins. So Jenkins has got a lot of useful information set up on it in terms of the build environments, in terms of workspace. All this can be very easily backed up using a plugin. So this is what I'm going to be covering as a part of this tutorial. Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. I have listed popular 3 mechanisms in which Jenkins is usually installed on any system. The topmost one is as a Windows or a Linux based services. So if at all you have Windows like the way I have, and I'm going to use this mechanism for this demo. So I would download a MSI installer that is specific to Jenkins and install this service. So whenever I install it as a service, it goes ahead and nicely installs all that is required for my Jenkins. And I have a service that can be started or stopped based upon my need. Any flavor of Linux as well. One other way of running Jenkins is downloading this generic WAR file, and as long as you have JDK installed, you can launch this WAR file by the command, opening up a command prompt or shell prompt if at all you're on Linux box, specifying java-jar and the name of this WAR file. It typically brings up your web application, and you can continue with your installation. The only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt. You either do a Control-C and then bring down this prompt, and your Jenkins server would be down. Other older versions of Jenkins were run popularly using this way, in which you already have a Java-based web server up and running. So you kind of drop in this WAR file into the root folder or the HTTPD root folder of your web server. So Jenkins would explode and kind of bring up your application. All user credentials or user administration is all taken care of by the Apache or the Tomcat server or the web server on which Jenkins is running. This was a very older way of running, but still some people use it because if they don't want to maintain 2 servers, if they already have a Java web server which it's being nicely maintained and backed up, Jenkins can run attached to it. Alright, so either ways, it doesn't matter however you're going to bring up your Jenkins instance. The way we're going to operate Jenkins is all going to be very same or similar one, with the subtle changes in terms of user administration if at all you're launching it through any other web server which will take care of the user administration. Otherwise, all the commands or all the configuration or the way in which I'm going to run this demo, it is going to be same across any of these installations. Alright, so the prerequisites for running Jenkins, as I mentioned earlier, Jenkins is nothing but a simple web application that's written in Java. So all that it needs is Java, preferably JDK 1.7 or 1.8. 2 GB RAM is the recommended RAM for running Jenkins. And also, like any other open source toolsets, when you install JDK, ensure that you set in the environment variable Java home to point to the right directory. This is something very specific to JDK, but for any other open source tools that you install, there is always a preferred environment variable that you got to set in, which is specific to that particular tool that you're going to use. This is a generic thing that is there for, for any other open source projects, because the way open source projects discover themselves is using these environment variables. So as a general practice or a good practice, always set these environment variables accordingly. So I already have JDK 1.8 installed on my system, but in case you do not, what I would recommend is just navigate on your browser to the Oracle homepage and just type in or search for install JDK 1.8 and navigate to the Oracle homepage. You'll have to accept the license agreement, and there are a bunch of installers that you can pick up based upon the operating system on which you're running. So I have this Windows 64 installer that is already installed and running on my system. So I will not get into the details of downloading this or installing it. Let me show you once I install this, what I've done with regard to my path. So if you get into those environment variables, all right, so I've just set in a Java home variable. If you see this, C:\program files Java JDK 1.8. This is where my Java is located. C program files Java. Okay, so this is the home directory of my JDK. So that is what I've set it up here in my environment variable. So if you see here, this is my Java home. All right, one other thing to do is ensure that in case you want to run Java or JavaC from a command prompt, ensure that you also add that path into this path variable. So if you see this, somewhere I will see, yes, there you go. C:\program files Java JDK 1.8 bin. So with these two, I'll ensure that my Java installation is nice and good enough. So to check that, to double check that, or to verify that, let me just open up a simple command prompt. And if I type in Java -version, all right, and Java C -version. So the compiler is on the path, Java is on the path, and if at all I do this, even the environment variable specific to my Java is installed correctly. So I'm good to go ahead with my Jenkins installation. Now that I have my prerequisites all set for installing Jenkins, let me just go ahead and download Jenkins. So let me open up a browser and say download Jenkins. All right. LTS is nothing but the long-term support. These are all stable versions. Weeklies, I would not recommend that you try these unless until you have a real need for that. Long-term support is good enough. And as I mentioned, there are so many flavors of Jenkins that is available for download. You also have a Docker container wherein you can launch Jenkins as a container, but I'll not get into details of that in this tutorial. All right, so what I want is, yes, this is the WAR file, which is a generic WAR file that I was talking to you earlier, and this is the Windows MSI installer. So go ahead and download this MSI installer. I already have that downloaded, so let me just open that up. All right, so this is my downloaded Jenkins instance, or rather installer. This is a pretty, maybe a few months old, but this is good enough for me. Before you start Jenkins installation, just be aware of one fact that there is a variable called Jenkins Home. This is where Jenkins would store all this configuration data, jobs, project workspace, and all that specific to Jenkins. So by default, if at all you don't set this to any particular directory, if at all you install an MSI installer, all your installation gets into C:\program files 86 and Jenkins folder. If at all you run a WAR file, depending upon the user ID with which you're running your WAR file, the Jenkins folder, there's a .jenkins folder that gets created inside the user home directory. So in case you have any need wherein you want to back up your Jenkins or you want Jenkins installations to get into some specific directories, go ahead and set this Jenkins home variable accordingly before you even begin your installation. For now, I don't need to do any of these things, so I've already downloaded the installer. Let me just go ahead with the default installation. All right, so this is my Jenkins MSI installer. I don't want to make any changes into the Jenkins configuration. C:\program files is good for me. Yeah, this is where all my destination folder and all the configuration specific to it goes. I'm happy with this. I don't want to change this. I would just say go ahead and click installation. Okay, so what typically happens once the Jenkins installation gets through is it'll start installing itself, and there are some small checks that needs to be done. So, and by default, Jenkins launches on the port 8080. So let me just open up localhost 8080. There's a small checking that will be done as a part of the installation process, wherein I need to type in a hash key. All right, so there's a very, very simple hash key that gets stored out here. So I'll have to just copy this path. If at all you're running as a war file, you would see that in your logs. All right, so this is a simple hash key that gets created every time when you do a Jenkins installation. So as a part of the installation, it just asks you to do this. So if that is not correct, it will crib about it, but this looks good. So it's going ahead. All right, one important part during the installation. So you would need to install some recommended plugins. What happens is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugin and it's got a dependency which is not installed, and you get into all those issues. In order to get rid of that, what Jenkins recommends, there's a bunch of plugins that is already recommended. So just go ahead and blindly click that install recommended plugin. So if you see, there is a whole lot of plugins which are bare essential plugins that is required for Jenkins in order to run properly. So Jenkins, as a part of the installation, would get all these plugins and then install it for you. This is a good combination to kind of begin with. And mind you, at this moment, Jenkins needs lots of bandwidth in terms of network. So in case your network is not so good, few of these plugins would kind of fail. And these plugins are all available on openly or mirrored sites, and sometimes some of them may be down. So do not worry in case some of these plugins kind of fail to install. You'd get an option to kind of retry installing them, but just ensure that at least most or 90-95% of all these plugins are installed without any problems. Let me pause the video here for a minute and then get back once all these plugins are installed. My plugin installation is all good. There was no failures in any of my plugins. So after that, I get to create this first admin user. Again, this is one important point that you got to remember. Give in any username and password, but ensure that you kind of remember that, because it's very hard to get back your username and password in case you forget it. All right, so I'm going to create a very, very simple username and password, something that I can remember. That's my name, and an email ID is kind of optional, but it doesn't allow me to go ahead in case I don't. So I just give in an admin and I got a password. I remember my password. This is my full name. All right, I say save and finish. All right, that kind of completed my Jenkins installation. It was not that tough, was it? Now that I have my Jenkins installed correctly, let me quickly walk you through some bare minimal configurations that is required. These are kind of a first time configuration that is required. So, and also let me warn you, the UI is little hard for many people to wrap their head around it, specifically the Windows guys. But if at all you're a Java guy, you know how painful it is to write UI in Java, you will kind of appreciate, all the effort that has gone into the UI. Bottom line, UI is little hard to, wrap your head around it, but once you start using it, possibly you'll start liking it. All right, so let me get into something called as Manage Jenkins. This can be viewed like a main menu for all the Jenkins configuration. So I'll get into some of those important ones. Something called as Configure System. Configure System, this is where you kind of put in the configuration for your complete Jenkins instance. Few things to kind of look out for. This is a home directory. This is a Java home where all the configurations, all the workspace, anything and everything regarding Jenkins is stored out here. System message, you want to put in some message on the system, you just type in whatever you want and it's possibly show up somewhere up here on the menu. Number of executors, very, very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. You can kind of visualize it like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, number of executors 2 should be good enough. In case at any point in time, if there are multiple jobs that kind of get triggered at the same time, in case the number of executors are less compared to the number of jobs that have woken up, no need to panic, because they will all get queued up and eventually Jenkins will get to running those jobs. Just bear in mind that whenever a new job kind of gets triggered, the CPU usage and the memory usage in terms of the disk write is very high on the Jenkins instance. So that's something that you got to kind of keep in mind. All right, but number of executors, 2 for my system is kind of good. Label for my Jenkins, I don't want any of these things. Usage, how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this node as much as possible. Quiet period. Each of these options have got some bare minimal help kind of a thing that is out here. By clicking on these question marks, you will get to know as to what are these particular configurations. All right, so this all look good. What I want to show you here is there's something regarding the Docker, timestamps, Git plugin, SVN, email notifications. I don't want that. What I want I want this SMTP server configuration. Remember, I mentioned earlier that I would want Jenkins to be sending out some emails. And what I've done here is I've just configured the SMTP details of my personal email ID. In case you're in an organization, you would have some sort of an email IDs that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of send out emails. But in case you want to try it out like me, I have configured my personal email ID, which is on my Gmail, for sending out notifications. So the SMTP server would be smtp.gmail.com. I'm using the SMTP authentication. I've provided my email ID and my password. I'm using the SMTP port, which is 465, and I'm reply to address is the same as mine. I can just send out an email and see if at all this configuration works. Again, Gmail would not allow anybody to send out notifications on your behalf. So you'll have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notifications on your behalf. So I've done already that. I'm just trying to see if I can send a test email with the configurations that I've set in. Yes. All right. So the email configuration looks good. So this is how you configure your your Gmail account in case you want to do that. If not, put in your organization SMTP server details, which are with a valid username and password, and it should all be set. All right, so no other configurations that I'm going to change here. All of these look good. All right, so I come back to manage Jenkins. Okay, one other thing that I want to kind of go over is the global tool configuration. Imagine this scenario, or look at it this way. Jenkins is a continuous integration server. It doesn't know what kind of a code base it's going to pull in, what kind of a tool set that is required, or what is the code that it's going to pull in and how is it going to build. So you would have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in from your source code repositories. So just to give an example, in case your source code is a Java source code, and assuming that because in this demo, this is my laptop and I've put in all the configurations, JDK, everything on my laptop because I'm a developer, I'm working on the laptop. But my continuous integration server would be a separate server without anything being installed on it. So in case I want Jenkins to run a Java code, I would need to install JDK on it. I need to specify the JDK location of this out here this way. Okay, since I already have the JDK installed and I've already put in the Java home directory, or rather the environment variable correctly, I don't need to do it. Git, if at all I want the Jenkins server to use Git, Git is a command bash or the command prompt for running Git and connecting to any other Git server. So you would need Git to be installed on that particular system and set the path accordingly. Gradle and Maven, if at all you have some Mavens as well, you want to do this. Any other tool that you're going to install on your system, which is your continuous integration server, you will have to come in here and configure something. In case you don't configure it, when Jenkins runs, it will not be able to find these tools for building your task and it'll crib about it. That's good. I don't want to save anything. Manage Jenkins. Let me see what else is required. Yes, configure global security. All right, the security is enabled. And if you see by default, it's the security access control is set to Jenkins own user database. So what does this mean? Jenkins by default, it uses file system where it stores all the usernames, which hashes up these usernames and kind of stores them. So as of now, Jenkins is configured to use its own database. Assuming that you are running in an organization, you would probably want to have some sort of an AD or an LDAP server using which you would want to control access to your Jenkins repository, rather Jenkins tool. So you would specify your LDAP server details, the root DN, password or the manager DN and the manager password and all these details in case you want to connect your Jenkins instance with your LDAP or AD or any of the authentication servers that you have in your organization. But for now, since I don't have any of these things, I'm going to use this own database. That's good enough. All right. So I will set up some authorization methods and stuff like that once I put in few jobs. So for now, let me not get into any of these details of this. Just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own servers, which is happening as of now. So I'm going to save all this stuff. That's good for me. So enough of all these configurations. Let me put in a very, very simple job. All right. So job, new item, little difficult to kind of figure out, but then that's the new item. So I'll just say, first job, this is good for me. I just give a name for my job. I would say it's a freestyle project. That's good enough for me. I don't want to choose any of that. So unless until you choose any of this particular button would not become active. So choose the freestyle project and say, okay. At a very high level, you would see general, source code management, build triggers, build environment, build and post build. In case you install more and more plugins, you will see a lot more options. But for now, this is what you would see. So what am I doing? At the moment, I'm just putting up a very, very simple job. And the job could be anything and everything. So I don't want to put in a very complicated job for now. For the demo purpose, let me just put in a very, very simple job. I'll give a description. This is an optional thing. This is my first Jenkins job. All right. I don't want to choose any of these. Again, there are some helps available here. I don't want to choose any of this. I don't want to connect it into any source code for now. I don't want any triggers for now. I'll come back to this in a while. Build environment. I don't want any build environment. As a part of this build step, I just want to, run few things so that I kind of complete this particular job. So since I'm on a Windows box, I would say execute Windows batch command. All right. So what do you want to do? Let me just echo something. Echo. Hello. This is my first Jenkins job, and possibly I would want the date and the timestamp pertaining to the job. I mean, the date and time in which this job was run. All right. Very, very simple command that says, this is my first job. It just puts out something along with the date and the time. All right. I don't want to do anything else. I want to keep this job as simple as this. So let me save this job. All right. So once I save this job, the job names comes up here, and then I need to build this job. And you would see some build history out here. Nothing is there as of now because I've just put in a job. I've not run it yet. All right. So let me try to build it now. You see a build number, you would see a date and a timestamp. So if I click on this, you would see a console output. If I go here, okay, as simple as that. And where is all the job details that is getting into? If you see this, if I navigate to this particular directory, all right, so this is the directory what I was mentioning earlier regarding Jenkins home. So all the job related stuff that is specific to this particular Jenkins installation is all here. All the plugins that is installed, the details of each of those plugins can be found here. All right, so the workspace is where all the jobs that I've created, whichever I'm running, there will be individual folders specific to the jobs that has been put up here. All right, so one job, one quick run. That's what it looks like. Pretty simple. Okay, let me do one thing. Let me put up a second job. I would say second job. I would say freestyle project. All right, this is my second job. I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put up on Jenkins, which will be triggered automatically. Remember what I said earlier about Jenkins, because at the core of Jenkins is a very, very powerful automation server. All right, so what I'm going to do, I will just keep everything else the same I'm going to put in a build script pretty much similar to second job that gets triggered automatically every minute. All right, let me do that. Percentage date, and I'll put in the time. All right. So I just put in another job called second job, and it pretty much does the same thing as what I was doing earlier in terms of printing the date and the time. But this time I'm just going to demonstrate the powerfulness of the automation server that is there. If you see here, there's a build trigger. So a build can be triggered using various triggers that is there. So we'll get into this GitHub triggering or hook or a webhook kind of a triggering later on. But for now, what I want to do, I want to ensure that this job that I'm going to put in would be automatically triggered on its own. Let's say every minute, I want this job to be run on its own. So build periodically is my setting. If you see here, there's a bunch of help that is available for me. So for those of you who have written cron jobs on Linux boxes, you'll find it very, very simple. But for others, don't panic. Let me just put up a very, very simple regular expression for scheduling this job every minute. All right, so that's 1, 2, 3, 4, 5. All right, come up, come up, come up. All right, so 5 stars is all that I'm going to put in. And Jenkins got a little worried and he's asking me, do you really mean every minute? Oh yeah, I want to do this every minute. Let me save this. And how do I check whether it gets triggered every minute or not? I just don't do anything. I'll just wait for a minute. And if at all everything goes well, Jenkins would automatically trigger my second job in a minute's time from now. This time around, I'm not going to trigger anything. Look, there you see. It's automatically got triggered. If I go in here, yep, second job that gets triggered automatically. It was triggered at 1642, which is 4:42 my time. That looks good. And if everything goes well, every 1 minute onwards, this job would be automatically triggered. Now that I have my Jenkins up and running, a few jobs that has been put up here on my Jenkins instance, I would need a way of controlling access to my Jenkins server. This is wherein I would use a plugin called role-based access plugin and create few rules. The rules are something like a global role and a project role, project specific role. I can have different roles and I can have users who have signed up or the users whom I create kind of assigned to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwarranted. All right, so first things first, let me go ahead and install a plugin for doing that. So I get into manage Jenkins and manage plugin. A little bit of a confusing screen in my opinion. There is updates available, installed and advanced. As of now, we don't have the role-based plugin. So let me go to available. It'll take some time for it to get refreshed. All right, now these are the available plugins. These are the installed plugins. All right, so let me come back to available and I would want to search for my role-based access plugin. So I would just search for role and hit enter. Okay, role-based authorization strategy enables user authorization using a role-based strategy. Roles can be defined globally or for particular jobs or nodes and stuff like that. So exactly, this is the plugin that I want. I would want to install it without a restart. All right, looks good so far. Yes. Go back to the top of the page. Yes. Remember, Jenkins is running on a Java using a Java instance. So typically many things would work the same way unless and until you want to restart Jenkins once in a while. But as a good practice, whenever you do some sort of a big installations or big patches on your Jenkins instance, just ensure that you kind of restart it. Otherwise, there would be a difference in terms of what is installed on the system and what is there on the file system. You would need to flush out few of those settings later on. But for now, these are all very small plugins, so these would run without any problems. But otherwise, if at all there are some plugins which would need a restart, kindly go ahead and restart your Jenkins instance. But for now, I don't need that. It looks good. I've installed the plugin. So where do I see my plugin? I installed the plugin that is specific to the user control or the access control. So Let me go into, yes, global security, and I would see this role-based strategy showing up now. All right, so this comes in because of my installation of my role-based plugin. So this is what I would want to enable, because I already have my own database set up. And for the authorization part, in the sense that who can do what, I'm going to install. I mean, I've already installed a role-based strategy plugin, and I'm going to enable that strategy. All right, I would say save. Okay, now I've installed the role-based access plugin. I would need to just set it up and check that, I would go ahead and create some roles and ensure that I assign users as per these roles. All right, so let me go to manage Jenkins, configure. All right, let me see, where is this? Configure global security. Is that where I create my roles? Nope, not here. Yes, manage and assign roles. Okay, again, you would see these options only after you install these plugins. So for now, I've just enabled the plugin. I've enabled role-based access control, and I would go ahead and create some roles for this particular Jenkins instance. So I would say first, manage roles. So I would need to create some roles here, and the roles are at a very high level. These are global roles, and there are some project roles, and there are some slave roles. I'll not get into details of all of these. At a very, very high level, which is a global role, let me just create a role. A role can be kind of visualized like a group. So I would create a role called developer. Typically, the Jenkins instance or the CA instance are kind of owned up or controlled by QA guys. So QA guys would need to provide some sort of limited access to developers. So that's why I'm creating a role called developer, and I'm adding this role at a global role level. So I would say add this here, and you would see this developer role that is there. And each of these options, if you hover over it, you would see some sort of a help on what are these permissions specific to. So what I want is, like, it sounds a little different, but I would want to give very, very little permissions for the developer. So from an administration perspective, I would just want him to have a read kind of a role. Credentials, again, I would just want a view kind of a role. I don't want him to create any agents and all that stuff. That looks good for me. For a job, I would want him to just possibly read. I don't want him to build. I don't want him to cancel any jobs. I don't want him to configure any job. I don't even want him to create any job. I would just want him to read few things. I would not give him possibly a role to the workspace as well. I mean, I don't want him to have access to the workspace. I would just want him to read a job or check, have read-only access to the job. Run. No, I don't want him to give him any particular access which will allow him to run any jobs. View, configure, yeah, possibly create, yeah, delete. I don't want read, yes, definitely. And this is the specific role. So what I'm doing, I'm just creating a global role called developer, and I'm giving him very, very limited roles, in the sense that I don't want this developer to be able to run any agents, nor create jobs, or build jobs, or cancel jobs, or configure jobs. At the max, I would just want him to read a job that is already put up there. Okay, so I would save. Now I've created a role. I still don't have any users that is there on the system. So let me go ahead and create some user on the system. That's not here. I would say configure, manage Jenkins, manage users. Okay, let me create a new user. I would call this user as, yeah, developer one sounds good. Some password that I can remember. Okay, his name is developer1 d@d.com or something like that. Okay, so this is the admin with which I kind of configured or brought up the system, and developer1 is a user that I have configured. So still have not set any roles for this particular user yet. So I would go to manage Jenkins. I would say manage and assign roles. I would say assign roles. Okay, so if you see, what I'm going to do now is assign a role that is specific to that particular developer. I will find the particular user and assign him the developer role that I have already configured. the role shows up here, I would need to find my user, whoever created, and then assign him to that particular role. So if you remember, the user that I created was developer 1. I would add this particular user, and now this particular user, what kind of a role I want him to have, because this is the global role that I had created. So developer, I would assign this developer 1 to this particular global role, and I would go ahead and save my changes. Now let me check the permissions of this particular user by logging out of my admin account and logging back as developer 1. If you remember, this role was created with very less privileges. So there you go. I have Jenkins, but I don't see a new item. I can't trigger a new job. I can't do anything. I see these jobs. However, I don't think so I'll be able to start this job. I don't have the permission set for that. The maximum I can do is look at the job, see what was there as a part of the console output and stuff like that. So this is a limited role that was created, and I added this developer to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs, because the Jenkins instance is owned by a QA person. He doesn't want to give developer any administrative rights. So the rights that he set out by creating a developer role, and anybody who is tagged, any user who is tagged as a part of this developer role would get the same kind of permissions. And these permissions can be, fine grained. It can be a project specific permissions as well. But for now, I just demonstrated the high level permission that I had set in. Let me quickly log out of this user and get back as the admin user, because I need to continue with my demo. With the developer role that was created, I have very, very less privileges. One of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins that is provided by users or community users who don't charge any money for these plugins, but it's got plugins for connecting anything and everything. So if you can navigate to, or if you can find Jenkins plugins, you would see index of over so many plugins that is there. All of these are wonderful plugins. Whatever connectors that you would need, if you want to connect Jenkins to an AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you would have a plugin. You can go and search up. If I want to connect Jenkins to Bitbucket, Bitbucket is one of the Git servers. There's so many plugins that is available. Okay, so bottom line, Jenkins without plugins is nothing. So plugins is the heart of Jenkins. For you to connect, or in order to connect Jenkins with any of the containers or any of the other tool sets, you would need the plugins. If you want to connect, or you want to build a repository which has got Java and Maven, you would need to install Maven and JDK on your Jenkins instance. If at all you're looking for a .NET build or a Microsoft build, you would need to have MS Build installed on your Jenkins instance, and the plugins that will trigger MS Build. If at all you want to listen to some server-side webhooks from GitHub, you would need GitHub specific plugins. If you want to connect Jenkins to AWS, you need those plugins. If you want to connect to a Docker instance that is running anywhere in the world, as long as you have the URL which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. SonarQube is one of the popular static code analyzers. So you can connect a Jenkins build, you can build a job on Jenkins and push it to SonarQube, and get SonarQube to run analysis on that and get back the results in Jenkins. All of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to GitHub. I already have a very, very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. All right. So this is my very, very simple, repository that is there called Hello Java. And this is what is there in the repository. There is a hello.java application that is here, or a simple class file that is there. It's got just one line of system.out. So this is already present on github.com at this place, and this would be the URL for this repository. If I pick up the HTTPS URL, this is my HTTPS URL. So what I would do is I would connect my Jenkins instance to go to GitHub, provide my credentials, and pull out this repository which is on the cloud hosted github.com, and get it to my Jenkins instance, and then build this particular Java file. I'm keeping the source code very, very simple. It's just a Java file. How do I build my Java file? How do I compile my Java file? I just say Java C and the name of my class file, which is hello.java. And how do I run my Java file? I would say Java and hello. Okay, so remember, I don't need to install any plugins now because what it needs is a Git plugin. So if you remember, when we were doing the installation, there was a bunch of recommended plugins. So Git is already installed on my system, so I don't need to install it again. So let me put up a new job here. It says Git job. Let it be a freestyle project. That's good for me. I would say okay. All right, so the source code management. Remember in the earlier examples, we did not use any source code because we were just putting up some echo kind of jobs. We did not need any integration with any of the source code systems. So now let me connect this. So I'm going to put up a source code and Git would show up because the plugin is already there. SVN, Perforce, any of those additional source code management tools, if at all you would need, just install those plugins and Jenkins connects wonderfully well to all these particular source control tools. Okay, so I would copy the HTTPS URL from here. I would say this is the URL that I'm supposed to go and grab my source code from. But all right, that sounds good. But what is the username and password? So I'll have to specify a username and password. All right, so I would say the username, this is my username, and this is my HTTPS credential for my job. Okay, so this is my username and this is my password. I just save this. I say add, and then I would say, use these credentials to go to GitHub and then on my behalf, pull out a repository. All right. If at all at this stage, if there's any error in terms of Jenkins not able to find Git or the git.exe, or if my credentials are wrong, somewhere down here, you would see a red message saying that, something is not right. You can just go ahead and kind of fix that. For now, this looks good for me. I'm going to grab this URL. What am I going to do? This step would pull the source code from the GitHub. And then what would be there as a part of my build step? Because this repository just has a Java file, correct? Hello.java. So in order for me to build this, I would just say execute Windows batch command, and I would say Java C hello.java. That is the way I would build my Java code. And if I have to run it, I would just say Java hello. Pretty simple, 2 steps, and this would run after the repository contents are fetched from GitHub. So Java C, Java, that sounds good. I would say save this and let me try to run this. Okay, if you see, there's a lot of, it executes Git on your behalf. It goes out here, it provides my credentials and says, it pulls all my repository, and by default, it will pull up the master branch that is there on my repository. And it kind of builds this whole thing, Java C hello.java, and it runs this project Java hello. And there you see, this is the output that is there. And if at all you want to look at the contents of the repository, if you can go here, this is my workspace of my system. Hang on, this is not right. Okay, Git job. If you see here, this is my hello.java. This is the same program that was there on my GitHub repository. Okay, so this is a program that was there on my GitHub repository. All right, so this was the same program that was here, and Jenkins on our behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to my local system on my Jenkins instance. It compiled it and it ran this particular application. Okay, now that I've integrated Jenkins successfully with GitHub for a simple Java application, let me build a little bit on top of it. What I will do is I have a Maven based web application that is up there as a repository in my GitHub. So this is the repository that I'm talking about. It's called MVN web app. It's a Maven based repository. As you would know, Maven is a very, very simple Java based build tool that will allow you to run various targets, and it'll compile. It will, based upon the goals that you specify, it can compile, it can run some tests, and it can build a war file and even deploy it into some other server. For now, what we're going to use Maven is just for building and creating a package out of this particular web application. It contains a bunch of things, and what is important is just the index.jsp. It just contains an HTML file that is there as a part of this web application. So from a perspective of requirements, now since I'm going to connect Jenkins with this particular repository, Git, we already have that set. We only need 2 other things. One is Maven, because Jenkins will use Maven. So in order to use Maven, Jenkins would have to have a Maven installation that is there on the Jenkins box. And in this case, the Jenkins box is this laptop. And after I have my Maven installed, I also need a Tomcat server. Tomcat is a very simple web server that you can freely download. I'll let you know how to quickly download and install the Tomcat. All right, so download Maven first. There are various ways in which you can kind of download this Maven. There is zip files, binary zip files, and archive files. So what I've done is I've just already downloaded Maven, and if you see, I've unzipped it here. So this is the folder with which I've unzipped my Maven. So as you know, Maven again is a one open source build tool. So you'll have to set in a few configurations and set up the path. So mvn -- version, if I specify this, after I set in my path, Maven should work. And if at all I echo m2 home, which is nothing but the environment variable specific to Maven home, it is already set here. So once you unzip Maven, just set this m2 home variable to the directory where you unzipped your Maven. Also, just set the path to this particular directory /bin, because that is where your Maven executables are all found. All right, so that's with Maven. And since I've set the path and the environment variable Maven is running perfectly fine on my system, I've just verified it. Okay, next one is the Tomcat server. Download Apache Tomcat server 8.5 is what I have on my system. So I'm just going to show you where to download this from. This is where you download Tomcat server, and I already have the server downloaded. Again, this doesn't need any installation. I just unzip it here, and it kind of has a bin and configuration. I've made some subtle changes in the configuration. First and foremost, Tomcat server also by default runs on port 8080. Since we already have our Jenkins server running on port 8080, we cannot let Tomcat run on the same port. There will be a port clash. So what I've done, I have configured Tomcat to use a different port. So if I go to this configuration file here, there is a server.xml. Let me open this up here. All right. Okay. So this is the port. By default, it will be 8080. I've just modified it to 8081. So I've changed the port on which my Tomcat server would run. All right. So that's one change. Second change, when Jenkins kind of tries to get into my Tomcat and deploy something for someone, he would need some authentications so that he'll be allowed deployment by Tomcat. So for that, I need to create a user on Tomcat and provide these user credentials to my Jenkins instance. So I would go to Tomcat users.xml file here. I've already created a username called deployer and the password is deployer, and I've added a role called manager-script. Manager-script will allow programmatic access to the Tomcat server. So this is the role that is there. So using these credentials, I will enable or I'll empower Jenkins to get into my Tomcat server and deploy my application. All right, only these two things that is required. Let me just start my Tomcat server first. So I get into my bin folder, I open a command prompt here, and there's a startup.bat. It's pretty fast. It just takes a few seconds. Yes, there you go. Tomcat server is up and running. Now this is running on port 8081. So let me just check if that looks good. So localhost 8081. Okay, my Tomcat server is up and running. That sounds good. The user is already configured on this. That's also fine. So what I'll do as a part of my first job, Maven is also installed on my system. So I'm good to use Maven as a part of my Jenkins. So I will put up a simple job now. I will say job, mvn, web app. I'll call this freestyle job. That's good. Okay, so this will be a Git repository. What is the URL of my Git repository? Is this guy, HTTPS URL. Okay, that's this URL. I will use the credentials. The old credential that I set up will work well because it's the same Git user that I'm kind of connecting into. All right, so now the change happens here where after I get this, since I said this is a simple Maven repository, I will have some Maven targets to run. So the simple target first is, let me run Maven package. This creates a war file. Okay, so mvn package is the target. Package is the target. So whenever I run this package, it kind of creates it, it builds it, it tests it, and then creates a package. So this is all that is required. Maybe let me try to save this, and let me first run this and see if it connects well, if there's any problem with my war file, or the war file gets created properly. Okay, wonderful. So it built a war file, and if you see, it all shows you what is the location where this war file was generated. So this will be the workspace. If you see this war file was successfully built. Now I need to grab this particular war file, and then I would need to deploy it into Tomcat server. Again, I would need a small plugin to do this because I need to connect Tomcat with my Jenkins server. Let me go ahead and install the plugin for the container deployment. So I will go to Manage Plugins, Available, type in container, container, deploy to container. Okay, so this would be the plugin that I would need. I would install it without a restart. Right, seems to be very fast. Nope, sorry, it's still installing. Okay, it installed the plugin. So if at all you see this, if you go to my workspace, okay, in the target folder, I would see this web application war file that is already built. So I would need to configure this plugin to pull up this war file and deploy it onto the Tomcat server. For deploying onto the Tomcat server, I will use the credentials of the user that I've created. Okay, so let me go to configure this particular project again. And okay, all this is good. So the package is good. I'm going to just create a package. That's all fine. Now add a post build step. So after the war file is built as a part of this package directive, let me use this deployment to container. Now this will show up after you install the plugin. So deploy this one to the container. Now what is that you're supposed to specify? You're supposed to specify what is the location. Okay, so this is a global configuration that is there that will allow you to, from the root folder, it will pick up the war file that is there. So ******war, that's good for me. Okay, what is the context path? Context path is nothing but just the name of an application that, under which it will get deployed into the Tomcat server. I will just say mvn web app. That's the name of my thing. Now I need to specify what kind of a container that I'm talking about. All right, so the deployment would be for this Tomcat 8.5 is what I need. Okay, because the server that we have is a Tomcat 8.5 server that I have. So this would be the URL. So the credentials, yes, I need to add a credential for this particular server. So if you remember, I had created a credential for my web application. So let me just find that. My Tomcat server, yes, configuration of this. Okay, so deployer and deployer. Username is deployer, password is deployer. Okay, so let me use that credential. I would say add a new credential, Jenkins credential. The username is deployer and the password is deployer. So I would use this deployer credentials for that. And what is the URL of my Tomcat instance? So this is the URL of my Tomcat instance. So take the war file that is found in this particular folder. And then, context path is mvn web app, use the deployer deployment credentials and get into this localhost, which is there 8081. This is the Tomcat server that is running on my system, and then go ahead and deploy it. Okay, so that is all that is required. So I would say just save this and let me run it now. Okay, it successfully built the war file. It is trying to deploy it, and looks like the deployment went ahead perfectly well. So The context path was MVN web app. So if I type in this, right, if at all I go ahead into my Tomcat server, there would be a web apps folder. You would see the the date timestamp. So this is the file that got recently copied, and this is the Explorer version of our application. So the application was built, the source code of this application was pulled from the GitHub server. It was built locally on the Jenkins instance, and then it was pushed into a Tomcat server which is running on a different port, which is 80881. Now for this demo, I'm running everything locally on my system, but assuming that this particular Tomcat instance was running on some other server with some other different IP address, all that you got to go and change is the URL of the server. So this would be the server in case you already have that, if you have a Tomcat server which is running on some other machine, that's all fine. With a different IP, that's all good enough. The whole bundle or the war file that was built as a part of this Jenkins job gets transferred onto the other server and gets deployed. That's the beauty of Jenkins and automatic deployments, or rather deployments using Jenkins and Maven.
The four components are as follows: the Docker client and server, which we've already done a deeper dive on, Docker images, Docker containers, and the Docker registry. So if we look at the structure that we have here, on the left-hand side, you see the relationship between the Docker client and the Docker server. And then we have the REST API in between. Now, if we start digging into that REST API, particularly the relationship with the Docker daemon on the server, we actually have our other elements that form the different components of the Docker ecosystem. So the Docker client is accessed from your terminal window. So if you are using Windows, it's going to be PowerShell. On Mac, it's going to be your terminal window. And it allows you to run the Docker daemon and the registry service. When you have your terminal window open, so you can actually use your terminal window to create instructions on how to build and run your Docker images and containers. If we look at the images part of our registry here, we actually see that the image is really just a template with the instructions used for creating the containers which you use within Docker. The Docker image is built using a file called the Docker file. And then once you've created that Docker file, you'll store that image in the Docker Hub or registry. And that allows other people to be able to access the same structure of a Docker environment that you've created. The syntax of creating the image is fairly simple. It's something that you'll be able to get your arms around very quickly. And essentially what you're doing is you're creating the option of a new container. You're identifying what the image will look like, what are the commands that are needed, and the arguments for within those commands. And once you've done that, you have a definition for what your image will look like. So if we look here at what the container itself looks like, is that the container is a standalone executable package which includes applications and their dependencies. It's the instructions for what your environment will look like. So you can be consistent in how that environment is shared between multiple developers, testing units, and other people within your DevOps team. Now, the thing that's great about working with Docker is that it's so lightweight that you can actually run multiple Docker containers in the same infrastructure and share the same operating system. This is its strength. It allows you to be able to create those multiple environments that you need for multiple projects that you're working on. Interestingly though, within each container, that container creates an isolated area for the applications to run. So while you can run multiple containers in an infrastructure, each of those containers are completely isolated. They're protected so that you can actually control how your solutions work there. Now, as a team, you may start off with 1 or 2 developers on your team, but when a project starts becoming more important and you start adding in more people to your team, you may have 15 people that are offshore, you may have 10 people that are local, you may have 15 consultants that are working on your project. You have a need for each of those developers or each person on your team to have access to that Docker image. And to get access to that image, we use the Docker registry, which is an open source server-side service for hosting and distributing the images that you have defined. You can also use Docker itself as its own default registry and Docker Hub. Now, something that has to be very in mind though is that for publicly shared images, you may want to have your own private images, in which case you would do that through your own registry. So once again, public repositories can be used to host the Docker images, which can be accessed by anyone. And I really encourage you to go out to Docker and see the other Docker images that have been created, because there may be tools there that you can use to speed up your own development environments. Now, you will also get to a point where you start creating environments that are very specific to the solutions that you are building. And when you get to that point, you'll likely want to create a private repository so you're not sharing that knowledge with the world in general. Now, the way in which you connect with the Docker registry is through simple pull and push commands that you run through terminal window to be able to get the latest information. So if you want to be able to build your own container, what you'll start doing is using the pull commands to actually pull the image from the Docker repository. And the command line for that is fairly simple. In terminal window, you would write docker pull, and then you put in the image name and any tags associated with that image and use the command pulls. So in your terminal window, you would actually use a simple line of command once you've actually connected to your Docker environment. And that command will be docker pull with the image name and any associated tags around that image. What that will then do is pull the image from the Docker repository, whether that's a public repository or a private one. Now, in reverse, if you want to be able to update the Docker image with new information, you do a push command where you would take the script that you've written about the Docker container that you define and push it to the repository. And as you can imagine, the commands for that are also fairly simple. In terminal window, you would write docker push the image name, any associated tags, and then that would then push that image to the Docker repository. Again, either a public or a private repository. So if we recap, the Docker file creates a Docker image that's using the build commands. A Docker image then contains all of the information necessary for you to be able to execute the project. Using the Docker image, any user can run the code in order to create a Docker container. And once a Docker image is built, it's uploaded to a registry or to a Docker hub where it can be shared across your entire team. And from the Docker hub, users can get access to the Docker image and build their own new containers.
Welcome to all our viewers. I'm Anjali from Simplilearn, and today I'll be taking you through the installation process for Docker. So before we begin, let me give you an intro to Docker. So what is Docker? Docker is a tool which is used to automate the deployment of applications in lightweight containers. So when I say containers, I mean a software package that consists of all the dependencies required to run the particular application. And when you deploy containers, you're basically providing the capability for the application to run in any kind of environment. So Dockers have multiple features, some of which are that multiple containers can run on the same hardware. It has very high productivity when compared to virtual machines. It maintains isolated applications and has a very quick and easy configuration process. So now let's begin with the demo. We'll be installing Docker on an Ubuntu system. So this is my system. I'll just open the terminal. So the first thing you can start with is removing any Docker installation that you probably already have present in your system if you want to start from scratch. So this is the command to do so, sudo apt-get remove docker engine docker.io. Enter your password and Docker is removed. So now we'll start from scratch and we'll install Docker once again. Before that, I'll just clear my screen. Okay, so before I install Docker, let me just ensure that all the softwares on my system currently is in its latest state. So sudo apt-get update. Great, so that's done. Next thing, we'll actually install our Docker. So type in sudo apt-get install Docker. Now, as you can see here, there's an error that's occurred. So sometimes it's possible that due to the environment of the machine that you're working in, this particular command does not work. In which case, there's always another command that you can start with. Just type docker install. And that by itself will give you the command you can use to install Docker. So as it says here, sudo apt install docker.io is a command that we will need to execute to install Docker. And after that, we'll execute the sudo snap install Docker. So sudo apt install docker.io first. And this will install your Docker. After that's done, we will have sudo snap install Docker. So snap install Docker installs a newly created snap package. They are basically some other dependencies for Docker that you'll have to install. Of course, since this is the installation process for the entire Docker IO, it will take some time. Great, so our Docker is installed. The next thing we do, as I mentioned earlier, is that we need to install all the dependency packages. So the command for that is sudo snap install docker. Enter your password. So with that, we have completed the installation process for Docker, but we'll perform a few more stages where we will test if the installation has been done right. So before we move on with the testing for Docker, let's once again just check the version that we have installed. So for that, the command is docker version. And as you can see, Docker version 17.12.1 CE has been installed. Next thing we do is we pull an image from the Docker hub. So docker run hello world. Now hello world is a Docker image which is present on the Docker hub. Docker hub is basically a repository that you can find online. So with this command, the Docker image hello world has been pulled onto your system. So let's see if it's actually present on your system now. The command to check this is sudo docker images. And as you can see here, hello world repository, this is present on our system currently. So the image has been successfully pulled onto the system, and this means that our Docker is working. Now we'll try out another command. Sudo docker ps -a. This displays all the containers that you have pulled so far. So as you can see here, there are 3 hello world images displayed, and all of them are in exited state. So I did this demo previously too, which is why the 2 hello worlds which is created 2 minutes ago is also displayed here. And the first hello world which has been created a minute ago is the one we just did for this demo. Now, as you have probably noticed that all the hello world images over here, all these containers are in the exited state. So when you give the option for docker ps -a, where -a stands for all, it displays all the containers whether they are in exited or running state. If you want to see only those containers which are in their running state, you can simply execute sudo docker ps. Sudo docker Yes. And as you can see, no container is visible here because none of them are in running state. And with that, we come to an end of our Docker installation.
Welcome everyone to our another demo on which we are going to see that how exactly we can do the installation of Docker on the Windows platform, specifically on Windows 10. Now Docker is something which is available for most of the operating systems, different platforms. So it supports both the Unix and the Windows platform as such. So Linux, through various commands we can do the installation, but in the case of Windows you have to download the exe file and a particular installer from the Docker Hub websites. You can simply Google it and you will get a kind of link from where you will be able to download the package. So let's go to the Chrome and try to search on for the Windows 10 particular installer. You will get a link from Docker Hub. You download it, you get the stable version, you get the Edge version, whichever version you wish to download, you can download it. So let's go back to the Chrome. So here you have the Docker desktop for Windows, so you can go for the stable or you can go for the Edge, right? So you also have the comparison that what is the difference between these two versions, right? So the particular Edge version is something which is getting releases every month, and the stable version is getting the releases every quarter. So they are not doing much of the changes to the stable version as compared to the Edge there. So you just have to double click on the installer and that will help you to do the installation of the process. So let's get started. So you just click on the get in stable version. So when you do that, the particular installer is going to install. Now it's going to take like around 300 MB there. So that's the kind of installer which is available. So once the installer is downloaded, so what you can do is that you can actually go ahead and you can proceed with doing the double click on this installer. When you double click on that, you have to proceed with some of the steps, like from the GUI itself you are going to proceed with these steps. So we'll wait for 10 to 20 seconds more and then the installer will be done, and then we can do the double click and the installation will proceed. So another thing is that there is a huge difference between the installer. Like for example, in case of Unix, the installer is a little bit less, but in case of Windows, it's a GUI is also involved, and there are a lot of binaries which is available there. So that's the reason why the huge size is there. Now it's available for free, that's for sure, and it also requires the Windows 10 Professional or Enterprise 64-bit there. So if you are working on some previous version of operating systems like Windows 7 and all, you have the older version called Docker Toolbox. So they used to call it as like Docker Toolbox earlier, but now they are calling it as a Docker Desktop with the new Docker Windows 10 support as such here. So another couple of seconds and then the installer will be done, and then we will be able to proceed with the installation. So let's see that how much progress is there to the download. So we'll click on the downloads, and here still we have some particular installations or some download going on. So we'll wait for some time, and once the installation is done, then we'll go back and we'll proceed with installation. So couple of seconds. So it's almost done. So I'll just click on this one. You can go to the directory to the downloads and you can double click on that also. But if you want to do the installation, you can click on this one also, and it will ask for the approval, yes or no you have to provide. Now once that is done, so a desktop, a kind of a GUI component will open there. So it will start proceeding with the installation. So it's asking whether you want to add a desktop, the shortcut to desktop. So you can say okay. I'm going to click on okay. So it will unpack the files, all the files which is required for Docker to successfully install, that is getting unpacked over here. So it will take some time to do the installation because it's doing a lot of work here. So you can just wait for till the execution of the installer to be completed, and once the installer is done, you can open your command line and start working on the Docker. So taking some time to extract the files. Now it's asking us to do the close and do the restart. So once that is done, you will be able to proceed further, and you can just run the command line, and any Docker command if you can run, so that will give you the response whether the Docker is installed or not. So you can see here that Docker is something which is installed, so you can run like Docker version. You will be able to get a version of the client. When you do the restart of the machine, then at that moment of time the Docker server will also be started, and then this particular error message will go off. Right now the Docker daemon is not up and running because the installation requires a restart, and when you close on this one and go for the restart, the machine will be restarted here. So this is the way that how exactly we can go for a Docker installation, and we can go on that part. Welcome everyone to this topic on Docker tutorial for the beginners here. Now in this one we are going to talk about the various components. For example, what is the DevOps here, why the DevOps is important, what is Docker, the advantages of Docker, installation of Docker, architecture of Docker, components of Docker here. So these are the different things which we are going to talk about over here. Now let's start with what exactly is in DevOps all about here. Now DevOps is nothing but a collaboration between the development and the operations teams over here, which enables continuous delivery of the applications and services to the end user. So it's a combination or collaboration between the two teams, development and operations, which helps us to go for a further implementation of various processes like continuous integration, continuous deployment, continuous delivery. All these things are possible with this collaboration over here. Now why exactly Docker is important for us as such? In a city far away from this one, so a developer decided to develop a tons of software on a single VM. Now he can put up applications. He is having a big server and he wants to host the multiple applications on a single machine. But for him, these virtual machine got a crash, because definitely if you are putting up more different applications as such on a single VM, it's not able to take up that much kind of load over there. So in order to avoid this situation, how exactly he can do the various options, or what he can implement to have this issue resolved. So ultimately Docker is something which is the solution of him. So if he really wants to host multiple applications on a single virtual machine, or he want to have different applications, then Docker is the ultimate solution for him to do that. And by doing so, there will be no issues as such when we talk about that the errors or the virtual machines cannot be crashed, and there will be no impact on the virtual machine as such. So why exactly Docker is important? So let's talk about the comparison between the Docker and virtual machine. There are very few reasons why exactly the Docker is being chosen over a virtual machine, because virtual machine is a full-fledged component which can take up any kind of load. But some of the reasons are still that in which case we will be preferring the Docker instead of the virtual machine here. The very first one is the memory uses. So Docker is having a very less memory uses because there is no concept of guest operating system, whereas on the other hand the virtual machines are going to take a huge amount of RAM resources in order to keep that particular operating system up and running. Second one, performance, because if you have less utilization and the users is less, the performance will be better. But for some reason, if you are taking up more resources, and you will not be able to deliver that amount of performance as such over there. And then again we have portability. So portability is also quite easy when we talk about the virtual machines. In case of Docker, it's quite portable as compared to the virtual machine. And then the last time is that the boot up time. So virtual machine boot up time is probably in minutes, but in case of Docker it's in seconds. So if we summarize it on this one, so the memory utilization, the boot up time, the performance, everything is better in case of Docker as compared to the virtual machines, right? For a classic example, let's say that what about the memory user? 9 GB of memory is something. If you can see that app1, app2 and app3 is there. So green and red color represents the occupied memory and the wasted memory. Now there is a particular utilization of, let's say that a server which is available there, and 3 GB of RAM is something which is wasted, and 4 GB of RAM is something which is being occupied there. So app2 is using like 2 GB, and then you can see that the specific 2 GB of RAM is occupied and 3 GB is occupied, and the wasted one is 1 GB. So VM can see over there that 9 GB of RAM is used, and the remaining 6 GB of unused RAM cannot be reused here, because if, for example, I allocate like 4 GB of RAM to the virtual machine, it's there itself, it gets logged on. So it's not like, okay, I'm using only 4 GB RAM out of this 9 GB of RAM, then the next 5 GB of RAM will be totally wasted, so you cannot reuse it for any purpose. So this is a problem with the virtual machine, that if you allocate some memory to the specific virtual machine, if you are not using that much resources or that much memory, the remaining memory will be simply wasted, because this is hardcorely allocated to the virtual machine and you cannot utilize this unused memory as such over there. So this is the limitation from the memory perspective. But in case of Docker, definitely if out of the 9 GB of RAM, if we are using only 3 GB of RAM, so whatever the unused memory is there, so we can actually reuse it for the new containers. So it's not dedicatedly allocated to the virtual machines. If you are using out of 9 GB, if you are using 1 GB, 2 GB, 3 GB or 4 GB, whatever the remaining memory is available, that you can simply use it for the other containers also. This ensures that you always go for an optimal utilization of your resources, and unnecessarily there is no wastage of the different resources or the different components over here in this one. So that's the reason why the Docker containers are quite efficient in terms of memory when we compare it with the virtual machine. Next one is the performance. Now in a virtual machine, we know that on the infrastructure, on the physical infrastructure, on top of that you put up a kind of operating system, a base operating system is there, and then on top of that you have the hypervisor, and this hypervisor then is used to create the virtual machines, which is having a kind of guest operating system inside it. Now the issue over here is that you have two operating systems over here. So the guest operating system is also going to take some particular resources, and for example the memory or a space, a processor. So in every resource terms, it is going to go ahead and say that okay, I'm going to use the particular some of the resources. Now problem is that if you're hosting a very small application, you will end up in having a more consumption, because of this guest operating system will take more of the resources, and then you are just using some very small resources for your application in an real world. So Docker container on the other hand does not have a concept of the guest operating system, and that's where what happens, that the Docker engine is more than sufficient to handle the Docker containers, and inside the Docker containers there is the application which is being hosted over there. Now with this one, definitely the performance is quite better as compared to any virtual machine, because of the terms that there is no unnecessarily wastage of the resources. Because in the previous case, virtual machines, a full-fledged guest operating system is up and running, you need some resources to be allocated to that, but in case of containers, you don't need to have that particular functionality implemented. Then portability. So having a portability or moving an application which works on a system A does not mean that it will work on the system B also. This is a similar problem which we face, that usually the application works perfectly fine in a lower environment, and when it goes to the production environment, it sometimes fails and it does not comes up properly. So this is an portability issue which we have when we talk about the virtual machines. But when in case of containers, when we got a container up and running in a lower environment, and once the container is prepared, you don't have to do the changes or modification to that depending on the environment. The same container can be deployed to production environment, and it's very easy. So whatever container prepared in the lower environment in a dev environment, the same will work in production environment without any issues, because it contains all the dependencies and executables, everything inside it. So you don't have to do any kind of modifications or changes to these containers as such over here. And the last one is the boot up time. So the boot up time of the virtual machines is in minutes, and whereas the boot up time of the Docker containers is in seconds or probably in milliseconds. So these are the reason why we consider the virtual machine as an resources based environment. But on the other hand, Docker is something which is quite light, and fast as compared to virtual machines. So let's see that what exactly is in Docker all about here. So in this one, you can see we have the physical infrastructure on which we have the host operating system. Now we don't have the hypervisor and the guest operating system. Instead of that, we have the Docker engine, which is taking care of managing the Docker containers. And inside these Docker containers, you have the applications and all the required binaries and the libraries here. So there is no concept of the guest operating system. This Docker engine is the person or is the process which is taking care of all the requests which is going on, and if this Docker engine is up and running, then all the containers will also be accessible and will be available. Now, Docker is nothing but a OS level virtualization software platform that enables developers and IT administrators to create, deploy, and run applications in a Docker container with all its dependencies. So Docker is a very important tool nowadays if you want to look forward to host your application, because of its portability benefit that you don't require much of the changes depending on the platform or depending on the environment. So whatever the developers are able to build up, the same thing will go till the production environment. Now let's talk about what exactly is in Docker container here. Now Docker container is a lightweight software package that includes all the dependencies, whether it's a base operating system, some frameworks, some libraries. It's something which is a part of this one, so that if you will be if you want to host your application, you will be able to do that. So it's a complete package. So both the source code and the dependencies is what you put up inside the Docker containers. Now within these Docker containers, you can have multiple applications there, multiple programming languages, multiple frameworks can be hosted there. In fact, the databases also can be hosted within these Docker containers. You can host them as such over there. Now, what are the different advantages of Docker? Let's talk about that. Now, the first one is the rapid deployment. So rapid deployment is the very first advantages which we are getting over here. Second, quick and easy configuration, better efficiency, portability, scalability, and security over here. Now there are different ways in which we can understand the benefits, or we can have the understanding about the Docker here. So these are some couple of benefits. Now let's take them one by one. The first one is the deployment part. So it supports the rapid deployment. Now just like a web application, for instance, I want to deploy to website, so there are some couple of steps which needs to be done across different environments. Like for example, if I have 5 environments, I have to do the deployment, the same steps in all the 5 environments at the different period of time. Now when we talk about Docker containers, we don't have to run those steps multiple times, because once those steps are executed in one Docker container, the same Docker container goes till the production environment. So you don't have to actually do a rebuild of the Docker containers, and you can simply say that, okay, I have got the Docker container here, so you can just run one or two couple of commands and that will help you to host your Docker containers. So you don't have to redo or rework on any kind of the deployment work into the production environment or into the higher environments. And then we goes for the quick and easy configurations. So the configurations of Docker containers is quite easy. You can have your own custom Docker images built out the Docker files. So these processes can be integrated within the Jenkins also. So CI/CD is quite possible with the help of Docker if you want to really do that. And then we have better efficiency. Yes, they have a better efficiency and resources management as compared to the virtual machines. Portability, we have already talked about that it's easy to move from one environment, from one system to another. In fact, it's easy from the developer also. So from one machine, from one developer to another developer, it's very easy to move these different Docker containers. Then we have scalability. Scalability is also possible with these Docker containers. Just like multiple virtual machines, you can also create multiple containers and you can share the traffic out of that. So but that scalability and all is possible with the orchestration tools. Then security is there, so you can have your best practices of the security implemented, because it's just a kind of a virtualization, just like a virtual machine. So you have all the different possibilities which is available, which you can explore when you want to make these Docker containers secure, right? So these were some of the benefits which was there for the Docker here. Now let's talk about the installation of Docker here. Now, installation of Docker is pretty common, and whatever platform you want, it's available over there. So it's available for Ubuntu, Windows. It's available for Mac operating system. So for Ubuntu, you have to run the commands on the Ubuntu operating system to download it. And for Windows, it's actually having a particular exe file, so you can go for the installation of exe file. And then we have the Mac operating system. So for Mac operating system, you have the DMG files, and when you do the DMG file, so it will help you to install the component over there. So Mac, you can also use the homebrew once to do the installation of that particular component. Now next one is the architecture of Docker. Now the architecture of Docker is pretty straightforward. There are key components which is available there in the architecture of Docker here. The very first one is as the client facing is the Docker client. Now Docker client, or you can say the Docker CLI, is available there. Now this is the component, it's a command line interface which takes up the request from the end user. Like for example, I'm running the command, so it will take all the requests from me as an end user, and it will send those particular things or the requirements to the Docker daemon, to the server, using the REST API interface. So this Docker daemon is something which keeps on running on the server, and it's a background process. It gets deployed as a service there. In case this Docker daemon is not available or it's not up and running, you will not get the proper response from the Docker command line here. So in order to get your activity or your procedures implemented, you need to have the Docker server or Docker daemon up and running. In fact, this Docker CLI can be configured to connect to any other servers or any other different server Docker daemon also. So it's a connectivity which is happening over the REST API interface, where all the requests are processed, are sent to the Docker daemon, and whatever response is coming back, that is given back to the end user. So what are the different components of Docker here? Let's talk about that. So Docker client consists of the CLI component, like we have already discussed. So that is something which is going to take up all the requests from the end user. Then it's using the REST API interface, which is there to have the connectivity with the Docker daemon. So Docker daemon is something which is always up and running. So if you run couple of commands like docker pull, push, and also that activity, you are actually sending the request to the Docker daemon, and Docker daemon is actually doing all the work. So it's not a Docker client which is doing it, just taking its kind of interface which will take the things up and send it back or send it forward to the Docker day. Right, so it's a background process which keeps on running on the server, on the operating system, and it's the same process across all the infrastructure, all the different platforms. Whether you use Mac operating system, you use Windows, or you use Linux, everywhere this is the basic functionality. And it keeps on listening to the REST API interface. So whatever the new request comes in, it immediately processes it, and whatever the response, whether you are stopping a container, whether you are running a container, according to that the action will be taken, and the response will be sent back to the REST API to the Docker client. So a Docker is a process, or it's a command line which is used to start the Docker daemon. When you run the command like service docker status on the server, you will be able to see the command which is getting executed in the backend. So there you can see that Docker is the process, or is the command line which is used to initialize the Docker daemon. And of course there is a kind of configurations which you have to pass it on as parameters. So even if you run ps-ef command, you will be able to know that what process is running from the Docker perspective. And the third component is a particular Docker registry. So we have a ready-made cloud service which is available, known as the Docker Hub. So you can actually store the Docker images on these Docker registry. So there are a lot of ready-made Docker images which is available there, but Of course, you can have your own Docker image also over there, or you can have your own custom registry, Docker registries also. For example, in JFrog, you can have your private hosted registries also. So all these different repositories you can use with your Docker containers. So Docker containers is having the flexibility that whichever registries or repositories you want to connect or you want to establish the connectivity, you can always do that. Now let's talk about the Docker image over here in detail. Now a Docker image is nothing but a template of instructions. It's having a couple of instructions in which you will be using these instructions to create a final Docker container. So Docker image is nothing but for example, I want to have a Tomcat Apache Docker image. So what are the instructions I have to do? So the very first thing is that I have to pick up a base operating system. Then on top of that, I will be installing the JDK or some prerequisite packages. And then on top of that, we will be configuring onto the Tomcat Apache there. So these are the steps. These are the different instructions, step-by-step procedure, which we are implementing so that at the end of the activity, we will be able to have a Docker container ready, which we can deploy to host Tomcat Apache. So it's a template which is having all the particular instructions. In order to build a Docker image, you require a file called Dockerfile, which is of course having all these different instructions embedded in that. So when you run the Dockerfile, it acts like a build tool. So whatever the instructions you are putting up over there, all those instructions are getting processed and you are able to get an end result. Then these Docker images are actually comprised of multiple layers. So multiple layers are available there. So step by step. So you will be first of all having a base layer from which the image starts. On top of that, another layer. For example, you did the installation of JDK. So another layer will be there. And then you did the configuration of the Tomcat Apache, and then another layer will be there. So it's a multi-layered in component which is available. And these layers are in incremental order. So definitely the oldest one will be known as the base layer, and then on top of that all the latest changes will be done in the latest layers there. So this is an example. Now here you can see that there are 4 instructions, and these 4 instructions are also known as the 4-layered Docker image. So whatever the final Docker image you will get, in there you will be able to see 4 layers of the Docker image here. Now the very first is Ubuntu. So Ubuntu 18.04 we are pulling up, and then we are pulling like the file over here, and then we are running the make utility, and once that is done, then we are running that file dot Python file over here in this one. So these are 4 instructions which is available, right? So which will definitely help us to do that, how exactly we can make or we can perform the different activities right from the base. So in this case, the base layer will be like the Ubuntu one. So Ubuntu one will be the base image, and the moment the final CMD attribute or CMD attributions are processed and executed, after that you will be able to get a final full-fledged Docker image over there. So this will be a full complete Docker image or Docker container which you will get once the whole build process is completed. Now in this ways you have you can see that the previous Docker file which we processed, so the base layer is Ubuntu 18.04. we are not building that, actually it's automatically it's by default getting downloaded as a full base layer. After that only we have like layer 1, layer 2, layer 3 added up, because those modifications we are doing it after the because from does not means that you are doing any kind of layer modifications. It's just like you are importing some base operating system or base image. So the modification or adding up the layers is only done after the base layer there. So whenever a user creates a container, a new layer is something which is stored on top of the image. These layers are known as the containers layers. So Ubuntu one, the very first instruction does not comprises it. It's not a kind of container layer. We can call it as an base image layer there. So every container has a separate read-write container layer, and any modification in a container is reflected upon the container layers only. So layer 1 may be having some different of instructions, layer 2 may be having different instructions. So like that is a step-by-step processor. In case, you know, whenever a container is deleted, the top layer also gets deleted over there in that one. So if I delete some particular containers, and that is something which is gone. So it was suppose having like 3 layers, so the top layer will be simply deleted because the container is also deleted for that particular part. Now Docker uses a copy on write strategy with both Docker images and Docker containers. So whenever we perform any activity, or whenever copy on write strategy is a strategy to share and copy files for better efficiency. So it's something which is being used to increase the overall performance of the Docker containers. It also makes Docker efficient by reducing the uses of disk space, because whenever required, okay, whenever is needed, only at that moment of time it's actually performing the copy, and it definitely reduces the overall disk utilization. And this is very important also, because when you have so many Docker containers up and running, so you have to worry, or you have to make the utilization of a disk, or your disk users or resources also minimum. So that is also, you need to make sure that it does not exceed a particular value. So once the utilization is also less, then definitely the overall performance will also be better and improved over here in this case. So let's talk about some of the facts here. So the base layers are something which is purely read-only format, so you cannot do the modifications. Union file system saves the memory by avoiding the duplications of the files. The layers can be combined in a union file system to create a single image. So all these layers are combined and got a final product, or called a, you can call it as Docker image or Docker containers. And this allows a file system to appear as a writable, which is known as copy on write. So copy on write strategy is being used so to do the changes, or to do the perform the modifications to this union file system while creating the different layers. So now let's talk about the Docker registry. Very important component, because even if you prepare the Docker image locally and you don't have the collaborative tool, or you don't have the tool where you can share these images, definitely it's not easy for you to port these Docker images from one system to another. So Docker registry is very important for the portability feature of Docker. So Docker registry is a service to host and distribute Docker images among users. So it can be built up by one user and multiple users can use it. For example, I'm using a Jenkins one. So Jenkins image is prepared only once, but it's being used by different people as such. Docker registry, again, it's a repository, is a collection of Docker images. So in a repository you will be having like different Docker images as such. So in registry, a user can distinguish between the Docker images with their tag names. So for example, Jenkins is a kind of a single image. There might be different type of images there. Let's say that, okay, let's talk about Jenkins JDK8. So there will be an image called Jenkins. The name of the image will be same, but the tags will be different. So one tag could be like JDK8, one tag would be like JDK9, and one tag would be JDK10. So the difference between all these 3 Docker images is that JDK8 one is prepared on JDK8, it's running on JDK8, and if you want to use JDK9, in that case you have to pull down the Docker image of Jenkins with the JDK9 installed. So depending on the frameworks, or depending on the runtimes, so with these tags, different tags are processed, so you can have the distinguish between the Docker images, and whichever Docker image you feel you want to use, you can implement according to your requirement. And Docker by default is having its own cloud-based registry called as Docker Hub, which gets automatically connected when the moment you do the Docker installation. But in case you are working into your private infrastructure, so in that case you may use the repositories, Docker repositories on the specific JFrog Artifactory, or the private repositories also can be hosted. But Docker Hub is something which is having a public and private repositories both. So you can create either the public and private repositories. You can use push and pull activities to interact with these Docker images. If you want to download a Docker image, so you can run pull. If you want to push your Docker image to the Docker registry, in that case you can run the push activity. So in both the cases you are doing the interaction with the Docker Hub. So when you run some build process, or when you run the containers, there may be some Docker containers which is getting pulled down from the specific registry from the Docker Hub, and if that specific image and tag is available, definitely pull command will be successful. But in case of push command, you are pushing your custom Docker images. You cannot push the ready-made Docker images which is available. You can publish your own Docker image only to the Docker Hub, and then you can further on do the pull and push activity accordingly to those repositories. So whatever the ready-made and third-party images which is available, you can only do the pull activities to them. You cannot do the push activities. Push command scenario will only come when you are interacting with your custom Docker image. Next one is the Docker container. Now, Docker container is an executable package of an application and its dependencies together. So when we prepare a Docker container, we actually combine both the dependencies and the application source code inside it. So the Docker container don't have to look for the dependencies on the host machine on the server. So this is one of the benefits where we see that the portability is very easy, because whatever I'm building up on one system, everything is inside the Docker container, so I don't really need to do any further activity on other machines. So whatever works on one system can be easily worked on another system. So it's very lightweight also, so it can be easily deployed and executed on on their particular servers, because it does not take that much utilization like a virtual machine. So if you are looking forward for having your application hosted into your local system, you can easily do it within the Docker container. So the utilization is very less as compared to the virtual machine, so you don't have to worry about your host operating system and the configurations. So Docker containers can run in totally isolation, just like a virtual machine. So there is no interaction or there is no interference. So they share the OS called kernel, but the thing is they don't have the interface as such over there. So it works totally in isolation. Two different containers will not have any interaction unless and until we set up the containers to have the interactions. Now there is data volumes which can be shared and be used among the multiple containers. So you have the capability over here that if there is some unused space that can be easily shared across the multiple containers here. So it is built using the Docker images. So using the Docker images, the Docker containers are built up, and Docker run is a specific command which is used to build a Docker container. So if you got a Docker image, let's say that I have prepared a Docker image, a custom Docker image using the Docker file. Now if I need to create a Docker container out of a Docker image, I have to run a Docker run command. So Docker run command is nothing but it initializes or creates an instance of a Docker image. Now next component is the Docker Compose. Now typically when we work with the Docker containers, so we had to run, like if I want to run like 5-6 containers, I have to initialize like 5-6 times, or I have to run Docker run commands 5-6 times there. So and if you want to create a relationship between the containers, then definitely that is something which you need to manage using the Docker commands. But sometimes it's not an easy task for you to run those commands manually or remember those commands. So Docker Compose is a utility over here using which you can actually run multiple containers with a single service. You just got a kind of a single file, you just run it, and all the containers, definitions and relationships, everything is inside this Docker file here. So you want to run 2 containers, that's totally fine. Instead of running 2 commands, now you just have to run 1 file, and that will take care of that. Now you may be having more than 2 containers, 5, 6, 7, whatever number of containers you have, that can be easily deployed without any manual activity or without any maintenance onto the server. So these containers totally run in isolation, but yes, you can establish the interaction, that how they want to interact with each other, and that interaction you can put up in these Docker Compose file. So Docker Compose file is something which is written in a YAML format, and in this you define that okay, I need 2 containers, and this image should be there. These are the parameters which you need to run, and if you want to have the interaction or the linkage between the images, that also you can establish within this YAML files or within this Docker Compose file here. right? So let's say, for example, I want to have an application which requires Apache web server and MySQL database. Now I can create a Docker Compose file which can run both containers, and without, you don't require to restart or start them separately or initialize them separately. So I will be having a final Docker Compose file which is having like containers like Apache containers and MySQL containers both inside a single Docker Compose file here. So that's the benefit you're going to get, because now you don't have to run them separately, separate Apache and separate YAML MySQL. So you can get it done with the help of a single Docker Compose file here. Now, what exactly is the Docker Swarm? Now, Docker Swarm is a inbuilt, or it's a default orchestration tool which is being provided by the Docker itself. It's a service for containers which allows the IT administrators and the developers to create and manage a cluster of Swarm nodes. So in a typical world, when you do the installation of Docker, there is a limitation that some of the features like high availability, multiple instances, or scalability, all these things are not possible as it is with the core Docker. Now on top of that, you require the orchestration tools like Docker Swarm, where you have a swarm of node machines, 5-6 node machines are there, on which you can have your highly available application infrastructure implemented. Now this one means that if I want to run my applications 5 containers, 6 containers and 7 containers, for that purpose we are using the Docker Swarm. So each node of Docker Swarm is having a Docker daemon which is used for performing the interaction. So there will be a master node which is available, so it will be interacting with all the node machine on all the client machines, and this interaction will be in such a way that it will let them know, okay, I want to deploy the container or onto the node 3, so it will perform that activity and the container will be up and running on the node 3 there. So a swarm consists of 2 type of nodes. One is the manager node and one is the worker node. So manager is the master node which you can refer, and the worker node is the one which is actually doing most of the work. So the manager node is not something which is expected to host anything apart from the main component, but yes, you can always configure if you feel that you want to only deploy the container on the worker node. So that also you can do during the deployment of the containers. So manager will keep on connecting to the different worker nodes there, and whenever new request comes in, so it will basically try to connect and see that, okay, I just want to go ahead and deploy a container. So it will do the deployment of the container on the worker node. So the main work will be done by the worker nodes, and manager is just doing the management of all these resources. The worker nodes will be definitely receiving the request from the manager, and it will be proceeding and performing those activities. And if for some reason worker node is not active or online, so the master node will not be able to deploy the containers on that server. So right now, let's talk about a demo in which we have to create a Docker image using a Docker file on the Ubuntu 20. So we want to use a base operating system as an Ubuntu 20 there, and using that we are going to create a custom Docker image. So let's connect to our virtual machine and see that how we can do that. Okay, so as part of this demo here, we are going to prepare a Docker image, and in that we are going to use a base image of Ubuntu. So let's take an operating system of Ubuntu 20. 20 is the latest version of the Ubuntu operating system. So I have got a server, so let's see. So first of all, we have to install the docker.io package, which will install the Docker package, and then we can enable the service. We can make sure that the Docker service is up and running, because if the service itself is down, then we will not be able to perform any activity. And then a sample, if you run docker run hello-world, so that is going to pull a Docker image from the Docker hub, and a particular activity will be done to you. So once that is done, so we can say that, okay, the container is up and running and everything is got over there up and running. And then you can also try some of the Ubuntu Docker image also. If you feel that you want to try, you can do that. But the main demo which we need to do over here is that we need to prepare a custom Docker image, and in this one we will be having we will be using an Ubuntu base operating system. On top of that, we will be installing PHP, Nginx, all these different components. So we are going to have a PHP based website hosted onto the Apache web server as an Nginx, and then we will be able to access that application. So the very first thing which we need to do is that we need to create a folder. Let's say that I just create a particular folder called nginx-image, and then I create a Docker file over there. So Docker file content we are going to take from this one. So let's go to the server and see that how we can go ahead with the activity. Now what we can do is that we have got a server over here. Now in this server, what I'm going to do is that I'm going to proceed with the installation of Docker first. Now when I do the Docker installation first, so what will happen that I will be able to have my Docker installation completed, and then further on I can take the further steps of having the accessibility of going through the understanding that what is this particular platform, or how to prepare different kind of containers. So I have got a particular container over here. So what I can really do is that I can simply say that, okay, I have got a server. So this is a Ubuntu server, so I'm going to run the command called app update first. Now this will do the update locally, so all the links and everything will be updated. Now the whole idea about doing the updates is that so that I will be able to have establish the fact that I'm trying to connect to the Ubuntu URL, so that at any moment of time I should be able to fetch on the latest packages. Now once that is done, so I'm going to run the command called apt install docker.io. Now the moment I do this, what will happen that it will try to download some packages. It will ask for the confirmation. You can give your confirmation and I can say yes. The moment you give the confirmations, the download of the packages will proceed over here. Step by step it will download the packages and the installation will go on. Now once the installation is done, so what you can do is that you can see that Docker is deployed into your system or not. You can run Docker version command, or you can also use the service command to check, to make sure, to ensure that the Docker service is always up and running. If the service is not up and running, you have to make sure you have to enable it, you have to start that service. So these are some couple of steps which you need to do in order to make sure that your connectivity or your environment is ready with the Docker installation. And once the Docker installation is done, then only you will be able to proceed further with the further activities like preparing the containers, preparing the images and all that stuff. But if you don't have the Docker installed prior to that, then definitely it's going to be a problem. So just make sure that before even doing any kind of activity, before even doing any kind of steps, we ensure that the Docker is fully up and running. So it's going to take some time to download the packages, and we will wait for that. And once the installation is done, we will continue further on that part. Okay, now once the installation is done, so you can run the command called service docker status, and when you do that, it will let you know that whether the Docker service is available there or not. So you can start the service in case you don't get the proper response, and now you can see that it's showing up that a process is running. So earlier it was not up and running, it was inactive, but now it's active. And you can see here that dockride is the process which is running over here as a process to initialize the Docker daemon. So Docker daemon is up and running now, and we are good to go here. So now if we go and say like docker run hello -world, so we are doing a validation to our Docker instance that whether our Docker instance is working fine as expected or not, because if there is any kind of problem with the Docker daemon and Docker daemon is not up and running properly, we would be able to get an error message over there. But right now there is no error message, which represents that yes, you are pretty much running the Docker image and it's giving you the proper response. So you will be able to see the Docker images when you run. So you will be able to see that the Docker image is pulled down to your system, and definitely you have executed that and it got you the response. Now the next thing which we need to do is that we need to run a particular Ubuntu one. So for example, if I go for docker run -it Ubuntu Bash. So what exactly we are doing in this one is that we are pulling down a Ubuntu Docker image and we are running the Bash executable on top of that. The whole purpose of doing that activity is that so that if I want to do some process or I want to perform some activity, I should be able to connect to that Docker image. So the moment I do this, first of all, if this Docker image is available locally, that's great. It will immediately create the container. if the Docker image is not available locally, the very first thing which it will perform over here is to pull down the Docker image, the correct one. And as you can see here that it definitely pulls down a Docker image, and once it is done, so it got a terminal for you. Now you can see it shows that root at the ID, root at the rate 1 ID is there. This ID is nothing but it's a container ID which we are getting here. So definitely you are inside the Docker container, and when you run the Docker, when you run the exit command, you will see that you have come out of the Docker container over here. And the moment you run docker ps-a command, you can actually see also that how many container you deployed so far. So you ran hello world, you ran the Ubuntu one, both of them are stopped there. You can see the exit 0 in the status over here, because both of them are something which you ran in the interactive mode, so they are done. So if you want to keep your container up and running, you need to have a container which runs in the dash mode and always up and running. But for that, you have to go ahead to the level where we need to create a custom Docker image and do the setup accordingly. So let's see that how we can do that. Now I'm going to create a particular folder called nginx-image. You can pretty much give any name, whatever name you feel you want to perform, you can do that. Now in this one, I'm going to put up a file called Docker file. So let's see that what content we need to put as such when we talk about the Docker file, because whatever content you put over here, that is what according which the Docker image will be prepared. Now here we have to talk about, so first we have to see a base image. So we are saying that okay, Ubuntu 20.04 is what I want to use. Then we are giving some labels. Now these labels are used to give some information like what is the version, who is the maintainer, what is the description. You can do the customizations to this one. So these labels are actually defined and utilized so that I will be able to give an information that okay, so and so developer is something which we can contact. So if there is any kind of problem with the Docker file or with this build script, we have to reach out to that specific person. So this is what we typically do with the labels here. Now we also have to set up a parameter like Debian_frontend as in non-interactive, because whenever we talk about any build process in Docker file, it cannot be there in the interactive session. It should be there in the non-interactive. And definitely a typical scenarios like you can run app update command, and then we are installing the PHP, Nginx, supervisor, all these things we are doing the installation. We are using the run attribute, run a particular step, and in there whatever the commands are executed, these statements will be executed when we will be doing the build process. And then we are using some environment variables. Okay, so nginx virtual host, php_conf, nginx_conf, and supervisor_conf. These are the different environment variables which we configuring over here. Now next thing which we have is that we have to transfer some files like probably nginx and the virtual host file. We may have to transfer from a Linux server to the destination to the Docker container. So for that we are going to run some copy commands, copy statements, so that we can do that stuff. And then definitely we are transferring the supervisor configuration file also to the server, so that we can have that configurations set up over there. And these supervisor_conf and all these different variables we have already established, where we are saying that what exactly configuration we are looking forward over here. And then we are creating some folder structure. We www.html folder structure we are creating, so that we will be able to push some content over there. And then we have the volume configurations. So whatever the volume configurations are there, we are putting up, so that we will be able to have all the specific directories mounted on the host machine, on the host server, so that we can even talk about locally also. And then the star.sh is something which we need to run, because that's that will go into the command statement which needs to be executed. Because when you want to run your process, when you want to run your nginx process or your Docker container, some process should be up and running. That's where if any interactive process will run, then only the Docker container will be hold up. So that's what you can do or you can configure over there. So I'm going to copy this whole content. Now this whole content represents the complete Docker file. So we have already gone through this content one by one, but if we combine all these content together, till the expose part, that's where we come up into this one. So expose, we are doing ATN443 over here, right? After this one, we have to create the host file, virtual host file, supervisor D file, and the star.sh file. So let's go back to the server here. Now in this one, you have to you can use whatever editor you feel you want to use, you can do that. So this is what my master file will look like. You can see I'm running some run commands. These are the environment variables I'm using. Then further on, these variables I'm using just to define the paths. Okay, so you can see that this default file we are copying from the host machine, from the server to the Docker container, and then second file is supervisor d.conf file, and then we have star.sh file. So these are the different files which we want to configure here. So once this file is prepared, we have to type in, or we have to create a default file over here in this current directory. So in this current directory, we have to put up a file called default. Now in this one, we will be having the default virtual host configuration config. So we need to put a server attribute saying that we have to look forward for index.html or index.php and these kind of files from the var www.html directory there. So I'm just going to copy this content and put it up into this one. So this is how my final file look like. So I'll save it, and then we have a supervisor d.conf file. So I'll just copy the content of this one. I'll copy it, and we have to create a file called supervisor d.conf file. Now names we can double check because we are referring these names into our Docker file, so we can double check that. So once this is done, save it, and we can check the Docker file. We can grab, so you can see, okay, this one, so supervisor D, so the name is correct, that's correct. So we got a default, we got supervisor D. Now we have to create the star.sh file, because in this one we will be configuring that how we want to start our process of this Nginx or this web server. So in this one, again, we have to run the supervisor D process over here and a configuration file. So we are going to put this one, and we'll go here and put this content, right? So we got the supervised config also available, so that's also there. And the moment this is done, so you are going to give the execute permission to this one, because you can see that into our Docker file that we are having the attribute where we want to run this into the slash there. So if you want to refer in that mode, you have to change the permissions. In case so that change mode, you have to give the execute permission to the start.sh here. Now once this is done, so what you got is that you got a particular components, like you got some couple of commands, you have got Docker file, supervisor.conf default, all these files are there. Now the only thing which we need to do next is that we need to do the build process. So if we look forward for the build process, so what happens, the Docker build is the command which we need to use, and nginx-image is the name which you want to refer. Now you can totally use this custom name, whatever name you feel that you want to use, you can always use that. There's no restriction on that part. And once that is on, so you will be able to list down those images that you got a new custom Docker image here. So you can see that you got the Ubuntu as a base image which is built down, and the nginx-image is also prepared over there. And once that is done, so you are going to create a web root folder, and you can run the docker run command to see that if you really got connected with that particular one. So let's go back and see that how we can create the Docker custom Docker image here. So the moment I do this, so it will pick up the Docker file over here and start performing the activities, the package installations, all those configurations ones will be performed over here in a non-interactive mode. There is no confirmation which will be asked from the user, because you cannot put that confirmations. So the command should be in such a way that it should not take any kind of confirmations at all from the end user. So because tomorrow you may be putting up these things in the Jenkins, so that will not be a feasible thing for you to put up the commands and put up the confirmations during the execution. So So it's trying to do the package installation for the PHP. So fpm packages are getting installed, and here we go. So we caught the successful message. Now you can see it says successfully tagged this one. This means that there is no issues at all with the Docker image, and when you run the Docker images or Docker images ls, you can run these two couple of commands. So when you do that, you got a 237 MB of the size of this image. That represents that this Docker image is fully ready to run to execute. So now what we are going to do is that we are going to map a volume over here with the var www.html directory during the execution of this container, because I really want to deploy some pages, some web pages there. If you have the web pages now, as part of the build process, as part of the Docker file, you can do a git clone also of some repository, but I don't want to do that during the preparation of Docker image. I just now got an environment where the Nginx is set up properly and it's up and running there. Now it should be upon me that how I want to put up my content and all. So that's the reason why I'm putting up a kind of a folder structure over here and sharing it with the Docker container, so that the moment I put that the HTML files or the PHP files into that local folder, I should be able to get some web page up and running there. So that's what I'm going to do over here in this one. So I'm going to create a folder structure saying /web root here. Okay, so there is a folder structure which is created. Now in this web root, I will be putting up some files, and then same files will be redirected inside the Docker container with the help of Docker volume. So let's go back to the document. Now here you have to run once, like I said, that you are going to connect on that part. Okay, so you can use this port as an AT also, but here 880 is used, so whatever port you feel you want to use, you can do that. And we are giving the container name as test and hyphen container. That also you can change. And Nginx hyphen image is the one which we are using, so if you use some different particular image, you can also use that. And you can see that the web root is something which we are connecting with the var www.html directory. So the moment you put some file in the web root, the same file will be reflected into the var www.html directory there. So I'm going to run this command, and once this is done, so you can see that for the testing purpose we are putting up some content in the HTML one. So I'll come to that point also and we'll validate. As of now, we should be having our container up and running over here in this one. Now I'm going to copy that command, okay, and hit on. So if the 80 port is used, so you have to make sure that port gets gets stopped automatically, or it should not be up and running. So just double check whatever port you are using, that should be free. Now when you run the docker ps command, so you will be able to see a Docker container up and running. But if you see like docker ps-a, that gives also the stopped and running, both the containers are there. But the main thing which we want to run is that we want to run the docker ps command, and you can see that this is a container which is running. So 8080 is the container which is running, and test-container is the name. Now you got a container up and running, so you can actually do a curl on localhost colon 8080. So this is a way to get the content. You can get the public IP also, and in the browser you can put up and you can have the content there. But right now we are getting the response. At least it's showing as 403 error, forbidden error, but that's fine. We will be putting up some web pages there in the var www.html directory, or we can say in local web root directory, so that we will be able to have some content. So what we can do is that we can have some echo commands executed, so that we can have some content added up into the particular files there. So let's see that what different contents we can do. So you can use the vi mode also to do a couple of files. So I'm just using this echo command. So the moment I go for this execution, so what happens that a file will be created into that /web root there. So I'm expecting that I have put up a index.html page. So if you feel that you want to put some different page, you can always do. And the moment you do the curl, now you will be able to see the same response. So whatever the things you put up in the index.html file, the same content is going to pop up when you run the curl command. Now you want to use some PHP files, you want to put up some PHP content, all that stuff you can do it. Now what I'm going to do is that rather than just HTML static content, I'm going to put some PHP content that is going to help me to get a file. So my web root will have now 2 files. So if you feel that index.html file should have some meaningful content, you can always do that. You can pull some of the websites also. You can put that into the, you can do a git clone in the web root, and the whole application will be started. And now if you feel that I got a info.php file, so I can use that name into the URL. I have to modify the URL because index.html file is the what as in default name page you do. If you want to put up some different name, you can change the server configuration of Nginx, and according to that it will work. So when I do this, so you will start getting the output. So this is the PHP content output which is there. It's a complete information. Now it may look like a very bulky content to you, but when you put up this one into the browser, into the web browser, that will be a meaningful information, probably in terms of some tables or something like that, right? So let me scroll to the top here. So you can see that it's showing an error. Sorry, it's showing in the output, and this output represents that you got a particular PHP content here. So this is how we will be able to have a container, and you know, this container is up and running. You can modify to at any level. You feel that you want to prepare a Docker image with the code embedded also, you can have the git clone, or you can have this configuration into some git repository, have the source code also there, and then prepare a complete bundle altogether. So this is what we have in this demo, how we can deploy a container and a container up and running in case of the Docker here. So
today we're going to cover what is a Docker container, why you would want to consider using it in your DevOps environment. So let's have a look at what we have in our current environment. So today, when you actually have your standard machine, you have the infrastructure, you have the host operating system, and you have your applications. And then when you create a virtual environment, what you're actually doing is you're actually creating virtual machines, but those virtual machines actually are now sitting within a hypervisor solution that sits still on top of your host operating system and infrastructure. And with a Docker engine, what we're able to do is we're able to actually reduce significantly the different elements that you would normally have within a virtualized environment. So we're able to get rid of the bins and so we're able to get rid of the guest OS, and we're able to eliminate the hypervisor environment. And this is really important as we actually start working and creating environments that are consistent, because we want to be able to make it so that it's really easy and stable for the environment that you have within your dev and ops environment. Now, critical is getting rid of that hypervisor element. It's just a lot of overhead. So let's have a look at a container as an example. So here we actually have a couple of examples. On the right hand side, we have different containers. We have one container that's running Apache Tomcat with Java. A second container is running SQL Server in a Microsoft.NET environment. The third container is running Python with MySQL. These are all running just fine within the Docker engine and sitting on top of a host OS, which could be Linux. It really could be any host OS within a consistent infrastructure. And you're able to have a solution that can be shared easily amongst your teams. So let's have a look at an example that you'd have today if a company is doing a traditional Java application. So you have your developers working in JBoss on his system, and he's coding away, and he has to get that code over to a tester. Now, what will happen is that tester will then, typically in your traditional environment, then have to install JBoss on their machine and get everything running and hopefully set up identically to the developer. Chances are they probably won't have it exactly the same, but they'll try and get it as close as possible. And then at some point, you want to be able to test this within your production environment, so you send it over to a system administrator who would then also have to install JBoss on their environment as well. Yeah, this just seems to be a whole lot of duplication. So why go through the problem of installing JBoss 3 times? And this is where things get really interesting, because the challenge you have today is that it's very difficult to almost impossible to have identical environments if you're just installing software locally on devices. The developer's probably got a whole bunch of development software that could be conflicting with the JBoss environment. The tester has similar testing software, but probably doesn't have all the development software. And certainly the system administrator won't have all the tools that the developer and tester have, their own tools. And so what you want to be able to do is kind of get away from the challenge you have of having to do local installations on 3 different computers. And in addition, what you see is that this uses up a lot of effort, because when you're having to install software over and over again, you just keep repeating doing really basic foundational challenges. So this is where Docker comes in, and Docker is the tool that allows you to be able to share environments from one group to another group without having to install software locally on a device. You install all of the code into your Docker container and simply share the container. So in this presentation, we're going to go through a few things. We're going to cover what Docker actually is, and then we're going to dig into the actual architecture of Docker and kind of go through what Docker container is and how to create a Docker container. And then we'll go through the benefits of using Docker containers and then the commands, and finalize everything out with a brief demo. So what is Docker? So Docker is, as you'd expect, because all the software that we cover in this series is an open source solution, and it is a container solution that allows you to be able to containerize all of the necessary files and applications needed to run the solution that you're building. So you can share it from different people in your team, whether it's a developer, tester, or system administrator. And this allows you to have a consistent environment from one group to the next. So let's kind of dig into the architecture so you understand why Docker runs effectively. So the Docker architecture itself is built up of two key elements. There is the Docker client, and then there is a REST API connection to a Docker daemon, which actually hosts the entire environment. Within the Docker host and the Docker daemon, you have your different containers, and each one has a link to a Docker registry. The Docker client itself is a REST service, so as you'd expect, a REST API that sends command line to the Docker daemon through a terminal window or command line interface window. And we'll go through some of these demos later on so you can actually see how you can actually interact with Docker. The Docker daemon then checks the request against the Docker components and then performs the service that you're requesting. Now, the Docker image itself, all it really is a collection of instructions used to create a container. And again, this is consistent with all the DevOps tools that we have. The DevOps tools that we're looking to use throughout this series of videos are all environments that can be scripted. And this is really important because it allows you to be able to duplicate and scale the environments that you want to be able to build very quickly and effectively. The actual container itself has all of the applications and the dependencies of those applications in one package. You kind of think of it as a really effective and efficient zip file. It's a little bit more than that, but it's one file that actually has everything you need to be able to run all of your solutions. The actual Docker registry itself is an environment for being able to host and distribute different Docker images among your team. So say, for instance, you had a team of developers that were working on multiple different solutions. So say you have a team of developers and you have 50 developers and they're working on 5 different applications. You can actually have the applications themselves, the containers, shared in the Docker registry. So each of those teams at any time check out and have the latest container of that latest image of the code that you're working on. So let's dig into what actually is in a container. So the important part of a Docker container is that it has everything you need to be able to run the application. It's like a virtualized environment. It has all your frameworks and your libraries, and it allows the teams to be able to build out and run exactly the right environment that the developer intended. What's interesting though is the actual applications then will run in isolation, so they're not impacting other applications that's using dependencies on other libraries or files outside of the container. Because of the architecture, it really uses a lot less space, and because it's using less space, it's a much more lightweight architecture. So the files, the actual folder itself is much smaller. It's very secure, highly portable, and the boot up time is incredibly fast. So let's actually get into how you would actually create a Docker container. So the Docker container itself is actually built through command line, and it's built of a file and Docker image. So the actual Docker file is a text file that contains all the instructions that you would need to be able to create that Docker image. And then we'll actually then create all of the project code within inside of that image. Then the image becomes the item that you would share through the Docker registry. you would then use the command line, and we'll do this later on, select Docker run and then the name of the image to be able to easily and effectively run that image locally. And again, once you've created the Docker image, you can store that in the Docker registry, making it available to anybody within your network. So something to bear in mind is that Docker itself has its own registry called Docker Hub, and that is a public registry, so you can actually go out and see other Docker images that have been created and access those images. As your own company, you may want to have your own private repository, so you want to be able to go ahead and either do that locally through your own repository, or you can actually get a licensed version of Docker Hub where you can actually then share those files. Now, something that's also very interesting to know is that you can have multiple versions of a Docker image. So if you have a different version control, different release versions, and you want to be able to test and write code for those different release versions because you may have different setups, you can certainly do that within your Docker registry environment. Okay, so let's go ahead and we're going to create a Docker image using some of our basic Docker commands. And so there are essentially really, kind of just two commands that you're going to be looking for. One is the build command, and another one is to actually put it into your registry, which is a push command. So if you want to get an image from a Docker registry, then you want to use the pull command, and a pull command simply pulls the image from the registry, in this example using nginx as our registry, and we can actually then pull the image down to our test environment on our local machine. So we're actually running the container within our Docker application on a local machine. We're able to then have the image run exactly as it would in production. And then you can actually use the run command to actually use the Docker image on your local machine. So just a few interesting tidbits about the Docker container. Once the container is created, a new layer is formed on top of the Docker image layer. It's called the container layer. Each container has a separate read-write container layer, and any changes made in that Docker container is then reflected upon the particular container layer. And if you want to delete the container layer also gets deleted as well. So, why would using Docker and containers be of benefit to you? Well, some of the things that are useful is that containers have no external dependencies for the applications they run. Once you actually have the container running locally, it has everything it needs to be able to run the application. So there's no having to install additional pieces of software, such as the example we gave with Bosch at the beginning of the presentation. The containers are really lightweight, so it makes it very easy to share the containers amongst your teams, whether it's a developer, whether it's a tester, whether it's somebody on your operations environment. It's really easy to share those containers amongst your entire team. Different data volumes can be easily reused and shared among multiple containers. And again, this is another big benefit, and this is a reflection of the lightweight nature of your containers. The container itself also runs in isolation, which means that it is not impacted by any dependencies you may have on your own local environment. So it's a completely sandboxed environment. So some of the questions you might ask is, can you run multiple containers together without the need to start each one individually? And you know what? Yes, you can with Docker Compose. Docker Compose allows you to run multiple containers in a single service. And again, this is a reflection on the lightweight nature of containers within the Docker environment. So we're going to end our presentation by looking at some of the basic commands that you'd have within Docker. So we have here on the left-hand side, we have a Docker container and then the command for each item. We're actually going to go ahead and use some of these commands in the demo that we're going to do after this presentation. You'll see that in a moment. But just, some of the basic commands we have are committing the Docker image into the container. Kill is a standard kill command to terminate one or more of the running containers so they stop working. Then restart those containers. But certainly you can look at all of the commands here and try them out for yourself. So we're going to go ahead and start a demo of how to use the basic commands to run Docker. So to do this, we're going to open up terminal window or command line, depending whether you're running Linux, PC, or Mac. And we're going to go ahead, and the first thing we want to do is see what our Docker image lists are. So we can go sudo docker images, and this will give us, well, first of all, enter in our password. So let's go enter that in. And this will now give us a list of our Docker images. And here are the Docker images that have already been created in the system. And we can actually go ahead and actually see the processes that are actually running. So I'm going to go ahead and open up this window a little bit more, but this will show you the actual processes and the containers that we actually have. And so on the far left-hand side, you see under names, we have learn, Simplilearn, b_cool. These are all just different ones that we've been working on. So let's go ahead and create a Docker image. So we're going to do sudo docker run -d -p 0.0.0.0 :80:80 Ubuntu, and this will allow us to go ahead and run an Ubuntu image, and this will run the latest image. And what we have here is a hash number, and this hash number is a unique name that defines the container that we've just created, and we can go ahead and we can check to make sure that the container actually is present. So we're going to do sudo docker.ps, and this will actually show us on there. So it's not in a running state right now, but that doesn't mean that we don't have it. So let's list out all the containers that are both running and in the exit state. So let's do sucker ps-a, and this lists all the containers that I have running on my machine. And this shows all the ones that have been in the running state and in the exit state. And here we see one that we just created about a minute ago, and it's called learn. And these are all running Ubuntu, and this is the one that we had created just a few seconds ago. Let's open it up, and there we go. So let's change that to that new Docker container to a running state. So scroll down, and we're going to type sudo docker run -it -name my. So this is going to be the new container name. It's going to be my Docker. So this is how we name our Docker environment. And we'll put in the image name, which is Ubuntu. And -bin -bash. And it's now in our root, and we'll exit out of that. So now we're going to go ahead and start the new my Docker container. So sudo docker start my, and we'll get the container image, which will be my Docker, return, and that started that Docker image. And let's go ahead and check against the other running Docker images to make sure it's running correctly. So sudo docker ps, and there we are. Underneath name on the right hand side, you actually see my Docker along with the other Docker images that we created. And it's been running for 13 seconds. Quite fast. So if we want to rename the container, let's use the command sudo docker rename. We can take another Docker image. Let's grab this one and we'll put it in rename. And we'll rename, and we'll put in the old container name, which is image, and then we'll put in the new container name, and let's call it purple. So now the container image that had previously been called image is now called purple. So we do sudo docker ps to list all of our Docker images, and if we scroll up, and there we go, purple. How easy is that to rename an image? And we can go ahead and use this command if we want to stop a container. So we're going to write sudo docker stop, and then we'll have to put in the container name, and we'll put in my Docker, the container that we originally created, and that image has now stopped. And let's go ahead and prove that. We're going to list out all the Docker images, and what you see is that it's not listed in the active images. It's not on the list on the far right hand side. But if we go ahead and we can list out all of the Docker images, so you actually see it's still there as an image, it's just not in an active state, it's what's known as in an exit state. So here we go. And there's my Docker. It's in an exited state. So that happened 27 seconds ago. So if we want to remove a container, we can use the following command. So sudo docker rm for remove my Docker, and that will remove it from the exited state. And we're going to go ahead and we're going to double check that. And yep. Yep. It's not listed there under exited state anymore. It's gone. And there we go. That's where it used to be. All right, let's go back. So if we want to exit a container in the running state, so we do sudo kill and then the name of the container. I think one of them is called yellow. Let's just check and see if that's going to kill it. Oops, no, I guess we don't have one called yellow. So let's find out the name of a container that we actually have. So sudo docker kill. Oh, we're going to list out the ones that are running. Oh, okay, there we go. Yellow isn't in that list, so let's take Simplilearn. And so we can actually go ahead and let's write sudo docker kill Simplilearn. And that will actually kill an active Docker container. Boom, there we go. And we list out all the active containers. You can actually see now that the Simplilearn container is not active anymore. And these are all the basic commands for Docker container.
Hey everyone, welcome to this Simplilearn video on Kubernetes full course. In this full course, we will learn everything about Kubernetes in detail. We will begin this full course video with understanding what exactly Kubernetes is. Next, we will see how to install Kubernetes and the differences between Kubernetes and Docker. Then, we will look into the services and components of Kubernetes in detail. After that, we will be discussing everything about the architecture of Kubernetes. Then we will see how Kubernetes can be implemented on AWS. Finally, we will conclude this video by discussing the important Kubernetes interview questions and answers for beginners and experienced candidates. By the end of this video, I can assure you that all your Kubernetes career-related queries will have been answered. So, let's start with an exciting video on the configuration management tool. Before we begin, make sure to subscribe to our YouTube channel and hit that bell icon to never miss an update from Simplilearn.
Hello and welcome to Simplilearn. In this session, we're going to cover what Kubernetes is and why you would want to be using it within your DevOps team. But before we get started, remember to hit the like button if you like this video and the subscribe button if you want to get notified about more of these videos as they come out. And as always, if you have any comments about the content that we're covering or questions that you have on the subject, please post them in the comments below. So let's get started. We're going to break up this presentation into 4 key areas. We're going to talk about life before Kubernetes, which some of you are probably experiencing right now. What is Kubernetes? The benefits that Kubernetes brings to you, particularly if you are using containers in a DevOps environment. And then finally, we're going to break down the architecture and working infrastructure for Kubernetes so you understand what's happening and why the actions are happening the way that they are. So let's jump into our first section of life before Kubernetes. So the way that you have done work in the past, or you may be doing work right now, is really building out and deploying solutions into 2 distinct areas. One is a traditional deployment where you're pushing out code to physical servers in a data center, and you're managing the operating system and the code that's actually running on each of those servers. Another environment that you may potentially be using is deploying code out to virtual machines. So let's go through and look at the two different types of deployment that you may be experiencing. When you have applications running on multiple machines, you run into the potential risk that the setup and configuration of each of those machines isn't going to be consistent and your code isn't going to work effectively, and there may be issues with uptime and errors within the infrastructure of your entire environment. There's going to be problems with resource allocation, and you're going to have issues where applications may be running effectively and not effectively and not load balanced effectively across the environment. The problem that you have with this kind of infrastructure is that it gets very expensive. You can only install one piece of software or one service on one piece of hardware, so your hardware is being massively underutilized. This is where virtual machines have become really popular. With a virtual machine, you're able to have better resource utilization and scalability at much less cost. And this allows you to be able to run multiple virtual machines on a single piece of hardware. The problem is that VMs, or for virtual machines, are not perfect either. Some of the challenges you run with VMs is that the actual hardware and software needed to manage the VM environment can be expensive. There are security risks with VMs. There are security risks with VMs. There have been data breaches recorded about solutions that run in virtualized environments. You also run into an issue of availability, and this is largely because you can only have a finite number of virtual machines running on a piece of hardware. And this results in limitations and restrictions in the types of environment you want to be running. And then finally, setting up and managing a virtualized environment is time consuming. It can take a lot of time, and it can also get very expensive. So how about Kubernetes? Well, Kubernetes is a tool that allows you to manage containerized deployment of solutions. And inherently, Kubernetes is a tool that is really a next level maturity of deployment. So if you can think of your maturity curve as deploying code directly to hardware in a data center, and then deploying your solutions to virtual machines, the next evolution of that deployment is to use containers and Kubernetes. So let's kind of go through and look at the differences between a virtual machine and Kubernetes. And we've got a few here that we want to highlight, and you'll get an understanding of what the differences are between the two. So first of all, with virtual machines, there is inherently security risks. And what you'll find as we dig through the architecture later in the presentation is that Kubernetes is inherently secure. And this is largely because of the legacy code, the legacy of Kubernetes and where it came from. And we'll talk about that in just a moment. But Kubernetes is inherently secure. Virtual machines are not easily portable. Now, with that said, they are technically portable. They're just not very easily portable. Whereas with Kubernetes, it's working with Docker container solutions. It is extremely portable. That means that you can actually spin up and spin down and manage your infrastructure exactly the way that you want it to be managed and scale it on the demands of the customers as they're coming in to use the solution. From a time-consuming point of view, Kubernetes is much less time-consuming than with a virtual machine. A few other areas that we want to kind of highlight from differences. Virtual machines use much less isolation when building out the encapsulated environment than Kubernetes does. For instance, with a virtual machine, you have to run hypervisor on top of the OS and hardware, and then inside of the virtual machine, you also have to have the operating system as well. Whereas in contrast, on a Kubernetes environment, because it's leveraging Docker container or container-like technologies, it only has to have the OS and the hardware, and then inside of each container, it doesn't need to have that additional OS layer. It's able to inherit what it needs to be able to run the application. This makes the whole solution much more flexible and allows you to run many more containers on a piece of hardware than versus running virtual machines on a single piece of hardware. So as we highlighted here, VMs are not as portable as Kubernetes, and Kubernetes is portable directly related to the use of containerization. And because Kubernetes is built on top of containers, it is much less time consuming because you can actually script and automatically allocate resource to nodes within your Kubernetes environment. This allows the infrastructure to run much more effectively and much more efficiently. So this is why if we look at our evolution of the land of time before Kubernetes, why we are running into a solution where Kubernetes had to come about, because the demand for having more highly scalable solutions that are more efficient was just really a natural evolution of the software deployment model that started with pushing out code to physical hardware and then pushing code out to virtual machines and then needing to have a solution much more sophisticated. Kubernetes would have come about at some point in time. I'm just really glad it came about when it did. So what is Kubernetes? Let's dig into the history of Kubernetes and how it came about. So in essence, Kubernetes is an open source platform that allows you to manage and deploy and maintain groups of containers. And a container is something like Docker. And if you're developing code, you're probably already using Docker today. Consider Kubernetes as the tool that manages multiple Docker environments together. Now, we talk a lot about Docker as a container solution with Kubernetes. The reality is that Kubernetes can actually use other container tools out there, but Docker just simply is the most popular container out there. Both these tools are open source. That's why they're so popular. And they just allow you to be able to have flexibility in being able to scale up your solutions. And they were designed for the post-digital world that we live and exist in today. So a little bit of background, a little bit of trivia around Kubernetes. So Kubernetes was originally a successor to a project at Google, and the original project was Google Borg. Google Borg, it does exactly what Kubernetes does today, but Kubernetes was rewritten from the ground up and then released as an open source project in 2014 so that people outside of Google could take advantage of the power of Kubernetes containerization management tools. And today it is managed by the Cloud Native Computing Foundation. And there are many companies that support and manage Kubernetes. So for instance, if you're signing up for Microsoft Azure, AWS, Google Cloud, all of them will leverage Kubernetes. And it's just become the de facto tool for managing large groups of containers. So let's kind of step through some of the key benefits that you would experience from Kubernetes. So we have 9 key benefits. The first, it is highly portable. It is 100% open source code. And this means that you can actually go ahead and contribute to this code project if you want to through GitHub. The ability to scale up the solution is incredible. What's the history of Kubernetes being part of a Google project for managing the Google network and infrastructure kind of really sets the groundwork for having a solution that is highly scalable. Out of the high scalability also comes the need for high availability. And this is the desire to be able to have a highly efficient and highly energized environment that also you can really rely on. So if you're building out a Kubernetes management environment, you know that it's going to be available for the solutions that you're maintaining. And it's really designed for deployment. So you can script out the environment and actually have it as part of your DevOps model so you can scale up and meet the demands of your customer. Then what you'll find is that the load balancing is extremely efficient, and it allows you to distribute the load efficiently across your entire network so your network remains stable. And then also the tool allows you to manage the orchestration of your storage. So you can have local storage such as an SSD on the hardware that the Kubernetes is maintaining. Or if the Kubernetes environment is pulling storage from a public cloud such as Azure or AWS, you can actually go ahead and make that available to your entire system. And you can inherit the security that goes back and forth between the cloud environments. And one of the things you'll find consistent with Kubernetes is that it is designed for a cloud-first environment. Kubernetes as well is that it's really a self-healing environment. So if something happens or something fails, Kubernetes will detect that failure and then either restart the process, kill the process, or replace it. And then because of that, you also have automated rollouts and rollbacks in case you need to be able to manage the state of the environment. And then finally, you have automatic bin packaging, so you can actually specify the compute power that's being used from the CPU and RAM for each container. So let's dig into the final area, which is the actual Kubernetes architecture. And we're going to cover this at a high level. There's actually another video that you can that Simplilearn has developed, which digs deeper into the Kubernetes architecture. And so the Kubernetes architecture is a cluster-based architecture, and it's really about two key areas. You have the Kubernetes master, which actually controls all of the activities within your entire Kubernetes infrastructure. And then you have nodes that actually are running on Linux machines that are controlled by the master. So let's kind of go through some of these areas. So if we look at the Kubernetes master to begin with, we'll start with etc. This is a tool that allows for the configuration of information and the management of nodes within your cluster. And one of the key features that you'll find with all of the tools that are managed within either the master environment or within a node is that they are all accessible via the API server. And what's interesting about the API server is that it's a RESTful based infrastructure, which means that you can actually secure each connection with SSL and other security models to ensure that your entire infrastructure and the communication going back and forth across your infrastructure is tightly secured. Scheduler goes ahead and actually, as you'd expect, it actually manages the schedule of activities within the actual cluster. And then you have the controller, and the controller is a daemon server that actually manages and pushes out the instructions to all of your nodes. So the other tools really are the infrastructure, and you can consider them the administration side of the master, whereas controller is the management. It actually pushes out all of the controls via the API server. So let's actually dig into one of the actual nodes themselves, and there are three key areas of the nodes. One is the Docker environment, which actually helps and manage and maintain the container that's actually inside of the node. And then you have the kubelet, which is responsible for information that goes back and forth, and it's going to do most of the conversation with the API server on the actual health of that node. And then you have the actual Kubernetes proxy, which actually runs the services actually inside of the node. So as you see, all of these infrastructures are extremely lightweight and designed to be very efficient and very available for your infrastructure. And so here's a quick recap of the different tools that are available. And it really breaks down into two key areas. You have your Kubernetes master and the Kubernetes node. The Kubernetes master has the instructions of what's going to happen within your Kubernetes infrastructure. And then it's going to push out those instructions to an indefinite number of nodes that will allow you to be able to scale up and scale down your solution in a dynamic way.
Hi guys, in today's video I am going to show you how to install Ubuntu on Kubernetes. Kubernetes is an open source platform used for deployment and management of containers. So let's get started. Now the first step is to install the necessary dependencies using two of the commands. First is sudo apt get update, which gets all the updates, and then you have to enter a password. So this will take a few seconds. That's done. The next step is to install apt transport HTTPS. This is basically used to make repositories via HTTPS. So let's go ahead with that. Sudo. Okay, that's done. Going ahead, the next thing we have to do is to install the Docker dependency using the command sudo apt install docker.io. You have to choose Y, and this will take a few minutes. Okay, that's done. So after installing the Docker, we have to start and enable the Docker using the command sudo systemctl start docker and sudo systemctl enable docker. So now the Docker is enabled. So now we are done with the first step of installation. The next step is we have to install the necessary components for Kubernetes. Before that, we have to install the curl command because curl command is used to send data using a URL syntax. Let's install the curl command using the command sudo apt get install curl. So you have to select Y, and this will take few minutes. So moving on, the next step we have to do is download and add key for Kubernetes installation from a URL. So let's go ahead with that. Sudo curl. So this is where we get the key, and then we have to add it using sudo apt key add, and it's done. So the next step is we have to add a repository in a certain location. So before doing that, we have to change the permission of that file. So we do that using sudo chmod command. Okay, so the permission is changed. Now let's go ahead and save this file in that location. First, we have to enter this command into the file. This is a URL. Save as. So we have to save it in this location. Let's rename this to Kubernetes.list. Now let's see. Okay, so here it is. Now moving forward, now we have to check for any updates available. In the next command, we are going to install the Kubernetes components, that is kubelet, kubeadm, kubectl, and Kubernetes CNI. So let's go ahead with that. So this is going to take a few minutes. Now that's done. So the next step, we have to initialize the master node, and to do this we have to first use a swap off command to disable the swapping on other devices. So let's do that. Sudo swap off -a. Now let's go ahead with the initialization. Sudo kubeadm init. This is going to take a few minutes. Okay, so before going to the next step, to start the cluster, we have to use these three commands. Let's just copy paste it. Okay, that's done. So, moving forward, the next step is to deploy pods using the following command. Now the pods have been deployed to our network. To see all the pods, you have to use the command sudo kubectl get pods. There you can see the pods that have been deployed.
Hello, and in this video we're going to cover a common conversation, which is Kubernetes versus Docker. But before we jump into that, I want you to hit the subscribe button so you get notified about new content as it gets made available. And if you hit the notification button, that notification will then pop up on your desktop as a video is published from Simplilearn. In addition, if you have any questions on the topic, please post them in the comments below. We read them and we do reply to them as often as we can. So with that said, let's jump into Kubernetes versus Docker. So let's go through a couple of scenarios. Let's do one for Kubernetes and then one for Docker. And we can actually go through and understand what the problems specific companies have actually had and how they're able to use the two different tools to solve them. So our first one is with Bose. And Bose had a large catalog of products that kept growing and their infrastructure had to change. So the way that they looked at that was actually establishing two primary goals to be able to allow their product groups to be able to more easily catch up to the scale of their business. So after going through a number of solutions, they ended up coming up with a solution of having Kubernetes running their IoT platform as a service inside of Amazon's AWS cloud service. And what you'll see with both these products is they're very cloud friendly, but here we have Bose and Kubernetes working together with AWS to be able to scale up and meet the demands of their product catalog. And so the result is that we were able to increase the number of non-production deployments significantly by taking the number of services from being large, bulky services down to small microservices, being able to handle as many as 1,250 plus deployments every year. An incredible amount of time and value has been opened through the use of Kubernetes. Now let's have a look at Docker and see what a similar problem that people would have. So the problem is with PayPal, and PayPal processes something in the region of over 200 payments per second across all of their products. And PayPal doesn't just have PayPal, they have Braintree and Venmo. So the challenge that PayPal was really being given is that they had different architectures which resulted in different maintenance cycles and different deployment times and an overall complexity from having a decades-old architecture with PayPal through to a modern architecture with Venmo. Through the use of Docker, PayPal was able to unify the application delivery and be able to centralize the management of all of the containers with one existing group. The net result is that PayPal was able to migrate over 700 applications into Docker Enterprise, which consists of over 200,000 containers. This ultimately opened up a 50% increase in availability for being able to add in additional time for building, testing, and deploying of applications. Just a huge win for PayPal. Now let's dig into Kubernetes and Docker. So Kubernetes is an open source platform, and it's designed for being able to maintain a large number of containers. And what you're going to find is that your argument for Kubernetes versus Docker isn't a real argument. It's Kubernetes and Docker working together. So Kubernetes is able to manage the infrastructure of a containerized environment, and Docker is the number one container management solution. And so with Docker, you're able to automate the deployment of your applications, being able to keep them in a very lightweight environment, and being able to create a nice, consistent experience so that your developers are working in the same containers that are then also pushed out to production. So with Docker, you're able to manage multiple containers running on the same hardware much more efficiently than you are with a VM environment. The productivity around Docker is extremely high. You're able to keep your applications very isolated. The configuration for Docker is really quick and easy. You can be up and running in minutes with Docker once you have it installed and running on your development machine or inside of your DevOps environment. So we look at the deployment between the two and the differences. Kubernetes is really designed for a combination of pods and services in its deployment, whereas with Docker, it's around about deploying services in containers. So the difference here is that Kubernetes is going to manage the entire environment, and then that environment consisting of pods, and inside of a pod, you're going to have all of your containers that you're working on, and those containers are going to control the services that actually power the applications that are being deployed. Kubernetes is by default an auto-scaling solution. It has it turned on and is always available, whereas Docker does not. And that's not surprising because Docker is a tool for building out solutions, whereas Kubernetes is about managing your infrastructure. Kubernetes is going to run health checks on the liveness and readiness of your entire environment. So not just one container, but tens of thousands of containers. Whereas Docker is going to limit the health check to the services that it's managing within its own containers. Now, I'm not going to kid you, Kubernetes is quite hard to set up. It's of the tools that you're going to be using in your DevOps environment, it's not an easy setup for you to use. And for this reason, you want to really take advantage of the services within Azure and other similar cloud environments where they actually will do the setup for you. Docker, in contrast, is really easy to set up. You can, as I mentioned earlier, you can be up and running in a few minutes. As you would expect, the fault tolerance within Kubernetes is very high. And this is by design because the architecture of Kubernetes is built on the same architecture that Google uses for managing its entire cloud infrastructure. In contrast, Docker has lower fault tolerance, but that's because it's just managing the services within its own containers. What you'll find is that most public cloud providers will provide support for both Kubernetes and Docker. Here we've highlighted Microsoft Azure because they were very quick to jump on and support Kubernetes. But the reality is that today Google, Amazon, and many other providers are having first level support for Kubernetes. It's just become extremely popular in a very, very short time frame. The companies using both Kubernetes and Docker is vast, and every single day there are more and more companies using it, and you should be able to look and see whether or not you can add your own company to this list. Hello and welcome to Simplilearn. Today we're going to be giving you a Kubernetes tutorial. We'll provide the overview of how and why you should be using Kubernetes. But before we get started, don't forget to hit the subscribe button and the like button if you want to get notified about additional content from Simplilearn. And as always, if you have any comments about the material that you're about to see and you have any questions, please post them in the comments below. We do read them and we do reply to them. So with that said, let's jump in. So we're going to go through a bunch of things today around Kubernetes. We're going to cover what Kubernetes is and why you should be using it, along with the features of Kubernetes. We're also going to take a little bit of a look at Kubernetes versus Docker Swarm, as the two technologies do tend to get referred to quite frequently. And then we're going to do a deep dive into the actual Kubernetes architecture itself and how Kubernetes runs and operates within your network. And then finally, we're going to look at some Kubernetes use cases of how you can actually apply best learnings that other companies have used with Kubernetes. We'll finish everything off with a demo where we actually step through and use some of the actual codes that you can actually use to run from your terminal window to actually activate Kubernetes itself. So with that said, let's jump in. So why Kubernetes? Well, Kubernetes is really being built from allowing you to be able to have a more reliable infrastructure. The tool itself is designed to manage the containers you have within your network. It's very modular in architecture, which allows it to be very easy to be able to maintain and to be able to scale and meet the demands that your current customers are offering you today. The actual ability for you to be able to deploy and update software at scale is really at the heart and center of Kubernetes. It's really one of the reasons why Kubernetes was created, was to be able to scale up the deployment of software to tens of thousands of networks and servers within a data center. And then finally, when you start working with Kubernetes, really what you're doing is laying the foundation for building cloud native applications. And part of this comes from the architecture and history of Kubernetes, which we'll get to in a little bit. But it's good to know that as you're using Kubernetes and containerized solutions, that you're really building out an infrastructure that's designed for cloud-centric solution delivery. So let's dig into what Kubernetes is. So the history of Kubernetes is that it was originally developed by Google. Google actually used the precursor to Kubernetes to manage and maintain the data structure and data infrastructure that they had within their network. They really liked it, and one of the big benefits that Google provided is that they converted their code into an open source program that they released as Kubernetes in 2014 and made it open source. This means that any company can use Kubernetes. There's no charge for it. All you have to do is know how to use the command lines to actually get up and running. The benefit of Kubernetes being open source is that most cloud providers now support Kubernetes. So whether you're using Microsoft Azure, you're using Google Cloud or AWS, you'll find that you can actually use Kubernetes. And Kubernetes at its core really helped eliminate manual processes. So it allowed for deploying and scaling your container-based solutions much more effortless within a cloud environment. So let's jump into the features of Kubernetes and why you'd want to be using it. And we have a number of features that we want to kind of step through. Again, the first thing that Kubernetes is a strong benefit of is that it eliminates those manual processes and allows you to automate them. The benefit you have from this is that you can then scale up your automation across your entire network. So whether you are managing 10 nodes within your network or whether you're managing 10,000, doesn't matter. You have the ability to scale. That's something you simply didn't have before. Kubernetes also will manage the actual containers themselves, including the security, the storage, and the networking within those containers. The great benefit of working with Kubernetes is that not only is it a cloud-centric solution, but it was really built from a core need of a secure solution. So security is at the heart and center of all the work you're doing, which really helps benefit any teams scaling out containers. Your Kubernetes environment will be constantly monitored so that when you have nodes that have your containers, the health of those nodes is being constantly communicated back to the Kubernetes environment so that the entire environment is always being managed and checked. So if you have any additional hosting and launching that needs to be done. Kubernetes will help you automate those manual processes. If something does go wrong, you can actually set up your Kubernetes environment to do an automatic rollback. Again, this is just allowing you to have that confidence that when you're deploying a solution, that everything is going to work within that environment. And then finally, Kubernetes will allow you to mount and add the storage needed to run your apps. So whether you have storage such as a local SSD storage device physically on the hardware, or if you're connecting to storage via the cloud, Kubernetes will allow you to access the storage you need, how you're accessing it. So let's look a little bit into the differences between Kubernetes and Docker Swarm. So if we just step back a little bit, Kubernetes and Docker often get connected with each other, largely because Kubernetes manages containers, and Docker is really famous for creating the most popular container management solution, which is called Docker. If you're a developer, you're probably already using Docker today. So one of the things that Kubernetes is really, really good at is that it manages containers at scale, just massive volume of containers. Docker Swarm is Docker's alternative to Kubernetes. It's a tool that allows you to also manage large numbers of containers. There are differences between the two of them, and right now, without doubt, the most popular open source solution out there is Kubernetes from Google. It just has a massive community behind it, and the community really have embraced Kubernetes. Yes, the original product was developed by Google, but Google has been great stewards, and they've allowed the community to drive the future evolution of the product. Docker Swarm is actually managed and developed by Docker. There is a smaller community, but it is also a very passionate community, and the reason being is that both products are actually pretty good, and you just really kind of have to choose which one you want to go with. Without doubt, there is more customization and extensions built for Kubernetes simply because the community is just so much bigger than the Docker Swarm community. But with that said, Docker Swarm is really easy to set up. So if you are used to working within the Docker environment, you'll be able to set up Docker Swarm very, very quickly. Whereas Kubernetes does require some heavy lifting to get up and running. Now, with that said, if you are using Microsoft Azure or Google Cloud, very often those environments will actually set up Kubernetes for you, so you don't have to do it, and you can actually then focus on writing the instructions to maintain your Kubernetes environment. Kubernetes has extremely high fault tolerance. Again, it's because Kubernetes has been road tested. The foundation for Kubernetes is based on managing sites such as Gmail, Google.com, YouTube. I mean, just incredibly robust environment compared to Docker Swarm, which has lower fault tolerance. And this really kind of leads into the final areas where Kubernetes does guarantee strong clusters management, just a really reliable environment. Docker Swarm, however, is able to take containers and deploy them into large clusters very, very quickly. Two interesting differences is that with Kubernetes, the load balancing is still manual, and it'll be interesting to watch how Kubernetes matures that skill set. In contrast, load balancing is automatic within Docker Swarm. So let's dig into the Kubernetes architecture and just kind of expose some of those key elements. If you're interested in actually having a very deep dive into Kubernetes architecture, we have already got another video, and we should have a link in the comments that you can select that will take you to that video as well. But this will provide you an overview as well. So the way that Kubernetes runs is that it uses nodes to actually manage all the individual hardware within a specific unit. And so a node is really a physical machine in a data center or a virtual machine. And when you're setting up an environment on a cloud environment such as Microsoft Azure or Google Cloud or AWS, Kubernetes will be managing the containers within that node. So it's important to know that Kubernetes itself doesn't work with the individual nodes, but actually works with the cluster as a whole. And why that's important is that it's a tool to manage your entire environment. It's not going to come down and manage the individual node itself. It's going to manage the entire environment. The actual control of data within a cluster is very, very flexible within Kubernetes. You can have local storage, such as an SSD card or a traditional local storage, or you can actually connect to the cloud and use cloud-based storage. And the benefit that cloud-based storage offers you is that you are increasingly moving your solution into more of a hardware-free environment, cloud-based architecture, where you're not reliant on a physical piece of hardware within your data center. And why that's important is that it gives you the opportunity to scale up your solutions much more effectively. So if you need to increase the hard drive space, you can do that very easily from the cloud, whereas local hardware is a little bit harder to manage. Great news, Kubernetes gives you both options to be able to choose from. And so the next layer down is the actual management of the application, and that's within a container. And as mentioned earlier, Docker is the most popular container solution out there. And again, if you're a developer, you're probably already using Docker, as it was a natural maturity from using a virtual machine. But Kubernetes itself will actually manage the containers that you have within your nodes. And so you have a collection of containers working together, and then you pull those together into what's called a pod. And what's great is Kubernetes will actually manage the health of that pod. So if a container or a pod fails, Kubernetes will automatically deploy out a replica so your entire environment can stay running and being efficient. And so the pods themselves will actually be managed by Kubernetes. You really want to let Kubernetes do this, because it's allowing you to step away from the manual management of pods. Your environment is just going to be healthier relying on Kubernetes to do the actual management of all the pods you have out there. So you are able to allow access to, from services outside of your Kubernetes, and this is done through a process called ingress. And going back earlier, we talked about how security is a key part of all the work that goes into Kubernetes. And this is a great example of where you can use an external service but still have that layer of security that is vital for your solution. Because to be able to provide the ingress connection, Kubernetes requires an SSL connection, which automatically allows for a secure data transfer. Absolutely fantastic. So here we have an overview of the actual architecture. On the right hand side, we have our nodes and the pods within our nodes, and within those pods are the containers. On the left hand side, we have the master architecture, and the master architecture is the actual brains behind the work that you're doing. It's actually managing the schedules, the controllers for all of the nodes. And then at the bottom left hand side, we have commands which are written on a local workstation, and those commands are pushed up to the master. So let's kind of dig a little bit further into the architecture of the master. So the master itself is comprised of a number of key components. Again, this is the tool that's going to manage your entire Kubernetes infrastructure. The key components that you have are the etcd, control manager, scheduler, API server, and the key four components are etcd, or the cluster store, the controller manager, the scheduler, and the API server. The cluster store is the tool where all the details of the work that you're doing is stored. It's going to manage the rules, it's going to manage all the instructions, and this is where you're going to post that information. The controller is actually going to then perform the tasks that are stored in the cluster store. And as you'd expect, the scheduler is the tool that actually controls when instructions and tasks are pushed out to all the pods and nodes within your network. And then finally, you have an API server which allows you to be able to control all the operations. The actual operations themselves are all instructions written as REST instructions, which allows you to take advantage of the security that has been built into REST. And so you end up with a worker-slave architecture, and slaves are all the different nodes and pods within your network. And so a pod itself will have one or more multiple containers, and then each container and then each pod will have a Docker container, a kubelet, and a Kubernetes proxy. And these are tools to allow you to communicate back up to the master layer. So the Docker is the actual container itself, and this is going to actually run your application. And the instructions here are to pull down the correct container from the Docker images that you have within your library. The kubelet is going to manage your containers, and your container instructions that will be deployed to the kubelet are going to be written in either YAML or JSON format. YAML is just great. If you haven't had a chance to start working with YAML, I certainly encourage you to do so. It's very easy to pick up. If you know any XML, you'll pick up YAML very quickly. And finally, the Kubernetes proxy is the tool that interacts with the master environment within the Kubernetes network and allows all the instructions that are pushed to the kubelet and to Docker to be able to perform effectively. So let's have a look at some of the companies using Kubernetes. There are a lot. And if you're doing any work today in the cloud, or even if you're just starting off and doing some simple work in the cloud, there's a really good chance that you are using Kubernetes. But some of the companies that you would probably not surprised are using Kubernetes are Spotify, SAP, eBay, and of course some of the big companies out there, Google with their entire network of solutions, and Microsoft with Office and their tools. So let's take a step into now let's have a look at a Kubernetes use case. And in this example, we're going to look at the New York Times and how they use Kubernetes to solve a problem that their IT department was struggling with. So when New York Times started working out of their data centers, their actual deployments were small and the applications were managed across VMs. But the problem is that as New York Times became more of a digital company, they started building more digital solutions. And at some point, they realized that what they needed to do was to embrace the cloud and move all their solutions to the cloud. However, their first step of using the cloud, and this is, I think, typical for a lot of companies, is that they treated the cloud-hosted provider in the same way as they would with a data center. And at some point, they realized they had to take a change. And this is where the development team came in and they said, look, how about we stop thinking of our solutions as a data center, even though they're being run in Amazon, and start thinking of them as cloud-first solutions. And so what they proposed and what they ended up doing was using Google Cloud Platform with Kubernetes as a service to provide greater efficiency. And so by using Kubernetes, they had the following advantages. They're able to deliver solutions at a much faster speed, and in the world of digital content, speed is everything. They were able to reduce the time for deployment from minutes to seconds, and by doing this, they were able to increase the amount of time, uptime for the actual infrastructure. Updates began to be deployed independently and when required, so you didn't have to schedule an event when you do the deployment. It just happened. And there was a more unified approach to deployment from the engineering staff, which just made the whole solution more portable. So the fundamental end line for the New York Times is that by leveraging Kubernetes, they were able to automatically manage their deployments and scheduling of solutions instead of having to do solutions through a more traditional ticket-based system. It just really speed up the efficiency of the New York Times website. So let's finally kind of look into some of the important terminologies before we take our time to do a demo. So we have 6 terms that we're going to look through, and we'll let you read through these, but we have a cluster, which is a set of machines, physical or vertical, in which applications are managed and run. We have a node, that are the worker machines that run containerized applications and other workloads. There is the pod, which is within a node and is a group of containers that are deployed together on the same host. We have replication controllers, and a replication controller is used to define a pod's life cycle rather than to create the pods directly. We have a selector, which is an expression matched label to filter specific resources. Labels are key value pairs that are attached to objects such as pods. The key value pair or the label can be filtered, organized, and perform operations on resources. Replication sets define how many replicas of each pod will be running and managed when you want to either replace a pod when it dies. Annotation is a label with much larger data capacity. A name is a resource as it is identified. Volume is the directory in which data is accessible to a container. Namespaces provide additional qualification to a resource's name. And then finally, servers is an abstraction of a top-tier pods which provide a single IP address and DNS name by which the pods can be accessed. So at this time, what we want to do is take you through Kubernetes demo, actually runs through some of these basic controls. So we're going to take you through a video of how to actually install Kubernetes and to use some of the basic instructions. So Kubernetes is the most widely used platform for container management. The first step is to actually install the necessary dependencies. So let's see if there's any updates first. So to check if there's any updates, we're going to use the command sudo apt-get update. We're going to enter in our password, and this looks like it's going to take a few minutes because we've got a few updates that need to be running. All right, we're done. All right, next we're going to write sudo apt-get install -y apt-transport-https, and this will install all of the dependencies we need to actually start installing the solutions needed for Kubernetes. All right, that was quick. Now we're going to put in the Docker dependency, and the way we do that is write the command sudo apt install docker.io. Got a typo, correct that quickly, and put in y, so for yes, and we continue. And that's going to take a while because we're going to download and install Docker off the internet, and it's quite a large installation. Now would be a good time to go get a cup of coffee because it'll take us about a minute to get this all done. Once we actually have Docker installed, we'll actually go ahead and we'll start Docker and enable Docker using our sudo commands. All right, so that's all done. So let's start to enable Docker. We're going to use sudo systemctl start Docker and sudo systemctl enable Docker. This will be quite quick. So the next step is to install all the components for Kubernetes, and we're going to install the curl command and then kubelet, kubec, and then kubeadm. We're going to install all the necessary tools. We're going to do the curl command, kubelet, kubec-c2, and kubeadm. And so let's go ahead and put in the sudo apt-get install curl. We're going to get a prompt. We can say yes for that. And then after this, we'll go ahead and install Kubernetes. So what we're going to do is we're going to actually put in the Kubernetes key. So that's going to be sudo curl-s, and then we have a long URL, which is https packages.cloudgoogle.com apt-doc apt-key.gpg sudo apt-key. There we go. Correct my typo there. Okay, now we have to go ahead and change permissions of a folder. So we do that with sudo chmod 777 /etc/apt/sources.list.d. All right, we're good. Okay, now you want to go ahead and open up your text editor, and we're going to make an actual edit, and we're going to create a simple file. And so what we're going to type in is the following command: db http apt-kubernetes.io/kubernetes-xenial main. And we're going to save this file in the etc folder, and then look for, and then apt, which is going to be down a little bit. And there we have it. And we're going to save it in the apt-get updates. And we're going to name this file as kubernetes.list. And we'll save that. And then we can close out the notepad and go back to the terminal window. And let's look and see if there are any updates again. So we're going to go ahead and run apt-get update, and it's going to run any updates from what we've created. And we want to check what's in the folder. And so we do cat/etc/apt/sources.list.d/kubernetes.list. And there we are. It shows what we have in that text file. And so we're going to go ahead and we're going to install kubelet, kubec2, and kubeadm. But first we're going to have to initialize the master. I'm going to show you an error you would get if you were to install kubelet and the other files too quickly. You get the following error. All right, so we have installed kubelet, kubeadm, kubectl, and Kubernetes CNI. And so we're going to go ahead and use sudo swap-up -a. And now we're going to initialize the master node. And we're going to do that with sudo kubeadm init. And this will take a few minutes for it to initialize. All right, so that's all done. All right, so we're going to deploy the pod to a network, and we have two commands that we're going to use. We use sudo kubectl apply, and then we have a long path we have to type out, which is -f https raw githubs content.com corios flannel master documentation cube-flannel.yml. What we have to do is we have to actually go ahead and deploy the nodes first. So we're going to do that by creating mkdir-p, and then we have $home-.cube. We'll create that new directory, and sudo cp-i, and then the path will be etc/kubernetes/admin.conf, and then $home/.cube.config. And then the final one will be sudo chown $open paren id -u close paren colon $open paren id /g close paren $home/.cube/config. All right, now we're going to go ahead and deploy, and let's see. Oh, I think I have a typo in my command here. Yep. Oh yeah, I did have a typo, and so I've got that incorrect now. So documentation is actually spelled with a T, not an S. And then we're going to go ahead and we're going to put in the next line, which is sudo kubectl apply -f, and then we're just going to change a little bit of the actual link here, and that runs great. And now we want to be able to see all of the pods that we have in our network. And so we're going to do that by writing the command sudo kubectl get pods -all -namespaces. And it should list all of our pods. We only have one. There we are. There's all of our content. Now we're going to, so there's only one node, so let's see what we have here. So we're going to use the command sudo kubectl get nodes. There we are, just one node. So our final step is to actually go ahead and deploy a service. And so what we're going to go ahead is deploy the nginx service, and we're going to do that with the command sudo kubectl run --image equals nginx. And we're going to put this into port 80, so it's going to be nginx-app --port equals 80 --environment env equals open quotes domain equals cluster close quotes. And we're going to write one more command, which is sudo kubectl expose deployment nginx-app --port equals 80 --name equals nginx-http. And once we've done this, we will be able to then run the command to actually see our services. And there'll be quite a few of them. And our final command is sudo docker ps-a. There we are, quite a lot of lists, quite a lot of services listed. So there you are. That's the instructions on how to get Docker up and running, and with some basic commands. It's worth going through a few times to get right, but once you actually have the Kubernetes environment up and running, managing your Docker environment and containers, it's extremely powerful.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Welcome to Kubernetes architecture from Simplilearn. We're going to take a deep dive into the Kubernetes architecture. If you're new to Kubernetes, we already have an introduction that goes and provides an overview of Kubernetes, and we have the link below so you can go straight to that if you want to have a refresher. Otherwise, hang around and join us in this presentation. And if you want to see more of these videos, hit the subscribe button, and if you want to get notified, hit the notification bell, and every time we post up a new video, you'll get the notification right onto your phone or on your desktop that the new video has been uploaded. And as always, if you have any questions, please post them in the comments below. We do read the questions and we try to respond to all of them as quickly as we can. With that said, let's jump into Kubernetes architecture. So we're going to break out the presentation into the following areas. We're going to cover what Kubernetes is and why you want to be using it. We're going to introduce the actual architecture and provide an overview of how it contains the containers and the other components that you'd have within the architecture. We'll also compare Kubernetes with Docker Swarm, and one of the things that you hear with Kubernetes almost in the same breath is Docker. We have to be careful not to confuse Docker from a container point of view and Docker Swarm, which is a container management tool. And Kubernetes is also a container management tool, so we'll compare the two of those. And then we'll look at the hardware and software components, and then finally do a deep dive into the architecture of Kubernetes and provide a case study of where Kubernetes has been used successfully in the past. So let's jump into this. So what actually is Kubernetes? So Kubernetes is a tool that was designed to actually help manage and contain large groups of containers. It was developed originally by Google out of the Google Borg solution, and then open sourced by Google. The actual environment allows you to manage large groups of containers. So if you're a developer in DevOps and you're working with Docker, then you're used to the concept of a container. And you'll also know that containers and cloud technologies tend to be almost breathed in the same breath. So the work that you're doing with Kubernetes is to be able to manage large groups of containers inside of the cloud. The thing that's great about working with Kubernetes is that it is incredibly flexible and it allows you to have incredibly complex applications run efficiently. So let's step into why you'd want to use Kubernetes. So a couple of key points. Kubernetes itself is an open source solution originally developed by Google, but it is available on most cloud platforms today. So AWS, Google Cloud, Microsoft Azure, all of them support Kubernetes. And what you'll find is as you're setting up your infrastructure, particularly if you're using containers, you'll see that the support for Kubernetes is floated up very, very efficiently and effectively by all three vendors. It's extremely useful for being able to manage large modular environments, and that's really kind of the, I think one of the big benefits of Kubernetes is its modularity, is that it really breaks down containers into their smaller parts. And once you do that, it becomes much more efficient for you as an administrator to be able to manage that entire environment. The reproducibility of Kubernetes is extremely high. You can build out infrastructures very quickly and have them being able to manage and have containers coming on and off and killed and created to be able to help load balance your entire environment. And so again, we keep talking about containers, but that's really what Kubernetes is all about, is being able to manage your applications that are managed through containers and being able to do that in a virtualized infrastructure. And the thing that's also really good with Kubernetes is it's really easy to deploy solutions. You just have to use a simple curl call and you can actually push out your Kubernetes infrastructure. So let's have an overview of the Kubernetes architecture. So Kubernetes is really broken up into three key areas. So you have your workstation where you develop your commands and you push out those commands to your master, and the master is comprised of four key areas which essentially control all of your nodes, and the node contains multiple pods, and each pod has your Docker container built into it. So consider that you could have really almost an infinite number of infinite number of nodes being managed by the master environment. So you have your cluster, which is a collection of servers that maintain the availability and the compute power, such as RAM, CPU, and disk utilization. You have the master, which is really components that control and schedule the activities of your network. And then you have the node, which actually hosts the actual Docker virtual machine itself and be able to actually control and communicate back to the master the health of that pod. And we'll get into more detail on the architecture later in the presentation. So you keep hearing me talk about containers, but they really are the center of the work that you're doing with Kubernetes. And the concept around Kubernetes and containers is really just a natural evolution of where we've been with internet and digital technologies over the last 10-15 years. So before Kubernetes, you had tools where you're either running virtual machines or you're running data centers that had to maintain and manage and notify you of any interruptions in your network. Kubernetes is the tool that actually comes in and helps address those interruptions and manages them for you. So the solution to this is the use of containers. So you can think of containers as that natural evolution from 15, 20 years ago. You would have written your code and posted it to a data center. More recently, you probably posted your code to a virtual machine and then moved the virtual machine. Now you actually just work directly into a container, and everything is self-contained and can be pushed out to your environment. The thing that's great about containers, they're isolated environments, very easy for developers to work in them, but it's also really easy for operations teams to be able to move a container into production. So let's kind of step back and look at a competing product to Kubernetes, which is Docker Swarm. Now, one of the things that we have to remember is that Docker containers, which are extremely popular, are built by the company Docker and made open source. And Docker actually has other products. One of those other products is Docker Swarm, and Docker Swarm is a tool that allows you to be able to manage multiple containers. So if we look at some of the benefits of using Docker Swarm versus Kubernetes, one of the things that you'll find is that both tools have strengths and weaknesses. But it's really good that they're both out there because it helps it really kind of justifies the importance of having these kind of tools. So Kubernetes was designed originally from the ground up to be auto-scaling, whereas Docker Swarm isn't. The load balancing is automatic on Docker Swarm, whereas with Kubernetes you have to manually configure load balancing across your nodes. The installation for Docker Swarm is really fast and easy. I mean, you can be up and running within minutes. Kubernetes takes a little bit more time, is a little bit more complicated. Eventually you'll get there. I mean, it's not like it's going to take you days and weeks, but it is a tool that's, when you compare the two, Docker Swarm is much easier to get up and running. Now, what's interesting is that Kubernetes is incredibly scalable, and that's its real strength, is its ability to have strong clusters. Whereas with Docker Swarm, its cluster strength isn't as strong when compared to Kubernetes. Now, you compare it to anything else on the market, it's really good. So this is kind of a splitting hairs kind of comparison, but Kubernetes really does have the advantage here if you're looking at the two compared to each other for scalability. I mean, Kubernetes was designed by Google to scale up and support Google Cloud network infrastructure. They both allow you to be able to share storage volumes. With Docker, you can actually do it with any container that is managed by the Docker Swarm, whereas with Kubernetes, it manages the storage with the pod, and a pod can have multiple containers within it, but you can't take it down to the level of the container. Interestingly, Kubernetes does have a graphical user interface for being able to control and manage the environment. The reality, however, is that you're likely to be using terminal to actually make the controls and commands to control your either Docker Swarm or Kubernetes environment. It's great that it has a GUI to get you started, but once you're up and running, you're going to be using terminal window for those fast, quick administrative controls that you need to make. So let's look at the hardware components for Kubernetes. So what's interesting is that Kubernetes is extremely light. Of all the systems that we're looking at, it's extremely lightweight. It allows you to have, if you compare it to like a virtual machine, which is very heavy, Kubernetes is extremely lightweight and hardly uses any resources at all. Interesting enough, though, is that if you are looking at the usage of CPU, it's better to actually take it for the cluster as a whole rather than individual nodes, because the nodes will actually combine together to give you that whole compute power. Again, this is why Kubernetes works really well in the cloud, where you can do that kind of activity rather than if you're running in your own data center. So you can have persistent volumes such as a local SSD, or you can actually attach to a cloud data storage. Again, Kubernetes is really designed for the cloud. I would encourage you to use cloud storage wherever possible rather than relying on physical storage. The reason being is that if you connect to cloud storage and you need to flex your storage, the cloud will do that for you. I mean, that's just an inherent part of why you'd have cloud storage. Whereas if you're connecting to physical storage, you're always restricted to the limitations of the physical hardware. So let's kind of pivot and look at the software components as compared to the hardware components. So the main part of the components is the actual container, and all of the software running in the container runs on Linux. So if you have Docker installed as a developer on your machine, it's actually running inside of Linux. That's what makes it so lightweight. And really, one of the things that you'll find is that most data centers and cloud providers now are running predominantly on Linux. Inside of the container itself is then managed inside of a pod, and a pod is really just a group of containers bundled together. And the Kubernetes scheduler and proxy server will then actually manage how the pods are actually pushed out into your Kubernetes environment. The pods themselves can actually then share resources for both networking and storage. So pods aren't pushed out manually. They're actually managed through a layer of abstraction and part of their deployment. And this is the strength of Kubernetes. You define your infrastructure, and then Kubernetes will then manage it for you. And there isn't that problem of manual management of pods if you have to manage the deployment of them. That's simply taken away, and it's completely automated. And the final area of software services is on ingress, and this is really the secure way of being able to have communication from outside of the cluster and passing of information into that cluster. And again, this is done securely through SSL layers, and allows you to ensure that security is at the center of the work that you have within your Kubernetes environment. So let's dive now into the actual architecture before we start looking at a use case of how Kubernetes is being employed. So Kubernetes, again, is we looked at this diagram at the beginning of the presentation, and there are really three key areas. There's the workstation where you develop your commands, and then you have your master environment, which controls the scheduling, the communication, and the actual commands that you have created, and pushes those out and manages the health of your entire node network. And each node has various pods. So we break this down. So the master node is the most vital component. With the master, you have four key controls. You have etc., controller manager, scheduler, and API server. The cluster store, etc., this actually manages the details and values that you've developed on your local workstation, and then we'll work with the controller, schedule, and API server to communicate that out, those instructions of how your infrastructure should look like to your entire network. The control manager is really an API server, and again, this is all about security. So we use RESTful APIs, which can be packaged in SSL to communicate back and forth across your pods and the master, and indeed the services within each of them as well. So at every single layer of abstraction, the communication is secure. The schedule, as the name would imply, really schedules when tasks get sent out to the actual nodes themselves. The nodes themselves are dumb nodes. They just have the applications running on them. The master is really doing all of the work to make sure that your entire network is running efficiently. And then you have the API server, which has your REST commands and the communication back and forth across your network that is secure and efficient. So your node environment is where all the work that you do with your containers gets pushed out to. So a work is really it's a combination of containers, and each container will then logically run together on that node. So you'd have a collection of containers on a node that all make logical sense to have together. Within each node, you have Docker, and this is your isolated environment for running your container. You have your kubelet, which is a service for conveying information back and forth to the service about the actual health of the Kubernetes node itself. And then finally, you have the proxy server, and the proxy server is able to manage the nodes, the volumes, the creation of new containers, and actually helps pass the health of the container back up to the master to see whether or not the container should be either killed, stop started, or updated. So finally, let's see where Kubernetes is being used by other companies. So, Kubernetes is being used by a lot of companies, and they're really using it to help manage complex existing systems so that they can have greater performance, and with the end goal of being able to delight the customer, increase value to the customer, and hence increase value and revenue into the organization. So an example of this is a company called BlackRock, where they actually went through the process of implementing Kubernetes. So BlackRock had a challenge where they needed to be able to have much more dynamic access to their resources. They were running complex installations on people's desktops, and it was just really, really difficult to be able to manage their entire infrastructure. So they actually then pivoted to using Kubernetes, and this allowed them to be able to be much more scalable and expansive in the management of their infrastructure. And as you can imagine, Kubernetes was then hooked into their entire existing system and has really become a key part of the success that BlackRock is now experiencing of a very stable infrastructure. And the bottom line is that BlackRock is now able to have confidence in their infrastructure and be able to give that confidence as back to their customers through the implementation and more rapid deployment of additional features and services.
Kubernetes specific to AWS Cloud Platform. So what's a part of this tutorial and demo? What's in store for you? At our offset, I would like to cover the basics of orchestration tools. As most of you would know, Kubernetes is one of the most popular orchestration tools in recent times, specifically for applications which are cloud native and deployed on some or the other types of containers. But what are these orchestration tools? Why would one need to use orchestration tools? What are the facilities or features provided by these orchestration tools? That's the first thing that I'm going to cover. After that, I will pick two orchestration tools specific to container management, Docker Swarm versus Kubernetes. I'm going to compare them with regard to the features that they provide, the use cases that they cover, what facilities that they provide, and when to use what. After that, I will get into a little bit details of the Kubernetes architecture, what exactly is required for setting up a Kubernetes cluster, what runs in a control plane or a master node, what runs as a part of the worker node. After that, I will end the tutorial by running you through a demo by setting up a 3-node Kubernetes cluster on AWS platform. I will use something called as kops, which is one of the admin tools for setting up production grade Kubernetes cluster. So I will use this to set up a 3-node cluster on AWS. Alright, now that we set the context right, let me get started. So what are orchestration tools? The application development and the lifecycle management from the time the application is developed, connecting the source code to your continuous integration, to testing them all along your development process, and eventually moving it down to production, managing your production servers, the dependencies that your software has, the requirement that it has in terms of the hardware, the features of fault tolerance, self-healing capabilities, auto-scaling, all this has complicated over the last few years. As a part of DevOps, one thing that everyone is interested in is managing all this application dependency or lifecycle management using some or the other kind of a tool. So that's where these orchestration tools have become very, very popular. So what kind of features that they provide is you'll have to just let them know what are the kinds of tool sets that is required, what are the fault tolerance mechanisms that it has to be adopted to, what kind of a self-healing capabilities that application will have to need, and if at all there is any auto-scaling features that is required. If at all you can bake in all these specific parameters into your tool, your orchestration tool becomes a one-stop shop for all your deployment and configuration management needs. That's where these orchestration tools have become a very, very popular and relevant, specifically these days when people are more and more interested in adopting DevOps practices. Alright, so having said that about orchestration tools, let's concentrate on two of these orchestration tools specifically for container management, Docker, Swarm, and Kubernetes. Many of the applications that are written for these kind of containers are called or kind of fall into a category of cloud native, where the application need not know much about the underlying infrastructure or the platform where these applications are running. So these two, along with Apache Mesos, there are many other container management systems, but I'm going to pick Docker, Swarm, and Kubernetes for comparing the features that is provided by these two frameworks. For the sake of comparison, I picked up Docker Swarm and Kubernetes just because of the reason that both of them operate in the space of container management. They do something very, very similar to containers. That's the similarity that exists between these two orchestration tools. However, there's a big difference that exists when it comes to the types of containers that both of them cater to, and also the capacity of workloads they can be used for. Docker Swarm is a cluster management solution that is provided by Docker Container. Docker is one of the very popular containers of recent times, and in case you have your applications that is totally powered by only Docker containers, if you have a need where you want to run a cluster of servers which are running only Docker containers, Docker Swarm should be your choice for your orchestration tool. Kubernetes, on the other hand, can cater to any other types of containers other than Docker, and including Docker as well. So in case you have your applications which have got Docker in them, which have got RKT in them, which have got LXC in them, or any other type of container, Kubernetes should be your choice of orchestration tool. A Docker Swarm can manage up to 40, 50 or 60 max nodes. So in case your application is totally written in Docker containers and the load or the expected cluster size is about 50-60 nodes, Docker Swarm should be your choice of orchestration tool. On the other hand, Kubernetes is something that was open sourced by Google, and the scale of operations that Kubernetes can cater to is Google scale. So if in case your applications are more than 1,000 nodes, that is where Kubernetes comes into play. That's the big difference that exists between Docker Swarm and Kubernetes. Putting those differences aside, let me compare Docker Swarm and Kubernetes based upon other features which are similar in nature. The first and important feature that Kubernetes provides is something called as auto-scaling. If at all the load on your cluster is too high and your application is experiencing more load, so Kubernetes can add new nodes to your cluster. Of course, you'll have to configure Kubernetes in order to have those capabilities where it can spin up new VMs or new nodes. If at all you do that configuration correctly, Kubernetes has got the capacity, or it has got the feature where it can bring up a new node and add it to the cluster on the fly based upon the load that exists at that moment. On similar lines, if at all the load is not too high, it can identify a few of those nodes which have got less number of replicas or less number of application containers running on it. It can move them to some other node and also scale down by deleting few nodes from your cluster. So that is the powerfulness of auto scaling which is provided by Kubernetes, and this unfortunately does not exist in Docker Swarm. The other feature of load balancing, specifically application load balancing. So Docker Swarm gives you an application level auto load balancing. However, Kubernetes gives you the flexibility of manually configuring any other type of load balancer of your choice for application load balancing. Installation. As I mentioned earlier, Docker Swarm is a loose cluster of containers which are running on nodes. It is very easy to spin up a new node and then connect them to a swarm. And this can be done in a very loosely coupled way where you can create swarms of your choice. Nodes are allowed to connect to swarms and quit or leave the swarms on the fly. So in and all, the installation is pretty easy and fast. Kubernetes, on the other hand, the configuration of Kubernetes, the way to spin up a big cluster specifying the size of the node, how many master nodes, how many config planes that you want, how many nodes that you want. It's a pretty tough thing to bring up a Kubernetes. Scalability. Kubernetes strength is very strong. They are very tightly coupled, and even they have the capability where on the cluster size things or the nodes can be increased on the fly based upon the requirement. On a Docker Swarm, the cluster strength is weak as compared to Kubernetes. Worker nodes can be added to a swarm. Worker nodes can be asked to leave a swarm or can be taken out of a swarm based upon the requirement. So this is kind of a loosely coupled architecture for Docker Swarm, while Kubernetes, the cluster is very tightly coupled. Since Docker Swarm runs only Docker containers, containers find it very easy to share data and a lot of other things with each other because they all have the same signature. They are all from the same family. So it's very easy for them to share not just volumes, but a lot of other things. However, for Kubernetes, since it manages containers of different types, if your application has to share some data across different containers, there's a little bit of a complexity in how you would want your containers to share data. Also, when it comes to Kubernetes, Kubernetes groups containers in something called as pods, while a pod can have either one container, that's the preferred choice, or multiple containers. And the idea of pod is like each pod can run in any other node. It's not guaranteed that you would want to have 2 or 3 pods to be running on the same node. That makes data sharing a little bit of a different thing compared to Docker Swarm. GUI. So there's not a good enough UI tool in Docker's form, at least the CE edition of it, which will allow you to get to know what is running on your containers, what is the size of the containers, what is the volume of the containers, and all that stuff. There are some free and open source tools like Portainer, which gives you a good visibility into your running Docker containers. However, there's nothing at a swarm level that is provided by Docker. Kubernetes gives you an out-of-the-box dashboard, which is easy to configure and set up. You can also club it with some metrics services, and you can also get information about the size of the cluster that is running, what is the load on the nodes, and stuff like that. All this across your cluster in a very beautiful dashboard perspective. So that way, this is a little bit of a good UI for Kubernetes, while for Docker Swarm, there isn't anything that is provided out of the box. Let me spend some time in explaining a little bit about the Kubernetes architecture, what comprises of the Kubernetes cluster, what resides in a master or a control plane, and what resides in a worker node. This is a very high level depiction of a Kubernetes cluster. So this is the master node, which has got something called as a cluster store, a controller, a scheduler component, and an API server. And these are the bunch of nodes that are connected or administered by the master node. The master node can be 1, 3, 5, typically an odd number. This is as per the typical cluster management thing, where you would need the master nodes to be in odd numbers, so that whenever there's any contention in terms of what needs to be deployed where, or where to give the job to whom and stuff like that, all the masters would cast their vote and they would decide on the outcome. So that's the master node, and there are a bunch of nodes which can be connected and administered by the master node. kubectl, or the command from using which anybody can assign some workloads to the cluster, can also be run either on the same node or on a separate node. So kubectl is the command line tool that we will be installing and using in order to fire up our commands to our cluster. So if at all I have to put up a job on our cluster, if I have to give out any specific commands to my cluster, all this is done using kubectl. There's a bunch of REST APIs which is used by kubectl, and kubectl will talk to the API server and fire up the commands specific to my cluster. What runs in the master node? Master node, without saying, it's the most important component of any of the cluster. If at all you're running cluster with only one master node, if your master node goes down, there's no other way that you can, or any user can talk to the different nodes in the cluster. So master node is the most vital component responsible for the complete Kubernetes cluster. There's always one node that should be running as a master node. That's the bare minimal requirement for your cluster. So what are the other components in the master node? The most important one is called etcd. So this is nothing but a data store, a value of key value pair, which is stored, which contains all information about your cluster. So all the configuration details, which node is up, which worker node is down, all this information is stored in the cluster store. So all the managers would access this cluster store before they go ahead and decide any other work item or anything else that has to be done specific to your cluster. What's in the controller? As the name says, controller is something, it's like a daemon server that is running in a continuous loop. All the time it is responsible for controlling the set of replicas, the kind of workloads that is running based upon the configuration that the user has set in. So if at all, if you are aware of something called as replication controllers, endpoint controllers, namespace controllers, all these controllers are managed by the controller component. If any user asked for some 3 replicas of a particular pod or a service to be running, and if at all any of the nodes goes down or the pod goes down for whatever reason, the controller is the one who wakes up and assigns this particular job or the pod to some other available node by looking up for the details using in the cluster store. That's the importance of the control manager or the controller. The scheduler assigns the tasks based upon whoever is asked for any job to be scheduled, based upon a time frame or based upon some criteria. It also tracks the working load as to what exactly is the load, who is running what in the cluster, and places the workload on whoever is the available resource at that time. Alright, API server. This is one other important component in our Kubernetes cluster, where how would the end user deploy or give out any sort of a workload onto your cluster? All the requests come to the API server. So this is an entry point for all your requests that come into your cluster. Anybody wants to deploy something, anybody wants to scale up a controller, anybody wants to bring down few services, anybody wants to put in a service, all this will have to come in as a part of a REST API endpoint. And API server is the entry point in case you don't want somebody to access your cluster, in case you want only specific people or a specific users to be running some specific workloads. You can set all those role-based access control for this API server. So this is the entry point for anyone who wants to submit any job to your cluster. So that's a quick overview about the master node. What are the important components of a master node? Now let's go over to what runs in a worker or a slave node. As I mentioned earlier, slave nodes are something where the job that is submitted to your cluster is eventually run as a pod, as a service, as a container. So in Kubernetes world, there is something called as a pod. A pod is nothing but a combination of a container. It is a wrapper around your running containers. So slave nodes or the worker nodes typically run these pods. So that is where the whole workload typically gets run. But there are a bunch of other components in the node which also manages what runs in the pod, who has to have access to the pod, what is the state of the pod, is it in a running state, is it going down for some reason, and all that stuff. So let's quickly go over those components that is there in the slave node. The most important component, in my opinion, that should be on the node should be the container runtime. As I mentioned earlier, Kubernetes can run any different types of containers, not just Docker. So in case you want to have a node which wants to have Docker running on it, RKT running on it, LKC running on it, or any other container environment that is running on it, you have to ensure that the specific container runtime environment is available on that specific node, so that whenever a job is submitted, a description of what needs to be run as a part of the pod, what should be the image with which it should be powered, and what kind of a container to spin up. So that's what, when the job is finally assigned to this particular node, it would definitely need a container runtime to be up and running. So that exists only if at all the container runtime is installed and running on your Kubernetes worker node. Okay, now that we know what our Kubernetes node can run, how would somebody assign a job to our node? That is using something called as a kubelet. As the name says, kubelet is a small subset which talks to the kube API server. So any node which has to run any kind of a pod, all these instructions are passed around by the kube API server to the kubelet. And kubelet is capable of processing whatever job that is assigned to it and ensuring that so many pods and so many services are spun up based upon the requirement. The last component that exists in the worker node is the kube proxy or Kubernetes proxy. This plays a very, very important role, acting as a load balancer and a network proxy. So what typically happens is whenever the pods are running in nodes, the pods can be typically running in any node. There is no affinity towards any node on which these pods are running, because pods or containers are something called as ephemeral. They can run anywhere. So how would somebody reach out to these applications that is running in some pod which is running in one container now and running in probably another container, another node altogether tomorrow? So that is where your Kubernetes proxy comes into picture, and this component will ensure that any container that is spun up or any pod that is spun up, it keeps track of all these pods and kind of connects the endpoints or acts like a DNS server, so that it knows when somebody is trying to reach out to this particular service, which is the pod on which the service is typically running. So that plays a very, very important role by acting as a load balancer and a network proxy. Now that at a very high level we know what are all the components that make up of our Kubernetes cluster, let's go ahead and create a small cluster. We'll spin up this cluster on AWS platform. Finally, we get to the demo section of my tutorial. Now that you guys are aware as to what is Kubernetes, what is the use of Kubernetes, you also know at a very, very high level what are the components of a cluster. What is a master node or a control plane? What are the components of a master node and what should be existing in a worker node. You're probably thinking that it's maybe pretty hard to kind of set this up. So let me demystify that by running you with a quick demo of how to set up a simple 3-node Kubernetes cluster using a tool called kops. And I will be doing this whole setup on my AWS cloud. Okay, so what is kops? Kops is nothing but a simple tool. This is an admin tool that allows you to bring up production grade Kubernetes environments. As I said, setting up a Kubernetes cluster on a bare metal is a little challenging. So that is why I would use something called as a kops, and I will use this on my cluster, which I will spin up on my AWS instance. So I have an AWS account, and what I will do first is I will first spin up an EC2 server. I will power this with one of the Linux AMIs, and I will install kops on it. Now this will be my starting point from where I'm going to trigger running up a big cluster. In our case, I'll try to keep it a little small. I don't want too many nodes in my cluster. I'm going to have one master node and 2 worker nodes. This whole operation would be done programmatically by installing this kops admin tool. So as you may know, AWS, it's a little hard for me to programmatically run other components or rather bring up servers. It's not pretty simple. So what I would do is I will create an IAM role which will attach to my EC2 server so that my EC2 server gets powered with all the required role so that it can go ahead and spin up cluster based upon my configuration that I'm going to specify. Alright, so once I have my cluster set up, I will also install kubectl, which you would probably know by now is nothing but a command line utility using which I can kind of connect to my cluster, give out some jobs, put some pods and stuff like that. So I will use kubectl. I will also have a pair of SSH keys so that from this machine, I would be able to successfully get onto the master node and submit jobs on my behalf. So let me begin by first logging into my AWS account. All the steps that I will be following to bring up my AWS cluster, Kubernetes cluster, will be documented, and I'll be sharing you this document in a GitHub repository so that in case anybody wants to try, you'll be more than happy to find all the required instructions in one place. Okay, now the first thing that I would need is to launch an AWS EC2 instance. Now this is an instance where I'm going to install kops and I will use it as a base server from where I'm going to fire some commands which will bring up my Kubernetes cluster. So let me log into my AWS account and let me stick to one particular region and let me bring up one EC2 instance. Alright, so let me launch my instance. Let me choose, doesn't matter either ways, but in case you want to try it on your free tier, I would recommend choose free tier only and choose an AMI of your choice. Let me choose this instance. I will make it T2 micro. That is good for me. Configuration, instance details. All right. I don't want to change anything here. That looks good. Maybe I will change this 30 gig. That's good for me. Let me add a tag to my instance. I will name this as my kops server. Alright, I would need a bunch of ports to be opened up. So what I will do is I will create a new security group called open to the word. I would not recommend that you do this since I don't want to, it'll take a long time for me to specifically pick and choose the ports that has to be open for running my cluster. I don't want to do that. I will open up all the HTTP and HTTPS ports so that it's quicker. So I will say all TCP. I would say from anywhere, just to be on the safer side. I also open HTTP and HTTPS, and I will make this anywhere and anywhere. This is good for me. I will say review and launch. Alright, so I chose a T2 micro instance. Just for the sake of easiness, I've opened up all the ports, and the instance details are, you've seen what is that I've chosen. Alright, now important part is like I would need a key pair. I need to create a new key pair. I will call this as Simplilearn keys. I will download this key pair and then I will launch the instance. It will take some time for my EC2 instance to come up. In the meanwhile, what I'll do is I will convert. I have this PEM file, which is the pair of keys, the SSH keys with which I need to log into my EC2 instance. So I'll need to convert this because I'm trying to connect from my Windows box. I would need to convert this into a PPK file. So I have puttigen. I'm going to load my set of keys here and convert that key into a PPK key. All right, open. All right, I would say save. Hang on, save private key. Yes. I would say Simplilearn or Simplilearn private key. I'll save this here. Done that. That's also, this is my public key, which is the PEM file, and this is my PPK or my private key. Now using the private key, I will log into my EC2 instance. Okay, now my EC2 instance is up and running. It is running in this Ohio region, and this is the IP address of my public IP address of my machine. So let me connect to it. So I use MOBA Xterm, which is nothing but an SSH emulator. You can use PuTTY or any of these sessions which allow you to do an SSH. This is my IP address of my machine, and since I've spun up an Amazon AMI, this is the default user. I would need to specify the private keys for my session, and this is the private key for my session. Say OK. I am in my Amazon EC2 instance. So let me look at what are the other things that I need to do. Alright, so as I said, I just brought up my EC2 instance, but I would need my EC2 instance to run few things on my behalf so that it can spin up other EC2 instances. It can also talk to an S3 bucket where I'm going to store the instance state of my Kubernetes cluster. Also some sort of an auto scaling group because I want to spin up more and more instances. I also want to have a private hosted zone using my Route 53. So I would need my EC2 instance to have all these sort of permissions for my server. So what I would do is I will go and create a permission, a role in the EC2, rather in the AWS IAM role, and I will attach this IAM role to my EC2 instance. Alright, so let me go to my IAM, which is nothing but the identity and access management. I will create a role called as possibly COPS role. I will create a role. This role will be used by my EC2. So I'm going to click on EC2. I will say next permissions. They would need a lot of permissions, specific permissions to be very honest. And the permissions are all listed out here. S3, EC2 and all this stuff. Just to keep it pretty simple, what I would do is I will create a role with the administrative access. Alright, so I don't want any tags. I'm going to review. I'll create a role name. I will say COPS role for EC2. Alright, so I'm going to create a role which has got administrative access roles. I'm going to create a role. So this would ensure that my EC2 instance from which I'm going to run my cluster would have all the prerequisite permissions so that it can go and spin up instances, talk to S3 buckets and all that stuff. Alright, now let us have our running instance get powered by this role. So I will connect this role to my running instance. Alright, so this is my EC2 instance that is running. I will say action, attach, replace IAM roles. So there is no role as of now. I would want my COPS role for EC2. This is the role that I created. So I want this new role to be assigned to my EC2. Alright, great. Now my EC2 instance, which is my COPS server, has got all the required permissions so that he can create a cluster on my behalf. Great. Now before this, let me do a sudo yum update -y. So that any of the, because this is a newly provisioned VM, I just want to ensure that all my system libraries are all updated. So that when I do install COP and kubectl and all those things, none of them will fail because of some dependency or package issues. So I'm just running a sudo update -y so that all the libraries are updated. Okay, looks like it is done. So let me go ahead and install COPS. COPS is a pretty simple installation. It is available in a particular location. I have to just copy this and ensure that I do a curl and I install this particular stuff. Alright, so it is fetching the COPS tool. It's installing for me. Once it is copied down, let me change the mode so that I can execute it, and then also let me move it to my user local bin so that it is available for me in my path. Okay, that's pretty much the COPS installation. Let me also do one other thing. Let me install something called as kubectl. So this is what would be, a tool using which I'm going to be firing my commands to my Kubernetes cluster once it comes up. Right, this is a pretty smaller executable. So kubectl. Alright, so I have kubectl as well as COPS installed on my EC2 server now. Okay, now what I'll do next is I'm going to create an S3 bucket in AWS so that the Kubernetes cluster state is persisted in this bucket. So let me create a simple bucket with this name, S3 bucket with this name. So let me go to S3 and let me create a simple bucket with this name. I will just say create a bucket. Okay, so the Simplilearn.Kubernetes is the bucket that I created. So this bucket will store all information about my cluster. Let me now go and create a DNS entry or a DNS zone or a AWS Route 53 hosted zone for my cluster. So this is required so that I can give a cluster name for my Kubernetes cluster that I'm coming up. So I will create a private hosted zone, and possibly I will call this as Simplilearn.in. So this will be my name of my private hosted zone. In case you already have any other public hosted zones in your name, you can always put a Route 53 hosted zone specific for your domain name. Since I don't have anyone, I'm just going to create a simple private hosted zone. So let me head down to Route 53, click on any of these and you'll get these hosted zones out here. So I'm going to create a hosted zone here. I'm going to create a hosted zone. Click on create hosted zone. This would be Simplilearn.in. I want to create a public. No, I don't want a public. I want a private hosted zone, and I'm going to associate my VPC ID for this hosted zone. Since I'm going to try out all my exercises in the Ohio region, I will associate the VPC of the Ohio region for this. Alright, so this is the one that is specific to the Ohio region. So I will say this one, I'll say create a hosted zone. Great. Now let me come back to my EC2 box. My EC2 is all powered with whatever it needs in order to go ahead with the installation of my cluster. Only few things that I need to take care of is that, now that I put a name for my cluster, I also have an S3 bucket that I've configured for my cluster. I will have to ensure that I need to put in these two configurations as a part of my cluster building activity. So I will open my bash rc file and I'm going to export these two variables. If at all you remember well, these two variables are nothing but the cluster name, which is nothing but the the private hosted zone that I created, and the S3 bucket where I'm going to create, or rather I'm going to store my cluster state. So let me copy these two and open up my bash rc file. Alright, so I will just add these two and copy these and export them out as my variable. I'm going to save this here. Now let me ensure that this gets picked up. Alright, I've got these two that I've configured, and I've also ensured that these environment variables are set. Now let me create a pair of SSH keys. This is to ensure that I can log into the box that I'm going to be provisioning as a part of my cluster. SSH-keygen. I don't want to give any parameters. Let it go to the home directory with the default name and without any passphrase. Alright, so I created a bunch of my key pair. Now I'm all set to go ahead and run my kops. Now kops will ensure that this will take some time for the cluster to come up, but this is exactly how I would define my kops command. I already got it copied here. So kops create cluster. The state of the cluster will be stored in this particular variable, which is what I have exported out. The number of node count is 2. Node count is the worker node count. If at all I don't specify, there's a configuration for specifying the master or the control plane as well. If I don't specify that, the default one is 1. So I'm going to create one primary or the master node and two worker nodes. Size of my master, node size of the worker nodes, what are the zones where I want this to be created, and where do I store the cluster information. And okay, I've already added this master count. This is actually not required, but this is the command that I'm going to fire off so that I bring up my cluster. All right, that went off very fast, but this actually did not create a cluster. It is just the definition of a cluster, and that's why this came out very fast. Now that everything looks good with whatever configuration that I specified, now let me go ahead and create the cluster by saying kops update cluster -a. Yes. Now this will take some time, a good 5 to 10 minutes for it to, because this will actually start provisioning the servers. And as I mentioned earlier, based upon my configuration, I'm going to come up with one master server and two nodes, or the worker nodes. All right, so this is the command for me to validate the cluster. And I'm going to try it out first. I'm pretty sure that it will fail because all my servers are not up yet. It is taking some time. The validation, everything failed. But let me try to look at my EC2 instances and see how many servers do I have running as of now. If you see, I had only one server that I had started, which was my cop server, and automatically the other three instances, one is called nodes.simply.in, these two are the nodes, and this is the master node. So these three got automatically provisioned by the kops command that I ran. Alright, so this may take a while for it to get validated, a good 5 to 10 minutes. So what I'll do is I'll pause the video now and I'll come back once the cluster is up and running. it's been a good 8 to 9 minutes since I started my cluster. So let me validate now. Okay, seems good. So there's a master node, minimum 1, max 1, some nodes which are nothing but the slave nodes or the worker nodes. There are 2 of them, T2 micro, subnet. So my clusters seem to be up and running, and my cluster name is simplilearn.in. So what I would want to do is now let me just log into the master and see if I can run some pods. So let me get back to my installation steps here. The validation cluster is done. So let me log into since my cluster name is simplilearn.in, this is the way to log into my box. So let me get into my box. So if you see here, this is the host name of the machine that I'm currently in. If you see this is nothing but this COP server. This is a server. Now from here, I'm trying to get into the master box. Alright, so if you see, the IP address has changed. I was in a different box. I'm in a different box now. If I see host name, you'll find a different host name. So this is 153, which is nothing but the master node. Yep, it's 153. This is the particular host. So I'm getting into this machine now. So I started the cluster from my COP server here. It ran and brought up 3 nodes. So I'm actually getting into my master node and see if I can run some pods on it. Alright, so let me try kubectl get cluster info. Try kubectl get nodes. Alright, so there are 3 nodes here, master node and 1 master node and 2 worker nodes. So let me see if I have some pods here. Kubectl get pods. So there's no pod as of now. So what I'll try to do is let me just spin up a very simple pod just to check if my connections everything is correct or not correct. I have a simple Node.js application that I've built and I've got a container for that. This is already pushed to the Docker Hub registry. It is called Simplilearn Docker Hub, and the image name that I have here is called my node app, and I will use this image to power one of my pods that I will run. So this is the way in which I'm going to launch my pod. Let me show you these commands. Kubectl run, the name for my deployment that I'm going to run, -- image, and this is the image that is going to be powering my container. So this is Simplilearn Docker Hub / my node app -- replicas equal to I want 2 replicas to be running, and the port that I want to expose this particular pod is on 8080. So let me run this. As soon as this is run, it creates something called as a deployment. Alright, now let me just say I'm not really interested in the deployment. I'm interested in checking if at all the pods are up and running. So I will say kubectl get pod. Alright, so that was pretty fast. So I have 2 pods that are running here. These are 2 replicas because I asked for 2 replicas. These pods are running, so I can run kubectl describe pod pickup. Alright, I can pick up any of the pod name and see what is the pod, what is the information does it contain, from what is the image that is pulling, what is the image name, ID. This is actually running my pod, which is actually spinning up a container. Great, so far so good. So in Kubernetes, the pods are ephemeral, so they can be there at any time, cannot be at any time. If I need to expose my pod outside, I will have to create a service for my pod. So what I'll do is I'll create a very simple service by exposing this particular deployment. Before that, let me check kubectl get deployment. So there's a deployment that is created. The deployment name is Simplilearn app. So I will expose my deployment Simplilearn app as I'll just expose this. Let me see. Alright, I'm not specifying what type and all. I don't want to get into the complications of what are the different types of exposing this service and all that stuff. So if I don't specify anything, it gives me something called a cluster IP. So this is where my pod is actually exposed. So let me just check if at all this pod is up and running. I'll just try a simple curl command. Curl http : this is my cluster IP, and the port is 8080. If at all I hit this, it's actually hitting my application and giving me whatever. I put a simple sys.out kind of a thing where I'm just printing the container ID of whatever pod is serving being served out of. So I'm actually hitting my container and I'm getting this output from the container. So everything looks good. My container is up and running. So let me just go and clean it up. I'll say kubectl delete deployment Simplilearn app. This should get rid of all the pods that I created. Kubectl get pod. Alright, these pods are interminating things. Let me just check kubectl get services. There's one service. I don't want this service. Let me delete that. Kubectl delete service. I want this. All right, this looks good. So let me come back to my host, my COP server from where I'm running. So I managed to successfully verify this pod, see if everything is up and running. So what I'll do is I'll just go ahead and complete this demo by going and getting rid of my cluster. So cops delete cluster -es. All right, so this will ensure that it will clean up my complete cluster that I created. So I had 3 or 4 running instances. If you see that, all the 3 are shutting down because the cops server, which had cops installed on it, has now got a mandate to go ahead and shut down and clean up the whole instances and all those things that are created as a part of my deployment.
Hey everyone, I welcome you all to this Puppet full course by Simplilearn. In this complete course, we will learn everything that we need to know to excel in Puppet. We have Mathav and Anjali to guide us through this journey. We shall begin with having a basic understanding of Puppet and what is its relevance today. After that, we shall dive deeper and understand the components of Puppet followed by its architecture. After checking its architecture, we shall look at the process to install Puppet and configure it in our local system. Moving forth, we shall see companies that have adopted Puppet and all about writing manifest in Puppet. After that, we will check regarding the Puppet community and Puppet DSL, post which we shall see the hands-on demo that will explain the working of Puppet from scratch. After we have ample knowledge regarding the tool, we shall understand the difference between Chef, Puppet, Ansible and SaltStack. Finally, we shall take a look at some of the interview questions that might increase your chances of cracking any Puppet interview. So before we begin, make sure that you have subscribed to our YouTube channel and don't forget to click that bell icon to never miss an update from Simplilearn. Now without further ado, let's begin with our introduction.
Hello, this is Matthew from Simplilearn. We're going to focus specifically on Puppet. So in this session, what we're going to do is we're going to cover what and why you would use Puppet, what are the different elements and components of Puppet and how does it actually work, and then we'll look into the companies that are adopting Puppet and what are the advantages that they have now received by having Puppet within their organization. And finally, we'll wrap things up by reviewing how you can actually write a manifest in Puppet. So let's get started. So why Puppet? So here is a scenario that as an administrator, you may already be familiar with. You as an administrator have multiple servers that you have to work with and manage. So what happens when a server goes down? It's not a problem. You can jump onto that server and you can fix it. But what if the scenario changes and you have multiple servers going down? So here is where Puppet shows its strength. With Puppet, all you have to do is write a simple script that can be written with Ruby and write out and deploy to the servers your settings for each of those servers. The code gets pushed out to the servers that are having problems, and then you can choose to either roll back to those servers to their previous working states or set them to a new state and do all of this in a matter of seconds. And it doesn't matter how large your server environment is, you can reach to all of these servers. Your environment is secure, you're able to deploy your software, and you're able to do this all through infrastructure as code, which is the advanced DevOps model for building out solutions. So let's dig deeper into what Puppet actually is. So Puppet is a configuration management tool. Maybe similar tools like Chef that you may already be familiar with. It ensures that all your systems are configured to a desired and predictable state. Puppet can also be used as a deployment tool for software. Automatically, you can deploy your software to all of your systems or to specific systems. And this is all done with code. This means you can test the environment and you can have a guarantee that the environment you want is written and deployed accurately. So let's go through those components of Puppet. So here we have a breakdown of the Puppet environment. And on the top, we have the main server environment. And then below that, we have the client environment that would be installed on each of the servers that would be running within your network. So if we look at the top part of the screen, we have here our Puppet master store, which has and contains our main configuration files. And those are comprised of manifests that are actual codes for configuring the clients. We have templates that combine our codes together to render a final document. and you have files that will be deployed as content that could be potentially downloaded by the clients. Wrapping this all together is a module of manifest templates and files. You would apply a certificate authority to sign the actual documents so that the clients actually know that they're receiving the appropriate and authorized modules. Outside of the master server where you'd create your manifest templates and files, you would have Puppet Client is a piece of software that is used to configure a specific machine. There are two parts to the client. One is the agent that constantly interacts with the master server to ensure that the certificates are being updated appropriately. And then you have the factor, that the current state of the client, that is used and communicated back to through the agent.
So now that we know what Puppet is, let's look into the Puppet architecture. So Puppet has a master-slave architecture. As you can see here, on the top we have the Puppet master and below we have the Puppet clients. So the Puppet master is the system where your system administrator sits. The clients are those systems which require configuration. You can have n number of clients connected to the Puppet master. So don't worry, we look into each of these components in detail. Firstly, we have the Puppet master. So the Puppet master is where the system administrator sits and he or she types in the codes here. So the codes are not only written in the system, but they are also stored here. And whenever the client requires these codes for their configuration, they simply request it. So manifest is the first subcomponent of the Puppet master. These are the actual files where the codes are written. So in case of Puppet, these are Ruby files. Modules tie manifest, templates, and files into a single unit. Now these codes dictate the instructions for performing various tasks on your client. The next component is templates. So if manifests are your code, templates are the data. So let me explain this to you with an example. Consider you want to create a file called index.html on one of your client machines. So what you do is, you write the code for creating this file in your manifest and the content of this file is written in your templates. Then you simply link them. But here's the thing, when you divide your code and data in this way, it's a very clean structure. So it's preferred to do it in this manner. Files are your static contents. So the files are basically sent to your client and they are simply downloaded at the client. There is no execution or compilation involved with your files. Now this is where files and templates are extremely different. Because with templates, they are never sent over to your client. The templates are simply read by the parser at the master itself. Modules ties the manifest templates and files into a single unit. So modules is not a separate component as such, it just provides a very clean hierarchy. This is the most important component of the Puppet master, CA, which stands for Certificate Authority. Now, as we will see later in this video, the Puppet master and the Puppet client communicate through an exchange of SSL certificates. So when the client sends over the certificate to the master, CA provides the master the authority to sign these certificates. The minute the master signs a certificate, the master is basically saying that yes, this client is registered with me and I agree to exchange data with this client. Our next component, Puppet client, of course these are the systems that require to be configured. Agent is a service installed on the client. The agent is solely responsible for all the communication between the master and the client. And finally, we have Factor. So Factor is responsible for collecting all the data about the present state of our clients and sending this data over to the Puppet master. At the master, this data is compared against the manifests, which are your code files, and then these manifests are sent over to the client depending upon the results of this comparison. So now that we had a look at the various components of Puppet, let's see how these work together. So we have a master and we have 3 clients. Now before any information can be transferred between the master and the client, it's important that these components recognize each other. Also, there needs to be an encrypted channel of communication between each pair of master and client. Now all the data which is transferred between the master and the client, it flows through this channel. So let's see how this entire procedure of recognizing each other works. The core of this procedure are the SSL certificates. SSL stands for Secure Socket Layer. Secure Socket Layer is a security protocol and it forms an encrypted channel between 2 components. What this encrypted channel ensures is that all the data that is passed through this channel is not accessible by any other system outside. So it provides complete security. Okay, so we will consider a very general scenario. We have a master and a client here. This is not the Puppet master or the Puppet client. They are just two systems and we are just going forward with master-slave architecture. So the client so far is not a client. It is just a system and we will refer to the system as system A. So system A sends over a client certificate to the master. Associated with this client certificate is the host name of system A. Now master goes through this certificate, it sees the host name and then it decides whether it wants to form a communication link with the system A. If it does, it signs the certificate and this signed certificate is sent back to system A. Now the system A is officially a client. The minute the master signed the client certificate, it said that yes, I am willing to exchange information with this system and I do take the system as one of my clients. So now that the system is officially a client, it can request for data from the master and the master will simply send over the data. Now we are here to talk about Puppet. So if this was a Puppet master and this was a Puppet client, then the first three stages will be the same. So the Puppet client sends over the certificate to the master signs the certificate, sends it back, and the client requests for data. Now by data here, of course, we mean the configuration data. Those are the manifest or even could be your files. So what happens after this request? After this request, the factor service which is present on your clients collects all the information regarding the present state of your client. So this information could include the operating system that's installed on them, the various number of software present on them, the versions of these software. Now all this information is collected, it's called the fact and it's sent over to the master. At the master, this information, that is the facts, is compared against the manifest. So why does the master do this? The master basically compares the facts against the manifest to know if what the manifest is about to perform is already performed on these systems. So if the manifest has some additional functionality, they are compiled into catalogs and then these catalogs are sent over to the client. Now remember those agent services which existed in your clients? Here's where they come in. The agents take the catalog and execute them on the client. Once executed, these catalogs make the required changes on the client and a report is generated. This report is then sent back to the master. So the master keeps record of all the changes that's made in the system, and this comes very handy when one of the systems fail and it's required to be rolled back to its previous working state. So this entire procedure can be repeated n number of times and it can be repeated at regular intervals. So if you have a scenario where a system needs to be configured every 30 minutes, what you can do is you can set your interval and automatically every 30 minutes your systems will be configured.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So today I'll be showing you how you can use Puppet to install Apache on one of your client machines. So we'll be using two machines here. We'll have a server and we'll have a node machine. The server is essentially your master. The node is your client. I'm just using the term server and node instead because I want to keep it very close to as they are used in the commands. Now both these machines are going to be CentOS 7 machines and I have Oracle VM VirtualBox installed on my machine. So on that I've simply created two virtual boxes, both CentOS 7 of course. So before we move on to the actual demo, I'll just take you through the various steps. So first we'll install the Puppet server on our server or master machine. We'll then start this server service. We then shift over to our node or the client machine and we'll install the Puppet agent service. We will then start this service too. And the minute you start the Puppet agent service, an SSL certificate is created. So this certificate will have the host name of your node attached to it. And this is how the master or the server will recognize this certificate and then it'll sign this certificate. So once your master or the server signs the certificate, you can write your manifests. So the manifests are just the code for configuration. And once that too is done, you shift back to your client or the node system and you run the agent service. So once you run the agent service, your manifest or your catalogs, because as you know, the manifests are compiled into catalogs, these are executed on your node and this will make the required changes. So that's how this entire process is going to work. Now let's move on to the actual demo. This is my Oracle VM VirtualBox Manager. The last two machines you see here are the ones we'll be using for this demo. The Puppet server is your Puppet master, Puppet client, of course, is the client. So let's just have a look at these two machines. This is my Puppet server. So just so you can differentiate, guys, the terminals have been set accordingly. Puppet server has a black background with white text, and Puppet client here has a black background with green text. So we'll move on to server machine or the master machine because that's the one we'll be working on first. So before we begin, we need to set the host name of our master to Puppet. So this is a very essential step in the configuration of Puppet. If you miss this out, there are quite a lot of other changes you'll have to make in certain files. So let's do this first. So that's the command to set the host name. The last word you see there, that's the new host name you want. Okay, so now we'll just check if our host name is set. So just type host name. And yeah, it's Puppet. So next, we will check the IP of this machine. So for that, you just type ifconfig. Enter. So this is your IP, guys, under ENP0S3 init's value, that is 192.168.2.183. Of course, the IP will differ for you guys, needless to say. So note that down somewhere because we'll require it when we are configuring our client. Okay, so now you want your Puppet server and your client to communicate. So for this, we need to remove certain firewalls. So the command for this is sudo, because we want the root permission, systemctl stop firewall d, and put in the password. Okay, so all your firewalls are removed. So the next step, now we start on with our Puppet process. So we download the Puppet labs at first. Now guys, ensure that your systems, your virtual boxes in this case, are connected to the net. Also, you won't be getting an IP if it's not for the first time. So here's the command to download the Puppet lab. Enter the password again. Okay, so the Puppet Labs is downloaded. Now you need to install this. So installation, guys, we will be installing the Puppet server on the master machine or the Puppet server machine. So this may take a while. So that took a while, so I just skipped to the last part where it's completed. The installation process is over. Now we need to make a small change in our system config Puppet server file. So let's just move to the file first. This file will open in VI editor. So this line here, it basically allocates memory for your Puppet server. Now you do not need 2 GB. So we are going to reduce this size. $512 MB should be enough. So guys, notice here I did not type the B, okay? So I just changed this to XMS 512M. Let's save that. Always remember to open this file using sudo. Otherwise, saving the changes you made could be quite troublesome. Okay, so now we can start our Puppet server service. We enable the service. Okay, so that's done. So basically our Puppet server service has started. It's running presently. So for a while we are done with the server machine. Let's move on to our client machine. Okay, first things first, we open our etc host file with sudo because you need to make a few changes and save it. Open this in the VI terminal. Okay guys, so here you have to add this one line at the end. Type in the IP for your Puppet server machine. Puppet -master. So let's save this file. Now we'll move on to downloading Puppet Labs on our Puppet client. So the command is the same that we use for Puppet server. So Puppet Labs is downloaded. Now we need to install the Puppet agent service here. Again, this will also take some time. Puppet server is installed. Let me just clear this window. Now that our Puppet agent service is installed, we'll start this service. So I'll just type in the command for starting the Puppet agent service. As you can see here, ensure changed stop to running. So basically the service was not running before and now it's changed to the running state. And while we executed this command, not only did the service start running, but an SSL certificate was also created. So this certificate should have the host name of this machine, that's a Puppet client machine, attached to it. So let's just check what the host name of our machine is. That's localhost.localdomain. So our certificate should have this attached to it. So guys, the first time your client sends a certificate, the name of the certificate itself is usually the host name of the machine. So our certificate's name should be localhost.localdomain. We'll check this on our master system, and that's where we'll sign the certificate to. So first we list out all the certificates. In our case, since we have just one client and we just started the client, we should have technically just one certificate, and it will be so. Yeah, so this is our certificate, localhost.localdomain. We'll now sign the certificate. Okay, sorry about that. Just need to remove these brackets. Yeah, as you can see here, the certificate is signed. Sign certificate request here. So once the certificate is signed, the request for signing the certificate is removed. That's this line. Now that a certificate is signed, we can begin to write our manifest. So let's move into a manifest folder and we'll create a placeholder file. So we'll create a file called sample.pp. This is just a sample file. We won't be writing anything in this file as of now. So we are just checking here. We are just creating this file and then we'll go to our client machine and just check there if we can access this file from there. So now we'll move to our client machine. So let's test the connection. So as you can see here, it says applied catalog in 0.03 seconds. So our catalog is executed on our client machine. Now our catalog was just a placeholder basically. So the file that we created, which is sample.pp, had no content and we were just testing our client. Now let's go back to our master server, put some content into this file and see how the execution takes place. So we'll open our file sample.pp which we created earlier in the VI editor. Let's type our code here. So node, and then within the brackets we enter the host name of our client machine. So this ensures that our manifest is executed on this particular machine. Now the Apache service package on CentOS is called the HTTPD. So this line that I just typed in is the action. It will ensure that the HTTPD package is installed on your client. And that's it. So this is our code. We'll save it. Now let's go back to our client machine and test it. So this is our client machine. And our catalog's applied on the client. So I just cleared the screen. Now we'll start the Apache service. Okay, so how do we see if it's running? We just need to go to our browser and at localhost, you must have the testing page for your Apache. So we type localhost, enter. And yeah, this is the testing page for Apache. So as you can see, we have successfully used Puppet to install the Apache service on our Puppet client. And this is the end of our demo.
So let's have a look at companies that are using Puppet today. There are a number of companies that have adopted Puppet as a way to manage their infrastructure. So companies that are using Puppet today include Spotify, Google, AT&T. So why are these companies choosing to use Puppet as their main configuration management tool? And the answer can be seen if we look at a specific company. Staples. So Staples chose to take and use Puppet for their configuration management tool and use it within their own private cloud. The results were dramatic. The amount of time that the IT organization was able to save in deploying and managing their infrastructure through using Puppet enabled them to open up time to allow them to experiment with other and new projects and assignments, a real tangible benefit to a company. So let's look at how you write a manifest in Puppet. So manifests are designed for writing out in code how you would configure a specific node in your server environment. The manifests are compiled into catalogs, which are then executed on the client. Each of the manifests are written in the language of Ruby with a .pp extension. And if we step through the 5 key steps for writing a manifest, they are 1. Create your manifest, and that is written by the system administrator. 2. Compile your manifest, and it's compiled into a catalog. 3. Deploy. The catalog is then deployed onto the clients. 4. Execute. The catalogs are run on the client by the agent. And then 5. End. Clients are configured to a specific and desired state. If we actually look into how a manifest is written, it's written with a very common syntax. If you've done any work with Ruby or really configuration of systems in the past, this may look very familiar to you. So we break out the work that we have here. You start off with a package, file, or service as your resource type, and then you give it a name, and then you look at the features that need to be set, such as IP address. Then you're actually looking to have a command written, such as present or start. The manifest can contain multiple resource types. If we continue to write our manifest in Puppet, the default keyword applies a manifest to all clients. So an example would be to create a file path that creates a folder called sample in a main folder called etc. The specified content is written into a file that is then posted into that folder. And then we're going to say we want to be able to trigger an Apache service and then ensure that that Apache service is installed on a node. So we write the manifest and we deploy it to a client machine. On that client machine, a new folder will be created with a file in that folder, and an Apache server will be installed. You can do this to any machine and you'll have exactly the same results on those machines.
Now let's have a look at the Puppet community. The Puppet community is a rich community of a lot of people. Officially, there is no count. But counting the various channels where people collaborate, there are a little over 2,900 committers to GitHub projects who are directly or indirectly associated with Puppet Labs. There are 4,893 modules on the official Puppet Forge. These include modules from the Puppet Labs and also from open source contributors to GitHub. So that's nearly 5,000 modules of ready-made code available on the Puppet Forge. So before you write any code for Puppet, you can check to see if it's already been written by someone. Now there's a mailing list which has 6,588 participants. Apart from this, on Slack Overflow you have a big tag of Puppet Labs in Puppet, which gives you a list of only Puppet questions. That's a good playground for you to interact with people who are already using Puppet and who are contributing and helping others. Now let's have a look at Puppet Forge. So Puppet Forge is a GitHub client for a repository which is hosted by Puppet Labs. It has almost 5,000 modules of Puppet code. So these are both Puppet Labs and community contributed. The best thing about this is that they're easy to customize. So when you have a requirement for anything you're doing with your infrastructure, you can just grab one of those 5,000 modules, and then you can customize it according to your needs. One of the other benefits is they have built-in tests, so they follow all of the best practices. Now, if you write your own module, you also have to write your own tests, and you have to spend extra time writing best practice code. All of that has been taken care of, and you can just download any one of those and customize it according to your needs, and you're good to go. So that's the benefit you get from such a large community, where people contribute to the modules and the code and share with the community. The Puppet DSL. Puppet DSL is a Puppet domain-specific language. It's the Puppet's primary programming language. It's just like plain English, and you don't really need to be a programmer to write code in it. It's kind of a subchild of Ruby because it approaches and uses is equal to and greater than marks to define things. So it's very easy to learn. You can specify packages that you want to install. You can specify services to be managed. You can do things based on the operating system that you have. So we'll be writing a small Puppet module which will be using this Puppet DSL. We will do that after we install the Puppet server and the client. And then we will write a simple Puppet module to show how to use the Puppet DSL. Let's have a look at the demo we are going to do. So you will be setting up the machines using sudo DNS because we want to have a resolvable DNS. Because only by having a resolvable DNS can we use Puppet, because Puppet uses the SSL certificates. Now we'll be installing the Puppet server and the client. We'll be signing the certificates of the client on the server side. And then we'll proceed with writing an NTP module, which we'll be using for installation of NTP on the client. And then we'll look at the Puppet programming language, or DSL. Now, we are going to look at a demo here. So we will be setting up the machines. We'll set up a sudo DNS locally because Puppet requires a fully qualified domain name in order to run, since there is a certificate communication taking place here. We will be installing the Puppet server, the Puppet client. We'll be signing the certificate, and finally we will write an NTP module and make it run. So now we will be starting a Puppet master and a client. I have two machines here. One is the Puppet master and the second is the Puppet client. The Puppet master has got almost 4 gig of RAM and 4 vCPUs, which I can show you here. Because it's a Ruby on Rails application, it requires a lot of CPU and RAM. For the client, I don't need that much RAM and CPU, so I've allotted 1 gigabyte of RAM and 1 vCPU. I will start both of these machines and find out the IP addresses. Right-click, normal start. Both of these machines are starting up. The Puppet client has started up, and the first thing I'll do is log in using root and Red Hat password, and then I will change the host name. So I'll say vim etc host name. This will open a hostname file in a text editor, which is vim. Then we'll do a dd, which will delete that existing host name. And then I press the I for insert mode, and finally I'll type the Puppet-client, which will be the host name of this machine. I'll save this file by doing escape semicolon WQ exclamation mark. And I'll reboot the machine. Similarly, going to the Puppet master, I'll say root Red Hat. I'll open the hostname file. Say dd, then I'll say Puppet-master. I'll save this file and reboot the machine for the hostname change to take effect. The hostname change does not take effect unless you reboot the machine. Now both of these machines are ready. I'm going to find out the IPs and use the Mac terminal to log into these. So this is 23 and 21. So 23 is my server and 21 is my client. I'll SSH to 23 first. Now, in order for the Puppet Master to be installed, I need a fully qualified domain name here and a fake DNS, which means a fully resolvable DNS name. So if I do host name here, you see my host name is Puppet Master. In order to set up a fake DNS, I need to go to the etc host file, go to the end, then I say IP address, host name local, then space host name. Now, this is one of the techniques which makes the Linux server believe that there's a fully qualified domain name on this machine. I'll save this. Then I do a host name -f. You see it has a fully qualified domain name now. So now we will be downloading the Puppet Labs repository for Ubuntu 16.04, which is Xennial. So I'll say curl -0 https apt.puppetlabs.com /puppetlabs-release -pc1 -xennial.deb. You can see there's a Debian file which has been downloaded here. I will import this using the dpkg command. So I'll say dpkg-i puppetlabs-release -pc1 -xennial.deb. And then I'll say apt-get update, which will update my apt package indexes on this machine. And now I'll install the Puppet server. So I'll say apt-get install puppet server -y. So the Puppet server is now installed, and we will be configuring the memory allocation for the Puppet server. So I'll say etc default Puppet server. So by default, it has only got 2 GB allocated. We'll give it 3 GB because it's JVM. I'll make this 3, and I'll change this to 3 as well. And I'll save this file. I'll make sure the unconfigured firewall allows port 8140, which is the Puppet Lab Puppet server port. The rules have been updated to allow that. I'll now start the Puppet server. So I'll say systemctl start Puppet server. It takes some time because it's a JVM, so it takes a couple of minutes to start the Puppet server. So the Puppet server is now running. I'll also enable it at boot time. So I'll say systemctl enable Puppet to server. It will enable at boot time. Now I also need to configure a fully qualified domain name here. So I'll do that by going into the hosts file. I'll go to the end and I'll say 192.168.1.23 and then puppet-server.local and then puppet-server. If I do a hostname -f, put -master.local because the current hostname is puppet-master. So the trick is to have the hostname.local in front of the IP address in the host file. Having a fully qualified domain name now we will go to the client setup. The client setup is almost the same with just a small difference. The package which we need to install on the client is Puppet Agent. So we will go to the client. So you see this has got a host name. Now we also need to set up the fake DNS here. So I'll copy this host name, open the host line, go to the end, write the IP address, and then .local, and then host name again. So this will give me a fully qualified domain name. So when I do a host name, it says puppet-client. When I do a host name -f, it says puppet client local. To install the Puppet agent on this machine, I will need to download the Xenio packages. So I'll say wget https apt.puppetlabs.com/puppetlabs -release -pc1 -xenio.deb. I'll download this, and then I'll say dpkg-i puppetlabs-release -pc1 -xenio.deb. So this is the repository package which I'll be downloading here. And then I'll say apt-get update-y. This will update my apt caches on this machine. And now I'll finally install the Puppet agent. So I'll say apt-get install Puppet agent -y. Now the Puppet agent is here. I'll start the Puppet agent and I'll enable it at boot time. So I'll say system control, start Puppet, then system control, enable Puppet. Now Puppet is enabled. Now we have set up the fully qualified domain name on the client and the server, but each of them should know each other. So we'll have to do a cross-certificate host mapping. So we will be copying the host file entry of the client and adding it to the server. So I'll go to the etc hosts on the server side. Go to the end, paste it there. Okay, and I'll be adding the entry of the master on the client side. Okay, now both of the servers will recognize each other now, because one of them has the host entry of the other. So if I do from the master ping puppet-agent.local, if I ping the agent from the server, -client.local, it is able to ping it. And if I ping the master from the client, if I say ping puppet-master.local, both of them will be able to ping each other. Now the next step would be to create a certificate signing request. So I'll go to my to this directory, which is opt puppet labs puppet bin, and I'll say puppet agent -t -server is equal to, and I'll give the fully qualified domain name of the puppet master. Then I'll say -f. When I do this, it will create a certificate signing request, you see. Now, if I go to the server and I do an opt, I'll check and see how many certificates are pending to be signed. You'll see there is a puppet client certificate which is pending to be signed, which is denoted by the absence of a plus sign here. I'll be signing the certificate, so I'll say puppet cert sign and then the name. So puppet-client.local. This will sign the certificates. And when I go to the server on the client side, if I run the puppet agent again, you see it's actually pulling down the catalog. As of now, it has an empty catalog. That says there is nothing. Now we have configured the Puppet agent and the master. Now we will be taking a module from Puppet Forge. Puppet Forge is a big collection of open source modules which are free to use. As a first step, we will be using a ready-made module, and that would be a demonstration for how to actually get up and running with a module. So search for Apache module here. This is the Puppet Labs Apache module. I'll be using the Puppet command line, Puppet module install. This is the command for that. But I will make sure I run this command from the Puppet home. So I'll go to the master, I'll go to etc Puppet Labs, code, environments, production. In this I'll do modules. Now I will run it from the binary which is present at the opt Puppet Labs bin Puppet. And then module install. Puppet Labs -Apache, and then this version. So we are specifying the latest version, and I'll hit enter. When I press enter, it starts downloading from the Forge API. So you see the module is downloaded in addition to the dependencies. So there is concat, stdlib, and Apache. So now I'll go to a folder here which is one level up called manifests. So this is the file here, etc Puppet Labs code environments production manifests. So in this there's a file which I'll be creating called site.pp. The site.pp will specify, and this is the main controller of how the infrastructure looks. In the site.pp I specify that I want puppet-client.local node to have the Apache module included. I'll save this file, and the only thing I need to do now is, since all is set on the server side, I need to go to the client side and run Puppet agent. It will automatically download the Apache module and compile it, and then make sure the server is in a state. So when I press enter, we see a lot of output. It tries to configure Apache on this machine, and done. Now when I go to the front end of this machine, on this port, I should be able to see Apache's default page. So this is Apache's default page. So the module which we downloaded from the Forge was actually written in a way that Apache would be installed and run at boot time. So that is why it is running here. And that is all we have from the Puppet module. And this concludes the demo.
Today we're going to go through a real tough battle. We're going to decide which is better for your operations environment. Is it Chef, Puppet, Ansible, or Salt Stack? All four are going to go head to head. So let's go through the scenario of why you'd want to use these tools. So let's meet Tim. He's our system administrator, and Tim is a happy camper putting and working on all of the systems in his network. But what happens if a system fails? If there's a fire, a server goes down? Well, Tim knows exactly what to do. He can fix that fire really easily. The problems become really difficult for Tim, however, if multiple servers start failing, particularly when you have large and expanding networks. So this is why Tim really needs to have a configuration management tool, and we need to now decide what would be the best tool for him, because configuration management tools can help make Tim look like a superstar. All he has to do is configure the right codes that allows him to push out the instructions on how to set up each of the servers quickly, effectively, and at scale. All right, let's go through the tools and see which ones we can use. The tools that we're going to go through are Chef, Puppet, Ansible, and SaltStacks. And we have videos on most of these software and services that you can go and view to get an overview or a deep dive in how those products work. So let's go and get to know our contestants. So our first contestant is Chef. And Chef is a tool that allows you to configure very large environments. It allows you to scale very effectively across your entire ecosystem and infrastructure. Chef is by default an open source code. And one of the things that you find as a consistent metaphor for the tools that we recommend on Simplilearn is to use open source code. The code itself is actually written in the language of Ruby and Erlang. And it's really designed for heterogeneous infrastructures that are looking for a mature solution. The way that Chef works is that you write recipes that are compiled into cookbooks, and those cookbooks are the definition of how you would set up a node. And a node is a selection of servers that you have configured in a specific way. So for instance, you may have Apache Linux servers running, or you may have a MySQL server running, or you may have a Python server running. And Chef is able to communicate back and forth between the nodes to understand what nodes are being impacted and need to have instructions sent out to them to correct that impact. You can also send instructions from the server to the nodes to make a significant update or a minor update. So there's great communication going back and forth. If we look at the pros and cons, the pros for Chef is that there is a significant following for Chef, and that has resulted in a very large collection of recipes that allow you to be able to quickly stand up environments. There's no need for you to have to learn complex recipes. The first thing you should do is go out and find the recipes that are available. It integrates with Git really well and provides for really good, strong version control. Some of the cons, though, are really around the learning speed it takes to go from a beginner user with Chef to being an expert. There is a considerable amount of learning that has to take place, and it's compounded by having to learn Ruby as the programming language. And the main server itself doesn't really have a whole lot of control. It's really dependent on the communication throughout the whole network. All right, let's look at our second contender, Puppet. And Puppet is actually in many ways very similar to Chef. There are some differences, but again, Puppet is designed to be able to support very large heterogeneous organization. It is also built with Ruby and uses DSL for writing manifests. So there are some strong similarities here to Chef. As with a Chef, there is a master-slave infrastructure with Puppet, and you have a master server that has the manifests that you put together in a single catalog, and those catalogs are then pushed out to the clients over an SSL connection. Some of the pros with Puppet is that, as with Chef, there is a really strong community around Puppet, and there's just a great amount of information and support that you can get right out of the gate. It is a very well developed reporting mechanism that makes it easier for you as an administrator to be able to understand your infrastructure. One of the cons is that you have to really be good at learning Ruby again, as with Chef. You know, the more advanced tasks really need to have those Ruby skills. And as with Chef, the server also doesn't have much control. So let's look at our third contender here, Ansible. And so Ansible is slightly different. It is, the way that Ansible works is that it actually just pushes out the instructions to the server environment. There isn't a client server or master slave environment where Ansible would be communicating backwards and forwards with its infrastructure. It is merely going to push that instructions out. The good news is that the instructions are written in YAML, and YAML stands for YAML Ain't Markup Language. YAML is actually pretty easy to learn. If you know XML, and XML is pretty easy, if you know XML, you're going to get YAML really well. Ansible does work very well on environments where the focus is getting servers up and running really fast. It's very, very responsive and can allow you to move quickly to get your infrastructure up very fast. And we're talking seconds and minutes here, really, really quick. So again, the way that Ansible works is that you put together a playbook and an inventory, or you have a playbook. So the way that Ansible works is that you have a playbook, and the playbook, it then goes against the inventory of servers and will push out the instructions for that playbook to those servers. So some of the pros that we have for Ansible: we don't need to have an agent installed on the remote nodes and servers. It makes it easier for the configuration. YAML is really easy to learn. You can get up to speed and get very proficient with YAML quickly. The actual performance, once you actually have your infrastructure up and running, is less than other tools that we have on our list. Now, I do have to add a proviso. This is a relative less. It's still very fast. It's going to be a lot faster than individuals manually standing up servers, but it's just not as fast as some of the other tools that we have on this list. And YAML itself as a language, while it's easy to learn, it's not as powerful as Ruby. Ruby will allow you to do things that at an advanced level that you can't do easily with YAML. So let's look at our final contender here, SaltStack. So SaltStack is a CLI-based tool. It means that you will have to get your command line tools out or your terminal window out so you can actually manage the entire environment via SaltStack. The instructions themselves are based on Python, but you can actually write them in YAML or DSL, which is really convenient. And as a product, it's really designed for environments that want to scale quickly and be very resilient. The way that SaltStack works is that you have a master environment that pushes out the instructions to what they call grains, which is your network. And so let's step through some of the pros and cons that we have here with SaltStack. So SaltStack is very easy to use once it's up and running. It has a really good reporting mechanism that makes your job as an operator in your DevOps environment much, much easier. The actual setup, though, is a little bit tougher than some of the other tools, and it's getting easier with the newer releases, but it's just a little bit tougher. And related to that is that SaltStack is fairly late in the game when it comes to actually having a graphical user interface for being able to create and manage your environment. Other tools such as Ansible have actually had a UI environment for quite some time. All right, so we've gone through all 4 tools. Let's see how they all stack up next to each other. So let the race begin. Let's start with the first stage, architecture. So the architecture for most of our environments is a server-client environment. So for Chef, Puppet, and SaltStack. So very similar architecture there. The one exception is Ansible, which is a client-only solution. So you're pushing out the instructions from a server and pushing them out into your network. And there isn't a client environment. There isn't a two-way communication back to that main client for what's actually happening in your network. So let's talk about the next stage, ease of setup. So if we look at the 4 tools, there is one tool that really stands out for ease of setup, and that is Ansible. It is going to be the easiest tool for you to set up. And if you're new to having these types of tools in your environment, you may want to start with Ansible just to try out and see how easy it is to create automated configuration before looking at other tools. Now, and so with that said, Chef, Puppet, and SaltStack aren't that hard to set up either. And you'll find there's actually some great instructions on how to do that setup in the online community. Let's talk about the languages that you can use in your configuration. So we have 2 different types of language, with both Chef and Ansible being procedural in that they actually specify how you're actually supposed to do the task in your instructions. With Puppet and SaltStack, it's decorative, where you specify only what to do in the instructions. Let's talk about scalability. Which tools scale the most effectively? And as you can imagine, all of these tools are designed for scalability. That is the driver for these kind of tools. You want them to be able to scale to massive organizations. What do the management tools look like for our 4 contenders? So again, we have a 2-way split. With Ansible and SaltStack, the management tools are really easy to use. You're going to love using them. They're just fantastic to use. With Puppet and Chef, the management tools are much harder to learn, and they do require that you learn some either the Puppet DSL or the Ruby DSL to be able to be a true master in that environment. But what does interoperability look like? Again, as you'd imagine, with the similar to scalability, interoperability with these products is very high in all 4 cases. Now, let's talk about cloud availability. This is increasingly becoming more important for organizations as they move rapidly onto cloud services. Well, both Ansible and SaltStack have a big fail here. Neither of them are available in the most popular cloud environments. And Puppet and Chef are actually available in both Amazon and Azure. We've actually just haven't had a chance to update our Chef link here, but Chef is now available on Azure as well as Amazon. So what does communication look like with all of our 4 tools? So the communication is slightly different with them. Chef has its own knife tool, whereas Puppet uses SSL, so Secure Sockets Layer, and Ansible and SaltStack use Secure Socket Hashing, SSH, as their communication tool. Bottom line, all 4 tools are very secure in their communication. So who wins? Well, here's the reality. All 4 tools are very good, and it's really dependent on your capabilities and the type of environment that you're looking to manage that will determine which of these 4 tools you should use. The tools themselves are open source, so go out and experiment with them. There's a lot of videos. Our team has done a ton of videos on these tools, and so feel free to find out other tools that we have and covered so you can learn very quickly how to use them. But consider the requirements that you have and consider the capabilities of your team. If you have Ruby developers or you have someone on your team that knows Ruby, your ability to choose a broader set of tools becomes much more interesting. If, however, you're new to coding, then you may want to consider YAML-based tools. Again, the final answer is going to be up to you, and we'll be really interested on what your decision is. Please post in the comments below which tool you have decided to go with and what are the challenges that you're coming up with, because we'll help answer those challenges for you.
Ansible provides you with one of the easiest ways to automate your application and IT infrastructure. On that note, hi guys, welcome to this complete Ansible tutorial by Simplilearn. In this video, we'll be covering some of the most important concepts relating to the DevOps tool Ansible. We'll take you through how you can install Ansible and how you can use the tool to automate your processes. First, we have Anjali to tell us how to install Ansible on your system.
A very warm welcome to all our viewers. I'm Anjali from Simplilearn, and today I'll be showing you how you can install the configuration management tool Ansible. So let's have a brief about why one would use Ansible and what exactly is Ansible. So if you consider the case of an organization, it has a very large infrastructure, which means it has more than probably hundreds of systems. And giving one or even a small team of people the responsibility to configure all these systems makes their work really tough, repetitive, and as you know, manual work is always prone to errors. So Ansible is a tool which can automate the configuration of all these systems. With Ansible, a small team of system administrators can write simple codes in YAML, and these codes are deployed onto the hundreds and thousands of servers, which configures them to the desired states. So Ansible automates configuration management, that is configuring your systems. It automates orchestration, which means it brings together a number of applications and decides an order in which these are executed, and it also automates deployment of the applications. Now that we know what Ansible does, let's move on to the installation of Ansible. So here is my Oracle VM VirtualBox Manager. I'll be using 2 systems. There's the node system, which is basically my client system, and there's the server system or the master system. So let's begin at our server system. So this is my master system, guys. So the first thing we do is we download our Ansible tool. So one thing we must remember with Ansible is that unlike Chef or Puppet, Ansible is a push type of configuration management tool. So what this means is that the entire control here lies with your master or your server system. This is where you write your configuration files, and these are also responsible for pushing these configuration files onto your node or client system as and when required. Great, so our Ansible tool is installed. Now we need to open an Ansible host file. and there we'll specify the details of our node or client machine. So this is our Ansible host file. As you can see here, the entire file is commented, but there's a certain syntax that you'd observe. For example, here we have a group name, web servers, under which we have the IP addresses or certain host name. So this is about how we'll be adding the details for our client system. First, we need to give a group name. Under this group, basically, we add all the clients which require a certain type of configuration. Since we are using just one node, we'll give only the details for that particular node. First, we need to add the IP address of our client machine. So let's just go back to our client machine. And this here is the IP address 192.168.2.11. Once you have typed in your IP address, give a space, and then we'll specify the user for our client machine. So all communications between the server or the master system and the client or the node system takes place through SSH. SSH basically provides a secure channel for the transfer of information. Follow this up with your password. In my case, it's the root's password. And that's it, we are done. So now we save this file and go back to our terminal. So now that our host file is written, the next thing we do is we write our playbook. So playbook is the technical term used for all the configuration files that we write in Ansible. Now playbooks are written in YAML. YAML's extremely simple to both write and understand. It's in fact very close to English. So now we'll write our playbook. The playbook or any code in YAML first starts with 3 dashes. This indicates the beginning of your file. Next thing, we need to give a name to our playbook. So name, and I'm going to name my playbook sample book. We next need to specify our host systems, which is basically the systems at which the configuration file or the playbook in our case will be executed. So we'll be executing this at the client machines mentioned under the group Ansible servers. So we had just one client machine under it. We'll still mention the group name. We next need to specify the username with which we'll be logging into our client machine, which is root in my case. And become true specifies that you need to become the root to execute this playbook. So becoming the root's called a privilege escalation. Next, we need to specify our tasks. So these are basically the actions that the playbook will be performing. So you would have noticed everything so far is aligned, that is name, host, remote user, become and task, because these are at one level. Now whatever comes under task will be shifted slightly towards the right. Although YAML is extremely simple to understand and read both, it's a little tricky while writing because you need to be very careful about the indentations and the spacing. So my first task is install HTTPD, which is basically an Apache server. So now my command's yum, and this will be installing the HTTPD package. And the latest state of it will be installed. So that's our first task. Now our second task would be running our Apache service. So name, run HTTPD, and the action, which is service, will be performed on HTTPD, hence the name HTTPD, and state must be started. Now we come to our third task. So here we'll create a very simple web page that will be hosted. So create content is the name of our task. And the content that we are creating here will basically be copied to our node system at a particular file location that we'll provide. Our content will be congrats. And then we'll provide the destination at which this file will be copied. So this is the default location for all our HTML files. And that's it. We are done writing our playbook. Just save this and go back to your terminal. Before we execute the playbook or push the playbook onto our node system, let's check the syntax of our playbook. So the command for doing so is, and if everything's fine with your playbook, the output would be just your playbook name. So our syntax is perfectly fine. Now we can push on the playbook to our node or the client machine. And that's the syntax for doing so. Now, as your playbook is being sent over to the client machine, you can see that first the facts are gathered. That is, the current state of your client machine is first fetched to check what all is to be changed and what is already present. So the first thing is installing HTTPD. So our system already had HTTPD. So it says OK, because this does not need to be changed. Our next task was running HTTPD. Now, although our system had the Apache service, it was not running. So that is one thing that was changed. The next was there was no content available. So the content was also added. So 2 tasks were changed and 4 things were okay. Now, everything seems fine. And before you move any forward, it is very important that you check this one line of documentation provided by Ansible. You have all kind of information available here regarding which all tasks were executed, if your client machine was reachable or unreachable, and so on. So now that everything's fine here, we can move on to our node system and we'll just go to our browser. So if our playbook has been executed here, what should happen is that the HTTPD service must be in the running state and the web page that we created should be hosted. So let's just type localhost. And great, everything's working fine. So our web page is displayed here. So we come to an end for our installation and configuration video for the configuration management tool Ansible. If you have any doubts, please post them in the comment section below and we'll definitely get back to you as soon as possible.
Thanks, Anjali. Now we have Matthew and Anjali to take us through how to work with Ansible.
Ansible today as one of the key tools that you would have within your DevOps environment. So the things that we're going to go through today is we're going to cover why you would want to use a product like Ansible, what Ansible really is and how it's of value to you in your organization, the differences between Ansible and other products that are similar to it on the market and what makes Ansible a compelling product. And then we're going to dig into the architecture for Ansible. We're going to look at how you would create a playbook, how you'd manage your inventory of your server environments, and then what is the actual workings of Ansible. As a little extra, we're going to also throw in Ansible Tower, one of the secret source solutions that you can use for improving the speed and performance of how you create your Ansible environments. And finally, we're going to go through a use case by looking at Hootsuite, a social media management company, and how they use Ansible to really improve the efficiency within their organizations. So let's jump into this. So the big question is, why Ansible? So you have to think of Ansible as another tool that you have within your DevOps environment for helping manage the servers. And this definitely falls on the operations side of the DevOps equation. So if we look here, we have a picture of Sam. And like yourselves, Sam is a system administrator. And he is responsible for maintaining the infrastructure for all the different servers within his company. So some of the servers that he may have that he has to maintain could be web servers running Apache. They could be database servers running MySQL. And if you only have a few servers, then that's fairly easy to maintain. I mean, if you have 3 web servers and 2 database servers, and let's face it, wouldn't we all love just to have 1 or 2 servers to manage? It would be really easy to maintain. The trick, however, is as we start increasing the number of servers, and this is a reality of the environments that we live and operate in, it becomes increasingly difficult to create consistent setup of different infrastructures such as web servers and databases for the simple reason that we're all human. As if we had to update and maintain all of those servers by hand, there's a good chance that we would not set up each server identically. Now, this is where Ansible really comes to the rescue and helps you become an efficient operations team. Ansible, like other system solutions such as Chef and Puppet, uses code that you can write and describe the installation and setup of your servers. So you can actually repeat it and deploy those servers consistently into multiple areas. So now you don't have to have one person redoing and refollowing setup procedures. You just write one script and then each script can be executed and have a consistent environment. So we've gone through why you'd want to use Ansible. Let's step through what Ansible really is. So, this is all great, but, how do we actually use these tools in our environment? So Ansible is a tool that really allows you to create and control 3 key areas that you would have within your operations environment. First of all, there's IT automation. So you can actually write instructions that automate the IT setup that you would typically do manually in the past. The second is the configuration and having consistent configuration. Imagine setting up hundreds of Apache servers and being able to guarantee with precision that each of those Apache servers is set up identically. And then finally, you want to be able to automate the deployment so that as you scale up your server environment, you can just push out instructions that can deploy automatically different servers. The bottom line is you want to be able to speed up and make your operations team more efficient. So let's talk a little bit about pull configuration and how it works with Ansible. So there are 2 different ways of being able to set up different environments for server farms. One is to have a key server that has all the instructions on, and then on each of the servers that connect to that main master server, you would have a piece of software known as a client installed on each of those servers that would communicate to the main master server and then would periodically either update or change the configuration of the slave server. This is known as a pull configuration. An alternative is a push configuration, and the push configuration is slightly different. The main difference is, as with a pull configuration, you have a master server where you actually put up the instructions. But unlike the pull configuration where you have a client installed on each of the services, with a push configuration, you actually have no client installed on the remote servers. You simply are pushing out the configuration to those servers and forcing a restructure or a fresh clean installation in that environment. So Ansible is one of those second environments where it's a push configuration server, and this contrasts with other popular products like Chef and Puppet, which have a master-slave architecture with a master server connecting with a client on a remote slave environment where you would then be pushing out the updates. With Ansible, you're pushing out the service and the structure of the server to remote hardware, and you are just putting it onto the hardware irrelevant of the structure that's out there. And there are some significant advantages that you have in that you're not having to have the extra overhead weight of a client installed on those remote servers having to constantly communicate back to the master environment. So let's step through the architecture that you would have for an Ansible environment. So when you're setting up an Ansible environment, the first thing you want to do is have a local machine. And the local machine is where you're going to have all of your instruction and really the power of the control that you'd be pushing out to the remote server. So the local machine is where you're going to be starting and doing all of your work. Connected from the local machine are all the different nodes pushing out the different configurations that you would set up on the local machine. The configurations that you would write, and you would write those in code, are within a module. So you do this on your local machine for creating these modules, and each of these modules is actually consistent playbooks. The local machine also has a second job, and that job is to manage the inventory of the nodes that you have in your environment. The local machine is able to connect to each of the different nodes that you would have in your hardware network through SSH clients, so a secure client. Let's dig into some of the different elements within that architecture. And we're going to take a first look at playbooks that you would write and create for the Ansible environments. So the core of Ansible is the playbook. This is where you create the instructions that you write to define the architecture of your hardware. So the playbook is really just a set of instructions that configure the different nodes that you have, and each of those set of instructions is written in a language called YAML. And this is a standard language used for configuration server environments. Did you know that YAML actually stands for YAML Ain't Markup Language? That's just a little tidbit to hide behind your ear. So let's have a look at one of these playbooks it looks like. And here we have a sample YAML script that we've written. So you start off your YAML script with 3 dashes, and that indicates the start of a script. And then the script itself is actually consistent of 2 distinct plays. At the top we have play 1, and below that we have play 2. Within each of those plays, we define which nodes are we targeting. So here we have a web server in the top play, and in the second play, we have a database server that we're targeting. And then within each of those server environments, we have the specific tasks that we're looking to execute. So let's step through some of these tasks. We have an install Apache task, we have a start Apache task, and we have an install MySQL task. And when we do that, we're going to actually execute a specific set of instructions. And those instructions can include installing Apache and then setting the state of the Apache environment, or starting the Apache environment and setting up and running the MySQL environment. So this really isn't too complicated, and that's the really good thing about working with YAML, is it's really designed to make it easy for you as an operations lead to be able to configure the environments that you want to consistently create. So let's take a step back though. We have two hosts. We have web server and database server. Where do these names come from? Well, this takes us into our next stage and the second part of working with Ansible, which is the inventory management part of Ansible. So the inventory part of Ansible is where we maintain the structure of our network environment. So what we do here is part of the structure in creating different nodes is we've had to create two different nodes here. We have a web server node and a database server node. And under web server node, we actually have the names that we're actually pointing to specific machines within that environment. So now when we actually write our scripts, all we have to do is refer to either web server or database server, and the different servers will have the instructions from the YAML script executed on them. This makes it really easy for you to be able to just point to new services without having to write out complex instructions. So let's have a look at how Ansible actually works in real world. So the real world environment is that you would have the Ansible software installed on a local machine, and then it connects to different nodes within your network. On the local machine, you'll have your playbook, which is the set of instructions for how to set up the remote nodes. And then to identify how you're going to connect to those nodes, you'll have an inventory. We use secure SSH connections to each of the servers, so we are encrypting the communication to those servers. We're able to grab some basic facts on each server, so we understand how we can then push out the playbook to each server and configure that server remotely. The end goal is to have an environment that is consistent. So let's ask you a simple question. What are the major opportunities that Ansible has over Chef and Puppet? Really like to hear your answers in the comments below. Pop them in there and we'll get back to you, and really want to hear how you feel that Ansible is a stronger product, or maybe you think it's a weaker product as it compares to other similar products in the market. Here's the bonus. We're going to talk a little bit about Ansible Tower. So Ansible Tower is an extra product that Red Hat created that really kind of puts the cherry on the top of the ice cream, or is the icing on your cake. Ansible by itself is a command line tool. However, Ansible Tower is a framework that was designed to access Ansible. And through the Ansible Tower framework, we now have an easy to use GUI. This really makes it easy for non-developers to be able to create the environment that they want to be able to manage in their DevOps plan without having to constantly work with the command prompt window. So instead of opening up terminal window or a command window and writing out complex instructions only in text, you can now use drag and drop and mouse click actions to be able to create your appropriate playbooks, inventories, and pushes for your nodes. All right, so we've talked a lot about Ansible. Let's take a look at a specific company that's using Ansible today. And in this example, we're going to look at Hootsuite. Now, Hootsuite, if you've not already used their products, and they have a great product, Hootsuite is a social media management system. They are able to help with you managing your pushes of social media content across all of the popular social media platforms. They're able to provide the analytics, they're able to provide the tools that marketing and sales teams can use to be able to assess a sentiment analysis of the messages that are being pushed out. Really great tool and very popular. But part of their popularity drove a specific problem straight to Hootsuite. The challenge they had at Hootsuite is that they had to constantly go back and rebuild their server environment, and they couldn't do this continuously and be consistent. There was no standard documentation, and they had to rely on your memory to be able to do this consistently. Imagine how complex this could get as you're scaling up with a popular product that now has tens of thousands to hundreds of thousands of users. This is where Ansible came in and really helped the folks over at Hootsuite. Today, the DevOps team at Hootsuite write out playbooks that have specific instructions that define the architecture and structure of their hardware nodes and environments, and are able to do that as a standard product. Instead of it being a problem in scaling up their environment, they now are able to rebuild and create new servers in a matter of seconds. The bottom line is Ansible has been able to provide Hootsuite with IT automation, consistent configuration, and free up time from the operations team so that instead of managing servers, they're able to provide additional new value to the company.
A very warm welcome to all our viewers. I'm Anjali from Simplilearn, and today I'll be taking you through a tutorial on Ansible. So Ansible is currently the most trending and popular configuration management tool, and it's used mostly under the DevOps approach. So what will you be learning today? You'll learn why you should use Ansible, what exactly is Ansible, the Ansible architecture, how Ansible works, the various benefits of Ansible, and finally we'll have a demo on the installation of Apache or the HTTPD package on our client systems. We'll also be hosting a very simple web page, and during this demo, I'll also show you how you can write a very simple playbook in YAML and your inventory file. So let's begin. Why should you use Ansible? Let's consider a scenario of an organization where Sam is a system administrator. Sam is responsible for the company's infrastructure. A company's infrastructure basically consists of all its systems. This could include your web servers, your database servers, the various repositories, and so on. So as a system administrator, Sam needs to ensure that all the systems are running the updated versions of the software. Now when you consider a handful of systems, this seems like a pretty simple task. Sam can simply go from system to system and perform the configurations required. But that is not the case with an organization, is it? An organization has a very large infrastructure. It could have hundreds and thousands of systems. So here is where Sam's work gets really difficult. Not only does it get tougher, Sam has to move from system to system, performing the same task over and over again. This makes Sam bored. Not just that, repeating the same task leaves no space for innovation. And without any ideas or innovation, how does the system grow? And the worst of it all is manual labor is prone to errors. So what does Sam do? Well, here is where Ansible comes in use. With Ansible, Sam can write simple codes that are deployed onto all the systems and configure them to the correct states. So now that we know why we should use Ansible, let's look at what exactly is Ansible. Ansible is an IT engine that automates the following tasks. So first we have orchestration. Orchestration basically means bringing together of multiple applications and ensuring an order in which these are executed. So for example, if you consider a web page that you require to host, this web page stores all its values that it takes from the user into a database. So the first thing you must do is ensure that the system has a database manager, and only then do you host your web page. So this kind of an order is very crucial to ensure that things work right. Next, Ansible automates configuration management. So configuration management simply means that all the systems are maintained at a consistent desired state. Other tools that automate configuration management include Puppet and Chef. And finally, Ansible automates deployment. Deployment simply means the deploying of application onto your servers of different environments. So if you have to deploy an application on 10 systems with different environments, you don't have to manually do this anymore because Ansible automates it for you. In fact, Ansible can also ensure that these applications or the code are deployed at a certain time or after regular intervals. Now that we know what exactly Ansible is, let's look at Ansible's architecture. Ansible has two main components. You have the local machine and you have your node or the client machine. So the local machine is where the system administrator sits. He or she installs Ansible here. And on the other end, you have your node or the client systems. So in case of Ansible, there's no supporting software installed here. These are just the systems that require to be configured and they are completely controlled by the local machine. At your local machine, you also have a module. A module is a collection of your configuration files. And in case of Ansible, these configuration files are called playbooks. Playbooks are written in YAML. YAML stands for YAML ain't a markup language. And it is honestly the easiest language to understand and learn since it's so close to English. We also have the inventory. The inventory is a file where you have all your nodes that require configuration mentioned. And based on the kind of configuration they require, they're also grouped together. So later in the demo, we'll have a look at how the playbook and the inventory is written, and that will probably make it clearer. So of course, the local machine needs to communicate with the client. And how is this done? This is done through SSH. SSH is your secure shell, which basically provides a protected communication in an unprotected environment. Okay, so we saw the various components of Ansible. Now, how does Ansible exactly work? You have your local machine on one end. This is where you install Ansible. If you have gone through any previous material on Ansible, you would have come across the term agentless often being associated with this tool. So this is what agentless means. You're installing Ansible only on your local machine and there's no supporting software or plugin being installed on your clients. This means that you have no agent on the other end. The local machine has complete control and hence the term agentless. Another term that you would come across with Ansible is push configuration. So since the local machine has complete control here, it pushes the playbooks onto the nodes and thus it's called a push configuration tool. Now the playbooks and the inventory are written at the local machine and the local machine connects with the nodes through the SSH client. This step here is optional but it's always recommended to do so. It's where the facts are collected. So facts are basically the current state of the node. Now all this is collected from the node and sent to the local machine. So when the playbook is executed, the task mentioned in the playbook is compared against the current status of the node and only the changes that are required to be made further are made. And once the playbooks are executed, your nodes are configured to the desired states. So as I mentioned before, Ansible is currently the most trending tool in the market under the configuration management umbrella. So let's have a look at the various benefits of Ansible which gives it this position. Well, Ansible is agentless, it's efficient, it's flexible, simple, idempotent, and provides automated reporting. How does it do all this? Let's have a look at that. Agentless, as I already mentioned before, you require no supporting software or plugin installed on your node or the client system. So the master has complete control. And automatically this means that Ansible is more efficient because now we have more space in our client and node systems for other resources and we can get Ansible up and running real quick. Ansible is also flexible. So an infrastructure is prone to change very often and Ansible takes no amount of time to adjust to these changes. Ansible cannot get any simpler with your playbooks written in a language such as YAML, which is as close to English as you can possibly get. Idempotent basically means that if you have a playbook which needs to be run n number of systems, it would have the same effect on all of these systems without any side effect. And finally, we have automated reporting. So in case of Ansible, your playbook has a number of tasks and all these tasks are named. So whenever you run or execute your playbook, it gives a report on which tasks ran successfully, which failed, which clients were not reachable, and so on. All this information is very crucial when you're dealing with a very large infrastructure. And finally, we reach the most exciting part of our tutorial, the hands-on. Before we move on to the actual hands-on, let me just brief you through what exactly we'll be doing. So I'll be hosting two virtual boxes, both CentOS 7 operating systems. One would be my local machine and other my node or the client machine. So on my local machine, first I'll install Ansible. We'll then write the inventory and the playbook and then simply deploy this playbook. On the client machine, there's just one thing that we need to do is that we need to check if the configurations that we mentioned in our playbook are made right. So we'll now begin our demo. This is my Oracle VirtualBox. Here I have my master system, which is the local machine, and this is the client machine. So let's have a look at these two machines. This is my client machine. The terminal is open right now. So the client machine terminal has a black background with white text, and the master machine terminal has a white background with black text, just so you can differentiate between the two. So we'll start at the master machine. The first thing to do is we need to install our Ansible. So yum install Ansible-y is the command to do so. So this might take some time. Yeah, so Ansible's installed. The next step, we go to our host file. So our host file here is basically the inventory. It's where you'll specify all your nodes. In our case, we just have one node. That's the path to your host file. As you'll see, everything here is commented. So just type in the group for your client nodes. So I'm going to name it Ansible Clients. And here we need to type the IP address of our client machine. So my client machine's IP address is 192.168.2.127. So before you come to this, it's advised that you check the IP address on your client machine. The simple command for that is ifconfig. Now once you type the IP address, put a space, and here we need to mention the username and the password for our client. So I'll be logging in as the root user. So this is the password. And then the user. Which is root in my case. That's it. Now you can save this file. Just clear the screen. Next, we move on to our playbook. We need to write the playbook. So the extension for our playbook is YML, which stands for YAML. And as you can see here, I have already written my playbook, but I'll just explain to you how this is done. So a YAML file always begins with 3 dashes. This indicates the start of your YAML file. Now the first thing is you need to give a name to the entire playbook. So I have named it sample book. Host is basically where this would be executed. So as we saw earlier in our inventory, I mentioned client's group name as Ansible Clients. So we use the same name here. The remote user is the user you'll be using at your client. So in my case, that's root. And become true is basically to indicate that you need to set your privileges at root. So that's called a privilege escalation. Now a playbook consists of tasks. So we have here 3 tasks. The first task, I've named it to install HTTPD. So what we are doing here is we are installing our HTTPD package, which is basically the Apache server. And we are installing the most latest version of it. Hence the state value is latest. The next task is running HTTPD. So for the service, the name is HTTPD because that's the service we need to start running and the state is started. Our next task is creating content. So this is the part where we are creating our web page. So copy because this is the file that will be created at the client. The content will be welcome and the destination of the file will be var www.html index.html. As you know, this is like a default path that we use to store all our HTML files. Now, as you can see here, there's quite a lot of indentation. And when it comes to YAML, although it's very simple to write and very easy to read, the indentation is very crucial. So the first dash here represents the highest stage, that is the name of the playbook, and all the dashes under tasks are slightly shifted towards the right. So if you have 2 dashes at the same location, they basically mean that they are siblings. So the priority would be the same. So to ensure that all your tasks are coming under the tasks label, make sure they are not directly under name. So yeah, that's pretty much it. So when you write your YAML file, the language is pretty simple, very readable. Indentations absolutely necessary. Make sure all your spaces are correctly placed. We can now save this file. Next thing, we need to check if the syntax of our YAML file is absolutely right, because that's very crucial. So the command to check the syntax of the YAML file is Ansible playbook, the name of your playbook, syntax check. So we have no syntax errors, which is why the only output you receive is sample.yml, which is the name of your playbook. So our playbook is ready to be executed. The command to execute the playbook is Ansible playbook and the name of your playbook. So our playbook's executed, as you can see here, gathering facts. That's where all the facts of the node, that's the present state of the node, is collected and sent to the local machine. So it's basically to check that if the configuration changes that we are about to make is already made. So it's not made. We do not have the HTTPD package installed on our node. So this is the first change that's made. Also, if it's not installed, of course, it's not running. That's the second change that's made. So it's put into the running state. And a final task, which is create content, is under the OK state. This means that the content's already present in the client machine. So I made it this way so that you can at least see the different states that's present. So over here we have OK4, so 4 things are all fine. The facts are gathered, 2 things are changed, and 1 is already present. 2 changes are made. 0 clients are unreachable and 0 tasks have failed. So this is the documentation that I was referring to previously that Ansible provides automatically and is very useful, as you can see. So our next step, we need to just check on our client machine if all the changes that we desired are made. So let's move to our client. So this is my client machine. So to check this, since we are installing the HTTPD package and hosting a web page, the best way to do it is open your browser and type in localhost. So there you go. Your Apache server is installed and your web page is hosted.
Hey there! Are you exploring test automation? Are you wondering why everyone is talking about Selenium around you? Do you want to know what Selenium is all about? If yes, this is the video for you. Simplilearn brings to you a very simple tutorial on Selenium. What should you expect from this video? Before you start understanding any automation tool, it's good to look back into what manual testing is all about, what are its challenges, and how automation tool overcomes these challenges. Challenges are always overcome by inventing something new. So let's see how Selenium came into existence and how did it evolve to become one of the most popular web application automation tool. Selenium suite of tools. Selenium is not a single tool. It has multiple components. So we will look into each of them. And as you know, every automation tool has its own advantages and limitations. So we will be looking at what the advantages are and the limitations of Selenium and how do we work around those limitations. Alright, so let's get started. Manual testing. A definition, if you can say, a manual testing involves the physical execution of test cases against various applications. And to do what? To detect bugs and errors in your product. It is one of the primitive methods of testing a software. This was the only method which we knew of earlier. It is execution of test cases without using any automation tools. It does not require the knowledge of a testing tool. Obviously, because everything is done manually. Also, you can practically test any application since you're doing a manual testing. So let's take an example. So say we have a use case. You are testing, say, a Facebook application. And in Facebook application, let's open the Facebook application and say, create an account. This is your web page, which is under test now. Now, as a tester, what would you do? You would write multiple test cases to test each of the functionalities on this page. You will use multiple data sets to test each of these fields like the first name, the surname, mobile number, or the new password. And you will also test multiple links What are the different links on this page? Like say forgotten account or create a new page. So these are the multiple links available on the web pages. Also, you look at each and every element of the web page, like your radio buttons, like your drop down list. Apart from this, you would do an accessibility testing. You would do a performance testing for this page, or say a response time after you say click on the login button. Literally, you can do any type of tests manually. Once you have these test cases ready, what do? You start executing these test cases one by one. You will find bugs, your developers are going to fix them, and you will need to rerun all these test cases one by one again until all the bugs are fixed and your application is ready to ship. Now, if one has to run test cases with hundreds of transactions or the data sets and repeat them, can you imagine the amount of effort required in that? Now that brings us to the first demerit of the manual testing. Manual testing is a very time consuming process and it is very boring. Also, it is very highly error prone. Why? Because it is done manually and human mistakes are bound to happen. Since it's a manual execution, testers' presence is required all the time. One needs to keep doing manual steps, step by step again all the time. He also has to create manual reports, group them, format them so that we get good looking reports. Also send these reports manually to all stakeholders. Then collection of logs from various machines where you have run your test, consolidating all of them, creating repositories and maintaining them. And again, since it's all is a manual process, there is a high chance of creating manual errors there. Scope of manual testing is limited. For example, let's say regression testing. Ideally, you would want to run all the test cases which you have written. But since it's a manual process, you would not have the luxury of time to execute all of them, and hence you will pick and choose your test cases to execute. That way, you're limiting the scope of testing. Also, working with large amount of data manually is impractical, which could be the need of your application. What about performance testing? You want to collect metrics on various performance measures as a part of your performance testing. You want to simulate multiple loads on application under test, and hence manually performing these kind of tests is not feasible. And to top it all up, say if you're working in an agile model where code is being churned out by developers, testers are building their test and they're executing them as and when the builds are available for testing. And this happens iteratively. And hence, you will need to run this test multiple times during your development cycle, and doing this manually definitely becomes very tedious and boring. And is this the effective way of doing it? Not at all. So what do? We automate it. So this tells us why we automate. 1, for faster execution. 2, to be less error prone. And 3, the main reason is to help frequent execution of our test. So there are many tools available in the market today for automation. One such tool is Selenium. Birth of Selenium. Much before Selenium, there were various tools in the market, like say RFT and QTP, just to name a few popular ones. Selenium was introduced by a gentleman called Jason Huggins way back in 2004. He was an engineer at ThoughtWorks and he was working on a web application which needed frequent testing. He realized the inefficiency in manually testing this web application repeatedly. So what he did was he wrote a JavaScript program that automatically controlled the browser actions, and he named it as JavaScript Test Runner. Later, he made this open source and this was renamed as the Selenium Core. And this is how Selenium came into existence. And since then, Selenium has become one of the most powerful tools for testing web applications. So how does Selenium help? So we saw all the demerits of manual testing. So we can say by automation of test cases, 1, Selenium helps in speedy execution of test cases. Since manual execution is avoided, the results are more accurate, no human errors. Since your test cases are automated, human resources required to execute automated test cases is far less than manual testing. Because of that, there is a lesser investment in human resources. It saves time, and you know time is money. It's cost effective as Selenium is an open source. It is available free of cost. Early time to market. Since you save effort and time on manual execution, your clients will be merrier as you would be able to ship your product pretty fast. Lastly, since your test cases are automated, you can rerun them any point of time and as many times as required. So if this tool offers so many benefits, we definitely want to know more detail about what Selenium is. Selenium enables us to test web applications on all kinds of browsers like Internet Explorer, Chrome, Firefox, Safari, Edge, Opera, and even the headless browser. Selenium is an open source and it is platform independent. The biggest reason why people are preferring this tool is because it is free of cost. And the QTP and the RFT which we talked about are chargeable. Selenium is a set of tools and libraries to facilitate the automation of web application. As I said, it is not a single tool. It has multiple components which we'll be seeing in detail in some time. And all these tools together help us test the web application. You can run Selenium scripts on any platform. It is platform independent. Why? Because it is primarily developed in JavaScript. It's very common for manual testers not to have in-depth programming knowledge. So Selenium has this record and replay back tool called the Selenium ID, which can be used to create a set of actions as a script, and you can replay the script back. However, this is mainly used for demo purposes only, because Selenium is such a powerful tool that you should be able to take full advantage of all its features. Selenium provides support for different programming languages like Java, Python, C#, Ruby. So you can write your test scripts in any language you like. One need not know in-depth or advanced knowledge of these languages. Also, Selenium supports different operating systems. It has support for Windows, Macs, Linux, even Ubuntu as well. So you can run your Selenium test on any platform of your choice. And hence, Selenium is the most popular and widely used automation tools for automating your web applications. Selenium set of tools. So let's go a little more deeper into Selenium. As I said, Selenium is not a single tool. It is a suite of tools. So let's look at some of the major components or the tools in Selenium and what they have to offer. So Selenium has 4 major components. 1. Selenium ID. It's the most simplest tool in the suite of Selenium. It is integrated development environment. Earlier, Selenium ID was available only as a Firefox plugin, and it offered a simple record and playback functionality. It is a very simple to use tool, but it's mainly used for prototyping and not used for creating automation in the real-time projects because it has its own limitations like any other record and replay tool. Selenium RC. This is nothing but Selenium Remote Control. It is used to write web application tests in different programming language. What it does, it basically interacts with the browser with the help of something called as RC server. And how it interacts is it uses a simple HTTP POST GET request for communication. This was also called as Selenium 1.0 version, but it got deprecated in Selenium 2.0 version and was completely removed in 3.0, and it was replaced by WebDriver. And we will see in detail as why this happened. Selenium WebDriver. This is the most important component in the Selenium suite. It is a programming interface to create and execute test cases. It is obviously the successor of the Selenium RC which we talked about because of certain drawbacks which RC had. So what WebDriver does is it interacts with the browsers directly, unlike RC where the RC required a server to interact with the browser. And the last component is the Selenium Grid. So Selenium Grid is used to run multiple test scripts on multiple machines at the same time. So it helps you in achieving parallel execution. Since the Selenium WebDriver you can only do sequential execution, Grid is what comes into picture where you can do your parallel execution. And why is parallel execution important? Because in real-time environment, you always have the need to run test cases in a distributed environment. And that is what Grid helps you to achieve. So all this together helps us to create robust web application test automation. And we will go in detail about each of these components. So before that, let's look at the history of Selenium version. So what did Selenium version comprised of? It had an IDE, RC and Grid. And as I said earlier, there were some disadvantages of using RC. So RC was on its path of deprecation and WebDriver was taking its birth. So if you look at Selenium 2 version, it had an earlier version of WebDriver and also the RC. So they coexisted. From 3.0 onwards, RC was completely removed and WebDriver took its place. There is also a 4.0 version around the corner and it has more features and enhancements. Some of the features which are talked about are W3C WebDriver standardization, improved IDE and improved Grid. Now let's look at each of the components in the Selenium suite. Selenium IDE is the most simplest tool in the suite of Selenium. It is nothing but an integrated development environment for creating your automation scripts. It has a record and playback functionality and is a very simple and easy to use tool. It is available as a Firefox plugin and a Chrome extension. So you can use either of this browser to record your test scripts. It's a very simple user interface using which you can create your scripts that interact with your browser. The commands created in the scripts are called Selenium commands, and they can be exported to the supported programming language, and hence this code can be reused. However, this is mainly used for prototyping and not used for creating automation for your real-time projects. Why? Because of its own limitation, which any other record and replay tool has. So a bit history of Selenium IDE. So earlier, Selenium IDE was only a Firefox extension. So we saw that IDE was available since the Selenium version 1. Selenium IDE died with the Firefox version 55. That was, IDE was stopped supporting from 55 version onwards. And this was around 2017 timeframe. However, very recently, all new brand Selenium IDE has been launched by Apply Tools. And also they have made it a cross-browser. So you can install the extension on Chrome as well as an add-on on Firefox browser. So they completely revamped this IDE code and now they have made it available on the GitHub under the Apache 2.0 license. And for the demos today, we'll be looking at the new IDE. Now with this new IDE also comes a good amount of features. Reusability of test cases, better debugger, and most importantly, it supports parallel test case execution. So they have introduced a utility called Selenium Side Runner that allows you to run your test cases on any browser. So you can create your automation using IDE, say on Chrome or Firefox, but through command prompt, using your Side Runner, you can execute these test cases on any browser, thus by achieving your cross-browser testing. Control flow statement. So initially in the previous versions of IDE, there were control flow statements available. However, one had to install a plugin to use them. But now it is made available out of box. And what are these control flow statements? These are nothing but your if-else conditions, the while loops, the switch case, and so on. It also has an improved locator functionality. That means it provides a failover mechanism for locating elements on your web page. So let's look at how this IDE looks and how do we install it and start working on that. So for that, let me take you to my browser. So say, let's go to the Firefox browser. So on this browser, I already have the IDE installed. So when you already have an IDE installed, you will see an icon here which says Selenium IDE. And how do you install this? You simply need to go to your Firefox add-ons. Here, where it says find more extension, so just type in Selenium IDE and search for this extension. So in the search results, you see this Selenium IDE, just click on that. And now since I've already installed, here it says remove. Otherwise, for you, it is going to give you an add button here. Just click on the add button. It will install this extension. Once it is installed, you should be able to see this Selenium IDE icon here. Okay, so now let's go ahead and launch this IDE. So when I click on that, it is going to show me a welcome page where it's going to give me a few options. The first option is it says record a new test case in a new project. So straight away, if you choose this option, you can start recording a test case. In which case, it's going to just create a default project for you, which you can save it later. Then open an existing project. So you can open if you already have a saved project. Create a new project and close. So I already have an existing project with me for the demo purpose. So I'll go ahead and open that. So I'll say open existing project, and I have created a simple script. What the script does is it logs me into the Facebook using a dummy username and password. That's all. It's a very simple script with few lines, and this is what it's going to do. So what we will simply do is we'll just run the script and see how it works. For that, I'm just going to reduce the test execution speed so that you should be able to see every step of execution here. Alright, so what I'll do now here is I'll just adjust this window and I'll just simply say run current test. Alright, so I'll just get this side by side so that you should be able to see what exactly the script is doing. Okay, so now you're able to see both the windows. Okay, so now it's going to type in your user email here. There you go. And now it will enter the password and it has clicked on the login button. So it's going to take a while to say login. And since these are the dummy IDs, you are not able to log in here and you're going to see this error window. Fine. That is what is the expected output here. Now on the ID, if you look here, after I execute the test case, every statement or every command which I have used here is colored coded in green. So that means this particular step was executed successfully. And then here in the log window, it will give you a complete log of this test case, right from the first step till the end. And your end result is, it says FB login, which is my test case name, completed successfully. Let's look at few components of this IDE. The first one is the menu bar. So let's go to our IDE. Alright, so the menu bar is right here on the top. So here is your project name. So either you can add a new project here or rename your project. So since we already have this project which is named as Facebook. And then on the right, you have options to create a new project, open an existing project, or save the current project. And then comes our toolbar. So using the options in this toolbar, you can control the execution of your test cases. So first one here is the recording button. So this is what you use when you start recording your script. And then on the left, you have two options here to run your test cases. The first one is run all tests. So in case you have multiple test cases written here, you can execute them one by one sequentially by using this run all test. Else what you can do is if you just want to run your current test, this is what you would use. Then IDE has this debugger option which you can use to do a step execution. So say for example, now whenever I run the scripts, it's going to execute each and every command here sequentially. So instead, if I just select the first command and say do step execution, alright, so what it does is the moment it finishes the first command, which is opening of Facebook, right? I think which is already done here. Yeah. Alright. So once this is done, it is going to wait immediately on the second command and it says pause debugger. So from here, you can do whatever you would like to do. In case you want to change the command here, you can do that. You can pause your execution. You can resume your execution here, right? You can even completely stop your test execution, or you can just select this to run the rest of the test case. So if we say run the test case, what it is going to do is it's just going to simply go ahead and complete the test case. Now, there is another option here, which is, you see the timer there, which says test execution speed. So to execute your test cases in the speed you want. Say whenever you're developing an automation script, right, and say you want to give a demo. So you need to control the speed sometimes so that the viewer is able to exactly see all the steps which is being performed. And this gives you an option to control that complete execution, right? So do you see the grading here? So we have somewhere from fast to completely slow execution. So the previous demo which I showed was I controlled the speed and then I executed it so that we could see every command how it is being executed. Alright, so what's the next? This is called as an address bar. So whenever you enter an URL here, that is where you want to conduct your test. And another thing what it does is it keeps a history of all the URLs which you have used for running your test. Then here is where your script is recorded. So each and every instruction is displayed here in the order in which you have recorded the script. And then if you look here, you have something called as log and reference. So now log is an area where it records each and every step of your command as and when they get executed. Right? So if you see here, it says open https facebook.com and OK. So that means this command was executed successfully. And after the complete test case is done, it gives you whether the test case passed or failed. So in case there is a failure, you'll immediately see this test case is failed in red color. Also, there is something called as reference here. For example, say if I click on any of this command, the reference tab, what it is going to show me is details of this command which I have used in the script. It gives you the details of the command as well as what the arguments have been used or how is that you need to be using this particular command. Okay, so now what we'll do is let's go ahead and write a simple script using this IDE. So with this, you'll get an idea as how do we actually record scripts in IDE. So for that, I have a use case here, a very simple use case. So what we will do is we will open amazon.in, then we'll simply search for say product iPhone. And once we get that search page where all your iPhones are displayed, we will just do an assert on the title of the page. Simple. Alright, so let's do that. So first thing what I need is an URL. Okay, so first let me go to my Firefox browser here and say amazon.in. So why I'm doing this? Just to simply get the right URL, absolute URL path here. And so that I don't make any mistakes while typing in the URL. Okay, so I got this. So let me close all these windows. I don't need any of this. Let's minimize this. Alright, so here what I'll do, in the tests tab, I'll say add a new test and name this test as Amazon search. Done. I'll say add. Now I'll enter this URL which I just copied it from my browser. Okay, and then I'll just say start recording. So what it did was, since I've entered the URL in this address box, it just opened the amazon.in URL. Now let's do our test case. So in my test case, what I said was I want to search for iPhone. Once I have this, I'm just going to click on my search button. So now this gives me a list of all iPhones. And then I said I want to add an assertion on the title of this page. So for me to do that, what ID gives me an option is I have to just right click anywhere on this page and you'll see the Selenium ID options here. So in this, I will select assert title and then I will close this browser. So that kind of completes my test case. So now take a look at all the steps which is created for me. So it says open slash because I've already provided the URL here. So either you can replace it with your regular URL or you can just leave it as it is. So what I will do, since this is going to be a proper script and I might be using this to run it from my command prompt also. So I'll just replace this target with the actual URL. And then what it is doing, it is setting a window size. Then there are whatever I did on that particular URL on that website, it has recorded all the steps for me. So this is where it says type into this particular text box, which is my search box. And what did it type? iPhone. This was the value which I entered. Now there was one more feature which I told you in this new ID, which I said it has a failover mechanism for your locating techniques. Now that is what this is. Now if you look here, this ID is equal to tab search text box. This is nothing but that search box where we entered the text iPhone. And it has certain identification through which this IDE identifies that web element. And that has multiple options to select that particular search box. So right now what it has used is ID is equal to tab search box. However, if you know the different locating techniques, you will be able to see here that it has other techniques also which it has identified, like the name and the CSS and the XPath. So how does this help in failover is, say tomorrow if Amazon.in website changes the ID of this element, right? You are not going to come and rewrite the scripts again. Instead, by using the same script, what it will do is, if this particular ID fails, if it is unable to find the element using the first locator, which is the ID, it simply moves to the next available ones and it tries to search for that element until one of these becomes true. That is what was the failure mechanism which has got added now. It's a very brilliant feature because most of our test cases break because of element location techniques. Well, let's come back to this. So then we added an assert title, right? So what is assert title here? It simply captures the title of that particular page and it checks. This is all. A very simple test case. So what we will do now is we will stop the recording and then I've also given a close browser. So right now what I will do is I'll just comment this out. Why? Because if I just run this test case, it's going to be very fast and you might not be able to catch the exact command execution what has happened. Alright, so right now I'll just disable it so that it will just do all these test cases and it just stays there without closing the browser. So now I'll just say run the current test case. So your Amazon in is launched. Okay, it is typed in the iPhone. It's also clicked on the search. So it is done. So now if you look here, since we are in the reference tab, it is not able to show. So let's go to the log. And now let's see the log. So it's going to be a running log. So if you notice here, the previous examples which we have run for Facebook is also in the same log. So we will have to see the log from running Amazon search because that's our test case. So if you see here, every command line, right, was executed successfully. Assert title was also done and your test case was executed successfully. So it passed. Now what we will do is on this assert title, I'll just modify this and let's say just add some text. I'll just add double S here. Now this by intentionally I'm going to fail this test case just to show you that whenever there is a test case failure, how does the IDE behaves and how do you get to know the failures. Alright. So I'll just run the test case again. So before that, let's close the previous window. Alright, done. And now here I'll also uncomment the close because anyway it's a failure which I'm going to see, which I should be able to see it in the logs. So I'll close the browser after the execution of test case. Okay, so let's simply go and run the test case. Okay, Amazon.in is launched. It should search for iPhone now. Yeah, there you go. All right, now it should also close the browser. Yes, it has closed the browser and it has failed. Now see here. Now this is the line where our command failed. Why? Because the expected title was not there. And if you look in the logs, it says your assert title on Amazon.in failed. Actual result was something different and it did not match with what we had asked it for. So this is how simple it is to use your IDE to create your automation scripts. So we saw all the components of IDE. We saw the record button, then I showed you the toolbar, I showed you the editor box and also the test execution log. So now let's come to what are the limitations of this IDE. With IDE, you cannot export your scripts, your test scripts to WebDriver scripts. This support is not yet added, but it is in the works. Data-driven testing, like using your Excel files or reading data from the CSV files and passing it to the script, this capability is still not available. Also, you cannot connect to database for reading your test data or perform any kind of database testing. With Selenium WebDriver, yes, you can. Also, unlike Selenium WebDriver, you do not have a good reporting mechanism with the IDE, like say for example, TestNG or ReportNG. So that brings us to the next component of the suite, which is Selenium RC. Selenium Remote Control. So Selenium RC was developed by Paul Hammond. He refactored the code which was developed by Jason and was credited with Jason as a co-creator of Selenium. Selenium Server is written in Java. It is used to write web application tests in different programming languages, as it supports multiple programming languages like your Java, C#, Perl, Python and Ruby. It interacts with the browser with the help of an RC server. So this RC server uses a simple HTTP GET and POST request for communication. And as I said earlier also, Selenium RC was called as Selenium 1.0 version. But it got deprecated in Selenium 2.0 and was completely removed in 3.0, and it got replaced by what? WebDriver. And we'll see why this happened and what was that issue which we had with the RC server. So this is the architecture of Selenium Remote Control at a very high level. So when Jason Huggins introduced Selenium, you know the tool was called as JavaScript program. And then that was also called as a Selenium core. So every HTML has a JavaScript statements which are executed by web browser, and there is a JavaScript engine which helps in executing this command. Now this RC had one major issue. Now what was that issue? Say for example, you have a test script, say test.javascript here, which you are trying to access elements from anywhere from the google.com domain. So what used to happen is every element which is accessible are the elements which can belong only to google.com domain. Like say for example, mail, the search or the drive. So any elements from this can be accessible through your test scripts. However, nothing outside the domain of say google.com in this case was accessible. Say for example, if your test scripts wanted to access something from yahoo.com, this was not possible. And this is due to the security reasons, obviously. Now to overcome that, the testers, what they had to do was they had to install the Selenium core and the web server, which contained your web application which is under test on the same machine. And imagine if you have to do this for every machine which is under test. This is not going to be feasible or even effective all the time. And this issue is called as a same origin policy. Now what a same origin policy issue says is it prohibits a JavaScript from accessing elements or interacting with scripts from a domain different from where it is launched. And this is purely for the security measure. So if you have written a scripts which can access your google.com or anything related to google.com, these scripts cannot access any elements outside the domain. Like as we said in the example yahoo.com. This was the same origin policy. Now to overcome this, what this gentleman did was he created something called as Selenium Remote Control Server, to trick the browser in believing that your core, your Selenium core and your web application under test are from the same domain. And this is what was the Selenium Remote Control. So if you look at again a high level architecture or how did this actually work, first you write your test scripts, which is here, right, in any of the supported language like your PHP or your Java or Python. And before we start testing, we need to launch this RC server, which is a separate application. So this Selenium server is responsible for receiving the Selenium commands, and these Selenium commands are the ones which you have written in your script. It interprets them and reports the result back to your test. So all that is done through your RC server. The browser interaction which happens through RC server, right, from here to your browser. So this happens through a simple HTTP and post and get request, and that is how your RC server and your browser communicate. And how exactly this communication happens? This RC server, it acts like a proxy. So say your test scripts asks to launch a browser. So what happens is this commands goes to your server and then your RC server launches the browser. It injects the JavaScript into the browser. Once this is done, all the subsequent calls from your test script, right, from your test scripts to your browser goes through your RC. And now upon receiving these instructions, your Selenium core executes these actual commands as JavaScript commands on the browser. And then the test results are displayed back from your browser to your RC to your test scripts. So the same cycle gets repeated, right, until the complete test case execution is over. So for every command what you write in your JavaScript here or your test script here goes through a complete cycle of going through the RC server to the browser, collecting the results again from the RC server back to your test scripts. So this cycle gets repeated for every command until your complete test execution is done. So RC had definitely a lot of shortcomings, and what are those? So RC server needs to be installed before running any test scripts, which we just saw. So that was an additional setup since it acts as a mediator between your commands, which is your Selenium commands, and your browser. The architecture of RC is complicated. Why? Because of its intermediate RC server, which is required to communicate with the browser. The execution of commands takes very long. It is slower. We know why. Because every command in this takes a full trip from the test script to your RC server, to the core engine, to the browser, and then back to the same route, which makes your overall test execution very slow. Lastly, the APIs supported by RC are very redundant and confusing. So RC does have a good number of APIs. However, it is less object oriented. So they are redundant and confusing. Say for example, say if you want to write into a text box, how and when to use a type key command or just a type command is always confusing. Another example is some of the mouse commands, using a click or a mouse down. Both kind of, almost providing a similar functionality. So that is the kind of confusion which developers used to create. Hence, Selenium RC got deprecated and is no more available in latest Selenium versions. It is obsolete now. Now to overcome these shortfalls, WebDriver was introduced. So while RC was introduced in 2004, WebDriver was introduced by Simon Stewart in 2006. It's a cross-platform testing platform, so WebDriver can run on any platform like say Linux, Windows, Mac, or even if you have a Ubuntu machine, you can run your Selenium scripts on this machine. It is a programming interface to run test cases. It is not an IDE. And how does this work actually? So test cases are created and executed using web elements or objects using the object locator and the WebDriver methods. So when I do a demo, you will understand what these WebDriver methods are and how do we locate the web elements on the web page. It does not require a core engine like RC. So it is pretty fast. Why? Because WebDriver interacts directly with the browser and it does not have that intermediate server like the RC had. So each browser, in this case, what happens is each browser has its own driver on which the application runs. And this driver is responsible to make the browser understand the commands which you will be passing from the script. Like say for example, click of a button or you want to enter some text. So through your script, you tell which browser you want to work with, say Chrome, and then the Chrome driver is responsible for interpreting your instructions and to execute it on the web application launched on the Chrome browser. So like RC, WebDriver also supports multiple programming languages in which you can write your test scripts. So another advantage of WebDriver is it supports various frameworks like TestNG, JUnit, NUnit, and ReportNG. So when we talk about the limitations of WebDriver, you will appreciate how this support for various frameworks and tools help in making the Selenium a complete automation solution for web application. So let's look at the architecture of WebDriver at a high level. What is in WebDriver? So WebDriver consists of 4 major components. The first one is we have got client libraries, right? Or what we also call it as language bindings. So since Selenium supports multiple languages and you're free to use any of the supported languages to create your automation script, these libraries are made available on your Selenium website, which you need to download and then write your scripts accordingly. So let's go and see from where do we download this. So if I go to my browser, so seleniumhq.org, right? So if you're working with Selenium, this website is your Bible. So anything and everything you need to know about Selenium, right? You need to come here and use all the tabs here in this website. So right now what we are going to look at is what are those language bindings. So for that, I'll have to go to this download tab here, okay? And if you scroll down here, you will see something like Selenium client and WebDriver language bindings. And for each of the supported language of Selenium, you have a download link, right? So say for example, if you're working with Java here, what you need to do is you need to download your Java language binding. So let's go back to the presentation. So this is where your language bindings are available. Next, so Selenium provides lots of APIs for us to interact with the browser. And when we do the demo, I'll be showing you some of these APIs, right? And these are nothing but the REST APIs. And everything, whatever we do through the script happens through the REST calls. Then we have a JSON wire protocol. What is JSON? JavaScript Object Notation. It is nothing but a standard for exchanging data over the web. So for example, you want to say launch a web application through your script. So what Selenium does it creates a JSON payload and posts the request to the browser driver. That is here. And then we have this browser drivers themselves. And as I said, there is a specific driver for each browser. As you know, every tool has its own limitation. So does Selenium. So let's look at what these limitations are and if there are any workarounds for them. Cannot test mobile applications requires framework like APM. Selenium is for automating web application. It cannot handle mobile applications. Mobile applications are a little different and they need its own set of automation tool. However, what Selenium provides is a support for integrating this APM tool, which is nothing but a mobile application automation tool. And using APM and Selenium, you can still achieve mobile application automation. And when do you usually need this? When your application under test is also supported on mobile devices, you would want a mechanism to run the same test cases on web browser as well as your mobile browsers, right? So this is how you achieve it. The next limitation, so when we talked about the components of Selenium, I said that with WebDriver, we can achieve only sequential execution. However, in real-time scenario, we cannot just live with this. We need to have a mechanism to run our test cases parallelly on multiple machines as well as on multiple browsers. So though this is a limitation of WebDriver, but what Selenium offers is something called as grid, which helps us achieve this. And we will see in shortly what the Selenium grid is all about. Also, if you want to know more details as how do we work with the grid, how do you want to install that grid, so do check out our video on Simplilearn website on Selenium grid. Third limitation, so limited reporting capability. So Selenium WebDriver has a limited reporting capability. It can create basic reports, but what we definitely need is a more. So it does support some tools like say TestNG, ReportNG and even Extent reports, which you can integrate with Selenium and generate beautiful reports. Powerful, isn't it? Also, there are other challenges with Selenium, like Selenium is not very good with image testing, especially for the ones which are designed for web application automation. But then we have other tools which can be used along with Selenium like AutoIt and Securely. So if you look at all this, Selenium still provides a complete solution for your automation needs. And that's the beauty of Selenium, and that is why it makes the most popular tool of today for automation. Okay, let's do a quick comparison between the Selenium RC and the WebDriver. So RC has a very complex architecture. You know why? Because of the additional RC server. Whereas due to direct interaction with the browser, WebDriver architecture is pretty simple. Execution speed. It is slower in RC and much faster in WebDriver. Why? Because in WebDriver, we have eliminated that complete layer of Selenium server, right? That the RC server, and we established a direct communication with the browser through browser drivers. It requires an RC server to interact with the browsers. We just talked about it. And whereas WebDriver can directly interact with the browser. So RC, again, we talked about this as one of the limitations, that we have a lot of redundant APIs, which kept developers guessing as which API to use for what functionality. However, WebDriver offers pretty clean APIs to work with. RC did not offer any support for headless browser, whereas in WebDriver, you do have a support for using headless browsers. Let's see the WebDriver in action now. Now for the demo, we will use this particular use case. And what this use case says is navigate to the official Simplilearn website. Then type the Selenium in search bar and click on it, and click on the Selenium 3.0 training. So we are basically searching for Selenium 3.0 training on the Simplilearn website. First, let's do the steps manually, and then we will go ahead and write the automation script. So let's go to my browser. On my browser, what I'll do is let me first launch the Simplilearn website. Okay, and here what my use case step says is I need to search for Selenium and click on the search button. So once I do that, it is going to give me a complete list of all kind of Selenium trainings which is available with Simplilearn. And what I'm interested in is the Selenium 3.0 training here. Once I find this on the web page, I need to go and click on that. Alright. So this is all the steps which we are going to perform in this use case. Okay. Now, so for writing the test cases, I'll be using an IDE which is Eclipse. I've already installed my Eclipse, and also I have installed Selenium in this instance of my Eclipse. Alright, so if you can see the reference library folder here, you will see all the jars which are required for the Selenium to work. Next, another prereq which is required for Selenium, and that is your driver files. Now, every browser which you want to work with has its own driver file to execute your Selenium scripts. And since for this demo, I'll be working with the Firefox browser, I will need a driver file for Firefox. Now, driver file for Firefox is the Gecko driver, which I have already downloaded and placed in my folder called drivers. Now, where did I download this from? Let's go ahead and see that. So if I go back to my browser, and if you go to your seleniumhq.website, you have to go to this download tab here. In the download tab, when you scroll down, you will see something like third-party drivers, bindings and plugins. In this, you will see the list of all the browsers which is supported by Selenium. And against each of this browser, you will find a link which has the driver files. Now, since we'll be using the Gecko driver, this is the link where you need to go to, and depending on which operating system which you're working on, you need to download that particular file. Now, since I'm working on Mac, this is the file which I'm using. If you're a Windows user, you need to download this zip file and unzip it. So once you unzip that, you would get a file called Gecko driver for your Firefox or a Chrome driver for your Chrome browser. And then what you do is you just create a directory called drivers under your project and just place the driver files here. So these are the two prereqs for your Selenium. One is importing your jar files like this, and then having your drivers downloaded and keep them under a folder where you can reference to. Okay. So now we'll go ahead and create a class. I already have a package created in this project. So I'll use this project and create a new class. So I'll say create new Java class, and let's call this as search training. I'll be using a public static void main, and I'll click on finish. So let's remove this auto generated lines as we do not need them. Alright. Now the first statement which you need to write before even you start writing the rest of your code is what you need to do is you need to define or declare your driver variable using your class WebDriver. So what I would do is I'll say WebDriver driver. Done. Alright. Now you will see that this IDE is going to flash some errors for you. That means it is going to ask you to import certain libraries which is required by the WebDriver. So simply just go ahead and say import WebDriver from org.opensq.selenium. This is the package which we will need. Alright. So you have a driver created which is of the class WebDriver. And now after this I'm going to create three methods. Alright. So first method I will have for launching the Firefox browser. Okay. And then I will write a simple method for searching Selenium training and clicking on it. This is the actual use case what we'll be doing. And then third method I'm going to write is just to close the browser which I'm going to be opening, right? So these are the different methods which I'll be creating, and from the public static void main I will just call these methods one after the other. Okay, so let's go ahead and write the first method. Now my first method is launching the Firefox browser. So I'll say public void, since my return type is null or there is no return type for this, let's call it as launch browser. Okay, alright. Now in this, for launching any browser, I need to mention two steps. Now the first step is where I need to do a system.set property. Okay, let's do that first and then I'll explain what this does. I'll just say system.set property. So this accepts a key and a value pair. So what is my key here? My key here is webdriver.gecko.driver, and I need to provide a value. So value is nothing but the path to the Gecko driver. And we know that this Gecko driver which I'm going to use here is right here in the same project path under the drivers folder, correct? And that is what the path which I'm going to provide here. So here simply I need to say drivers/Gecko driver. It's GECKO. Alright, Done. And let me close this sentence. Alright. Now since I'm a Mac user, my Gecko driver installable is just the name Gecko driver. If you're a Windows user and if you're running your Selenium scripts on the Windows machine, you need to provide a complete path to this, including .exe, because driver executable on your machines is going to be gecko driver.exe. Alright. So just make sure that your path which you mentioned here in the system.set property is the correct path. Okay. Then the next thing what we need to do is, I need to just say driver is equal to new Firefox driver. Okay. So this command, new Firefox driver, creates an instance of the Firefox browser. Now this is also flagging me error. Why? Because again it's going to ask me to import the packages where the Firefox driver class is present. Okay, we did that. Now these two lines are responsible for launching the Firefox browser form. So this is done. So what's my next step in the use case? Now I need to launch the website Simplilearn. So for that we have a command called driver.get. Driver.get, what it does is, whatever URL you're going to give it here in this double quotes as an argument, it is going to launch that particular website. And for us, it's a Simplilearn website. So what I do as a best practice is, instead of typing out the URL, I go to my browser, launch that URL which I want to test, and I simply copy it. Come back to your Eclipse and just simply paste it. So this ensures that I do not make any mistakes in the URL. Okay, so done. So our first method is ready, where we are launching the browser, which is our Firefox browser, and then launching the Simplilearn website. Now, the next method. What is my next method? In my next method, I need to give the search string to search Selenium training on this particular website. Now for that, we need to do few things. What are those few things? Let's go to the website again. All right, so let me relaunch this. Let's close this. Okay, let me remove all this and let's go to the home page first. Okay, this is my home page. So as you saw, when I did a manual testing of this, I entered the text here. So now since I have to write a script for this, first I need to identify what this element is. For that, what I'm going to do is I'm just going to say right click here and I'll say inspect element. Alright, now this element, let's see what attribute it has which I can use for finding this element. So I see that there is an ID present. So what I'm going to do is I'm just going to simply use this ID and then I'll just copy this ID from here. Go back to Eclipse. Let's write a method first. So I'll say public void, and what do we give the method name? Say search training or just search. Alright, now in this I need to use a command called driver.findElement by ID is what I'm going to use as a locating technique, and in double quotes the ID which I copied from the website is what I'm going to paste here. Okay, and then what am I going to do on this element is I need to send that text, the text which I'm going to search for, which is Selenium. So I'll just say send keys, and whatever text I want to send, I need to give it in double quotes. So for that, Selenium. So this is done. So now I've entered the text here, and after entering the text, I need to click on this button. So for that, I need to first know what that button is. So let's inspect that search button. Okay. Now, if you look at the search button, other than the tag which is span and the class name, I do not have anything here. Alright. So what I can do is I can either use the class name or I can write an XPath. Since this is a demo which we have already used ID locating technique, I would go ahead and use the XPath here. So for me to construct an XPath, I will copy this class first. Okay. And then I already have a crow path installed on my Firefox. So I'll use the crow path and first test my XPath. So I'll just say /. Let's see what was that element. It has a span tag. Okay, so I'll have to use span and at class equal to, and I'll just copy the class name here. And let's see if it can identify that element. Yeah, so it is able to identify. So I'll just use this XPath in my code. So I'll go back to Eclipse and I'll say driver.findElement by.xpath. And the XPath which I just copied from crowpath is what I'm going to paste here. And what is the action I need to do here? I need to say click. Done. So I have reached a stage where I have entered this Selenium. Okay. And then I have clicked on the search button. Once I do this, I know that expected result is I should be able to find this particular link here, Selenium 3.0 training. Okay. And I should be able to click on that. So for that, again, I need to inspect this. So let's inspect this Selenium 3.0. Alright, so now what are the elements this has? Now this particular element has attributes like it has a tag h2, then it has got some class name and some other attributes. So I would like to use a XPath here. Now this time while using the XPath, I'm going to make use of a text functionality so that I can search for this particular text. So I'll simply copy this. I'll go to my crow path. The tag is h2. So I'll say simply h2. Okay. And here I'll say text equal to, and this is the text which I copied. I missed out that yes there. So I'm just going to add an S. Okay. So let's first test here whether it is able to identify that element. Yeah. So it is able to identify. So can you see a blue dotted line? It is able to show us which element it is identified. So I'll copy this X path now and let's go to my IDE Eclipse. So now here what I need to do is I'll have to again simply say driver dot find element by dot XPath and paste the XPath which we just did, and then again I have to do a click operation. Done. Alright. So technically we have taken all the steps of the use case and we have written the commands for that. Alright. Now let's add an additional thing here. Say after coming to this page, after finding this, we want to say print the title of this page. Now what is the title of this page? If you just hover your mouse on this, it says online and classroom training for professional certification courses Simplilearn. So what I will do is after doing all these operations, I will just print out this page title on our console. So for that I have to just do this driver dot so let's do a sysout. So I'll say sysout system.out.println. Okay, and here I would say let's add a text here. The page title is, and then let's append it with driver dot get title. So this is the command which we'll be using to fetch the page title. Done. Now what is the last method I need to add? Just to close the browser. Alright, so let me add a method here. I'll say public void close browser, and it's a one single command which I need to call. I'll say driver dot quit. Okay, and then I need to call all these methods from my public static void main. So I'll let me use my class name, which is this. So I'm going to create an object obj is equal to new class name, and then using this object, first is I need to call the method launch browser, and then I'll call the method search, right, and then I'll call the method close browser. Done. So technically our script is ready with all the functionality which we wanted to cover from our use case. Now there are few other tweaks which I need to do this, and I'll tell you why I need to do this. Now for example, after we click here, right, after we click on the search, if you observed on your website, it took a little while before it listed out all the Selenium trainings for us. And usually when you're actually doing it, you wait for the Selenium 3.0 training to be available and then you click on that. Now same thing, you also need to tell your scripts to do that. You need to tell your scripts to wait for a while until you start seeing the Selenium 3.0 training or it appears on your web page. There are multiple ways to do that in your script, and it is a part of overall synchronization, what we call, where we use kind of implicit and explicit kind of ways. Now since this is a demo, for demo purpose what I'm going to do is I'm going to use a command called thread.sleep, and I'm just going to give an explicit wait of say 3 seconds. So you can use this mainly for the demo purposes. You can use a thread.sleep command. Now this thread.sleep command needs us to handle some exceptions. So I'm just going to click on add throws declaration and say interrupted exception. Now same thing I'll have to do it in my main function also. Okay, so let's do that and complete it. Alright, so this is done. So by doing this, what am I doing? I'm ensuring that before I click on the Selenium 3.0 training, we are giving enough time for the script to wait until the web page shows this link to the Selenium 3.0 training. That's one thing I'm doing. Alright, and also now since you're going to be seeing this demo through the video recording, the script when it starts running, it is going to be very fast. So you might just miss out seeing how it does the send keys and how did it click on the search button. For us to enable us to see it properly, I'll just add some explicit waits here just for our demo purpose. So after entering the keys, right, so what I'll do is I'll just give a simple thread.sleep here. Okay, so probably a 3 seconds or a 2 seconds wait should be good enough. Okay, a 3 seconds wait should be good enough here so that we should be able to see how exactly this works on your browser when we execute this. Okay, now our complete script is ready. So what I'll do is I'll just save the script and then we will simply run the script. So to run the script, I'll just say right click, run as Java application. Okay, it says asks me to select and save. I've saved the script now. So let's observe how it runs. Okay, the simplylearn.com, the website is launched. So the Selenium text has been entered in the search box. It is clicked on the search. Okay, all right. So now it did everything whatever we wanted it to do. All right. So since we are closing the browser, you were unable to see whether the Selenium 3-dot training was selected or not. However, what I have given here is to fetch the title after all these operations were complete. And if you see here, the complete operations was done and we were able to see the page title here. Okay. So now what I'll do, since we are unable to see whether it clicked on the Selenium 3.0 training or not, I'll just comment out the close browser, the command. Okay. So we will not call the close browser so that the browser remains open and we get to see whether did it really find the training link or not. Okay. So let me close this window. We don't need this Firefox window. Close all tabs and then I'll just re-execute this script. So I'll say run as Java application. So save the file. Okay, simplylearn.com is launched. So search text is entered. Now it's going to click on the search button. Yes. All right. So we've got the search results. It should click on Selenium 3.0 training and yes, it is successfully able to click on that. All right. So now it's not going to close the browser because we have commented on that line. However, it did print us the title here. All right. So this is a simple way of using the Selenium scripts. Selenium Grid. So Grid is used to run multiple test scripts on multiple machines at the same time. With WebDriver, you can only do sequential execution, but in real-time environment, you always have the need to run test cases in distributed environment, and that is where Selenium Grid comes into picture. So Grid was conceptualized and developed by Patrick. The main objective is to minimize test execution time. And how? By running your test parallelly. So design is in such a way that commands are distributed on multiple machines where you want to run test, and all these are executed simultaneously. What do you achieve by this methodology? Of course, the parallel execution on different browsers and operating system. Grid is pretty flexible and can integrate with many tools. Like say you want a reporting tool integrated to pull all the reports from the multiple machines where you're running your test cases, and you want to present that report in a good looking format. So you have an option to integrate such report. Okay, so how does this Grid work? So Grid has a hub and node concept which helps in achieving the parallel execution. Let's take an example. Say your application supports all browsers and most of the operating system. Like as in this picture, you could say one of them is a Windows machine, one of them is a Mac machine, and another one is say a Linux machine. So your requirement is to run the test on all supported browsers and operating systems, like the one which is depicted in this picture. So what you have to do is, first thing is you configure a master machine, or what you also call it as a hub, by running something called a Selenium standalone server. And this standalone server can be downloaded from the Selenium HQ website. Using the server, you create a hub configuration, that is this node. And then you create nodes specific to your machine requirement. And how are these nodes created? You again use the same server, which is your standalone Selenium server, to create the node configuration. So I'll show you where the Selenium server can be downloaded. So if we go back to our Selenium HQ website, so you can see here right on the top, it says Selenium standalone server. And this is the latest version available. So you just need to download. Once you download this, keep a version of this one on your master machine, that is your hub, and this should also be present on your node machines. And there is a certain command which you can use to install this server as a node and as a master depending on your configuration. So once that is done, you have your master or the hub and the nodes created. Your master can control on which nodes you want to execute test. Now say if this is a Mac machine, this is a Windows machine, through your master or your hub, you control on which machine you want to execute what tests. Then also you could have a multiple combination of tests. Like say for example, smoke test to be run on all these nodes. That's the kind of configuration you can create. Or a certain component test to be run on say only Windows 10 with an Edge browser. Or say regression test on Mac machine. So any such things, whatever configurations you have for your node, what happens is the hub picks the right node which conforms to your requirements or the configurations which you have set up, and then sends a command to the node to execute those test cases on the node. Everything is controlled through your master machine only here. What happens on the node? So once the node gets the command from the master the node actually runs all the test cases which it intends to run on the specific browser which you have mentioned in your configuration file. So this is a very high level architecture and how a grid works. So if you want to know more details of how the grid works, you can refer to our video on Simplilearn. Alright, again, limitations. So what limitation does this grid have now? The first one, it has relatively poor scalability compared to many modern applications. It is pretty static. Each server is configured in advance with a subset of required browser instances available. So if you want to vary this, you will need to reconfigure. So any configuration tomorrow on any machines you want to change, it cannot be done automatically. You need to completely reconfigure that node and then add it back to the grid. Thirdly, although it is available to run on virtual servers, it is actually not designed as a cloud native application. And as a result of this, it isn't optimized to take advantage of things like say distributed storage or dynamic scaling or even automatic failover. So these are some of the limitations of the grid. Advantages of Selenium: speed and accuracy. Of course, since there is no manual execution, your test can run faster, and with grid, it helps in parallel execution, and you can run or execute large volumes of tests within a very short time frame. Let's take an example. Say just before the release of your product, say during the last lap of your testing, you find a bug, and of course it has to be fixed. So the developer fixes the bug and you want to run all the test cases pertaining to that area. Now, can you imagine that if you have to do this testing manually, how long it's going to take? So by automation, you can achieve this in a very short duration of time, and it will also help you release your product in time with very minimal or absolutely no human errors. The second advantage, it's an open source, so it's available free of cost, so anyone can download it and start using it. It supports wide spectrum of programming languages we have been seeing throughout this presentation. It is not restricted to any particular programming language. So whatever language you are comfortable with, you have an option to use that and write your Selenium scripts. Selenium has support for almost all browsers and operating systems. We also talked about headless browser support. So this helps you create test cases once using any of the browser and run them across all browsers and all operating systems, thus saving you a lot of time from manual execution and helping in achieving a very broad test coverage. And we also saw that pretty easy to use tool, right? So you can check out all our videos and it's just a matter of time that you can master the skill of writing your automation scripts. Reusability. Of course, like any programming language, it provides you a mechanism to reuse your code and avoid redundancy. Well, again, let's see an overall what are the limitations of Selenium itself. Now, since Selenium is open source, that is one of the biggest advantage. Now, there is a little disadvantage which comes with that. And what is it? You do not have much technical support because it's an open source code. However, there are loads and loads of documentations and forums available which you can definitely refer to. And Selenium, as we said, it is only for automating web applications. It cannot handle the mobile applications or even the desktop application. However, it does provide support for integrating tools like APM for mobile testing. Selenium is not very good with image testing, especially designed for your web application tools. Again, we have tools like AutoIt and Securely which can be integrated with Selenium. Selenium WebDriver has limited reporting capability, but again, it does provide us support for integrating tools like TestNG, ReportNG and Extend Report. It does not have test management capabilities. It need not, right? Not one tool need not have each and everything what is required, but there is always a way to integrate it. So Selenium does provide a way to integrate any of the test management tools. Now, since Selenium supports multiple programming languages, the developer of test automation will require to have some basic knowledge of any of the programming language it supports to write effective automation scripts, right? So this you could look at it as an advantage or as a disadvantage. So overall, if you look at all this, right, Selenium still provides a complete solution for our automation need. And that is why we can still say that Selenium is one of the most popular tool used in the industry today for your web application automation. How to install Selenium on Windows system? Selenium installation is a 3-step process. So it has certain prereqs. The first prereq is you need to have Java on your system. So we will be installing Java first. And then we will be working with Eclipse IDE. So we will be installing Eclipse. And then we will install Selenium. For Java, we will install the version Java 8. And for Eclipse, we have a version 4.10. This was the last stable version which was released in December last year. So I'll be using that version. And Selenium, we will download the latest 3.14 version. Okay, so let's get started with our first step, which is the Java installation. So to install Java, let's go to the browser and simply just search for Java 8 download. So now you will see that there is an Oracle site which is listed there, and that is where you would be downloading all your Java package. So go ahead and click on that. And for you to download any JDK package from the Oracle site, you need to create an account. So if you already have one, you just need to log in using that account, and then you can download any of the JDKs. And if you do not have one, please go ahead, create a new account on the Oracle, log into that account, and then you can just download the Java 8. So since I already have an account and I have already downloaded the package, but I'll show you how and where to download it from. So in this page, if you scroll down, so you will see this Java Development Kit 8.2.1.1. So this is the version we'll be downloading it. So click on the Accept License Agreement, and then since we are working on the Windows system today, so we will be downloading this, the Windows package. So just click on that and it will get downloaded in your downloaded folder. And as I said, I've already downloaded the packages. So here it is. What I've done is I've just created a directory called installers, and I'm going to be keeping all my installables here. So here I have a folder called Java Installer, and this is where my installable is. So now that we have this file, so we will just go ahead, double click on it and launch this installer. The installer is launched and just click on run. So this will take a few minutes to install Java. The installer is launched. Now just click on the next button here. So here for the installation directory, you can change the directory to the choice of whatever drive and the folder structure you want to. I would like to leave it as default here, and we'll just go and click on next, and then the Java installation is in progress. So let's wait until this is completed. It really shouldn't take too much time, maybe just a few more minutes here. Okay, accept the license term, just click on next. We'll leave the destination folder as it is. So JDK 8 is successfully installed on your system. So close the installer now, and let's go ahead and check whether the installation is done properly. So for that, what I'll do is I'll go to my command prompt and I'll just say Java -version. So it says Java version 1.8, and this tells us that the Java is installed successfully. Now, after this installation, there are a couple of configurations which we need to do. And what are those configurations? One is you need to set the path variable, and then we are also going to set a Java home directory. So for that, first let's go ahead and check where is the Java installed actually. Let's figure out the directory first. So if you remember, the directory structure where the Java got installed was in program files, Java. There are certain previous versions which I had installed and then uninstalled it. So that is why you see some residuals here sitting here. Let's not worry too much about that. Instead, let me go to the latest one what I have installed, which is this. Okay, and there is a bin folder here. And this is the path which we need to set in our path variable. So what I will do is I'll just copy this path and then go to your control panel. Here, go to your, where is my system? Yeah, so click on the system, go to advanced system setting, and here in the environment variables, find the path variable, okay, and then say edit. Now, what are we doing here in the path variable is we are going to add the Java bin directory to the path. Be very careful whenever you are editing your path variable. Do not overwrite anything. Always go into the edit mode, go towards the end here, and then just say Control V, paste the path which you have just copied from the Explorer window. That's it. Now just say OK, done. So your path setting is done. So what's the next one we need to do? We need to add a new environment variable called the Java home. Now what I'll do for that is I'll just say new. I'll just type Java home here. And what is the value of this we need to set? We need to set the same path but without the bin directory. So we just need to set the path till your Java directory. That is this. So we'll just copy the path again and paste it here. That is all. Just say OK, click on OK here, and we are done. So again, let's go to our command prompt and just say Java -version. So everything seems to be fine. So now successfully we have installed Java on the system. So what is our next installation step what we have? Now we need to install the Eclipse. So let's go back to the browser again. So to download Eclipse, we will be downloading the package from the eclipse.org. So when you go here to eclipse.org, you can see the latest version which is available. And the latest version available when this video was made was 2019-06. So especially with Eclipse, since it's an open source, I prefer to work with the last stable version, and so does most of the developers too. And hence that is the reason why I have picked up the version which is like last year's version, which is 4.10. which was released in last December. So you can always choose to go with the latest version, but then if there are any issues and if you're like first time working with the Eclipse, you're going to get confused as where these issues are coming from, right? So I would still recommend that you use the last stable version which is available with your Eclipse. So now to get the last stable version, what you need to do is go and click on this download packages. And here, if you scroll down this page, you can see here more downloads. So there is a list of all the previous releases of Eclipse which is available, and this is what we need to download. So just click on that 4.10 version and then click on the OS on which you want to install Eclipse. For us it is Windows, so I'll just click here on the 64-bit Windows and then click on the download and you will be downloading the complete package. So once you download, this is what it will look like. So let's go back to our directory of installers. So this is the installer for the Eclipse which I got. Now what's the next step I need to do? Just launch this installer and install Eclipse. So I'll just say double click on this. I'll say run. So here you'll see multiple options here for Eclipse installation. So depending on your requirement, you can go ahead and install any of these packages. So for us, we just need an Eclipse ID for Java developers. So I'll select this and I'll say install. So again, you'll have a choice of directory where you want to install. So I have chosen D drive here. This is the default directory name it takes, which is okay. We can leave it as it is. And then also you have an option to create a start menu entry and desktop shortcut. So just leave the default selection as it is and go ahead and click on install. So this will take a while to install the Eclipse. This says select all. You can close this window. This says select all and accept it. Okay, so the installation has been completed successfully. So let's go and click on this launch and let's see the first window what opens. When you launch the Eclipse, you need to specify a workspace directory here. Now what is this workspace directory? So this is a directory or a folder wherein all the Java files or any programs or any artifacts which you're going to create through Eclipse will be stored in this particular folder. So this could be any location on your system. So this is, you can go ahead, browse the location and change it. So in our case, what we will do is I'll go to the D drive and I already have a directory. So here I'll just select this folder and then create a folder called workspace. I'll say my workspace and then I'll say launch. So every time I open the Eclipse, right? So this is going to take as my default workspace and all my programs, all my Java scripts or my automation scripts are going to be stored in this particular location. So we'll say launch. So this is a welcome window which opens. We can just close this. And there we go. The Eclipse is open with a certain perspective. So there are certain windows here which we do not need. Let's just close them. So now the first thing what you do after launching the Eclipse is go ahead and create a new project. So I'll say file, new, and since I'm going to be using Java with Selenium, I'll say create Java project. So give a project name. Let's say my first project. Now you have an option here to select the JRE which you want to use. So we just installed this JDK 1.8. Okay, so I'm going to click on use default JRE. Otherwise, you also have an option to use a project specific JRE. For example, I could have two different projects where one project I'm going to be working with JRE 1.8 and there is another project which I want to work with the latest Java, maybe Java 12. And I can have more than one Java installed on the machine. So this gives me an option to select whichever Java I want to work with. So if you have another Java installed here, it will show up in this list. So and you can just go ahead and select that. Now since we have only one Java installed on our machine, which is Java 1.8, I will say use default JRE, which is 1.8, and I will click on finish. Now if you observe this folder structure, the project which is created, see all the reference libraries to this particular Java have been created here. Now we are ready to create any kind of Java programs in this project. So now we have successfully done the second step of our installation, which is the Eclipse installation. After this, we need to install the Selenium. So again, let's go back to the browser and see what files we need to download to install Selenium. So let me go to my browser and here I will be going to the seleniumhq.org. So if you're working with Selenium, this particular website, the seleniumhq.org, is going to be a Bible. Everything and anything related to Selenium is available in this website. Whether you want to download the files, whether you want to refer to the documentation, anything regarding to Selenium is available here. So what we want now is the installables for Selenium. So here, go to the download tab. Now, for you to install Selenium and start working with Selenium, there are 3 things which are required for you to download. One is a standalone Selenium server. So this is not required immediately when you get started with Selenium. However, when you start working with remote Selenium WebDriver, you would be requiring this. When you have a grid setup, you will be requiring the standalone server. So for that, what you can do is you can just download the latest version available here. So when you click on that, it will download the file into your download folder. So this is one particular file which you need to keep. Next, Selenium client and WebDriver language bindings. Now in today's demo, we will be looking at Selenium with Java. So that means my client package of Java is what I need to download. So whatever programming language Selenium supports, we have respective downloadables available with that. Say if you're working with Python, then you need to download your client library for Python. And since we are working with Java, you need to download this package. So simply what you need to do, click on this link and it will download the Java package for you, which are basically the jar files. So we have client libraries now, and then there is another component what we need. Now with Selenium, you're going to be automating your web browser applications, correct? And you also want your applications to run on multiple browsers. So that means your scripts, the automation scripts which you create, should be able to run on any browser. Selenium works with multiple browsers like Edge, Safari, Chrome, Firefox, and other browsers. Even it has a support for headless browser. Now every browser which it supports comes with its own driver file. Now say for example, we want to say work with Firefox driver. So that means for us to start working with Firefox browser, we need to download something called as a Gecko driver here. And if you want to work with Chrome browser, you need to install the Chrome driver. So depending on what browsers you'll be testing with, go ahead, click on each of this link and download the latest driver files. Now, since we are going to be working with Firefox in this demo, what I need to do is I just need to click here on the latest link. So when I click on the latest link, it is going to take me to this driver files. So driver files are specific to each of the operating system. So if you go down here, you will see there is a separate driver file available for Linux, for Mac, and for Windows. So depending on which operating system where you'll be running your test, download that particular driver file. And this is the driver file I need because we are working on Windows machine. So these are the 3 different packages which we need to download from the seleniumhq.org for us to install Selenium. So let me show you the folder where I have already downloaded all this. So if you see here, Selenium Java 3.141.59. Okay, this is nothing but our client library which we saw here. Let's go back to the main page here. That is this. So once I download this, this is a zip file. After I unzip the file, this is the folder structure I see. And let's see what is there in this folder structure. So there are 2 jar files here, and then in the libs there are multiple jar files. And we will need all this to work with Selenium. And then we also downloaded the driver files. So what I did was, after downloading those driver files for the browser, I created a directory here called drivers and have kept all my browser drivers here. So I have a driver file downloaded for Chrome. I want to work with Firefox, so I have a Gecko driver here, and then for Internet Explorer. That's it. So this is all we need. So once we have all this, what you need to do is go to your Eclipse. In the Eclipse, right click on the project which you have created, and then go to the build path and say configure build path. Go to the libraries tab here. Now, do you see this JRE libraries here? This is what got installed first. And now similarly, we are going to add the Selenium jars to this library. And how do we add that? On your right, you can see this add external jars. Click on add external jars. Go to your folder where you have downloaded your Selenium, which is this. Select all the jar files which is available. So I have 2 jar files here. I'll just say click open. Again, I will click on add external jars. Now from the libs folder, I will select all this 5. So select all the 5 jars and click on open. So you should see all the 7 jar files here. So once you have this, just say apply and close. Now, if you look into your project directory here, you will see a folder called referenced library. And this is where you will see all the Selenium jars here. This is a very simple installation. In Eclipse, when you want to install Selenium, you just need to export all the jars of the Selenium into Eclipse. And now your system is ready to start working with Selenium scripts. So for us to install Java, let us go to our browser. And simply what I'll do is I'll just Google for Java 8 download. Okay, so we would select the Oracle site for downloading the SDE. Okay, so once you go here, you can see that we have something called as Java Software Development Kit 8U211. So this is the version we'll be working with. So in order for you to download, you need to have an Oracle account. So since I already have one, I have directly been logged into that. So if you do not have an Oracle account, please go ahead, create an account for yourself so that you can download any of the Java installers. Now let's go for and download our package. So I'll be downloading this package. For that I need to click on accept license agreement, and then since we are going to be working on Mac, this is the package which I'm going to download. So let's go ahead and click on that. And now the download is going to start. However, we will not wait for the complete download to happen since I have already downloaded the package and I have kept it in one of my folders. So let me show you where that is. So let me go to my Finder. So what I have done is I have created a folder called installers, and all the software which we are going to require today for us to work with Selenium is what I have downloaded it and kept it here. So we'll go step by step so that you understand what each of these packages are. So as you see here, I have the JDK 8 which I've already downloaded. So let's go ahead and install JDK. So how do we install JDK? So you have the DMG file here. You just go ahead and double click on that. Okay, and then I'll double click on this package, and then we will say continue and install. So it's going to ask me for my password. Okay, I've given my password and I'll say install the software. Probably it will just take a couple of minutes to install Java. Okay, there you go. So now the Java has been installed. So let me close this window. Let me close this window too. And then now I'll go to my terminal window. So let's open my terminal, and here let's say Java minus version. Bingo. So there we have Java 1.8 installed on our system. Now there are a couple of other things which you need to do. Apart from installation of your JDK, you also need to set some system variables, right? So in Mac, how do you set the system variables or the environment variables? You do that in your Bash profile. So let's see how we do that. All right. So what I will do is I'll use an editor, which is my VI. Okay. And then I'll open my Bash profile. So what is Bash profile? It's a config file for your Bash shell. This is mainly used to export variables in your shell. Like in Windows, we are going to do the system variable setting from the advanced setting, right? So similarly, we are going to do that here. So I'll say vi dot bash underscore profile. So this is the file where I will be adding Java home path. Okay. Now I have other paths here already written because I'm working with other multiple software on this machines. And now I'll go to the end of this file and I'll say export Java home equal to. Now what is the path we need to give for Java home? We need to give the path where the Java has been installed on your system. Okay, first let's go and find out that path. So let's go back to our Finder, and then I have a folder called library here. So here there is a Java, and then there is something called as Java virtual machines. So if you have a single Java or multiple Java versions installed, so all those versions you're going to see under this directory, which is Java virtual machines. And Java 1.8 is what we installed just now. So let me go and open that folder. There is something called as content and then home. And in this you have your JRE and bin folder. So that means I need to give my Java home path until here, till this home directory. So simply what I'm going to do is I'll just go here, say get info, because I want to just copy the path. And what you can do is you copy this path, okay, and then go back to your shell, and here I'm going to paste this path, plus I want it till the home directory. So I'm just going to type out HOME home. That is it. So you have now set your Java home environment variable. So simply you do save the file, escape:\wq and come out of it. And now what you need to do for this bash profile to be activated, you just exit out of this terminal. Okay, close this terminal window, and I'll go ahead and open another terminal. So let me close this info text. So here, let me again give Java minus version. Okay, so everything seems to be working fine. So this completes our Java installation. Now your system is ready and you have your Java up and running. Other thing which you also can do is go to your system preferences. Okay, here you will see this Java control panel. Okay, this is another way of finding out that your Java has been installed successfully on the machine. So you can just open this Java control panel, and if there is any settings which you want to do here, you can do it through your control panel also. Alright, let's close this. Let's minimize this window and this folder windows. So we have successfully done our step 1. So what's our step 2? We need to go ahead and install the Eclipse. Now same thing what I will do, I'll go to my browser, okay, and now I'll open another tab here and I'll say Eclipse download, and we'll go to this eclipse.org. Now here, whenever you're going to do this installation, you will see the latest version appears here. My recommendation to you is, if you're working first time, instead of working on the latest version available, I would suggest that you work with the last stable version. And that's exactly what we are going to do today. So for me to go to the previous versions, I just need to go here on this download packages, click on it. Okay, so once you click on that, on this page, if you scroll down, you will see something called as more downloads. Right? In this, you will see all the builds of Eclipse which is available, all your previous versions. So since today I'll be working with 4.10 version, I will go ahead and click on this 4.10. This 4.10 was released last year, this is 2018 December. Okay, and now when you look at this installer, you have multiple packages available here. So depending on your need, you can choose which package you want to work with. So today for our demo, what I would be using is Eclipse IDE for Java developers. So since we are going to be working on Mac, I will go ahead and click on this downloadable. And then I'll click on this download, which is going to download this particular file for me. I've already downloaded this file and kept it in my folder. Let's go to my folder. Okay, it's not opening, so let me click from here. And then let's go to our Selenium demo folder and in that installers. Okay, so now do you see this? Eclipse Java 2018-12 R blah 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 .dmg. So this is the file which we are going to be using to install Eclipse. Now as simple as what we did for JDK, I'm going to double click on this and install the Eclipse. So let's see how the Eclipse gets installed. Alright, so now I'll just move this folder into applications. Done. So my Eclipse is ready now. So simply let's go ahead and launch. So what I'll do, I'll just simply search for that on my system. Eclipse, there you go. And I'll just double click this. It's an application downloaded from the internet. Are you sure you want to open it? Yes, please go ahead and open it. Okay, it is launching it. So did you see how simple the Eclipse installation is? It's just downloading the package and just installing it on your Mac machine. Alright, when you start the Eclipse for the first time, you need to set your workspace. So workspace is place where you're going to keep all your folders, all your Java code or whatever you're going to do in Eclipse, all under that particular directory. So right now it gives me a default directory. Rather, what I will do is, since I have created a separate folder for our demos, I will go ahead and select that folder, which is my Simply demo. And then in this, I will add a folder called workspace. Okay, so that means in this particular location, whatever files I'm going to create, whatever code I'm going to write in Selenium is going to be stored at this location. And then I'll go ahead and say launch. So it will take a minute to load your workbench. Yeah, there it goes. So when you launch your Eclipse, right? So let me just make this window bigger. The first screen, what you're going to see is the welcome screen. Okay. Just go ahead and close the welcome screen. And this is the first view of your Eclipse, what you're going to get. So let's close out all the windows which we are not going to be working today. And I just need this main screen here. Now, what is the first step you're going to do once you have the Eclipse? I would go ahead and create a project first. So I'll simply say open file new Java project. Let's give a nice name to this since this is our first project which is going to be created. So I'll say Selenium first project. Now, if you observe here, so we have a JDK already installed and Eclipse needs a JDK to work with. And what it has done while I create my new project, it has already given me an option to use the execution JRE which you already have in the system. Okay? That's why it has already chosen Java 1.8. In case you have multiple Javas installed, in that case, what you can do is you can always go here, select this and select the Java of your choice. So say if you have got the latest Java, which is Java 12 installed on your system, it will give you an option here along with Java Software 8. It will give you Java 12 here. So you can go ahead and select that for this particular project. That option is also available. Now since we have only one JTK installed here, I will go ahead and create this project. So I'll just click on finish and it's going to create a project for me. So there are few default things which it gets created. One is definitely the JRE system libraries, right? This is what we told Eclipse when we created project, that my Java is 1.8. So what it has done is it has imported all those jar file which it requires for our Java programs to work in our Eclipse IDE. And then it creates a SRC, which is your source directory, wherein we'll be creating all our Java code or our Selenium test scripts. Okay, good so far. So this is a simple way of installing your Eclipse and getting your Eclipse ready to work with your Selenium. Alright, so now let's go back. So we have done the installation of Java, we have done the installation of Eclipse. Now what's left? Just the Selenium. Right. So what is that we need for Selenium? Let's go back to our browser. Okay. And this time we will go to seleniumhq.org. So this is going to be a Bible for you if you're going to be working with Selenium. So in this website, what I do is I go to downloads. And there are two things which we need to download for us to work with Selenium. One is the Selenium standalone server. So when you're going to be working with remote Selenium WebDriver is when you would require this. However, I would suggest that we download whatever is required for us, even though we might not use it immediately. So what I just need to do is I need to click on this and it's going to download this server for me. Okay. So I have already downloaded it and I'll show you that. And then what we need is the Selenium client and WebDriver language bindings. Okay. We need a client. So what is the client which you are going to work in? We are going to working with Java client with the Selenium. And for that, I need to go ahead and download this. If you're working on say C# or Ruby or Python, then you have the respective packages which you can go and download. Now, since we are going to be working with Java here, I would go ahead and click on this and this is going to download the Java client for me. Now, as I said, since I've already downloaded it, so let's go ahead and look at what are those downloadables what we have. So let's close out this window. Now, if you see here, one is the Selenium server standalone, which we just downloaded. And then when you download the client libraries, what it does is it creates a zip file. It downloads a zip file and it unzips it. And what is contained in that particular folder? So if you look here, Selenium Java 3. In this folder, you have multiple jar files, with which is what we'll be working with Selenium. So here you have two jar files here and then under the folder libs you have other jar files. Now these are the files which we will need. And now let's see how do we utilize this file in our Eclipse. So for that, let's go back to our Eclipse. Okay. So let me maximize this window. So in Eclipse, first thing what you need to do is click on your project. Okay. Right click on that. And then you have something called as build path. Go to the build path and say configure build path. Now here in this configure build path, what you need to do is go to your libraries. Okay. Go to add external jars. Now when you click on that, this is where you need to select all your jar files from what you have downloaded from the Selenium site. So that is present in our Selenium Java 3. So what I'll do, I'll simply select these two first. Okay. Then again you click on the external jar files. So what we have is in libs. So select all the jar files in the lib. Say open. Okay. You have all the jar files what we need identified here. Go ahead and click on apply and close. Once you do that, how do you know whether all those jars have been imported correctly? Go to the reference libraries. Here you should be able to see all the Selenium jars which we have downloaded to be listed out here. And so it lists here. So that means we have successfully imported Selenium.
Hello, this is Matthew from Simplilearn, and today we're going to go through part 1 of a 2-part series on interview questions that you are likely to be asked if you are interviewing for a job that focuses on DevOps. So there are approximately 7 sections that we cover in DevOps. We go from general DevOps questions, source code management with tools such as Git, continuous integration, and here we'll focus on Jenkins, continuous testing with tools such as Selenium, and then you also have the operations side of DevOps, which is your configuration management with tools such as Chef, Puppet, and Ansible, containerization with Docker, and then continuous monitoring with tools such as Nagios. So let's just get into those general DevOps questions. So one of the questions that you're going to be asked is, how is DevOps different from Agile? And the reality is that DevOps is a cultural way of being able to deliver solutions that's different from Agile. If we look at the evolution of delivery over the last 5 to 10 years, we've gone from Waterfall based delivery to Agile delivery, which is on sprints, to where we are with continuous integration and continuous delivery around DevOps. The whole concept of DevOps is culturally very, very different from Agile. And the difference is that you're looking at being able to do continuous releases. What does that mean? The difference is that you want to be able to send out code continuously to your production environment. That means the operations team, the development team have to be working together. That means that any code that gets created has to be able to go to production very quickly, which means you need to be testing your code continuously, and then that production environment must also be able to be tested continuously, and any changes or any errors that come up have to be communicated effectively and efficiently back to the dev and op team. Another area in which I see that DevOps is different is really the response that we have for how we engage with the customer. So the customer is coming to your website, to your mobile app, to your chatbot, or any digital solution that you have, and has an expectation. When you're going through and actually doing a DevOps paradigm, the old model would be that you would capture requirements from the customer, then you do your development, then you do your testing, and there would be these barriers between each of those. As we move faster through from Waterfall to Agile, what we saw is that with Agile, we were able to respond much faster to customer demands. So instead of it being weeks or months, sometimes in some cases years between releases of software, what we saw was a transition to weeks and months for releases on software. Now we see with DevOps is that the release cycle has shrunk even further with the goal of continuously delighting the customer. How further has that release cycle shrunk to? There are companies that have gone from having releases of once a week or once every 2 weeks or once a month to now having multiple releases a day. Indeed, some companies have up to 50 releases a day. This isn't something to also bear in mind is that each of those releases are tested and verified against test records so that you can guarantee that the code that's going to production is going to be good continuous code. So what are the differences between the different phases of DevOps? So effectively, there are 2 main phases of DevOps. There's the planning and coding phase, and then there's the deploying phase. And you have a tool such as Jenkins that allows you to integrate between both environments. Some of the core benefits that you may have to DevOps are going to be some technical benefits and some business benefits. So when somebody asks you what are the benefits of DevOps, you can reply that from a technical point of view, you're able to use continuous software delivery to constantly push out code that has been tested and verified against scripts that have been written and approved. You can be able to push out smaller chunks of code so that when you have an issue, you're not having to go through massive blocks of code or massive projects. You're going through just very small microservices or small sections of code, and you're able to detect and correct problems faster. On the business side, the benefits are absolutely fantastic. From a customer that's coming to your website or to your mobile app, they're going to see responses happening continuously so that the customer is always aware that you as a company are listening to their demands and responding appropriately. You're able to provide a more stable environment, and you're able to scale that environment to the demands of the number of customers that are using your services. So how will you approach a project that needs to implement DevOps? So this is really an exciting area for you to be in. So there are effectively 3 stages when it comes to actually working in a DevOps. The first stage is an assessment stage, and think of this as the back of the napkin ideation stage. This is where you are sitting with a business leader and they're giving you ideas of what they would like to see from feedback that they've had from their customers. This is blue sky opportunity. This is thinking of big ideas. That second stage, and this often comes as a fast follow to stage one, is actually proving out that concept. So developing a proof of concept. And a proof of concept can actually be multiple different things. So it could be something as simple as a wireframe, or it could be something that is as complex as a mini version of the final application. Depending on the scope of the work that you're delivering will really depend on how complicated you want the POC to be. But with that in mind, whatever choice you make, you have to be able to deliver enough in the POC so that when you present this to a customer, they're able to respond to that creation that you've developed and able to give you feedback to be able to validate that you are going with the right solution and able to provide the right product to your customers. That third stage is where you get into your DevOps stage, and this is just the exciting part. This is where the rubber hits the road and you start releasing code based on a backlog of features that are being requested for the solution. In contrast to doing agile delivery where you just continuously work through a backlog, with DevOps, what you're also looking at is putting in analytics and sensors to be able to validate that you are being successful with the solution that's being delivered. So that once you actually start delivering out code that customers can interact with, you want to be able to see what are the pieces of the solution that they are using, what do they like, what is complicated, where are the failure points, and you want to use that data and feed that back into your continuous integration and have that as a means to be able to backfill the demand of work that gets completed in the backlog. So what is the difference between continuous delivery and continuous deployment? So continuous delivery is based on putting out code that can be deployed safely to production. It ensures that your businesses and functions are running as you would expect them to be. So it's going through and completing the code that you'd actually see. Continuous deployment, in contrast, is all about ensuring that you're automating the deployment of a production environment. So you're able to go through and scale up your environment to meet the demands of both the solution and the customer. This makes software development and release processes much more faster and more robust. So if we look here, we can actually see where continuous integration and continuous deployment come hand in hand. So when you actually start out with the initial pushes of your code, that's where you're doing your continuous integration and your continuous delivery. And then at some point, you want to get very comfortable with deploying the code that you're creating so that it's being pushed out to your production environment. One of the things that's great about working with the tools that you use in a DevOps continuous integration and continuous delivery model is that the development tools that you use, the containerization tools, the testing tools, should always reflect the production environment. And what this means is that when you actually come to deploying solutions to production, there are no surprises because your development team have been working against that exact same environment all the way through. So a question that you'll also be asked is, what is the role of a configuration management in DevOps? And so the role of configuration management really has three distinct areas. The first, and this is really the obvious one, and this is the one where you probably already have significant experiences, is the ability to manage and handle large changes to multiple systems in seconds rather than days, hours, or weeks, as may have happened before. The second area is that you want to also demonstrate the business reasons for having configuration management. And the business reason here is that it allows IT and infrastructure to standardize on resource configurations. And this has a benefit in that you're able to do more with fewer people. So instead of having a large configuration team, you can actually have a smaller, more highly skilled team that's able to actually manage an even larger operational environment. And thirdly, you want want to be able to highlight the ability to scale. So if you have configuration management tools, you're able to manage a significant number of servers and domains that may have multiple servers in. It allows you to effectively manage servers that are deployed on cloud or private cloud and allow you to do this with high accuracy. So how does continuous monitoring help in maintaining the entire architecture of the system? So when this question comes up, you want to dig in and show your knowledge on how configuration and continuous monitoring is able to control an entire environment. So the number one topic that you want to bring up when it comes to continuous monitoring is that with being able to effectively monitor your entire network 24/7 for any changes as they happen, you're able to identify and report those faults or threats immediately and respond immediately for your entire network instead of having to wait, as it happens sometimes, for a customer to email or call you and say, hey, your website's down. Nobody wants that. That's an embarrassing thing. The other three areas that you want to be able to highlight are the ability to be able to ensure that the right software and the right services are running on the right resources. That's your number one takeaway that you want to be able to give of continuous monitoring. The second is to be able to monitor the status of those servers continuously. This is not requiring manually monitoring, but having an agent that's monitoring those servers continuously. And then the third is that by scripting out and continuously monitoring your entire environment, you're creating a self-audit trail that you can take back and demonstrate the effectiveness of the operations environment that you are providing. So one of the cloud companies that is a strong advocate for DevOps is Amazon's Web Services, AWS, and they have really 5 distinct areas that you can zero in on for services. So when the question comes up, what is the role of AWS in DevOps? You want to really hold out your hand and list off 5 areas of focus using your thumb and finger. So you want to have flexible services, built for scale, automation, secure, and a large partner ecosystem. And having those 5 areas will really be able to help demonstrate why you believe that AWS and other cloud providers, but AWS is certainly the leader in this space, are great for being able to provide support for the role of DevOps. So one of the things that we want to be able to do effectively when we're releasing any kind of solution is to be able to measure that solution. And so KPIs are very important. So you will be asked for 3 important DevOps KPIs. And so 3 that really come to mind that are very effective. The first one is mean time to failure recovery. And what this talks about is what is the average time does it take to recover from a failure? And if you have experience doing this, then look at the experience that you have and use a specific example where you are able to demonstrate that mean time to failure recovery. The second is deployment frequency. And with deployment frequency, you want to be able to discuss how often do you actually deploy solutions and what actually happens when you're actually doing those deployments and what does the impact to your network look like when you're doing those deployments. And then the third one is really tied to that deployment frequency, which is around what is the percentage of failed deployments. So how many times did you deploy to a server and something happened where the server itself failed? What we're looking for when you're going through and being asked for these KPIs is experience with actually doing a DevOps deployment and being able to understand what DevOps looks like when you're pushing out your infrastructure. And then the second is being able to validate that self-auditing ability. And one word of caution is don't go in there and say that you have 100% success. The reality is that servers do degrade over time. And you maybe want to talk about a time when a server did degrade in your environment and use that as a story for how you were able to successfully get over and solve that degradation. So one of the terms that is very popular at the moment is infrastructure as code. And so you're going to be asked to explain infrastructure as code. And really, it's something that actually becomes a byproduct of the work you have to do when you're actually putting together your DevOps environment. And infrastructure as code really refers to the writing of code to actually manage your environment. And you can go through many of the other tools that we've covered in this series, but you'll see that XML or Ruby or YAML are used as languages to describe the configuration for your environment. This allows you to then create the rules and instructions that can be read by the machines that are actually setting up the physical hardware versus a traditional model, which is having software and installing that software directly onto the machine. This is really important when it comes to cloud computing. There really is a strong emphasis of being able to explain infrastructure as a service, and infrastructure as code is fundamental to the foundation to infrastructure as service. And then finally, it allows you to be able to talk about how you can use scripted languages such as YAML to be able to create a consistent experience for your entire network. All right, so let's now get into the next section, which is source code management. And we're going to focus specifically on Git. The reason being is that Git is really the most popular source code management solution right now. There are other technologies out there, but for the types of distributed environments that we have, source code management with Git is probably the most effective. So the first question you'll be asked when it comes to Git is to talk about the difference between centralized and distributed version control. And if we look at the way that the two are set up, older technologies such as older versions of Team Foundation Server, though the current version does actually have Git in it, but older versions required a centralized server for you to check in and check out of code. The developer in the centralized system does not have all the files for the application, and if the centralized server crashes, then you actually lose all of the history of your code. Now, in contrast, a distributed model, actually we do check in our code to a server. However, for you to be effective and building out your solution, you actually check out all of the code for the solution directly onto your local development machine. So you can actually have a copy of the entire solution running on your local machine. This allows you to be able to work effectively offline. It really allows for scalability when it comes to building out your team. So if you have a team that may be in Europe, you can actually then scale that team with people from Asia, from North America or South America very easily, and not have to worry about whether or not they have the right code or the wrong code. And in addition to that, if the actual main server where you're checking in your code does crash, it's not a big deal because you actually have, each person has a copy of the code. So as soon as the server comes back up, you're able to check back in and everybody's running back as if there was nothing had happened at all. So one of the questions you'll be asked is to give the answer to some of the commands you use for working with Git. So if you were to be asked a question is, what is the Git command that downloads any repository from GitHub to your computer? On the screen we have 4 options. We have Git push, Git fork, Git clone, and Git commit. The answer in this instance would be Git clone. Now, if you want to be able to push code from your local system to a GitHub repository using Git, then first of all, you want to be able to do is connect the local repository to a remote repository. And in the example, you may want to talk about using the command git remote add origin and then the actual path to a GitHub repository. You could, if you wanted to, actually at this point also talk about other repositories such as GitLab that you can also work with, or a private Git repository that would be used just for the development team. Once you've actually then added the local repository into your local computer, then the second action you want to use is a push, which is to actually push your local files out to the master environment. So you use the command git push origin master. So one question you may be asked is, what is the difference between a bare repository and a standard way of initializing a Git repository? So let's look through what is the standard way. So the standard way, using git init, allows you to create a working directory using the command git init. And then the folder that creates is the folder that creates all the revision history related to the work that you're doing. In contrast, Using the bear way, you have a different commands for setting that up. So it would be git init -- bear, and it does not contain any working or checked out source files locally on your machine. In addition, the revision history is actually stored in the root folder versus a subfolder that you would have with the normal git init initialization. So which of the following CLI commands would you be used to rename a file? So we have git rm, git mv, git rm-r, or none of the above. Well, in this instance, it would be git mv. A question that you'll be asked around commit is going to be, what is the process to revert a commit that has already been pushed and made public? And there are two ways you can address this. The first is to actually address the bad file in the new commit, and you can use the command git commit -m and then put in a comment for why that file is being removed. The second is to actually create a new commit that actually undoes all the changes that were made with the bad commit. And then to do that, you would use git revert and then the commit ID, and the commit ID could be something such as 56DE0938F, but you'd have to find that from the commit that you had made, but that would allow you to revert any bad files that you had submitted. So there are two ways of being able to get files from a Git repository, and you're going to be asked to explain the difference between git fetch and git pull. So git fetch allows you to fetch and download only new data from a new repository. It does not integrate any of the new data into your working files, and it can be undone at any time if you want to break out the remote tracking branches. In contrast, git pull updates the current head branch with the latest changes from the remote server. So you get all of the files downloaded. It downloads new data and integrates it with the current working files you have on your system, and it tries to merge remote changes with your local ones. So one of the questions you'll get asked about Git is, what is a Git stash? So as a developer, you will be working on the current branch within a solution. But what happens if you come up with an idea where it's something that will take a different amount of time for you to be able to complete, but you don't want to interrupt the mainline branch? So what you can actually do is you can actually create a branch that allows you to start working on your own work outside of the mainline branch. And this is called Git stash. It allows you to be able to modify your files without interrupting the mainline branch. So once you start talking about branching in Git, be prepared to answer and explain the concept of branching. So essentially what it allows you to do is have a mainline master branch that has all the code that the team is checking in and checking out against, but allows you to have an indefinite number of branches that allows for new features to be built in parallel to the mainline branch, and then at some point be reintroduced to the mainline branch to allow the team to add in new features. And so if we look through the merge and git rebase, these are the two features that you'd be using continuously to be able to talk about how you take a branch and merge it back into the mainline branch. So on the left hand side we have git merge, which allows you to take the code that you're creating and merge it back into the master. On the right hand side what you have is a slightly different approach. This is for projects where you reach a point in a project where you go, okay, we're going to effectively restart the project at this point in time, and we want to ignore the complete history that's happened before that, and that's called git rebase, and that would allow you to rewrite the project history by creating a brand new mainline branch that ignores all other previous branches that have happened before it. You can, if you want to, very quickly and easily find out all the files that have been used to make a particular commit. So when somebody asks you the question, how do you find a list of files that has been changed in a particular commit, you can actually say that all you have to go is find the command git diff-tree-r and then the hash that you would use for the commit, and that would actually then give you a breakdown of all the files that have been made with that particular commit. A question that you'll be asked when you're talking about merging files is, what is a merge conflict in Git? and how can it be resolved? So essentially a merge conflict is when you have two or more branches that are competing with commits in Git, and you have to be able to determine which is the appropriate files that need to be submitted. And this is where you would go in, and to actually help resolve this issue, you'd actually go in and manually edit the conflicted files to select the changes you want to keep in the final merge. So let me go through the steps that you would take to be able to illustrate this when you're talking about this particular question in your interview. There are essentially 4 stages. The first would be under the repository name, you want to select a pull request, and you want to be able to show how that pull request would be demonstrated inside of GitHub. So within the pull request, there's going to be a highlight of conflict markers, and you'll be able to select which conflicts you want to keep and which you want to merge and which ones you want to change. So it's a step through how you would actually resolve a merge conflict. The first step would be under GitHub. You want to be able to pull the repository name and then the pull request around that repository. In the pull request list, click the pull request with a merge conflict and that you'd like to be able to resolve. That will pull up a file that will list out all of the conflicts for you. Near the bottom of that file will be a list of the requests that need to be resolved. And then if you need to make a decision on which branches you want to keep or which ones you want to change, that will have to be something you have to put in instructions inside of the file. You'll actually see that there are conflict markers within the instructions which are going to ask you which files you want to change and which ones you want to keep. If you have more than one merge conflict in your file, scroll down to the next set of conflict markers and repeat steps 4 and 5 until you resolve all of the conflicts. You will want to mark your file as resolved in GitHub so that the repository knows that you are having everything resolved. If you have more than one file with a conflict, then you want to go then onto the next file and start working on those files and just keep repeating the steps we've done up to this point until you have all of the conflicts resolved. And then once you have all of the resolutions created, then you want to select the button which is commit merge and then merge all your files back into GitHub, and this will take care and manage the resolution of the merge conflict within GitHub. So you can also do this through command line, and with command line you want to use git bash, and so you want to, as a first step, open up git bash and then navigate to the local git repository in command line using the cd change directory, and then list out the actual folder where you actually are putting all of your code. And then you want to be able to generate a list of the files that are affected with the merge conflict. And in this instance here, you can actually see the file styleguide.md has a merge conflict in it. And as before, with working with GitHub, you actually go through and use a text editor, and you can use any text editor. But as you go through and edit out what you want to keep and what you want to manage in your conflict, so you actually have a resolution that's being created, so that you'll be able to then, once you're using the conflict markers, you can actually merge your files together so that the solution itself will allow you to incorporate your commits effectively into the resolution. Once you've gone through and applied your changes, you're able to then merge the conflicted commits into a single commit and able to push that up to your remote repository. All right, let's talk about the next section, which is continuous integration with Jenkins. So the first question you'll be asked about with Jenkins is explain a master-slave architecture of Jenkins. So the way that Jenkins is set up is that the Jenkins master will pull code from your remote Git repository such as GitHub and will check that repository every time there is a code commit. It will distribute the workload of that code and the tests that need to be applied to that code to all of the Jenkins slaves. And then on request, the Jenkins master and the slaves will then carry out all the builds and tests to be able to produce test reports. The next question you'll be asked is, what is a Jenkins file? And simply put, a Jenkins file is a text file that has a definition of the Jenkins pipeline and is checked into a source code repository. And this really allows for 3 distinct things to happen. One, it allows for a code review and iteration of the pipeline. It permits an audit trail for that pipeline, and also provides a single source of truth for the pipeline, which can be viewed and edited. So which of the following commands runs Jenkins from the command line? Is it java-jar jenkins.war, java-war jenkins.jar, java-jar jenkins.jar, java-war jenkins.war? And the answer is A, java-jar jenkins.war. So when working with Jenkins, you're going to be asked what are the key concepts and aspects of working with a Jenkins pipeline. And you want to really hold out your fingers here and go through 4 key areas, and that is pipeline, node, step, and stage. So pipeline refers to the user-defined model of a CD continuous delivery pipeline. Node are the machines which are part of that Jenkins environment within the pipeline. Step is a single task that tells Jenkins what to do at that particular point in time. And then finally, stage defines a conceptually distinct subset of tasks performed through the entire pipeline. And tasks could be build, test, and deploy. So which of the following file is used to define dependency in Maven? And do we have A, build.xml, B, pom.xml, C, dependency.xml, or D, version.xml? And the answer is pom.xml. Working with Jenkins, you're going to be asked to explain the 2 types of pipeline used in Jenkins along with the syntax. And so a scripted pipeline is based on GroovyScript as their domain-specific language for Jenkins. And there are 1 or more node blocks that are used throughout the entire pipeline. On the left-hand side, you can actually see what the actual script would look like, and the right-hand side shows what the actual declaration for each section of that script would be. The second type of Jenkins pipeline is a declarative pipeline. And a declarative pipeline provides a simple and a friendly syntax to define what the pipeline should look like. And then you can actually, at this point, use an example to actually break out how blocks are used to define the work completed in a declarative pipeline. So how do you create a copy and backup of Jenkins? Well, to create a backup, periodically back up Jenkins to your Jenkins home directory, and then create a copy of that directory. It's really as simple as that. The question you'll be asked as well is how can you copy Jenkins from one server to another? Well, there are 3 ways to do that. One is you can move a job from one installation of Jenkins to another by copying the corresponding job directory. The second would be to create a copy of an existing job directory and making a clone of that job directory but with a different name. And the third is to rename an existing job by renaming a directory. So security is fundamental to all the work that we do within DevOps, and Jenkins provides the center core to all the work that gets completed within a DevOps environment. There are 3 ways in which you can apply security to authenticate users effectively. And when you are asked about this question of security within Jenkins, the 3 responses you want to be able to provide is A, Jenkins has its own internal database that uses secured user data and user credentials. B is you can use a LDAP or lightweight directory access protocol server to be able to authenticate Jenkins users. Or C, you can actually configure Jenkins to authenticate by using such as OAuth, which is a more modern method of being able to authenticate users. You're going to be asked how to deploy a custom build of a core plugin within Jenkins. And essentially, the 4 steps that you want to go through are, first of all, copying the .hpi plugin file into the Jenkins home plugins subdirectory. You want to remove the plugin's development directory if there is one. You want to create an empty file called plugin.hpi.pinned. And once you've completed these 3 steps, restart Jenkins and your custom build plugin should be available. How can you temporarily turn off Jenkins security if the administrative user has locked themselves out of the admin console? Well, this doesn't happen very often, but when it does, it's good to know how you can actually get into Jenkins and be able to resolve the problems of authenticating effectively into the system as an administrator. So when you want to be able to get into a Jenkins environment, what you want to be able to do is locate the config file. You should see that it's set to true, which allows for security to be enabled. If you then change the user security setting to false, security will be disabled, allowing you to make your administrative changes, and will not be re-enabled until the next time Jenkins is restarted. So what are the ways in which a build can be scheduled and run in Jenkins? Well, there are 4 ways in which you can identify the way a build can be scheduled or run in Jenkins. The first is when source code management commits new code into the repository. You can run Jenkins at that point. The second can be after the completion of other builds. So maybe you have multiple builds in your project that are dependent to each other, and when so many other builds have been executed, then you can have Jenkins run. You can schedule builds to run at a specified time. So you may have nightly builds of your code that illustrate the changes in the solution you're building. And then finally, you also can manually build an environment on request. Occasionally, you will want to also restart Jenkins. And so it's good that when a question around how do you restart Jenkins manually comes up, that you have the answers. And there are 2 ways in which you can do it. One is you can force a restart without waiting for builds to complete by using the Jenkins URL that you have for your environment /restart, or you can allow all running builds to complete before restart are required, and in which case you would use the command of the URL for your Jenkins environment /safe restart. So let's go into the 4th and final section of this first video, which talks about continuous testing with Selenium. So the first question you will be asked most likely around Selenium are, what are the 4 different Selenium components? And again, you will want to hold open your fingers because there are 4 distinct environments. You have Selenium Integrated Development Environment, or Selenium IDE. You have Selenium Remote Control, or Selenium RC. You have Selenium WebDriver, and then Selenium Grid. You'll be asked to explain each of those areas in more detail, but let's start off by looking at Selenium Driver. What are the different exceptions in Selenium WebDriver? So it's useful to remember that an exception is an event that occurs during the execution of a program that disrupts the normal flow of that program's instructions. And so we have 4. We have a timeout exception, an element not visible exception, no such element exception, and a session not found exception. And each of those, if we step through them, are the 4 different types of exceptions that can be thrown up when using the Selenium WebDriver. So as we evolve in our digital world with the different types of products that are available for us to be able to build solutions onto multiple platforms, you're going to be asked, can Selenium and other DevOps tools run in other environments? And so a good question around this is, can Selenium test an application in an Android web browser? And the short answer is absolutely yes, it can. But you have to use the Android driver for it to be able to work. So you want to be able to talk about the 3 different types of supported test within Selenium. So when the question comes up, what are the different test types supported by Selenium, you can answer it. And there are 3 different types of tests. First is a functional test. Second is a regression test, and third is a load testing test. The functional test is a kind of black box testing in which test cases are based on a specific area or feature within the software. A regression test helps you find any specific areas that functional tests or non-functional areas of the code wouldn't be able to detect. The load testing test allows you to monitor the response of a solution as you increase the volume of hits in how you're using the code are put onto it. An additional question you'll be asked is, how can you get a text of a web element using Selenium? Well, the get command is used to retrieve text of a specific web element. It's important to remember, however, that the command does not return any parameters, but just returns a string value. So you want to be able to capture that string value and discuss about it. A question you'll be asked around Selenium is, can you handle keyboard and mouse actions using Selenium? And the answer is yes, you can, but you have to make sure that you're using the Advanced User Interaction API. And the Advanced User Interaction API is something that can be scripted into your tests, and it allows you for capturing methods such as a click and hold and drag and drop mouse events, and then keyboard down or keyboard up key release events, so that if you want to capture, say, the use of Control Shift or a specific function button off the keyboard, you'd be able to capture those. Of the following 4 elements, which of these elements is not a web element method? A, get text, B, size, C, get tag name, D, send keys. And it's B, size. You're going to be asked to explain what is the difference for when we use find element or find elements. And so if we look at find element finds the first element in the current web page that matches the specified locator value. In contrast, find element finds all of the elements on the web page that matches the specified value. When using WebDriver, what are the driver close and driver quit commands? And these are 2 different methods used to close a web browser session in Selenium. So driver close will close the current web browser on which your focus is set, and driver quit closes all the browser windows and ends the WebDriver session completely. The final question that you are likely to be asked in using Selenium is, how can you submit a form using Selenium? Well, in this instance, that's relatively easy. The following lines of code will let you submit a form in Selenium, which would be web element el equals driver.findElement, and then you put in the ID and the element ID, and then l submit, open close parentheses, semicolon. So let's just get into the first section, which is configuration management. So one of the questions that you'll get asked right away is, why do you have SSL certificates used for Chef? Really fundamentally, your immediate answer should be security. SSL provides for a very high level of private security and private and public key pairing. This really is essential to ensure that you have a secure environment throughout your entire network. The second part should be that if you're using SSL and you're using the private public key model within SSL, you're able to guarantee the systems on your network that the Chef, that you'll be able to validate that the nodes within your network that Chef is validating against actually are the real nodes themselves, not imposters. So you will also be asked some questions such as the following. Which of the following commands would you use to stop or disable the HTTP service when the system boots? And you'll typically get 4 responses, and there'll be hashtag systemctl disable httpd.service, or is it system disable http.service, system disable httpd, or the final option, which is systemctl disable httpd.service. Your answer should be the first one, which is hashtag systemctl disable http.service. So Chef comes with a series of tools that allow it to function effectively, and one of the tools that you're going to be asked about is, what is Test Kitchen? And Test Kitchen is essentially a command line tool that allows you to be able to test out your cookbook before you actually deploy it to a real node. So some of the commands that you would use are, for instance, if you want to create an instance of Test Kitchen, you would do kitchen create. If you want to destroy an instance after you created it, you do kitchen destroy. And if you want to be able to combine multiple instances, you would do kitchen converge. So a question you'll get is around Chef is, how does Chef Apply differ from Chef Client? So fundamentally, the difference between them is that Chef Apply will validate the recipe that you're working on, whereas Chef Client looks to apply and validate the entire cookbook that's run in your server environment. So one is focused on the recipe and the other is focused on the entire cookbook. So there are some differences when you're working with different command lines. So for instance, when you're working with Puppet and you're working with one version of Puppet and you want to do, what is the command to sign a requested certificate? The top example here is for Puppet version 2.7, whereas the lower option here is for Puppet version 3. And that's something to bear in mind when you're going through your interview process, is that the tools that are used within a continuous integration, continuous delivery DevOps model do vary. And so you want to be able to talk knowledgeably about the different versions of the tools so that when you're talking to your interviewer, you're able to show the deep knowledge that you have. Which open source or community tools do you use to make Puppet more powerful? And essentially this question is going to be asking you to look beyond the core foundation of Puppet itself. And so the 3 options you have is being able to track configurations with Jira, which you should be doing anyway, but it's a great way to be able to clearly communicate the work that's been done with Puppet. Version control can be extended with Git. and then the changes should be passed through Jenkins. So the 3 tools you want to be looking at: integration with Jira, Git, and Jenkins. So what are the resources in Puppet? Well, fundamentally, there are 4. The resources are basic units of any configuration management tool. They are the features of the nodes. They are the written catalog and the execution of the catalog on a node. So as we dig deeper into Puppet, one of the things that you are likely to be asked regarding Puppet is, what is a class in Puppet? And so a class in Puppet is really the name blocks in your manifest that contain the various configurations. And this can include services, files, and packages. And we have on the screen here an example of what a class would look like when you write it out. And you may want to memorize just one class. Don't memorize just a whole set of classes. Just memorize one. The person that's interviewing you is just really looking for someone who has a working knowledge. They're not looking for you to have memorized complete massive classes, but having one small class to be able to illustrate the experience you have is extremely valuable to the interviewer, particularly if it's a technical interview. So as we move into Ansible, one of the things that you're going to be asked around Ansible is, what is Ansible role? So a role is an independent block of tasks and variable files and templates embedded inside of the playbook. So the example we have here on the screen actually shows you one role within a playbook. And in this role, it is to install Tomcat on a node. Again, as with previous question within Puppet of a class, it's probably good to have memorized just 1 or 2 roles so you can talk knowledgeably about Ansible when you're having your interview. So when you're working with Ansible, when should you be using the curly brackets? And so just as a frame of reference, there's often 2 different ways that these kind of brackets are referred to. They're either referred to as French brackets or curly brackets. Either way, what you'll be wanting to ask is, when would you use these specific types of brackets within Ansible? And really, the answer comes down to 2 things. One is that it makes it easier to distinguish strings and undefined variables. And the second is for putting together conditional statements when you are actually using variables. And the example we have here is this prints the value of, and we have foo, and we have to then put in the variable conditional statement of foo is defined as something. So what is the best way to make content reusable and redistributable with Ansible? And there's really essentially 3. The first is to include a submodule or another file in your playbook. The second is to import an improvement of an include, which ensures that a file is added only once. And then the third is roles to manage the tasks within the playbook. So a question you will be asked is, provide a differences between Ansible and Puppets. So if we look at Ansible, it's a very easy agentless installation. It's based on Python. You can configure it with YAML, and there are no support for Windows. In contrast, Puppet is an agent-based installation. It's written in Ruby. The configuration files are written in DSL, and it has support on all popular operating systems. So we dig deeper into the actual architecture. Ansible, it has a much more simple architecture, and it's definitely a push-only architecture. In contrast to Puppet, it's a more complicated but more sophisticated architecture where you're able to have a complete environment managed by the Puppet architecture. So let's get on to our next section, which is containerization. So let's go through, and you're going to be asked to explain what the architecture of Docker is. And Docker really is the most popular containerization environment. So Docker uses a client-server architecture. The Docker client is a service which runs in a command line. And then the Docker daemon, which is run as a REST API within the command line, will accept the requests and interacts with the operating system in order to build the Docker images and run the Docker containers. And then the Docker image is a template of instructions which is used to create containers. The Docker container is an executable package of applications and its dependencies together. And then finally, the Docker registry is a service to host and distribute Docker images among other users. So you'll also be asked to provide what are the advantages of Docker over virtual machine. And this is something that comes up very consistently. In fact, you may want to even extend it as having what are the differences between having a dedicated machine, a virtual machine, and a Docker or Docker-like environment. And really, the arguments for Docker are just absolutely fantastic. First of all, Docker containers occupy significantly less space than a virtual machine or a dedicated machine. The boot up time on Docker is significantly faster than a VM. Containers have a much better performance as they are hosted in a single Docker image. Docker is highly efficient and very easy to scale, particularly when you start working with Kubernetes. Easily portable across multiple platforms, and then finally, for space allocation, Docker data volumes can be shared and reused among multiple containers. The argument against virtual machines is significant, and particularly if you're going into an older environment where a company is still using actual dedicated hardware and haven't moved to a cloud or cloud-like environment, your arguments for Docker are going to be very, very persuasive. Be very clear on what the advantages are for Docker over a virtual machine, because you want to be able to succinctly share them with your team. And this is something that's important when you're going through the interview process, but also equally important, particularly if you're working with a company that's transitioning or going through a digital transformation where they aren't used to working with tools like Docker. You need to be able to effectively share with that team what the benefits are. So how do we share Docker containers with different nodes? And in this instance, what you want to be able to do is leverage the power of Docker Swarm. So Docker Swarm is a tool which allows the IT administrators and developers to create and manage clusters of Swarm nodes within the Docker platform. And there are two elements to the node. There's the manager node, and then there's the worker node. The manager node, as you'd assume, manages the entire infrastructure, and the worker node is actually the work of the agent as it gets executed. So what are the commands to create a Docker Swarm? And so here we have an example of what a manager node would look like. And once you've created a swarm on your manager node, you can now add worker nodes to that swarm. And again, when you're stepping through this process, be very precise in the execution path that needs to be taken to be able to effectively create a swarm. So start with the manager node, and then you create a worker node. And then finally, when a node is initialized as a manager node, it can immediately create a token, and that token is used for the worker nodes and associating the IP address with the worker nodes. Question 17, how to run multiple containers using a single service. It is possible to run multiple containers as a single service by using Docker Compose. And Docker Compose will actually run each of the services in isolation so that they can interact with each other. The language used to write out the compose files that allow you to run the service is called YAML, and YAML stands for yet another markup language. So what is the use of a Docker file? So a Docker file actually is used for creating Docker images using the build command. So let's go through and show on the screen what that would look like. And this would be an opportunity where if you're actually in a technical interview, you could potentially even ask, hey, can I draw on a whiteboard and show you what the architecture for using the build command would look like and what the process would look like? Again, when you're going through an interview process, as someone who interviews a lot of people, one of the things that I really like is when an interview candidate does something that's slightly different. And in this instance, this is a great example of where you can stand up to the whiteboard and actually show what can actually be done through actually creating images on the whiteboard very quickly, little square boxes where you can actually show the flow for creating a build environment. As an architect, this should be something that you are comfortable doing, and by doing it in the interview, and certainly you want to ask permission before you actually do it, but doing this in the interview really helps demonstrate your comfortable feelings of working with these kind of architecture drawings. So back to the question of creating a Docker file. So we go through and we have a Docker file that actually then goes ahead and creates the Docker image, which then in turn creates the Docker container. And then we are able to push that out up to a Docker Hub and then share that Docker Hub with everybody else as part of the Docker registry with the whole network. So what are the differences between Docker image and Docker containers? So let's go through the Docker image. So the Docker images are templates of a Docker container. An image is built using a Docker file, and it stores that Docker file in a Docker repository or a Docker Hub. And you can use Docker Hub as an example. And the image layer is a read-only file system. The Docker container is a collection of the runtime instances of a Docker image, and the containers are created using Docker images, and they are stored in the Docker daemon, and every container is a read-write file system. So you can't replace the information, you can only append to it. So while you can actually use YAML for writing so a question you're going to be asked is, instead of YAML, what can be an alternate file to build Docker Compose? So YAML is the one that is the default, but you can also use JSON. So if you are comfortable working with JSON, and that is something that you should be get comfortable with, is you want to be able to use that to name your files. And as a frame of reference, JSON is a logical way of being able to do value paired matching using a JavaScript-like syntax. So you're going to be asked how to create a Docker container. So let's go through what that would look, and we'll break it down task by task. So the task is going to be create a MySQL Docker container. So to do that, you want to be able to build a Docker image or pull from an existing Docker image from a Docker repository or hub. And then you want to be able to then use Docker to create a new container, which has MySQL from the existing Docker image. Simultaneously, the layer of read-write file system is also created on top of that image. And below at the bottom of the screen, we have what the command lines look for that. So what is the difference between a registry and a repository? So let's go through that. So for the Docker registry and repository, for the registry, we have Docker registry is an open source server-side service used for hosting and distributing Docker images, whereas in contrast, for repository, it's a collection of multiple versions of a Docker image. In a registry, a user can distinguish between Docker images with their tag names. And then finally, on the registry, Docker also has its own default registry called Docker Hub. For the repository, it is a collection of multiple versions of Docker images. It is stored in a Docker registry, and it has two types, a public and private registry, so you can actually create your own enterprise registry. So you're going to be asked, what are the cloud platforms that support Docker? Really, list them all. We have listed here Amazon Web Services, Microsoft Azure, Google Cloud, Rackspace, but you could add in there IBM, Bluemix, could put in Red Hat. Really, any of the cloud service providers out there today do support Docker. It's just become an industry standard. So what is the purpose of expose and publish commands in Docker? So if we go through, expose is an instruction used in Docker file, whereas publish is used in Docker run command. For expose, it is used to expose ports within a Docker network, whereas with publish, it can be used outside of a Docker environment. For expose, it is a documenting instruction used at the time of building an image and running a container, whereas with publish, it is used to map a host port to a running container port. For expose is the command used in Docker, whereas for publish, we use the command -p for when we're doing our command line used in Docker. And examples of these are expose 8080, or with Docker, we would put in, or for publish, we would do the example Docker run -d-p and then 0.0.0.80 as our command line. So let's look at continuous monitoring. So with continuous monitoring, how does Nagios help in continuous monitoring of systems, applications, and servers? And so this is really just a high-level question of using Nagios within your environment. And you should be able to just come back very quickly and say, Nagios allows you to help manage the servers and check if they're being sufficiently utilized and if there are any task failures that need to be addressed. And so there are three areas of utilization and risk that you want to be able to manage. This is being able to verify the status and services of the entire network, the health of your infrastructure as a whole, and if applications are working properly together with web services and APIs that are reachable. So the second question you'll be asked is, how does Nagios help in continuous monitoring of systems, applications, and services? So it's able to do this by having the initial Nagios process and scheduler and the additional plugins that you would use for your network connect with the remote resources and the Nagios web interface to be able to run status checks on a predefined schedule. So what do you mean by Nagios Remote Plugin Executor, or the NPRE of Nagios? So NPRE allows you to execute plugins on Linux Unix machines that allow you to do additional monitoring and machine metrics such as disk usage, CPU load, etc. What are the ports used by Nagios for monitoring purposes? In this example, there are 3, and they're easy to remember, so I would memorize these 3, but they're essentially ports 5666, 5667, and 5668. So there are 2 types of checks within Nagios. So you will be asked for what is an active and passive check in Nagios. So an active check is initiated by the Nagios process and is run on a regular schedule. A passive check is initiated and formed by an external application or process. So this may be where a system is failing. And results are submitted to Nagios for processing. And to continue with this, for what is an active and passive check, active checks are initiated by the check logic within the Nagios daemon. Nagios will execute a plugin and pass information about what needs to be checked. Plugin will then check the operational state of the host or service and then process the results of the host or service check and send out notifications. In contrast with the passive check, it is an external application that initiates the check. It writes the results of the check to an external command line file. Nagios reads the external command file and places the results of all passive checks in a queue for later processing, so you can go back and revalidate. And then Nagios may send out notifications, log alerts, etc., depending on the results that they get from checking the information. So you're going to be asked to explain the main configuration file and its location in Nagios. So the main configuration file consists of a number of directives that affect how Nagios operates. So consider this as the configuration file that it's read by both Nagios processor and the CGIs. So this will allow you to be able to manage the main configuration file that's placed into your settings directory. So what is the Nagios Network Analyzer? And again, hold out your 4 fingers because there are 4 options here. So the Nagios Network Analyzer 1 provides an in-depth look at all your network traffic source and security threats. 2 allows system admins to gather high-level information on the health of your network. 3 provides a central view of your network traffic and bandwidth data. And then 4 allows you to proactive in resolving outages, abnormal behavior, and threats before they affect critical business processes. So what are the benefits of HTTP and SSL certificate monitoring with Nagios? So with HTTP certificate monitoring, it allows you to have increased server and services and application availability, obviously very important, fast detection of network outages and protocol failures, and allows web transaction and web service performance monitoring. The SSL certificate monitoring allows you for increased website availability, frequent application availability, and provides increased security. So explain virtualization with Nagios. So in response to this, the first thing you should be able to talk about is how Nagios itself can run on many different virtualization platforms, including Microsoft Visual PC, VMware, Xen, Amazon EC2, etc., etc. So just make sure you get that right off the bat. Nagios was able to provide capabilities to monitor an assortment of metrics on different platforms. It allows for quick detection of service and application failures, and has the ability to be able to monitor against many metrics, including CPU usage, memory, networking, and VM status. So name the 3 variables that affect recursion inheritance in Nagios, and it is name, use, and register. So name is a template name that can be referenced in other object definitions. Use specifies the name of the template object that you want to inherit its properties and variables from. And register indicates whether or not the object definition should be registered to Nagios. And on the right-hand side of the screen, we have an example of what that script would look like. Again, you may want to be able to memorize this, as it's something that you can actually write down and show someone if you're going through a technical interview. So why is Nagios said to be object-oriented? And fundamentally it comes down to the object configuration format that you can use in your object definitions. It allows you to inherit properties from other object definitions, and this is typical of object-oriented development and is now applied for the Nagios environment. So some of the objects that you can inherit are services, hosts, commands, and time periods. So finally, explain what is state talking in Nagios. And so there are really 4 options here when you're talking about state stalking. So state stalking is used for logging purposes in Nagios. It allows you to enable for a particular host or service that Nagios will watch over very carefully. It will log any changes it sees in the output of the check results, and then finally helps the analysis of log files.
And so with that, we come to the end of this DevOps Tools full course. If you have any doubts or queries, let us know in the comment section below. So watch out for more interesting videos like these. Until then, keep learning and stay tuned to Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.